All right, let's take a look at the practice test. For the instructions, we're asked to plot each point, state its quadrant. All right, for the first problem, we're given the ordered pair 3, 3. So let's come down to the coordinate plane, and I'm just going to write the ordered pair 3, 3. So before I just plot this and state the quadrant, which is very easy to do, I want to do a quick refresher in case you watched the lesson and you're still lost, or maybe you skipped the lesson and you're just finding this video. So the first thing is, when you think about the coordinate plane, the way it's set up, you're going to see these two number lines, and they have a common meeting point. Okay, so basically think about this horizontal number line first. So this, you see this x here, this stands for the x-axis, so that's going to be the horizontal number line here. So if you had a regular number line, just think about this being gone for a second. This is 0, and numbers to the right of 0, those are positive numbers. So here, this is in increments of 1. So 1, 2, 3, 4, 5, so on and so forth. To the left of 0, those are your negative numbers. So here's -1, -2, -3, so on and so forth. Now, you have this other number line that's involved here, and it's vertical. So this, you see a y here, this stands for y-axis. And essentially, above this 0 guy right here, you're going to have your positive numbers. So this is 1, 2, 3, 4, so on and so forth. Below 0, you're going to have the negative numbers. So -1, -2, -3, so on and so forth. You'll see that this guy right here is 0 for the x-axis and also 0 for the y-axis. So we call that the origin because it's the meeting point between the two. So this is labeled as the origin. So the origin. And the ordered pair for that is going to be 0, 0, because the x-coordinate comes first and the y-coordinate comes second. So when you look at an ordered pair, let me just get rid of this for a moment, it's the x value or the x-coordinate first, and then comma, your y value or your y-coordinate second, or you could say last. So let me actually label this as the x-coordinate, and this would be the y-coordinate. Okay, so if I want to plot this ordered pair, it's extremely simple. Basically, the x-coordinate tells you where you want to be on the x-axis. So if I have an x-coordinate of 3, it just says, hey, go to 3 on the x-axis. Or some people will say, okay, start from the origin and go 3 units to the right. However you want to think about that. So that puts me right there. The y-coordinate tells me where I need to be on the y-axis. So you could start at the origin and just go 3 units up. So that's going to be right there. So when you plot this ordered pair, it's just the meeting point between the two. So I could say I'm starting at the origin, I'm going 3 units to the right, and then 3 units up, and that would put me right there. You could also start at the origin and go 3 units up, and then 3 units to the right. However you want to think about this, it doesn't really matter. You're going to end up at that same point, which we would say this is 3, 3. And you could also draw this, if it's easier for you, as the meeting point between the two, just like that. And maybe I can make that a little bit better. So let me do my circle again, like this. Now let's talk a little bit about the quadrant that an ordered pair or a point is going to be in. When you think about the coordinate plane, we have it set up into 4 different quadrants. So let me just label this. This is the first quadrant, and that's where the x values are positive and the y values are positive. So let me put quadrant 1 here. This is going to be x values are positive and y values are positive. Then you have quadrant 2, and this is going to go counterclockwise. So this is quadrant 2 right here. And you can see that the x values are going to be negative, right? You're to the left of 0, and the y values are positive. You're above 0. So this is negative and then positive. And then we're going to have this quadrant 3. And so that's going to be down here. So this is 3. And if you look here, the x values are negative. You're to the left of 0. The y values are also negative because you're below 0. So this is going to be negative, negative. Okay, and then quadrant 4. So this is going to be over here. So this is quadrant 4. And you'll notice that your x values are positive and your y values are negative. So this is positive, negative. Okay, so this guy right here, you can see that obviously our point lies in quadrant 1. So maybe to make this simple, I'll just put Q1 here for my answer. All right, so one other thing I want to cover, we're not going to have a question like this here, but you will get one in the quiz. What if you got something like, let's say, I'm just going to put a little border here, 9, 0, or let's say you had 0, 9. So let's plot these two and let's think about what quadrant we're in. So 9, 0, well, the x location is 9 and the y location is 0. So basically, I'm not moving up from the origin on the y-axis. I'm just going to be on the x-axis. So I'm just starting at the origin going 9 units to the right. So that point would be right there. And let me actually label this. I'm just going to arrow to it and just put that this is 9 for the x-coordinate and then comma 0 for the y-coordinate. Now, the question is, what quadrant would you be in? Looking at these guys, it seems like nothing's going to match, and it's not going to. So if you're on the x-axis or the y-axis, you're said to not be in any quadrant. So be very careful about that if you get that on a test. Now this point right here was 0, 9, and so now the x location is 0. So I'm not going to move it all left or right. I'm just going to move up 9 units. So that would put me right there on the y-axis. So this right here would be 0 for the x-coordinate, 9 for the y-coordinate. And again, because I'm on the y-axis, I'm not in any quadrant. So really important to remember that. All right, let's take a look at problem 2. So here we have -4, -6. So let's come down here and write -4, -6. Let's remember how this works. This is going to be your x-coordinate. It's the leftmost value of your ordered pair. And this is going to be your y-coordinate. So this is your y-coordinate. That's your rightmost value or your last value of the ordered pair. And so again, if I want -4 on the x-axis from the origin, let's just label that in, you're going to go 4 units to the left. So let me actually put that this is -4 here. And I'm just going to put a little circle there. Then if I want a y-coordinate of -6, well, from the origin, I'm just going to go down 6 units. So that's going to be right there. So what's the meeting point between the two? Well, I can go 4 units to the left and then 6 units down. So it's going to be right there. I could have also gone 6 units down and then 4 units to the left. Again, whatever you want to do. So let's say this is the ordered pair, -4, -6. Now, what quadrant am I going to be in? Again, just always remember that this is the first quadrant where the x values are positive and the y values are positive. And then you're going to go counterclockwise. So this is 2, where the x values are negative and the y values are positive. This is 3, where the x values are negative and the y values are negative. And then this is 4. So this is where the x values are positive and the y values are negative. So here we're going to be in quadrant 3. So let's just put as an answer Q for quadrant and then 3. All right, let's take a look at problem 3. So here we have the ordered pair 2, 5. All right, so let's write this in. So we have 2, 5. And again, this guy right here would be our x-coordinate. So that's the leftmost value in this ordered pair. And this guy right here, the rightmost value in the ordered pair, that would be the y-coordinate. And then where's the meeting point between the two? Well, I'm looking for a value of 2 on the x-axis. So that's going to be right here. Let me label this. So this is 2. And then I'm looking for a y-coordinate of 5. So on the y-axis, I'm going up to 5. Let me label that. So I'm going 2 units to the right and 5 units up. So right there. Or again, you can go 5 units up and 2 units to the right, whatever you want to do. So this would be 2, 5. And then again, in terms of quadrants, this is the first quadrant where the x values are positive and the y values are positive, and it's going to go counterclockwise. So just do it a few times. So this is quadrant 2, x values are negative, y values are positive. This is quadrant 3, where the x values and y values are negative. And then this is quadrant 4, where the x values are positive and the y values are negative. So obviously this one's going to be in quadrant 1. So let's put a comma and put for the answer for that part, Q for quadrant 1. All right, let's take a look at problem 4. So here we have -6, 3. So let's come down here to the coordinate plane. So -6, 3. And again, this right here, the leftmost value is going to be the x-coordinate. So this is your x-coordinate. And then the rightmost value, that's going to be the y-coordinate. So on the x-axis, if I'm looking for a value of -6, from the origin, I would just go 6 units to the left. So let's say that's going to put me right there. And then for the y-coordinate, it's 3. So on the y-axis, I'm just going up by 3 from the origin. So that's going to be right there. So from the origin, you can go to the left 6 units and then up 3 units. So right there. Or again, you can start at the origin and go up 3 and to the left 6, whatever you want to do. So this is the point where we have -6, 3. And what quadrant are we going to be in? Again, this is quadrant 1, where the x and y values are positive. This is quadrant 2. Again, it's going counterclockwise. So your x values are negative, your y values are positive. This is quadrant 3, where x and y values are both negative, and then this is quadrant 4, where the x values are positive and the y values are negative. So this guy would be in quadrant, so I'll just put Q for that, and then 2. All right, let's take a look at problem 5. So here we have 3, -9. So let's again write that. So 3, -9. And this 3 here, again, it's the leftmost value, so this is the x coordinate. So this is your x coordinate. And then the rightmost value, which is -9, that's going to be the y coordinate. On the x-axis, where's 3? That's going to be right here. Again, from the origin, just move 3 inches to the right. And then on the y-axis, you want -9. So from the origin, you're just going to drop by 9 units, so that's going to be right there. So to plot this point, just go 3 units to the right and then 9 units down. So that's right there. Let's say this is 3, -9. Again, you could also start at the origin and go 9 units down and then 3 units to the right, whatever you want to do. Now, in terms of the quadrant, again, starting in this top right-hand corner, that's going to be your quadrant 1. X and Y values are positive. It goes counterclockwise. So this is quadrant 2. X values are negative. Y values are positive. This is quadrant 3. Both X and Y values are negative. And this is quadrant 4, where the X values are positive and the Y values are negative. So again, you don't have to actually plot this. You might get this as just saying, hey, well, what quadrant is this in? You don't have to draw this out. Just remember that the X value is positive and the Y value is negative if you're in quadrant 4. So this is going to be Q for quadrant and then 4. All right, let's take a look at the practice test. For the instructions, we're asked to find the distance between each pair of points. All right, so looking at problem 1, we have -3, 1, and then we have 2, 13. All right, so how do I find the distance between these 2 points? Well, you can just plug into this distance formula. We talked about where this comes from in the lesson. Essentially, you could plot each one of these points, and then you could create a right triangle. You would know the length of the 2 shorter sides, known as the legs, and then you could solve for the length of the hypotenuse, which would be the distance between these 2 guys, using the Pythagorean theorem. So that's where this comes from. If you want to check out the lesson to see that, you can go into more detail. For right now, we're just going to practice plugging into the formula. And so to do that, you first label one of these points as x sub 1, y sub 1, and the other is x sub 2, y sub 2. So I'm just going to pick this first point as x sub 1 and then y sub 1. And the second one, I'll say this is x sub 2 and then y sub 2. Now, it doesn't matter which point gets labeled as which, and I'll show you that here right now. So let's say I plug in, I say the distance is equal to the square root of, so x sub 2 is 2 and x sub 1 is -3. So this is 2 minus a -3. And let me actually change this over. We know 2 minus a -3 is 2 plus 3. So let me put that like that. And this is going to be quantity squared and then plus. Here you have y sub 2, which is 13, and then minus y sub 1, which is 1, and this is quantity squared. Let's say for a moment, we put distance is equal to, that we had changed this up. So I'm just going to get rid of this temporarily. I'll go back to it in a moment. But let's say I said that this is x sub 2 and this is y sub 2 and this is x sub 1 and y sub 1. Well, now if you plug into the formula, you have x sub 2, which is -3, and then minus x sub 1, which is 2, quantity squared. And then plus, you're going to have your y sub 2, which is 1, and then minus your y sub 1, which is 13, quantity squared. So notice that you're just changing the order of each thing. So here you have 2 plus 3. It's really 2 minus a -3. We converted it over. And now you have -3 minus 2. Here you have 13 minus 1, and now it's 1 minus 13. So the only thing that's really changing here is the sign. This would be positive 5. This would be negative 5. This would be positive 12. This would be negative 12. So we're squaring these guys, and when you square a negative, you get a positive. So that's why it doesn't matter the order that you go in. You're going to end up with the same result once you square things. Okay, so let me get rid of this, and let me get rid of this and go back to what we said originally. This is x sub 1, y sub 1, and x sub 2, y sub 2. Okay, so let me actually go a little bit slowly here so nobody gets lost. Let me put equals the square root of 2 plus 3 is 5. And so you would have 5 squared. So 5 squared. And then plus 13 minus 1 is 12. So you'd have 12 squared. And this equals the square root of. So 5 squared, hopefully you know that's 25. If you don't, you can just use a calculator. And then plus 12 squared. Again, hopefully you know that's 144. If not, you can use a calculator. So this is the square root of what's 25 plus 144? Well, if you punch that into your calculator or do it mentally, it's 169. And I think most of you know that the square root of 169 is going to be 13. But again, you could just punch it into the calculator if you don't. So 13 is going to be the distance between those 2 points. Okay, let's take a look at problem 2. So here we have one point, which is 5, 1, and another point, which is -4, 7. So let's just label this as x sub 1 and this as y sub 1. And then this as x sub 2 and this as y sub 2. Again, it doesn't matter if you switch this up and say this is x sub 2 and y sub 2, and this is x sub 1 and y sub 1, you'll get the same answer. So let's say the distance is equal to the square root of, so x sub 2, which is -4, minus x sub 1, which is 5, quantity squared, and then plus y sub 2, which is 7, minus y sub 1, which is 1, quantity squared. So let's say this is equal to the square root of -4 minus 5 is -9. So this would be -9. I'm going to make sure to wrap that in parentheses and square that because that negative needs to be squared, right? So this is not the same as if I had -9 squared like that. Hopefully you know that. So let's make sure to wrap that because this is inside of parentheses. Then this is plus 7 minus 1 is going to be 6. So this is 6 squared. Actually, let me make that 9 a little bit better there. Okay, so this equals the square root of -9, again, because this is wrapped in parentheses, -9 squared is going to be 81, and then plus 6 squared is 36. And so what is 81 plus 36? That's going to be 117. So this equals the square root of 117. Now, can I simplify this? Well, that's a good question. I would use my divisibility rules to think about it. So 1 plus 1 is 2, and then 2 plus 7 is 9. So I know that this guy is divisible by 9, and if it's divisible by 9, I know I can simplify it because 9 is going to be a perfect square. So let's go ahead and punch this into our calculator and say, what is 117 divided by 9? Well, it's going to be 13. So I can say that this is the square root of 13 times the square root of 9, and the square root of 9 is 3, so you can just write that. So you can just say that this is equal to 3 times the square root of 13, so that would be our simplified answer for the distance between the 2 points. All right, let's take a look at problem 3. So here we have one point which is -9, 11, and then another point which is 4, 4. So let's just say that this is x sub 1 and this is y sub 1, and this is x sub 2 and this is y sub 2, and just plug into the formula. So the distance between the 2 points is equal to the square root of, for x sub 2, that's going to be 4, and then minus for x sub 1, that's -9. Again, minus a -9 is the same thing as plus 9. So I'm just going to change this over now into 4 plus 9. So this is quantity squared, and then plus, for your y sub 2, this is 4, and then for your y sub 1, that's going to be 11, so 4 minus 11, quantity squared. So let's put equals here, and let's say this is the square root of, 4 plus 9 is 13, so this is 13 squared, and then plus 4 minus 11 is -7. So this is -7 squared. Make sure you use parentheses here. Again, if you don't, you're going to get a different answer if you're punching this into your calculator. So you need to make sure you wrap this if it's negative, because the negative and the 7 are both being squared. So very, very important. So let's go ahead and say this is equal to the square root of, we know that 13 squared is 169, or again, if you don't, you just punch it into the calculator. And then -7, again, because this is wrapped in parentheses, the negative and the 7 are both squared, and so that's going to be positive 49. So this is plus 49 here. And so 169 plus 49, that's going to be 218. So this is the square root of 218. Now, can we simplify this? Well, let's think about it. I know that this is an even number. Let me actually give myself a little bit of room. So this is 218. Let me start by just dividing it by 2 with my calculator. And so I get 109. So this is 2 times 109. Now 2 is a prime number, so you can stop there. What about 109? Let's think about this for a second. If I hit my square root key, let's just say it's about 10. I know it's 10.44, whatever. Let's just say it's about 10. So you just think about all the numbers going up to 10, and you're going to check. So we know it's not an even number, so it's not divisible by 2 or 4 or 6 or 8. So you can cross those numbers out. What about 3 and then 5 and then 7 and then 9? So you could check those guys. Obviously, it's not going to be divisible by 10. It's not going to be divisible by 5. Then for 3 or 9, you could just say, okay, 1 plus 0 is 1. Then plus 9 is 10. So 3 and 9 are out. What about 7? Well, again, there's a trick for that, but it's probably quicker just to go 109 divided by 7 in the calculator. And you get about 15.57, let's say. So this is going to be out as well. So you can go ahead and conclude that 109 is a prime number. And so you really can't make this any simpler. You could circle this. Basically, that is your answer. It's just going to be the square root of 218. All right, let's take a look at problem 4. So here we have -1 comma -4. And then we have 5 comma 4. So let's switch it up. Let's say this is x sub 2 and this is y sub 2. Let's say this is x sub 1 and this is y sub 1. So the distance between the 2 points is equal to the square root of x sub 2 is -1, and then minus x sub 1, that's going to be 5. This is quantity squared. And then plus y sub 2, that's -4. And then minus y sub 1, that's going to be 4. This is quantity squared. Let's slide down a little bit and say that this is going to be equal to the square root of -1 minus 5 is going to be -6. Again, make sure you wrap this in parentheses if it's negative. It's very important. So -6 squared. And then plus -4 minus 4 would be -8. So this is -8 squared. So again, in each case, it's wrapped inside of parentheses. So if we say this is equal to the square root of -6 squared, again, this is wrapped in parentheses. This is going to be positive 36. And then plus -8 squared with the negative wrapped in parentheses, that's positive 64. So 36 plus 64, that's going to be 100. So this is the square root of 100. So probably you know that the square root of 100 is 10. If not, just use a calculator. So the distance between the 2 points, we just get an answer of 10. All right, let's take a look at problem 5. So here we have -2 comma -2. So that's 1 point. And then -3 comma -1. So that's another point. So let me just label this as x sub 1. And this is y sub 1. This will be x sub 2. And then this will be y sub 2. So the distance is equal to the square root of x sub 2. Let's plug in a -3 for that. And then minus x sub 1, which is -2. Again, minus a negative is plus a positive. So let's just convert this over now to plus 2, quantity squared. And then plus y sub 2 is -1. And then minus y sub 1 is -2. Again, minus a negative is plus a positive. So let's put plus 2. This is quantity squared. So let's come down here and say that this is equal to the square root of -3 plus 2 is -1. So this is -1, again, wrapped in parentheses, squared. Then plus, this -1 plus 2 is 1. So you don't have to wrap this one. This is just 1 squared. It's only important when it's negative because, again, we want to wrap this. If you typed this into your calculator, you're going to get a different answer than if you typed this. So we want to make sure that we want the negative and the 1 to be squared. Okay, so let's put this equals the square root of. We see that -1 being squared, again, with it wrapped like this is positive 1. And then plus 1 squared is 1. So this right here would just be the square root of 2 for your answer. And really, you can't simplify that any further. So that's going to be the distance between the 2 points. All right, let's take a look at the practice test. For the instructions, we're asked to determine if the given points are the vertices of a right triangle. All right, for problem 1, we're given the points -5 comma 3, 6 comma 0, and 5 comma 5. What I would do if you're struggling with this concept is plot these points on a coordinate plane. So I've done that here. We have -5 comma 3, we have 5 comma 5, and we have 6 comma 0. The next thing you want to do is make a rough sketch of a triangle. This does not need to be perfect. You're just making this drawing so you have somewhere to put your information down. So the way you would figure out if these points are the vertices, or what we sometimes say as the endpoints of a right triangle, you would use your Pythagorean theorem. So the a squared plus b squared is equal to c squared. So recall that a and b, those are going to be your legs for the right triangle. These are the 2 shorter sides. And then c, that is the hypotenuse, that is the longest side because it is opposite of the 90-degree angle, which is the largest angle in a right triangle. So at this point, we don't know if we have a right triangle. So you have to find this side length, this side length, and this side length, and basically plug into the formula. So there's one thing that you have to make sure that you do. You have to get the largest value that you calculate and use that for C, because again, C is the hypotenuse or the longest side in that right triangle. Okay, so that's very important. So let's just say that we want to find the distance. I'm going to call this distance sub 1. And that's going to be for these 2 points here. So -5, 3. And then we're going to have 5, 5. And then distance sub 2, let's go from 5, 5. And this is going to be to 6, 0. And then distance sub 3, we're going to say this is going to be from -5, 3. And then to 6, 0. Okay, let me actually label this. I'm going to say this is distance sub 1, this is distance sub 2, and this is going to be distance sub 3. And I'm going to grab this real quick. All right, let me paste this in here. We're just going to knock this out one at a time. This can be a very tedious process because you have to use the distance formula 3 times. So first, let me write out that the distance between 2 points on a coordinate plane is going to be the square root of, you have x sub 2 minus x sub 1 quantity squared. And then you have plus the quantity y sub 2 minus y sub 1 being squared. Now, how you label the points is not going to matter. So I could label this as the first point and this is the second, or this is the second and this is the first. Doesn't matter. So let's just go ahead and say that. Let me scooch this down a little bit. This is x sub 1 and this is y sub 1. And let's say this is x sub 2 and this is y sub 2, and then just plug into the formula. So the distance is equal to the square root of, here x sub 2 is 5. So then 5 minus, for x sub 1 you have -5, minus the -5 is plus 5. This is quantity squared. And then plus, for y sub 2 you have 5. And then minus, for y sub 1 you have 3. And this is quantity squared. So this would be equal to the square root of, so 5 plus 5 is 10. 10 squared would be 100. And then plus 5 minus 3 is 2. 2 squared is 4. So this is equal to the square root of 104. Now, with this number, I can look at the final 2 digits and I get the number 4. And I know that 4 is divisible by 4. So that tells me that 104 will be divisible by 4. And the reason I think about 4 is that it's a perfect square. Okay, so 104 divided by 4 is 26. So let's write this as 26 times 4. And so the square root of 4 is 2. So I'll say this equals 2 times the square root of 26. Okay, so that's going to be for distance 1. So let's get rid of this. And I'll say that this is going to be equal to 2 times the square root of 26. Okay, let's go to the second one. So this is going to be for d sub 2. So the distance is equal to the square root of, let's call this x sub 1, and this can be y sub 1. This is x sub 2, and this is y sub 2. All right, so for x sub 2, we have 6, and then minus for x sub 1, we have 5. This is quantity squared. And then plus for y sub 2, we have 0. And then minus for y sub 1, we have 5, and this is quantity squared. So this equals the square root of, 6 minus 5 is 1, so this would be 1 squared. And then plus, 0 minus 5 is -5, so this would be -5. Make sure to wrap that in parentheses, and that's squared. So this equals the square root of, 1 squared is 1, and then plus -5, again, this is wrapped, being squared is 25. So 1 plus 25 would be 26, so this is the square root of 26. Now 26 is 2 times 13, so there's nothing else you can do there. So this would just be the square root of 26. So let's put this equals the square root of 26, and I'll actually just slide this up just a little bit. Maybe that 6 could be a little bit neater. The last guy here, so let's label this as x sub 1 and then y sub 1, and this can be x sub 2 and then y sub 2. So for x sub 2, it's 6, so this would be 6 minus, for x sub 1, it's -5, so minus the -5 is plus 5. This is quantity squared, and then plus, for y sub 2, this is 0, and then minus, for y sub 1, this is 3, and this is quantity squared. So this equals the square root of, 6 plus 5 is 11, so this would be 11 squared, plus 0 minus 3 is -3, so this would be -3. Make sure to wrap this. This is going to be squared. So this equals the square root of, 11 squared is 121, and then plus -3, again, it's wrapped here. If that's squared, that's going to give me 9. So 121 plus 9 is 130. Now think about 130. It's 13 times 10. 13 is a prime number, and 10 is 5 times 2. Can I do anything with any of those factors? No. So let's just write this as the square root of 130. That's the best we can do. So let's get rid of this. So let's say distance sub 3 is going to be equal to the square root of 130. Let's paste this in here real quick. So we said that the length of this side right here was d sub 1. So this is going to be 2 times the square root of 26. We said the length of this side right here is d sub 2. So this would be the square root of 26. And then we said the length of this side right here was d sub 3. So this would be the square root. Let me arrow to this. So the square root of 130. Okay, let me get rid of this. Now, you need to know which value here is the largest, because the largest value is going to be plugged in for C. Remember, C is the hypotenuse if you have a right triangle, so it has to be the longest side because it's opposite of that 90-degree angle. So if we estimate these with our calculator, 2 times the square root of 26 is about, let's say, 10.2 if I round to the nearest tenth. And then the square root of 26, we know that would be less than this guy, so you really don't have to do it. Well, let's say this is about, let's go 5.1. And then for the square root of 130, you just really need to know, is that larger than this guy right here? And the answer is yes. So this is about, let's go 11.4 if we round to the nearest tenth. So again, the reason we're doing that is because we have to make sure that the largest value here is plugged in for C. Okay, if you don't do that, you're not going to get the right answer. So we're just going to say, and I'm not going to use these estimates, I'm going to use the exact values, 2 times square root of 26 being squared plus the square root of 26 being squared is equal to the square root of 130 being squared. Let me drag this over here so it fits. So the square root of 130 being squared like this. So is this a true statement? If it is, we have a right triangle, and so these 3 points are the vertices of a right triangle. If it's not, then they are not. So 2 times square root of 26 being squared, 2 squared is 4, and then times the square root of 26 squared is 26, and 4 times 26 is 104. So this is 104. Then plus, square root of 26 squared is 26, and this equals the square root of 130 being squared is 130. So 104 plus 26 is 130. So you get 130 is equal to 130. So this is a true statement. So we can say, yes, this is going to be a right triangle. So this right here would be a right angle, and this right here would be your hypotenuse or your longest side. So we can come back up here and say that this is yes. All right, let's take a look at problem 2. So here we have the points 4, -3, 4, 1, and then 2, 1. So coming to the coordinate plane, we have 2, 1 plotted, 4, 1 plotted, and then 4, -3 plotted. So this one is obviously going to be a right triangle. I think everyone can see that, but let's just go through the process. So first I'm just going to label this guy right here, this side. Let's just say that's distance sub 1. And then let's say this side right here is distance sub 2. And then I'll call this one distance sub 3. Now you could use the distance formula here and also here, but again, there's a shortcut. So let me write this out. So the distance, let's say sub 1, this is going to be from 2, 1, and then going to 4, 1. And then distance sub 2, this is going to be from 4, 1, going to 4, -3. And then distance sub 3 is going to be from 2, 1, going to 4, -3. Now for these two, again, you don't have to use the distance formula. In this case, you're going to have the same y values. So you can just say, okay, well, I'm going from 2 to 4. So this is going to be 2, and I'll show you that in a moment. And then for this one, you have the same x values. So really, you could say I'm coming from 1 and going down to -3. So I'm traveling 4 units. Okay, let me show you that real quick. I'm just going to grab this and paste this in. So let me write down my little distance formula. So the distance is equal to the square root of, you have your x sub 2 minus x sub 1 quantity squared, and then plus your y sub 2 minus y sub 1 quantity squared. Okay, so let's say the distance is equal to the square root of. Let me slide these down temporarily. I'll label this as x sub 1 and then y sub 1, and this is x sub 2 and then y sub 2. So you can see that since the y values are the same, you're going to end up with 0, and so 0 squared would be 0. So you don't have to bother with that. You would just say that this is x sub 2 minus x sub 1 quantity squared. Now, what is the square root of this guy being squared? Remember, the square root of a squared is equal to the absolute value of a. So because you have this guy and this guy as being the same, the shortcut here is just to say that's the absolute value of, you can go 4 minus 2 like this, which would be the absolute value of 2. Or you could have also said that's the absolute value of 2 minus 4, which is the absolute value of -2, which in each case you're going to get 2. Okay, so you can do it that way, or again, you can plug in whatever you want to do. But if you recognize that you have either the same y coordinate or the same x coordinate like you're going to have here, you can just use that shortcut. So let's plug in. So x sub 2 is going to be 4, and then x sub 1 is going to be 2. 4 minus 2 is 2. So this is the square root of 2 squared, which is going to be 2. Okay, Let's get rid of this and just put that this is 2 here. And then for the other guy, I'm just going to use the shortcut. Again, you can plug in if you want, but notice that you have the same x value here as you have here. So that would give me a 0 squared right there. So you'd end up with a square root of this quantity y sub 2 minus y sub 1 being squared, which gives me the absolute value of y sub 2 minus y sub 1. So I'm just going to say, and you can plug this in any order, the absolute value of -3 minus 1. You could also do the absolute value of 1 minus a -3, right? Either way, you get the same thing. Let me just do that real quick so that nobody's lost. So this is 1 minus a -3 like this inside the absolute value bars. So this right here is the absolute value of -4, which equals 4. And if you did it this way, 1 minus a -3 is 1 plus 3. So that's 4. So this is the absolute value of 4, which is 4. Okay, so this is 4 either way. Let's put this as a 4. So this is the only one you actually have to plug into the distance formula on. The other ones is really not necessary. So let's say this is x sub 1 and this is y sub 1. And then this is x sub 2 and this is y sub 2. So then the distance is equal to the square root of. So for x sub 2, that's going to be 4. And then minus for x sub 1, that's going to be 2. This is quantity squared. And then plus for y sub 2, this is -3. And then minus for y sub 1, this is 1. And this is quantity squared. So this equals the square root of 4 minus 2 is 2, 2 squared is 4, and then plus over here, -3 minus 1 is going to be -4. -4 squared is 16. So 4 plus 16 is going to be 20. Now the square root of 20, let's go ahead and say this is the square root of 5 times 4. And again, I'm picking 4 here because it's a perfect square, right? So the square root of 4 is 2. So this is equal to 2 times the square root of 5. All right, so this right here would be 2 times the square root of 5. Now, we know what 2 is and we know what 4 is, but what is 2 times square root of 5? Let's just approximate that real quick. That gives me about, let's say, 4.5. The only thing we need to know is that it's larger than 4. So d sub 3, that's going to be your hypotenuse if this is a right triangle. Again, you can already tell that it is. So this is 2 times square root of 5. And this right here is 4. And then this right here, let me arrow to that again, this is 2. Okay, so just plug in to the Pythagorean theorem. So the a squared plus b squared equals c squared. Just make sure that for c, you use 2 times square root of 5. That's very important. So here, let's go 2 squared plus we're going to go 4 squared. And this should be equal to, we're going to have 2 times square root of 5 being squared. So 2 squared is 4, and then plus 4 squared is 16. 4 plus 16 is going to be 20. And then over here, 2 squared is 4. And then times the square root of 5 squared is 5, and 4 times 5 is going to be 20. So we get a true statement here. So these are the vertices of a right triangle. This right here would be your right angle, okay? And this is your hypotenuse. So let's come back up and just answer yes. All right, let's take a look at problem 3. So here we have -9, 4. We have 2, 6, and we have 1, -5. So coming down here, I plotted -9, 4. 2, 6, and then 1, -5. So again, we need to figure out this guy right here. So let's call this d sub 1 for the length of this guy right here. We need to figure out this length. Let's go ahead and call that d sub 2. And then this length, let's call that d sub 3. Okay, so let's write d sub 1. And then we're going to go -9, 4. And then we're going to go 2, 6. So the distance between those 2 points. And then d sub 2. Let's go ahead and say this is 2, 6, and then 1, -5. So the distance between those 2 points. And then for d sub 3, let's say that this is, let me make that 3 a little bit better there, from -9, 4, going to 1, -5. Okay, let's grab this real quick. And let me slide this down just a little bit. Let me write the distance formula here for reference. So the distance is equal to the square root of, we have x sub 2 minus x sub 1, quantity squared, and then plus we have y sub 2 minus y sub 1 quantity squared. And you can actually label this all right now just to get it out of the way. So let's just say that this is x sub 1 and this is y sub 1 and this is x sub 2 and this is y sub 2. Maybe I can make that x a little bit better there. And then over here, let's say this is x sub 1 and this is y sub 1 and then this is x sub 2 and this is y sub 2. And then down here, let's say that this is x sub 1 and this is y sub 1 and this is x sub 2 and this is y sub 2. Okay, so let's just plug in. So let's start with this one. So the distance is equal to the square root of. For x sub 2, we have 2. And then minus for x sub 1, we have -9. So minus a negative is plus a positive. So this is 2 plus 9, quantity squared. And then plus for y sub 2, we have 6. And then minus for y sub 1, we have 4. And and this is quantity squared. So this equals the square root of 2 plus 9 is 11. So you'd have 11 squared, which is 121. And then plus 6 minus 4 is 2. 2 squared is going to be 4. So this would be the square root of 121 plus 4 is 125. Now 125 is 5 cubed, right? So basically you could say that this is 25, which is a perfect square, times 5 under your square root symbol. So the square root of 25 is 5, and then times the square root of 5. So that d sub 1, I'll say this is 5 times square root of 5. And if I approximate this, I get about, let's say 11.2. Okay, so we're just going to need that to figure out what's the largest value here so we can plug in for C. Okay, for this one, let's say that we have the distance is equal to the square root of. For x sub 2, I have 1, and then minus for x sub 1, I have 2, quantity squared, and then plus for y sub 2, I have negative 5, and then minus for y sub 1, I have 6. This is quantity squared. So this equals the square root of 1 minus 2 is negative 1. So this would be negative 1 squared, which is 1. And then plus, here we have negative 5 minus 6, which is negative 11. Negative 11 being squared is going to be 121. So this is 1 plus 121 under the square root symbol. So this would give me the square root of 122. And for 122, it's going to be 61 times 2. So you really can't do anything else with this. We'll say this is equal to the square root of 122, which is approximately, if I round to the nearest tenth, let's say it's 11. In my calculator, I get 11.04536, so on and so forth. Let's just say it's about 11. And then for the last one, we have the square root of, for x sub 2, we have 1. And then minus, for x sub 1, we have negative 9. So minus a negative is plus a positive. So this is plus 9, quantity squared, and then plus. For y sub 2, we have negative 5. And then for y sub 1, we have 4. So minus 4 here, quantity squared. So 1 plus 9 is 10. 10 squared is 100. And then negative 5 minus 4 is negative 9. So this would be negative 9 being squared, which is going to be positive 81. So this would be equal to the square root of 100 plus 81, which is 181. So 181 is going to be a prime number. So this is as good as we can do. D sub 3 is going to be the square root of 181. And if we key this into the calculator and I round to the nearest tenth, I get about 13, let's say 0.5. Now, we're just using this to figure out, well, what is the largest value? Well, clearly it's the square root of 181. So when we think about plugging in to the a squared plus b squared equals c squared, this is going to be your c. Okay, so let's get this real quick. And I'm just going to paste this in here. So I'm going to put that this is 5 times square root of 5. I'm going to put that this is the square root of 122. And I'm going to put that this is going to be the square root of 181. Maybe I can make that a little bit better. So the a squared plus b squared is equal to c squared. So we'll just take 5 times square root of 5 being squared. Then plus we'll take the square root of 122 being squared. So again, these can go in any order. It's not going to matter. The one that matters is you have to take the largest value and put it in the place of C, because again, if you have a right triangle, C is the hypotenuse or the longest side. So it's going to have to go in that way for this to work. So let's say this is the square root of 181 being squared. So for this one, 5 times square root of 5 being squared, well, 5 squared is 25. And then times the square root of 5 squared is 5. So 25 times 5 is 125. And then plus the square root of 122 being squared is 122. So let's key that into the calculator. So 125 plus 122 is going to give me 247. Is this equal to the square root of 181 squared is 181? No, those are not equal, right? So this, we can go ahead and put, is not equal, or you could say that it's false, whatever you want to do. Either way, you know that these are not the vertices of a right triangle. So let's come back up and say the answer here is no. All right, let's take a look at problem 4. So here we have the points 6, 4, negative 5, 1, and then negative 7, negative 2. So this is already, again, plotted for us right here. So we have negative 5, 1, 6, 4, and negative 7, negative 2. So again, let me call this D sub 1. And so D sub 1, we're going to have from negative 5, 1, going to 6, 4. And then for D sub 2, let's say that's going to be, let me go with this one for D sub 2. So that's going to be from negative 5, 1, and then that's going to be going to negative 7, negative 2. And then for D sub 3, This is going to be this guy right here. So let's call that d sub 3. I'm going to say that's from -7, -2, going to 6, 4. Okay, let's grab this real quick, and let's paste this in here. And again, for the distance formula, this is the square root of, you have your x sub 2 minus x sub 1 quantity squared, and then plus your y sub 2 minus y sub 1 quantity squared. So here, let's say for this d sub 1, the distance is equal to the square root of, let me slide these down and out of the way. And actually, I'll just label everything real quick so we get that out of the way. So let's say this is x sub 1, and this is y sub 1, and this is x sub 2, and this is y sub 2. Let's say this is x sub 1 and y sub 1, and this is x sub 2 and y sub 2. And then lastly, this is x sub 1 and y sub 1, and then x sub 2 and then y sub 2. For the x sub 2 in the first guy here, we're going to have 6, and then minus for x sub 1, that's -5. So minus a negative is plus a positive, so this is 6 plus 5, quantity squared. Then plus. For y sub 2, this is 4, and then minus. For y sub 1, you have 1, and this is quantity squared. So this equals the square root of 6 plus 5 is 11, so 11 squared is 121. And then plus, over here, 4 minus 1 is 3. 3 squared is going to be 9. So 121 plus 9 is 130. So this is the square root of 130. 130 is 13 times 10, or 13 times 5 times 2. So really, this is as good as you can do. Okay, so you can't simplify that anymore. So let's get rid of this and say that this is equal to the square root of 130. If you want to approximate this now, just so you have it, let's just key it into the calculator, and I get about 11.4. For d sub 2, the distance is equal to the square root of, for x sub 2, it's -7, and then minus for x sub 1, it's -5. So minus a negative is plus a positive, so this is plus 5, quantity squared, and then plus. For y sub 2, it's -2, and then minus for y sub 1, it's 1, and this is quantity squared. So this equals the square root of, -7 plus 5 is -2, so then -2 being squared, that's going to be 4. And then plus, over here, -2 minus 1, that's -3. So -3 being squared, that's going to be positive 9. So 4 plus 9 is 13, so this is just going to be the square root of 13. And slide this up. So this equals the square root of 13. Do you need to approximate this? No, because you know the square root of 13 is less than the square root of 130, and I'm looking for the largest value here. So I don't actually need to approximate that. For completeness, it's about 3.6, so let's just put that. But if you're on a test or something, you know that this is larger than this, so don't even bother. Let me get rid of this and say that the distance is equal to the square root of. So we're on this last one here. So x sub 2 is 6 minus x sub 1, which is -7, minus the negative is plus a positive, so this is 6 plus 7 quantity squared, plus for y sub 2, that's 4, and then minus for y sub 1, that's -2. So minus the -2 is plus 2, and this is quantity squared. Okay, so this is going to be equal to the square root of, so 6 plus 7 is 13, so this would be 13 squared, so 13 squared, which is 169, plus 4 plus 2 is 6, so this is 6 squared, or 36. So this equals the square root of 169 plus 36, that's going to be 205. Now let me think about this. Let me get rid of this and say the distance is equal to the square root of 205. I know this number ends with a 5, so let me start by dividing 205 by 5 in my calculator, and I get 41. So 41 is a prime number. So basically this is 5 times 41, and I can't really do anything with that, so the square root of 205 is the best I can do. Okay, let me get rid of this and say this equals the square root of 205. Now, obviously, the square root of 205 is going to be larger than the square root of 130, and definitely larger than the square root of 13. But again, for the sake of completeness, you could just punch this into your calculator, and you get about 14.3. So 14.3. But again, just looking at the radicands, there's nothing outside, so it's not really tricky here. You can see that this would obviously be larger than this and this. And let's paste this in here. So this right here is the square root of 130. And then this right here is the square root of 205. And then this right here is the, let me arrow to this in a different way. Just use a longer arrow. So this is the square root of 13. So this is consistent with what we see. This is the shortest side. This is the middle guy in terms of the length, and this is the longest side. Okay, let's get rid of this and let's use our formula. So a squared plus b squared is equal to c squared. I think most of you can see visually this is not going to work out to be a right triangle, but let's just plug in anyway. So you'd have the square root of 13 being squared. then plus you have the square root of 130 being squared, and that should be equal to the square root of 205 being squared. Okay, so this right here, the square root of 13 being squared is going to be 13, and then plus the square root of 130 being squared, that's going to be 130. Is this equal to the square root of 205 being squared? Well, that's 205. Obviously, this is a false statement, right? So I could put this as not equal to here and just show it that way. I could also sum this and say that 13 plus 130 is 143. And we could say this equals 205. And you could, again, just say it's not equal to, or what I like to do is just say that this is a false statement, right? So all of these are, well, not this one because I put is not equal to, but if I got rid of this, then these are all false statements, right? But what I'd like to do is actually just show it two different ways. So this is a not equal to, so you could do it that way, or you could do it this way, write it as an equality, and then just say that it is false. So let's just come back up here and just say that the answer is no. All right, let's take a look at problem 5. So here we have the point -2, 5, 1, 3, and then -1, 0. So again, we've plotted these points on the coordinate plane and made a sketch of a triangle. This is something I always recommend if you're struggling with this. It just gives you a place to put your numbers down so you can figure out what's going on. So here's -2, 5, here's 1, 3, and then here's -1, 0. So let's just go ahead and say that the distance from here to here, I'll call that d sub 1. The distance from here to here, I'm going to call that d sub 2. And the distance from here to here, I'm going to call that d sub 3. Maybe that arrow could have been a little bit cleaner there. And so for d sub 1, let's just write down that this is going to be from -2, 5, and this is going to 1, 3. We could label this now if we want to, save some time. So x sub 1 and then y sub 1, and this is x sub 2 and then y sub 2. Okay, for d sub 2, what are we going to have there? So that's from here to here. So let's say that's 1, 3, and that's going to -1, 0. So let me label this as x sub 1, and then y sub 1, and then x sub 2, and then y sub 2. Okay, then for d sub 3, this last part right here, so from -2, 5 going to -1, 0. So let me write that, -2, 5, and then going to, let me make that 5 a little bit cleaner there. So we are going to -1, 0. And let me label this real quick. So this is x sub 1, and this is y sub 1, then this is x sub 2, and this is y sub 2. Okay, so everything's already labeled. Let me put a little border here, and let's set up the distance formula. So what I'm going to do to make this a little bit quicker, let me just do this 3 times. So I'm going to go, the distance is equal to the square root of, and then I'll put x sub 2 minus x sub 1 quantity squared, plus the y sub 2 minus y sub 1 quantity squared. And what I'm going to do, let me fix that 2. I'm just going to copy this, and I'm going to paste that in. Let me get rid of that, and I'll just paste that in again. Okay, so now we have 3 of them, and I'll put d sub 1, d sub 2, and d sub 3, so we can keep track of these, and I'm just going to plug in, and then we can just do it all at once. So for this one, x sub 2 is going to be 1, and then x sub 1 is going to be -2, so minus a -2 is going to be +2, and then for y sub 2, that's going to be 3, and then for y sub 1, that's going to be 5. So I'm not going to simplify this yet. Let me just move down here. We'll just get everything filled out. Now working with d sub 2, my x sub 2 is going to be -1. And then my x sub 1 is going to be 1. And then my y sub 2 is going to be 0. And my y sub 1 is going to be 3. Okay, let's move down here to d sub 3. So my x sub 2 is now going to be -1, and my x sub 1 is going to be -2, so minus a -2 is +2. My y sub 2 is 0, and my y sub 1 is going to be 5. Let me put -5 in there and close that down. I'm going to get rid of this and just move this over, and I think we can just do it like this, maybe a little bit quicker. So 1 plus 2 is 3, 3 squared is 9. So let's say this is going to be 9, and then 3 minus 5 is -2. Now, -2 is wrapped and it's squared, and so that's going to be +4. And of course, 9 plus 4 is 13, and 13 is a prime number, so this is just the square root of 13. So that's my d sub 1. Okay, for d sub 2, we have -1 minus 1, that's -2. So this is wrapped. -2 squared is going to give me +4. Here, 0 minus 3 is -3, so -3 squared is going to be 9. And once again, 4 plus 9 is 13, so this would be the square root of 13. Remember, 13 is a prime number, so this is as simple as we can make this. Then for d sub 3, you have -1 plus 2. That's going to be +1. And so 1 squared is going to be 1. Then here, 0 minus 5 is -5. -5 squared is 25. And so 1 plus 25 is 26. So this right here is the square root of 26. Okay, let me grab this and come back and paste this in. So for d sub 1, I'm just going to replace this with the square root of 13. So that's the length of this side right here. For d sub 2, I'm going to replace this with the square root of 13 as well. So that's the length of this side right here. And then for d sub 3, I'm going to replace that with the square root of 26. So that's the length of this side here. Okay, so let's plug into the a squared plus b squared is equal to c squared. So again, this is so important. When you think about c, if you have a right triangle, it's the longest side. So you have to pick the largest value that you came up with in this process and plug in for c. If you don't do that, you're not going to get the correct answer in this particular situation. So we'd want to plug in the square root of 13 for a, I'm going to square that, then plus the square root of 13 again for b, square that. Is that equal to the square root of 26 being squared? Again, square root of 26 is getting plugged in for c because it's the largest value there. So for this guy, square root of 13 being squared is 13. So you would have 13 plus 13 is equal to the square root of 26 being squared is 26. So this is obviously going to be a true statement. You get 26 is equal to 26. So yes, these are the vertices of a right triangle. You could say that this side right here is your hypotenuse, and this right here would be your 90-degree angle or your right angle. So let's just go back up and put a yes here for the answer. All right, let's take a look at the practice tests. For the instructions, we're asked to determine whether the points are collinear. So looking at problem 1, here we have -1, -2, we have 1, 8, and then we have -2, -7. So how can we determine if these points are collinear, meaning they lie on the same line? Well, one way you could do this is with the distance formula. So you're going to find the distance between each pair of points, and you're going to take those two smaller distances and you're going to sum them and see if it equals the largest distance. Now, before we do this, I'm just going to note that this is the slowest possible method, or maybe the most tedious possible method that you can use to figure this out. If you want to do this in the quickest way possible, you need to look up the method on matrices, which I do have a video on later on in this course. Okay, so you can go to that if you're just trying to do this in the quickest way possible. If your teacher told you to do this using the distance formula, then this is what you want to do. So let's first go to the coordinate plane, just to give you a visualization of what's going on. You can see that these points are going to be collinear, but I'm going to prove this to you. So here's 1, 8. Here's -1, -2, and here is -2, -7. So in other words, you want to find the distance from this point to this point, and then you want to find the distance from this point to this point, and then you want to find the distance from this point to this point right here, and the sum of the two smaller distances equals the largest distance. So let's do that real quick. So first we're going to work with 1, 8, and then we're going to work with -1, -2, and then we're going to work with -1, -2, and we're going to work with -2, -7. And then lastly, and this looks like a 21, so let me make that a little bit cleaner there. Then lastly, we're going to do 1, 8 going down to -2, -7. Okay, let me grab this and let me just paste this in here, and I'll put myself a little room there. I'm just going to label everything really quickly. So this is x sub 1 and y sub 1. This is x sub 2 and y sub 2. And then let me come down here and say this is x sub 1 and y sub 1. This is x sub 2 and y sub 2. And then this is x sub 1 and y sub 1. This is x sub 2 and y sub 2. Okay, so we're just going to plug into the distance formula. So the distance is equal to the square root of, you have this x sub 2 minus x sub 1 quantity squared, plus you have this y sub 2 minus y sub 1 quantity squared. Okay, so let me just go, the distance is equal to the square root of, I'm just going to start with this one up here. And so we're going to say that x sub 2 is -1, and then minus x sub 1 is 1. So this is quantity squared, plus y sub 2 is -2, and then minus y sub 1 is going to be 8, so this is quantity squared. So -1 minus 1 is -2, and if you square -2, you're going to get 4. So let's write a 4 there. And then here, negative 2 minus 8 is going to be negative 10. And if you square negative 10, you're going to get 100. So this is 4 plus 100, which is 104, underneath my square root symbol. So what is 104? Well, I know it's divisible by 4. 104 would be 4 times 26, and 4 is a perfect square. So let's write 4 times 26 like this. Square root of 4 is 2, so this is 2 times the square root of 26 for the distance between these two. So let me just put this as the distance sub 1, just so we can keep track of them, and I'll just arrow to this. And now we'll say the distance sub 2, and I'll just arrow to this, is equal to the square root of. So for x sub 2, we're going to have negative 2, and then minus for x sub 1, we're going to have negative 1. So minus negative 1 is plus 1, quantity squared. Then plus for y sub 2, we have negative 7, and then minus for y sub 1, it's negative 2. So minus negative 2 is plus 2, quantity squared. So negative 2 plus 1 is going to be negative 1. So negative 1 squared is going to be 1. And then negative 7 plus 2 is negative 5. So negative 5 being squared is going to be 25. So 1 plus 25 is 26. So this is the square root of 26. Obviously, 26 is 13 times 2, so you can't make that any simpler. And then let me say this is d sub 3 here. I'm just going to arrow to this. So this is the square root of. So x sub 2 is negative 2. And then minus x sub 1 is 1. And this is quantity squared. And then plus y sub 2 is negative 7. And then minus y sub 1 is 8. And this is quantity squared. So this right here, negative 2 minus 1 is negative 3. So this is negative 3 being squared. Negative 3 being squared is going to be 9. And then negative 7 minus 8 is negative 15. And then negative 15 being squared is going to be 225. And so 9 plus 225, that's going to be 234. So this is the square root of 234. So to simplify this, first I'm going to divide by 2. And I'm going to say that this is 2 times 117. Now 117 is divisible by 9. 1 plus 1 is 2, 2 plus 7 is 9. So if I divide that by 9 in my calculator, I'm going to get 13. So this is 9 times 13 like this. So 9 is a perfect square. The square root of 9 is 3. So we can say this is 3 times the square root. So 3 times the square root of 26. We know these are the two smaller distances, and this is the largest one. And you can see this is going to work out. 2 times square root of 26 plus, you could say 1 times square root of 26 would be 3 times square root of 26. Let me just grab this real quick. Let me just come back here. I'm just going to paste this in. And basically what we're saying is the distance from here down to here, this is going to be 2 times the square root of 26. And then the distance from here going down to here, that is going to be the square root of 26, or you could put 1 times square root of 26. And we're just saying if we sum these two together, we get this 3 times square root of 26. So then going from right here to right here, this is going to be 3 times the square root of 26. So yeah, this is going to be collinear. Obviously, you can see it because I've graphed it. But you just do 2 times square root of 26 plus 1 times square root of 26 is this equal to 3 times square root of 26. So always the two smaller lengths being added together is equal to the largest guy, okay, the largest length. So this would be 3 times square root of 26 is equal to 3 times square root of 26. So yes, this is true. So these are collinear points. We can just come back up here and say yes. All right, let's take a look at problem 2. So here we have the points 3, 1, negative 2, negative 1, and negative 8, 8. So again, I've already plotted these guys. So here's your negative 8, 8. Here's your 3, 1. Here's your negative 2, negative 1. So we can see that these points are not collinear. This forms a triangle. But again, I'm going to show you this using the distance formula method. And I just want to state again, this is the slowest possible method to do this. It's only something you want to use if your teacher makes you do it because you're in that section. So let's go ahead and just first say that I want this distance here. So that's going to be from negative 8, 8. And this is going to 3, 1. Let's label this as d sub 1. Maybe that'll be helpful. And I'll just arrow to this and say it's d sub 1. And then let's say we have a d sub 2, and I'll arrow to that and say this is my d sub 2. We would have 3, 1, and then going to negative 2, negative 1. And then let's call this one right here d sub 3. And so for d sub 3, we're going to have negative 2, negative 1, going to negative 8, 8. All right, let's grab these and let me space this out a little bit so we can label some things. I'm just going to label everything now just to save a little time. So let's just say this is x sub 1 and this is y sub 1 and this is x sub 2 and then y sub 2. And then what I'm going to do is double label this. So I'm just going to put x sub 1 and then y sub 1 and then x sub 2 and then y sub 2. And what I mean by double label, I'm just going to arrow here and then arrow here and then 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 here. So let's write out our distance formula for reference. So the distance between 2 points on the coordinate plane is equal to the square root of, you're going to have this x sub 2 minus x sub 1 quantity squared, then plus your y sub 2 minus y sub 1 quantity squared. For the first one, d sub 1, let me just write d here. We'll put the square root of, for x sub 2, that's going to be 3, and then minus, for x sub 1, you have negative 8. So minus a negative 8 is plus 8. This is quantity squared. Then plus, for y sub 2, that's 1. Then minus, for y sub 1, that's going to be 8. And this is quantity squared. So 3 plus 8 is 11. So this right here would be 11 squared. And we know that's 121. And then 1 minus 8 is going to be negative 7. So this would be negative 7 being squared, which would be 49. So if we think about 121 plus 49, that's going to be 170. So this is the square root of 170. Now for 170, it's 17, which is a prime number, times 10, which is 5 times 2. So you really can't make that any simpler. This right here is equal to the square root of 170. And let's move on to this d sub 2 here. So for the x sub 2, we have negative 2. And then minus for x sub 1, we have 3, quantity squared. Then plus, for y sub 2, we have negative 1. And then minus for y sub 1, we have 1, and this is quantity squared. All right, so negative 2 minus 3 is negative 5. So this right here would be negative 5 being squared. So that is 25. And then over here, negative 1 minus 1 is negative 2. And then negative 2 being squared is going to be 4. So 25 plus 4 is going to be 29. So this is the square root of 29, and 29 is a prime number, so we can't simplify that. So let's get rid of this. And I'll say this equals the square root of 29. And let's just slide this up just a little bit. And now let's go on to the last one here. So for x sub 2, we have negative 8. And then minus for x sub 1, it's negative 2. So minus a negative is plus a positive, so this is plus 2. And this is a quantity squared. And then plus, for y sub 2, it's going to be 8. And then minus for y sub 1, it's going to be negative 1. So minus a negative 1 is plus 1. And this is quantity squared. So looking at this, negative 8 plus 2 is going to be negative 6. So negative 6 being squared is going to be 36. And then over here, 8 plus 1 is 9. So this would be 9 squared, which is going to be 81. So 36 plus 81, that would give me 117. And the square root of 117 can be simplified. If you think about 117, it's 9 times 13. So the square root of 9 is 3. So you could put this as 3 times the square root of 13. Let's scooch this up and put equals. So I'm just going to put 3 times the square root of 13. And let me paste this in. For d sub 1, which is the distance from this point to this point, or you could say the length of the side of this triangle, this is the square root of 170. So let me write that in here. This is the square root of 170. Maybe I'll change that arrow. And then for d sub 2, that's the distance from here to here, or the length of this side of the triangle. We'll say this is the square root of 29. And then for d sub 3, this right here is 3 times the square root of 13. And maybe I'll just change that arrow up a little bit like that. Okay. So if we look at this visually, I think you can see that the square root of 170 is going to be the greatest distance, in other words, from here to here. It's hard to actually estimate things. You know that the square root of 170 is going to be larger than the square root of 29, but what about 3 times the square root of 13? There are certain techniques you can use for this, but to not go off on some sort of tangent here, I'm just going to use my calculator. I'm going to punch in the square root of 170, and let's say I get about 13. So just about 13, that's me rounding to the nearest tenth. And if I do 3 times square root of 13, I get about, let's just say 10.8, just rounding to the nearest tenth. Okay, you can do this one too, even though you know this one's going to be the smallest. That one would be about 5.4 if you round to the nearest tenth. So which one is the largest? What's the square root of 170, right? You can see that visually, that this guy right here is the longest side of this triangle. Now let's think about our little rule. We said that we would take the two smaller distances and sum them together and see if it equals the largest. Okay, so in other words, I would take this 3 times the square root of 13, and add that to the square root of 29 and say, does that equal the square root of 170? Just using the estimations here, you can see this is not going to work. But of course, you could just punch it into your calculator. 3 times square root of 13 plus the square root of 29. That would give me about, and I'm just going to round to the nearest tenth. Let's just say 16.2. Is this equal to the square root of 170? We said that's about 13. So obviously, these are not equal. You could put the not equal to symbol there. You could also just put false. I'll just do that one here. 2 different ways to show that. But we know that this is not going to work itself out where we say that the points are collinear. Obviously, looking at it, they form a triangle. So if we go back up, we would just say, no, these points are not collinear. All right, let's take a look at problem 3. So here we have 4, 0, we have -1, 5, and 8, -4. So coming down to the coordinate plane, here's your -1, 5, your 4, 0, and your 8, -4. So you can see clearly we're going to have collinear points, but let's prove that. So let's first find this guy right here, this distance, and then we want to find this distance right here. And then we're going to sum those. Those are the 2 smaller distances. It should be equal to this distance right here, the largest distance. So let's just go ahead and say we're looking for the distance from -1, 5, then to 4, 0. Let's call that distance 1, and I'll label this as distance 1. This will be distance 2, and then this will be distance 3. So let's say for distance 2, this is going to be from 4, 0 going to 8, -4. Maybe the negative could be a little bit better there. And let me slide this out of the way like this. And I didn't mean to drag this over here. So then for distance 3, this is the biggest one. So from -1, 5 going to 8, -4. Okay, let's grab this real quick and we'll paste this in. Let me put a little border and let me separate this stuff a little bit like this. And I'm just going to label everything now, get that out of the way. So let's say this is x sub 1 and y sub 1. This is x sub 2 and y sub 2. And I'll just draw an arrow like this and this. So let me just copy this and I'll paste this in here and then do that like that. And we'll say that the distance is equal to the square root of, again, you have your x sub 2 minus x sub 1 quantity squared plus your y sub 2 minus y sub 1 quantity squared. So the distance is equal to the square root of. For x sub 2, it's 4. And then minus for x sub 1, it's -1. So minus the -1 is +1. This is quantity squared. Plus for y sub 2, we have 0. And then minus for y sub 1, we have 5. And this is quantity squared. So 4 plus 1 is 5. 5 squared is 25. And then here, 0 minus 5 would be -5. -5 squared is also 25. So let's write this 25 plus 25, or 50, as 2 times 25. And so the square root of 25 is 5. So this is 5 times square root of 2. So the first one is going to be 5 times the square root of 2. Okay, for the second one, we'll say the distance is equal to the square root of. For x sub 2, you have 8. And then minus for x sub 1, you have 4. This is quantity squared. And then plus for y sub 2, you have -4. And then minus for y sub 1, you have 0. And this is quantity squared. So 8 minus 4 is 4. 4 squared is 16. So then -4 minus 0 is -4. And then -4 squared is going to be 16. So 16 plus 16 is 32. But I would write that as 2 times 16, since 16 is a perfect square. So the square root of 16 is 4. So this is 4 times the square root of 2. And I'll just drag this over here like this and say this is d sub 2. Maybe move this equal sign over here. And then for this one, let's say that the distance is equal to the square root of. For x sub 2, let me slide this up. X sub 2 is going to be 8. And then minus x sub 1, that's -1. So minus the -1 is +1, quantity squared, plus. For y sub 2, it's going to be -4. And then minus for y sub 1, it's going to be 5, and then quantity squared. So 8 plus 1 is 9. 9 squared is 81. And then -4 minus 5 is -9. -9 squared is also 81. So 81 is a perfect square. So you could do 81 plus 81. That's 162. But it's better to do 2 times 81 here, because 81, the square root of that is going to be 9. So this is 9 times square root of 2. Let me get rid of this and say this equals 9 times square root of 2. So for d sub 1, this is 5 times square root of 2. For d sub 2, this is 4 times square root of 2. And of course, if you add those together, you are going to get the largest distance here, which is 9 times the square root of 2. So let me go ahead and show that. So officially, you take 5 times square root of 2 plus 4 times square root of 2. So again, the two smaller distances, you sum them and you set it equal to the largest distance, which is 9 times square root of 2. And you see, is this a true statement? Well, yeah, 5 plus 4 would be 9 times the square root of 2, and that equals 9 times square root of 2. So yes, these points are collinear. So coming back up here, we would just put yes. All right, let's take a look at problem 4. So here we have -2 comma -1. We have -3 comma -3. And then we have 3 halves, or you could put 1.5 comma 6. So again, everything is plotted. We have 3 halves comma 6. We have -2 comma -1, and then -3 comma -3. So these points are going to be collinear. But again, let's prove this. So you want the distance from here to here, and then you want the distance from, let me do this in a different color, here to here. So those would be the two shorter distances. Let's just label this. You don't have to, but I'm just going to call this d sub 1 and this d sub 2. And then the largest distance here, like that, let's go ahead and call that d sub 3. So this plus this has to be equal to this if we have collinear points, meaning they lie on the same line. So let's go ahead and say that for d sub 1, this is going to be what? So it's from -3 comma -3 going to -2 comma -1. And then for d sub 2, let me make this d a little bit better. We're going to have from -2 comma -1 going to 3 halves comma 6. And then for d sub 3, let's say that's going to be from 3 halves comma 6 going to, let me make this a little bit better, going to this -3. Let me make that better there, comma -3. Let me grab this real quick. So let me give myself a little bit of room to label things. Just slide this down, and didn't mean to grab that. So let me put that back up there. And so let's say this is x sub 1 and then y sub 1, and then x sub 2 and then y sub 2. And I'm just going to arrow here and here, and then here and here, and then here and here, and then here and here. And so I'm just going to copy this, and let me paste that in there. So we're good to go with the labeling. So let's say the distance formula, d is equal to the square root of. You have x sub 2 minus x sub 1 quantity squared, plus you have y sub 2 minus y sub 1 quantity squared. All right, so what we're going to do here is say that the distance for this d sub 1 is equal to what? So the square root of, so x sub 2 is -2, and then minus x sub 1, that's -3, minus the negative is plus a positive, so this is plus 3, quantity squared, plus for y sub 2, it's -1, and then minus for y sub 1, it's -3, so minus the -3 is plus 3, the quantity squared. So -2 plus 3 is 1, 1 squared is 1. Let's put 1 there. -1 plus 3 is going to be 2, 2 squared is 4. So this right here is the square root of 5. D sub 1 is equal to the square root of 5. All right, for d sub 2, your x sub 2 is 3 halves, so you have 3 halves. And then minus your x sub 1 is -2. So that would be plus 2. Because we have a fraction here, let's write 2 as 4 over 2. So 4 over 2. Let me straighten this up a little bit like this. And this would be quantity squared. Maybe that could be a little bit longer than plus. Over here you have y sub 2, which is 6, and then minus y sub 1, which is -1. So minus the -1 is plus 1. This is quantity squared. All right, so 3 halves plus 4 halves is going to be 7 halves. So this is 7 halves, or 3.5. So if I square this, I'm going to get 49 fourths. So let's say this is 49 fourths. Okay, over here, this is 6 plus 1, which is 7. 7 squared is 49. So what I would do is actually get a common denominator. So I'd multiply this by 4 over 4. So 49 times 4 is 196. And then 49 plus 196, that would be 245. So this would be 245 over 4. So let's break this up and say this is the square root of 245 over the square root of 4. We can legally do that. So we know the square root of 4 is 2, so let me put 2 down there. And then up here, the square root of 245, well, you could write 245 as 5 times 49, and then 49, the square root of that is 7. So this would be 7 times the square root of 5 over 2. So let me get rid of this. Let me bring this up and say this equals. So you have 7 times square root of 5 over 2, like that. Let me get rid of that and put my square root symbol back in. Get rid of this and slide this up just a little bit. So we would say that this is x sub 2, which is -3, and then minus x sub 1, which is 3 halves. So 3 halves. And then this is quantity squared. Plus for y sub 2, that's -3. And then minus for y sub 1, that's 6. And this is quantity squared. So again, for this one, let's write -3 as -6 over 2. Basically, all I did was multiply. If you have -3 here, just multiply by 2 over 2. And you could write that as over 1. So this would be -6 over 2. So that's another way to write -3, again, so that we have a common denominator. And so here, -6 minus 3 is -9. So this would be -9/2. And if you square this, the negative goes away. 9 squared is 81, and then 2 squared is 4. So this would be 81/4. Maybe this could be a little bit deeper like that. So -3 minus 6 would be -9, and then -9 squared would be 81. So let's go ahead and say that I'm going to multiply this by 4/4. 81 times 4 is 324. So let's add 81 plus 324. That's going to be 405. So this would be 405/4. Okay, so let's split this up into the square root of 405 over the square root of 4. So we know the square root of 4 is 2. For 405, that's going to be 81 times 5. So let's write this as 81, which is a perfect square, times 5. So the square root of 81 is 9, so this is 9 times the square root of 5. Let's say this equals, you have 9 times the square root of 5 over 2. Okay, let's come back and paste this in. So this was our d sub 1. You can barely see it, so let me use a different color. I'm just going to arrow to it. So this is the square root of 5. So this is d sub 2. Let me use a different color, and I'll arrow to that. So this is 7 times square root of 5 over 2. Maybe that could be a little bit better there. And then this down here, this d sub 3, which is hard to see. Let me do this in a different color. This is 9 times square root of 5 over 2. Okay, let's get rid of this. And again, sum these two smaller distances. It needs to be equal to this largest distance in order to prove that these points are collinear. Okay, so we're going to say that the square root of 5 plus 7 times the square root of 5 over 2 should be equal to 9 times the square root of 5 over 2. So I'm going to multiply this by 2 over 2. So let's say this is over 1 times 2 over 2. So you would have 2 times square root of 5, then plus 7 times square root of 5 over the common denominator of 2 is equal to 9 times the square root of 5 over 2. So 2 plus 7 is 9. So we would have 9 times the square root of 5 over 2 is equal to 9 times the square root of 5 over 2. So yes, this is a check. So these points are collinear. Obviously, you can see that because we've graphed a line here. But let's go ahead and go back up and say, yes, these points are collinear. All right, let's take a look at problem 5. So here we have -5 comma -5. We have -2 comma 0, and we have 0 comma 2. So let's come down here. We have the -2 comma 0. So I've arrowed to that. We have 0 comma 2, and then we have -5 comma -5. So obviously this forms a triangle, and so these points are not going to be collinear, meaning lying on the same line. But again, we could just prove this. So let's look at, I'm just going to call this piece right here, let's say d sub 1. So for d sub 1, this is going to be from -2 comma 0 going to 0 comma 2. And then for d sub 2, let's call that this piece right here. So d sub 2 is going to be from, let's see, -2 comma 0 going to this -5 comma -5. And then for d sub 3, let's say that's this piece right here. So clearly that would be the largest distance here, right? Because that's the longest side of this triangle that we're forming. So let's say that's from -5 comma -5 going to 0 comma 2. Okay, let's grab this real quick. And once again, let's write our distance formula. So the distance is equal to the square root of, you have this x sub 2 minus x sub 1 quantity squared, plus you have y sub 2 minus y sub 1 quantity squared. All right, so let me drag this down and drag this down. And what I'm going to do is say this is x sub 1 and then y sub 1, and I'll arrow up and then down like this, and kind of missed that one, so let me do that way. And then I'll say this is x sub 2 and then y sub 2, and again, I'll just arrow up and down. And then I'll just copy this, move that like that, and then everything is labeled. So now we can just roll through it. So for the first distance, it's equal to the square root of. So you want your x sub 2, which is 0, minus your x sub 1, which is -2. So minus a -2 is plus 2, quantity squared. So 2 squared would be 4. So then plus for y sub 2, you have 2. And then minus for y sub 1, you have 0. And this is quantity squared. So 2 minus 0 is 2, so this would be 2 squared or 4. So 4 plus 4 is 8, but I would actually write this as 2 times 4, because 4 is a perfect square. Square root of 4 is 2, so this is 2 times square root of 2. So this, we'll say, is 2 times the square root of 2. Okay, for this d sub 2, let's say the distance is equal to the square root of, we have this x sub 2, which is negative 5. Let me make that a little bit clearer there. Minus for x sub 1, it's negative 2. So minus a negative 2 is plus 2. And then this is quantity squared. And then plus for y sub 2, it's negative 5. And then minus for y sub 1, it's going to be 0. So let me put that in there and say quantity squared. Negative 5 plus 2 is going to be negative 3. So this is negative 3 squared. This is going to be 9. And then negative 5 minus 0 is negative 5. Negative 5 squared is 25. So this right here, 9 plus 25 is 34. So this would be the square root of 34. And say this equals the square root of 34. Now 34 is 17 times 2, so you really can't make that any simpler. Okay, for the last one that we need to find, let's say the distance is equal to the square root of. For x sub 2, it's 0. And then minus for x sub 1, it's negative 5. So minus a negative 5 is plus 5. Quantity squared plus for y sub 2, it's 2. And then minus for y sub 1, it's negative 5. So minus a negative 5 is plus 5. And this is quantity squared. So 0 plus 5 is 5. So 5 squared would be 25. And then 2 plus 5 is 7. So this is 7 squared, which is 49. So 25 plus 49, that's going to be 74. So this is the square root of 74. Now 74 divided by 2 is 37, so you really can't do anything with this. And scooch this up here and say this equals the square root of 74. Okay, so let's paste this in here. And we have to be very careful about the approximations that we choose here, because we're going to add these two guys together and set it equal to this one. Now we can see visually that this is not going to work, but if you were to take, let's say 2 times square root of 2, and let's say you approximate that to be about 2.8. So I'm going to add more decimal places in a moment. Let's just say for right now we put 2.8. And then here, let's approximate this to be about 5 let's say 8. And here, let's approximate this to be about 8.6. Well, what's going to happen is if you use these values, you're going to get, if you said 2.8 plus 5.8, is that equal to 8.6? Well, the answer is yes. But we can see that this isn't going to be true. So what's happening is it's going to be close, but because we're using an approximation and we're not using enough decimal places, we're not getting an accurate enough answer. So sometimes you could just round to the nearest tenth like we did here. But for this one, I would go a few decimal places out. Let me actually label this so that we're not lost in what we're doing. So this piece right here is going to be 2 times the square root of 2. And then this piece right here of this guy, this is going to be the square root of 34. And then this piece right here, let me do that in a different color. So this piece right here, this is going to be the square root of 74. Again, you can see this is a triangle, but it's got sides that are very close together. So let's go through here and say 2 times square root of 2 plus the square root of 34. Is that equal to the square root of 74? So I'm going to tell you that it's not, but again, if we use these approximations, it seems like it is. So let's just punch this into the calculator without approximating it first. I'm just going to get rid of this. And let's say that 2 times square root of 2 plus the square root of 34. And I'm going to round to the nearest 10,000th. So let me write some digits here. So we have 8.6, and then 5, 9, 3, 7, and then 9. So this is what my calculator gives me. There's also a 0 and then a 2, but we don't really need that. So we're going to round to the nearest 10,000th. So here's the tenths, hundredths, thousandths, and then this is the 10,000ths. So the digit that follows is a 7. So I'm going to cut these off and change this into a 4. Okay, so let's look at this. So the square root of 74. So I'm going to say, is this equal to, we have 8.602325267. So tenths, hundredths, thousandths, 10,000ths. So this is where I want to set my round off place. The digit that follows is a 2. So I'm going to cut that off. And now look at these guys. And clearly they're not the same. Okay. Again, when we did a rounding to the tenths place, it looked like they were the same. But if you punch this into your calculator and then round, and I rounded to the nearest 10,000th here, well, what's going to happen is you can clearly see they're not the same. So I'm going to say this is not equal to here. And so obviously these guys are not going to be collinear. You can see that from the sketch. If we come back up, I'm just going to put no. All right, let's take a look at the practice test. For the instructions, we're asked to find the midpoint of each line segment PQ. All right, for the midpoint formula is very simple. I have it listed right here. But essentially, you're just going to take the average of the x coordinates and then the average of the y coordinates to get your midpoint. So we use a capital M for midpoint. The lowercase m is for slope. So we're using a capital M here. So you're just going to go x sub 1 plus x sub 2 over 2. Again, how you label these points is not going to matter. Typically, I just say that, okay, this is x sub 1, and this is y sub 1, and then this is x sub 2, and this is y sub 2. But obviously, if you change those up, it's not going to matter. So let's just say this is 2 plus 1. So 2 plus 1 over 2. And let me put some parentheses in there and a comma. And then this is going to be negative 4 and then plus 5 over 2. So to simplify, 2 plus 1 is 3. So this would just be 3 over 2 or 3 halves. So you could write 1.5 if you wanted to. In this one, negative 4 plus 5 is going to be 1. So this would be 1 half, or again, you could put 0.5 if you want to. So this would be your midpoint. So it would be 3 halves, comma, 1 half. All right, let's take a look at problem 2. So here for P, we have negative 1, comma, negative 7. And then here for Q, we have negative 4, comma, 4. So again, let me just label this as x sub 1 and this as y sub 1. And this will be x sub 2 and this will be y sub 2. And we're just going to plug into the midpoint formula. Again, for the x value, you're just going to take the average of these x values here. And then for the y value, you're just taking the average of the y values here. So we use a capital M for the midpoint, and this is equal to, so for the first guy, it's negative 1 plus negative 4. So negative 1 plus negative 4. And then we're going to divide this by 2. And then comma, over here, you're going to go negative 7 plus your 4, and this would be over 2. So just following this formula here. So to simplify, negative 1 plus negative 4 is negative 5. So this would be negative 5 halves. Or if you want, you can say negative 2.5, whatever you want to do. And this would be negative 7 plus 4. That's going to be negative 3. So this is negative 3 halves. So negative 3 halves. Or of course, you can go negative 1.5. So this would be your midpoint. It's going to be at negative 5 halves, comma, negative 3 halves. All right, let's take a look at problem 3. So here for my P, I have 10, comma, 8. And then for Q, I have 6, comma, 2. Again, for the midpoint, let me put capital M here. It's equal to, for the x coordinate, you're just going to find the average of the x coordinates here. So you can label this. I think as you do this a few more times, you're probably not going to, but this is x sub 1. Let's say this is y sub 1, and this is x sub 2, and this is y sub 2. And I put a 1 there and to put a 2. And so I'm going to go x sub 1 plus x sub 2. So 10 plus 6 is 16, and then divide that by 2. Let me show this. So 10 plus 6, and then divided by 2. And then for this one, I'm going to go 8 plus 2. So y sub 1 plus y sub 2. So 8 plus 2. We know that's 10, but we'll do that in a moment. And then divided by 2. So let's simplify now. 10 plus 6 is 16, and 16 divided by 2 would be 8. So this would be 8 for the x coordinate for the midpoint. And then this guy for the y coordinate, 8 plus 2 is going to be 10. And then if I divide 10 by 2, I'm going to get 5. So for the coordinates for this midpoint, we're going to have 8, comma, 5. All right, let's take a look at problem 4. So here we have P, which is given as negative 20, comma, 14. And then Q, which is given as negative 4, comma, 6. So let's label this. I'll say this is x sub 1, and this is y sub 1. And I think you probably don't need to label these because you're just averaging the x coordinates and then averaging the y coordinates, but let's just follow the formula. So we'll say this is x sub 2, and this is y sub 2, and just plug in. So M, the midpoint, is going to be, so x sub 1 plus x sub 2, let me write this out. So negative 20 plus negative 4, and then we're going to divide by 2, and then comma, over here we're going to go y sub 1, which is 14, plus y sub 2, which is 6, and then divide by 2. So negative 20 plus negative 4 is going to be negative 24. And this is divided by 2, so this will end up being negative 12 for the x coordinate. Then here, 14 plus 6 is 20. So this is 20 over 2, which is going to be 10. So when we think about the midpoint, it's going to be negative 12, comma, 10. All right, let's take a look at problem 5. So here we have P, which is negative 3, comma, 7. And then we have Q, which is negative 11, comma, 15. All right, so again, you can label this if you want. Probably not necessary, but let's say this is x sub 1, and this is y sub 1. And let's say that this is x sub 2, and this is y sub 2. And I say it's not necessary because, again, you're just finding the average of the x coordinates and then the average of the y coordinates. It's a very simple process, so a lot of times once you do this once or twice, you pretty much don't need the formula. You could just do this in your head. So we'll say that m, the midpoint, is equal to, for the first guy, again, x sub 1 plus x sub 2, so negative 3 plus negative 11 divided by 2. And then for this guy, it's y sub 1, which is 7, plus y sub 2, which is 15, and then divided by 2. Okay, negative 3 plus negative 11 is negative 14. So this would be negative 14 over 2, which is negative 7. Then this guy, 7 plus 15, that's going to be 22. So you would have 22 over 2, which is 11. So we end up with negative 7 comma 11 for the midpoint. All right, let's take a look at the practice test. For the instructions, we're asked to plot each complex number. So for the first one, we have 2 minus 2i. And I'm just going to rewrite this as 2 plus negative 2 times my imaginary unit I. So let's grab this real quick. And I'm going to come to the complex plane and just paste this in. Now, hopefully you did watch the lesson where we went into a lot of detail on this topic. But just in case you didn't, or in case you're still lost, I want to just spend a little bit of time on this first problem and give you a refresher. So the first thing is we should know at this point that a complex number in standard form is a plus bi. Or sometimes you'll see this in a book as x plus yi. But I'm going to stick to this one right now and get rid of this one just so I don't confuse anybody. So the a is the real part and the b is the imaginary part. So a, in this particular case, is 2. And b, the number that is multiplying the imaginary unit I here, is negative 2 in this particular case. And then, of course, I is the imaginary unit. By definition, I is equal to the square root of negative 1, or we could say that I squared is equal to negative 1. When we think about the complex plane, really the only difference here is that the horizontal axis, instead of being labeled as the x-axis, is now labeled as the real axis. And the vertical axis, instead of that being labeled as the y-axis, is being labeled as the imaginary axis. So how could you plot this complex number 2 plus negative 2i, or again, you could say 2 minus 2i if you wanted to do that? Well, essentially, it's just like you're taking the a, which is 2, and then the b, which is negative 2, and you're plotting that as an ordered pair. The a, or this 2, is my location on the horizontal axis or the real axis. Again, traditionally, this is the x, so we're moving right or left from the origin. Here, since this value is 2, from the origin, I'm going 2 units to the right. So that is my real part right there. Then my imaginary part is given right here. Again, that's the b, that's the number that's multiplying this imaginary unit. In this case, that's negative 2. So from the origin, let me just go down 2 units. So that's that part right there. So it's just the meeting point between those two guys. So from the origin, I could go 2 units to the right and then 2 units down. Or from the origin, I could have went 2 units down and then 2 units to the right. Either way, I would be at that point. Now, traditionally, that would be 2 comma negative 2. But let's just go ahead and say that we're going to put 2 plus negative 2i, or we could even write 2 minus 2i. I think that's a little bit cleaner to show that this is our point here that represents that complex number. All right, let's take a look at problem 2. So here we have 4 plus 2i. So let's come down here and say 4 plus 2i. Again, I'm going to write a plus bi to match things up. So the a, or the real part, is 4. And then the b, or the imaginary part, is 2. So it's always the number that's multiplying the imaginary unit I. So I'm looking for 4 on the real axis. So from the origin, I'm just going 4 units to the right. And I'm looking for 2 on the imaginary axis. So from the origin, I'm going 2 units up. So the meeting point between those two. So in other words, from the origin, I would go 4 units to the right and then 2 units up. So that's going to put me right there. Or I could have started at the origin and went 2 units up and then 4 units to the right. So either way, let's label this as 4 plus 2i. All right, let's take a look at problem 3. So here we have negative 5 plus 3i. So let's write negative 5 plus 3i. And once again, I'm just going to write a plus bi here. So a, the real part, is negative 5. And then b, the imaginary part, is 3. So from the origin, I'm going to go 5 units to the left. So that's going to be right here. Let me put a negative 5 there so that's crystal clear. And then I'm going to go 3 units up. So let me actually show this right here on the imaginary axis. So 5 units to the left and then 3 units up. That's going to be right there. So that would be your point. Let me just write it above. So negative 5 plus 3i. All right, let's take a look at problem 4. So here we have negative 6 minus 7i. So let's come down here and write negative 6. I'm going to go plus negative 7 times I. And let's just match things up. So a is negative 6. That's the real part. And then let's go plus bi like this. So b, that's the imaginary part. Here, that's negative 7. So again, it's just like I'm trying to find negative 6 comma negative 7 on my regular coordinate plane. The real part is negative 6. So I'm just going 6 units to the left from the origin. The imaginary part is negative 7. So I'm going 7 units down from the origin. And it's just the meeting point between the two. So from the origin, I could go 6 units to the left and then 7 units down. That's going to be right there. Or I could have went from the origin 7 units down and then 6 units to the left. Again, either way, that point represents the complex number, negative 6, and let's go minus 7i. All right, let's take a look at problem 5. So here we have 7 plus 8i. So let's write 7 plus 8i. And again, this is a plus bi here. So a, the real part is 7, and b, the imaginary part is 8. So it's just like I'm trying to plot 7 comma 8 on my regular coordinate plane. So again, the real part is 7. So on the horizontal axis, I'm going 7 units to the right from the origin. So that's going to be right there. Let me write in a 7. And then on the imaginary axis, the imaginary part is 8. So let me just go from the origin up 8 units. Let me write in an 8 there, and I'll just circle that. So if I wanted to plot the point that represents this complex number, from the origin, I could go 7 units to the right and then go 8 units up. So that will put me right there. Or I could have started at the origin and went 8 units up and then 7 units to the right. Again, whatever you want to do. So this point represents the complex number, 7 plus 8i. All right, let's take a look at the practice test. For the instructions, we're asked to find the absolute value of each. For the first problem, we have the absolute value of this complex number, negative 3 plus 3i. So when we want to find the absolute value of a complex number, we have a very simple formula to follow. So the absolute value of a plus bi is equal to the square root of a squared plus b squared. I'll talk more about where this formula comes from in a moment. We did discuss this in the lesson, so if you've seen it already, when I get to that, you can just skip it. Otherwise, you can stay tuned and I'll explain where this comes from. For right now, let's just solve this really quickly. It's not too bad. So you would just match things up. So a, which is the real part of the complex number, that's going to be negative 3. And then b, which is the imaginary part of the complex number, that's going to be 3. So just plug into the formula. This is the square root of a is negative 3, so negative 3. Make sure you wrap this with parentheses. This would be squared. And then plus b here is 3, so that's 3 squared. Let me erase this. So let's say this is equal to the square root of, you would have negative 3 being squared, which is 9. And then plus, you would have 3 being squared, which is 9. We know 9 plus 9 is 18, so this would be equal to the square root of 18. And of course, 18 you could think about as 2 times 9, and 9 is a perfect square. So what I would do is say that this is the square root of 9 times 2, and of course the square root of 9 is 3. So the simplified answer here is 3 times the square root of 2. Okay, for those of you that want to see where this formula comes from, let's just go ahead and start by plotting this negative 3 plus 3i that we were just working with. So we're going to do this on our complex plane. So let me again write a plus bi so we can match things up. So a, the real part here is negative 3, and b, the imaginary part here is positive 3. So we know on the complex plane, the horizontal axis is now the real axis, and the vertical axis is now the imaginary axis. So for negative 3 plus 3i, I'm basically going to plot negative 3 comma 3. In other words, I want to find negative 3 on the real axis. So from the origin, I'm going to go 3 units to the left. And I want to find 3 on the imaginary axis. So from the origin, I'm going to go 3 units up. So from the origin, go 3 units to the left and then 3 units up. So right there. And that would represent my complex number, negative 3 plus 3i in this complex plane. Let's stop for a moment and think about the concept of absolute value. If I asked you for the absolute value of, let's say, the number 6, so the absolute value of 6 equals what? Well, again, going back to pre-algebra, we would go to a horizontal number line and we would find 6 and we would say, how far away is this number from 0? So here's 0 right here, and you can count this way or this way. It doesn't matter. So let's just say it's 1, 2, 3, 4, 5, 6 units away. So the absolute value of 6 is going to be 6. And then the absolute value of negative 6 is also 6 because it is also 6 units away from 0 on the number line. So if I go to negative 6 here, you can count 1, 2, 3, 4, 5, 6 units away. Okay. So let's take that same concept and now apply it to this complex number. So if I wanted the absolute value of negative 3 plus 3i, what am I asking for? I'm asking for the distance from this point right here to the origin, or what we would say is 0 plus 0i in the complex plane. So what you could do here is form a little right triangle. We know that with the Pythagorean theorem, we have a squared plus b squared is equal to c squared, where c is the length of this hypotenuse here, or the longest side of the right triangle. It's the side that is opposite of this right angle. And then a and b, those are your shorter sides. They're known as legs. So what I would do here is just translate this into what I'm trying to work with. Let me get rid of this real quick. So this distance from here to here, or the length of the hypotenuse, is exactly what I'm trying to find to get the absolute value of this complex number. So this is going to be c, so I'm going to square that and say it's equal to, let me actually get rid of this real quick. We're going to think about what is the length of this leg here. Well, in this case, you could think about this right here as being negative 3, and this right here as being 0. So really, we don't want to say it's negative 3 minus 0, which gives us negative 3, because we're talking about a length. So what I'm going to do is just say it's the absolute value of, you could do negative 3 minus 0, or you could just do negative 3. It doesn't really matter. So let me say the absolute value of negative 3. And of course, this would be squared here, right? So where we take this, and then we would square it. So then plus, what's the length of this guy here? So you could say 3 minus 0, so that's 3. Let me just put this inside of absolute value bars, and I'll explain why I'm doing this in a little while. But basically, this is your c squared equals a squared plus b squared. So all you would do now is think about the fact that the absolute value of negative 3 being squared is the same thing as negative 3 being squared. And the absolute value of 3 being squared is equal to 3 being squared. In other words, the absolute value of a being squared is equal to a squared. This is for any real number a. So we can actually drop the absolute value bars like that and go to this right here. And then what I could do is take the square root of each side. So I could say the square root of this side, and this would go away, and you're back to your formula, right? We said the absolute value of a plus bi is equal to the square root of a squared plus b squared. So here we just have the square root of a squared plus b squared. So we're right back to that formula. And of course, we know this ends up becoming the square root of 9 plus 9, which is 18. And then we can break that up into 9 times 2. And of course, this becomes 3 times the square root of 2. So we just did that. We know what it comes out to. But we can take this and translate it into a generic formula, because essentially if I'm working with the absolute value of a plus bi, well, let me say this squared would be equal to the absolute value of a is always going to give you the length of the horizontal leg of that right triangle that you would form. So this would be squared, and then plus the absolute value of b, that's going to give you the length of the vertical leg that would be formed in the right triangle. So this would be squared. So again, c squared is equal to a squared plus b squared. We know the rule, so we can drop the absolute value bars. And of course, I can just take the square root of each side. Let me just move this up here so it's a little bit cleaner. So again, the absolute value of a plus bi is equal to the square root of a squared plus b squared. So that's where the formula comes from. All right, for problem 2, we have the absolute value of a negative I. So if I get something like this, I would rewrite it and say it's the absolute value of 0 plus, I'm going to write this as negative 1 times I like that. And it makes it easier to match things up. Again, we look at the absolute value of a plus bi as the square root of a squared plus b squared. So here, a is 0, right? So this is the square root of, you can put this in, and I'll probably just do this for completeness. So this is 0 squared plus, you would have a negative 1. make sure to wrap that inside of parentheses, and this would be squared. Okay, let me get rid of this. So 0 squared is 0, and we know that adding 0 to something is not going to change it. So let's just say this is equal to the square root of -1 squared. Now, here's where I want to caution people, because you get some people that try to cancel this with this and report the answer as -1. That is not correct. Remember, earlier in the course, we said that the square root of a squared is equal to the absolute value of a. The reason for this is simple. The -1 is going to get squared first, so that's going to change it into +1. So this would be the square root of 1, which equals 1. And you could just follow this rule and get this more quickly and say, okay, the square root of -1 squared is equal to the absolute value of -1, which is +1. So either way, you get 1 as the absolute value of this complex number. All right, let's take a look at problem 3. So here we have the absolute value of 1 plus 2i. So again, let's just write this out and say this is the square root of, let me go absolute value of a plus bi like this is equal to the square root of a squared plus b squared, and just match things up. A here is 1 and b here is 2. So this would be 1 squared plus 2 squared underneath the square root symbol. So this equals what? We would have the square root of 1 squared is 1 plus 2 squared is 4. So this is equal to the square root of 1 plus 4, which is 5. So the square root of 5 would be the absolute value of this complex number. All right, let's take a look at problem 4. So here we have the absolute value of 3i. So let's say that this is equal to the absolute value of, I'm going to write this as 0 plus 3i like this, just to make it crystal clear that, again, the a here is 0, and then your b here is going to be 3, right? So this is the square root of a squared plus b squared. So here this would be the square root of, you could put 0 squared in. I think we should do it because it's a tutorial, but if I was doing this on my own, I would just leave it off. And then plus, you have 3. That's going to be squared. So obviously, this would just be the square root of 3 squared, which is just going to be equal to 3. So let me write as a final answer that this is going to be 3 for the absolute value of this complex number. All right, let's take a look at problem 5. So here we have the absolute value of -3i. So just like the last problem, I would say this is the absolute value of 0. Instead of -3, I'm going to put plus -3 and then times I like that. And again, it's just easier to match things up. So the absolute value of a plus bi, match this up and match this up. So a is 0 and b is -3. So this is equal to the square root of a squared plus b squared. So here this is equal to the square root of, again, you could put 0 in there. I will do it for the tutorial, but I probably would not do that if I was working this on my own. So 0 squared plus, for b it's -3. Again, make sure to wrap this. So this is -3 squared like this. You can get rid of the 0 squared because 0 squared is 0. And again, adding 0 to something does not change it. So this is equal to the square root of, you have this -3. This is wrapped and this is being squared. So again, please don't cancel this with this and report your answer as -3. The square root of a squared is equal to the absolute value of a. So the shortcut here is just to say that this is equal to the absolute value of -3, which is 3. Or again, if you punch this into your calculator, what your calculator is doing is saying, okay, well, -3 squared is 9. So this would be the square root of 9, which is 3. But again, this rule would make it a little bit quicker. And so the absolute value for this complex number is going to be 3. Okay, let's take a look at problem 6. So here we have the absolute value of 3 plus 5i. So this is going to be equal to the square root of, again, let me write this down here. So the absolute value of a plus bi is equal to the square root of a squared plus b squared. So a here is 3 and b here is 5. So this is the square root of 3 squared plus 5 squared. Let me get rid of this real quick. So 3 squared, we know that's 9, and 5 squared is 25. So this is the square root of 9 plus 25. And so 9 plus 25 is going to be 34. So this would just be equal to the square root of 34. Now 34 is 2 times 17, and 2 is a prime number, and 17 is a prime number, so you can't do anything else to simplify this. So our answer here for the absolute value of this complex number would just be the square root of 34. All right, let's take a look at problem 7. So here we have the absolute value of 2 plus 6i. So this is equal to let me just write this down here. So the absolute value of a plus bi is equal to the square root of a squared plus b squared. So a here is 2 and b here is 6. So this is the square root of 2 squared because 2 is a, plus 6 squared because 6 is b. And so this would be equal to the square root of 2 squared is 4, and then 6 squared is 36. So let's put 4 plus 36. And of course, 4 plus 36 is 40. Let me get rid of this and say this is equal to the square root of 40. And I'm going to write 40 as 4 times 10 because 4 is a perfect square. So this is the square root of 4 times the square root of 10. And of course, the square root of 4 is 2. So my final answer for the absolute value of this complex number would be 2 times the square root of 10. All right, let's take a look at problem 8. So here we have the absolute value of -8 minus 8i. So this would be equal to, let me write this down here. So the absolute value of a plus bi is equal to the square root of a squared plus b squared. So here, a is -8 and also b is -8. To make that clear, go plus negative here in case you're struggling with that. So let's say this is the square root of -8 squared. Again, a is -8. Plus -8 again squared because b is also -8. And so in each case, you're going to get 64. Now, 64 is a perfect square. So instead of writing 64 plus 64 as 128, what I'm going to do is say that this guy is going to be equal to the square root. Let me just do this in 2 steps. So this is 128. And then actually, let me back this up so that nobody's lost. First, you would have the square root of 64 plus 64. So this equals the square root of 128 if you add those together. So this, I'm going to break up and say this is the square root of 64 times the square root of 2. And I picked, again, 64 because it's a perfect square. It's 8 times 8. So the square root of 64 is 8. So you can say that this is 8 times the square root of 2 as my absolute value for this complex number. All right, let's take a look at problem 9. So here we have the absolute value of 6 plus 3i. So again, let me write the absolute value of a plus bi is equal to the square root of a squared plus b squared. So here, this would be equal to the square root of a is going to be 6 and b is going to be 3. So 6 squared plus 3 squared. So this equals the square root of 6 squared is 36, and then plus 3 squared is 9. So 36 plus 9 is 45. Let me get rid of this. And we'll say that this is equal to the square root of 45. Okay, well, 45 is 5 times 9. So let me say this is the square root of 5 times 9. And of course, 9 is a perfect square. It's 3 times 3. So let's just go ahead and say that the square root of 9 is 3. And then times the square root of 5. So 3 times square root of 5 is going to be the absolute value of this complex number. All right, let's take a look at problem 10. So here we have the absolute value of -4 plus 4i. Let me write out the absolute value of a plus bi is equal to the square root of a squared plus b squared. So this here equals the square root of, so a is -4. So let's put -4. Again, make sure to wrap this if you get a negative value. And then plus b here is +4. So let's put 4 squared there. So -4 squared is 16, and then 4 squared is also 16. But 16 plus 16 is going to be 32. But if you want to shortcut this, I wouldn't write 32. I would go 2 times 16 because 16 is a perfect square. Let me not lose anybody. Let me just go step by step. So first, this would be the square root of 16 plus 16. And this equals the square root of 32. But again, I'm going to break this up and say this is the square root of 16 times 2 because 16 is a perfect square. So I'll say this is equal to, square root of 16 is going to be 4, and then times the square root of 2. So 4 times square root of 2 is going to be the absolute value of this complex number. All right, let's take a look at the practice test. So for the instructions, we're asked to find the distance between z and w. These are two complex numbers that are going to be plotted on the complex plane. So for problem 1, you see that we're given a complex plane. So the horizontal axis is labeled as the real axis, and the vertical axis is labeled as the imaginary axis. Remember that a complex number is of the form a, which is the real part, plus b, which is the imaginary part, times I, the imaginary unit. So looking at this guy, if I think about my complex number z, well, the real part is 5, and the imaginary part is going to be 4. So let's say that z is equal to 5, again, that's the real part, plus 4, that's the imaginary part, times I, the imaginary unit. Then if I look at this complex number w, well, the real part is going to be 8, and the imaginary part is also going to be 8. So this, for w, would be 8 plus 8i. Okay, so how do we find the distance between these 2 points? So of course we could create a right triangle. Okay, so this is my right triangle, and the length of the hypotenuse here is what I need to figure out. That's going to be the distance between these 2 complex numbers on the complex plane. So you can think about the length of this and the length of this, very easy to find. This guy is 8, and this guy is 5, so you would do 8 minus 5 to give yourself 3. You would have an 8, and you would have a 4, so 8 minus 4 would be 4. Most of you can see immediately that this is a 3, 4, 5 right triangle, but again, you can always use the Pythagorean theorem to solve. So you can say a squared plus b squared equals c squared, where c is the hypotenuse. So let's say that this is 3 squared plus 4 squared, so those are known. Let's pretend you didn't know this one. So let's say this is equal to c squared. So this is 9 and this is 16. 9 plus 16 is 25. And so basically you just take the square root of each side. And so you'd have c is equal to the principal square root of 25, which equals 5. Don't use the negative square root here because we're talking about a length, right? So that's going to be non-negative. So let's go ahead and say that the distance between these 2 points is going to be equal to 5. Now, of course, we don't want to draw a right triangle each time. So what we're going to do is modify our distance formula that basically makes this process very, very simple to work on the complex plane. So let me move this down just a little bit. I'm going to label this as a sub 1. I'm going to label this as b sub 1. I'm going to label this as a sub 2. And I'm going to label this as b sub 2. And of course, you could have switched that order up. It's not going to matter. So let's say the distance is equal to the square root of, instead of x sub 2 minus x sub 1 quantity squared, I'm now going to do a sub 2 minus a sub 1 quantity squared, and then plus, instead of y sub 2 minus y sub 1 quantity squared, I'm going to go b sub 2 minus b sub 1 quantity squared. So we're going to plug in and we're going to get 5 once we simplify everything. So a sub 2, we said that was 8, and then a sub 1, we said that was 5, and then for b sub 2, we said that was 8, and then for b sub 1, we said that was 4. So simplifying, 8 minus 5 is 3, so this is 3 squared or 9. And then 8 minus 4 is 4, so 4 squared is 16. So we know that 9 plus 16 is 25, and the square root of 25 is going to be 5. So a much quicker way to get this. But again, you want to understand the concept and where these things are coming from. So you're just modifying your distance formula to work on the complex plane. All right, let's take a look at problem 2. So here we have the complex number z and also the complex number w plotted on the complex plane. So for z, the real part is -3 and the imaginary part is 4. So let's say that z is equal to -3 plus 4i. Then for w, the real part is going to be 5 and the imaginary part is going to be 6. So we'll say this is 5 plus 6i. Again, this is following the format of a plus bi. Okay, so a is the real part, b is the imaginary part. So what I'm going to do is just label one of these guys as a sub 1 being here and then b sub 1 being here. And then the other will be a sub 2 and then b sub 2 here. Okay, so don't worry about the imaginary unit I. You're not going to involve it here. You're going to say the distance between these 2 points on the complex plane is the square root of. Again, it's a sub 2 minus a sub 1 quantity squared, and then plus, you're going to have b sub 2 minus b sub 1 quantity squared. So you just need to work with this a few times. It's very easy to remember, especially if you have the regular distance formula memorized. So that one is the distance is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So we're just going to plug in. So a sub 2 is 5. And then a sub 1 is -3. So minus a -3 is plus 3. And then for b sub 2, that's going to be 6. For b sub 1, that's going to be 4. So 5 plus 3 is going to be 8. 8 squared is going to be 64. Let's put that in there. And then 6 minus 4 is 2. 2 squared is 4. So we know that 64 plus 4 is 68. And instead of writing 68, let me write 17 times 4 because 4 is a perfect square. So the square root of 4 would be 2. So our final answer here would be 2 times the square root of 17 for the distance between these 2 points on the complex plane. All right, let's take a look at problem 3. So here we have z. our complex number that has a real part of -6, and then an imaginary part that's also -6. So z is equal to -6, and then minus 6i. And then for w, this is equal to what? Well, the real part is -1, and the imaginary part is going to be 6. So let's say -1 plus 6i. Okay, so we're going to label one of these, and I'll just pick this one, as a sub 1, and then this will be b sub 1. Let me go plus negative to make that crystal clear. And then the other one would be a sub 2, and then this part right here would be b sub 2. Again, don't worry about involving the imaginary unit I. You don't need it here. So the distance is equal to the square root of, we're going to have the a sub 2 minus a sub 1 quantity squared, and then plus b sub 2 minus b sub 1 quantity squared. So a sub 2 is -1, and then a sub 1 is going to be -6. So again, minus a -6 is plus 6, and then b sub 2 is 6, and then b sub 1 is -6, minus a -6 is plus 6. So -1 plus 6 is going to be 5. 5 squared is 25. And then here, 6 plus 6 is going to be 12. 12 squared is going to be 144. So 25 plus 144 is going to be 169. So the distance is equal to the square root of 169, which is 13. So a lot of you would have noticed that this is a 5, 12, 13 right triangle. Thought I'd just draw it real quick. So this is -6 and this is -1. So the length here is 5. Then up here, this is 6. And then this down here is going to be -6. So this right here would be 12 for the length of that side. So this is a 5, 12, 13 right triangle. Sometimes you can recognize that stuff right away and just answer without doing any labeling. So always take advantage of that if you can. It speeds up the process. All right, for the next few problems, the instructions are going to change. Now we want to find the midpoint of this line segment ZW. So coming down here to problem 4, we can see that Z is equal to, so the real part is 6 and the imaginary part is 3. So let's say 6 plus 3i. I'm going to go ahead and label this now. So I'm going to call this a sub 1 and I'm going to call this b sub 1. And then for W, the real part is going to be -1 and the imaginary part is 0. So I'm on the real axis. So this is going to be -1. Let's go plus 0i. And so I'll call this a sub 2. Let me make that a little bit better there. And maybe I can make that better. And I'll call this b sub 2. Okay, so if you want to do it this way, you could say the midpoint is equal to, remember, normally it's the average of the x values, so x sub 1 plus x sub 2 over 2, and then comma, the average of the y values, so y sub 1 plus y sub 2 over 2. Here, you're basically doing the same thing, but it's just the average of the real parts. So I'm going to go a sub 1 plus a sub 2 over 2, and then comma, the average of the imaginary parts. So let's say b sub 1 plus b sub 2, and then over 2. Okay, so you're just going to plug into this. So here, this is 6 and this is -1. So 6 plus -1, let's just do that now. That's going to be 5. So this is 5 over 2. And then for this one, this is 3 for b sub 1 and this is 0. 3 plus 0 is obviously 3. So this is just 3 halves. So what does this tell me? If I want to write this as a complex number, well, basically I'm going to say that this is 5 halves for the a value and then plus 3 halves for the b value and then times I, the imaginary unit. So this right here would represent the midpoint of this line segment. So we could go, 5 halves is 2.5, so let's just go ahead and say that's about right there. So 2.5 on the real axis, and then 3 halves, that's 1.5. So let's say that's going to be about right there on the imaginary axis. So I'm going to go here and then up here. So let's say that guy right there. So let me label that and say this is 5 halves plus 3 halves I. So that would be the midpoint for the line segment ZW. All right, let's take a look at problem 5. So here we are given a Z that's going to be equal to, the real part is 2 and the imaginary part is 6. So this is 2 plus 6i. Let me just label this as a sub 1 and this as b sub 1. And then for W, this is equal to what? The real part is -4 and the imaginary part is also -4. So this is -4 minus 4i. Maybe we'll just go plus negative here to make it a little bit easier. So we'll say this is a sub 2 and this is b sub 2. So just plug into that formula. So the midpoint is equal to, it's a sub 1 plus a sub 2 over 2. So we can write that out if you want. a sub 1 plus a sub 2 over 2, and then comma, it's going to be b sub 1 plus b sub 2 over 2. So this is the formula. And so a sub 1 plus a sub 2, you have 2 plus negative 4. That's going to be negative 2, and then negative 2 divided by 2 is negative 1. So this is negative 1. So that's going to be the real part. And then b sub 1 plus b sub 2, this is going to be 6 plus negative 4, that's 2. And 2 divided by 2 is 1, so that's going to be your imaginary part. So to put this as a complex number, I would go negative 1, so negative 1 plus 1i, or just I, if you want to do that. So looking at this guy, if I want to plot it, from the origin, I'm going to go 1 unit to the left, and then I'm going to go 1 unit up. So that right there, let me go ahead and do this like this. So that would be your midpoint. So this is negative 1 plus 1i, or let's just write it as negative 1 plus I. All right, let's take a look at the practice test. For the instructions, we're asked to find the center radius form. For problem 1, we have x squared plus y squared plus 12x minus 2y plus 12 is equal to 0. When we talk about the center radius form, otherwise known as the standard form for a circle, it's going to look like this. So you have x minus h quantity squared plus y minus k quantity squared is equal to the radius squared. So we want to take this equation, which is in general form right now, and transform it into the standard form, or again, the center radius form. Let me move this down here so we know what we're trying to get. So how could we achieve this? Well, essentially what you're going to do is group your x terms together and group your y terms together, and then take your constant and move it to the other side. And then you're going to complete the square twice, so that basically you have this binomial squared plus this binomial squared is equal to the radius squared. So I'm going to take x squared and go plus 12x, like this, just grouping those x guys together. And then plus, I'm going to leave a little blank there because I'm going to put something there to complete the square. Then plus, let's group the y's together. So y squared minus 2y, and then plus, I'm going to put a blank there. And I'll say this is equal to, I'm just going to subtract 12 away from each side of the equation. So it would go away over here, and then over here it would be negative 12. Okay, so let me get rid of this temporarily. I think we know what we're trying to do. If I wanted to complete the square here, remember what I'm trying to do. I'm trying to put something in this position here that creates a perfect square trinomial. So that is a trinomial that is going to factor into a binomial squared. So how do we do that? Well, the first thing is you make sure the coefficient on the squared variable, in this case it's x, is going to be a 1. Well, here we have that already. So then you move into the next step, which is to basically take the coefficient of your variable raised to the first power. So here that is going to be 12. And you cut it in half, meaning you multiply by half or divide by 2, however you want to think about that, and then you square that. So you cut it in half, so 12, I'm just going to divide that by 2, and then you're going to square that. So this becomes 6 being squared, which is 36. Now you take this value here, and you can use that to factor. So first I'm going to put a 36 in here, and that's going to enable me to factor this as x plus 6 quantity squared. Now, I can't just go around adding things to one side of the equation without doing it to the other. Otherwise, I would mess things up. So I added 36 over here. So to balance things out, I've got to add 36 over here. Okay, I'm going to do the same thing here. So plus, I'm going to add something here that gives me a perfect square trinomial. So the coefficient for y to the first power is negative 2. You can always do plus negative here if you struggle with that. So let's say this is negative 2 times 1/2, or you could divide by 2, whatever you want to do, and then square that. So this becomes negative 2 divided by 2, that's negative 1. And so this would be negative 1 being squared, which is 1. Use the negative 1 when you factor. So we're going to say this is the quantity y minus 1 squared. And again, I'm adding 1 here, so I need to add 1 over here. So this would be equal to, you've got to sum all these guys. So negative 12 plus 36, that's going to be 24. And then 24 plus 1 is 25. So when we think about the center radius form now, again, x minus h quantity squared plus y minus k quantity squared is equal to the radius squared. Well, in this form, we can quickly get information about the circle. So I could write this as x minus a negative 6 quantity squared. And then plus, I could say this is y minus 1 quantity squared is equal to, instead of 25, let me say it's 5 squared. So the center would occur at h comma k. So here, h is going to be negative 6 and k is going to be 1. You have to be really careful with the signs here. the minus here and the minus here, those have to match up. The minus here and the minus here, those have to match up. So you're just grabbing the h value here is -6 and the k value here is 1. So the center is at -6, 1. So h, k. And then your radius is, in this case, 5, right? So again, if you have 25 here, that's the radius squared. So 5 squared, your radius is being squared. So 5 is the radius. So that tells me the center, again, is at -6, 1, and the radius is going to be 5. All right, let's take a look at problem 2. So here we have x squared plus y squared minus 28x minus 14y plus 236 is equal to 0. So the same thing here. We want to put this in center radius form. So again, group the x's together. So let's say this is x squared minus 28x, and then plus, just leave a little blank there so we can complete the square. Then plus, group the y's together. So y squared minus 14y, and then plus, leave a little blank there to complete the square. And I'm going to say this equals -236. So again, I'm just subtracting 236 away from this side and this side. So now, let's think about completing the square. This coefficient for x squared is a 1, and this coefficient for y squared is a 1, so we're basically good to go there. All right, so now we think about the coefficient for x to the first power. Let's go plus negative here to make that crystal clear. It's going to be -28. We want to cut it in half, and then we want to square that. So -28 times a half, or -28 divided by 2, is going to be -14. So this is -14. This is the value you want to use when you factor. And we're going to square that. So that's going to give us 196. So let me go plus 196 over here. And let me add 196 over here. Again, the -14, the result from cutting it in half, that's what you want to use when you factor. So let me take this real quick and say that this is the quantity, x minus 14, being squared. And then plus over here, let me go plus negative again to make this easier. You have -14, cut it in half, so you can divide by 2 or multiply by half, whatever you want to do, and then square that. So this is going to be -14 divided by 2 is -7, and this is going to be squared, so this is 49. So -7 is what you use when you factor. So let me factor this into the quantity y minus 7 squared, and I'm going to add 49 here, and again, to make that legal, I'm going to add 49 here. So this would be equal to, again, just punch this into your calculator, -236 plus 196, that's going to be -40. And then if you add -40 and 49, you're going to get 9. So that would be my center radius form. So again, if you want to match this up with the quantity x minus h squared plus the quantity y minus k squared is equal to the radius squared, well, here h is 14. Let me write this out in case you want to see this. So the center occurs at h comma k, so h is 14, and k is 7. Again, be very careful with the signs there. The minuses match up. You just want to grab the h and grab the k. And then for the radius, again, this is the radius squared. So you could really write this as 3 squared if you wanted to say that the radius is 3. All right, let's take a look at problem 3. So here we have x squared plus y squared minus 4x minus 14y plus 4 is equal to 0. So again, let's group the x's together. So x squared minus 4x plus blank. And let's group the y's together. So y squared minus 14y plus blank. I'm going to subtract 4 away from each side of the equation. So this equals -4. Okay, so this is a 1, the coefficient for x squared, and this is a 1, the coefficient for y squared. So in each case, I really have to look at the coefficient for either x to the first power or y to the first power, just the variable raised to the first power. I'm going to cut it in half and then square it. Okay, so this, let's go plus negative, and let's go plus negative here as well to make it clear that this is -4. So cut it in half, you can just divide by 2 and square it. So this becomes -2 being squared, which is 4. Use -2 when you factor. So I'm going to add 4 here, and then I'm going to add 4 here. And I'm going to factor this into x minus 2 quantity squared. So x minus 2 quantity squared. Then plus. Over here, I'm going to think about -14, cut it in half, and then square it. -14 divided by 2 is -7. So this is -7 squared, which is 49. So let me factor this into, again, use the -7 to factor. So y minus 7 quantity squared. Add 49 over here, and add 49 over here. So this is going to be equal to -4 plus 4 is 0, and 0 plus 49 is going to be 49. Again, if you want to match things up, you can just say this is x minus h. Let me make that h a little bit better. Quantity squared plus your y minus k, quantity squared, is equal to your radius squared. So here the center is at h comma k. So h is 2 and k is 7. Again, be very careful about the signs. Minus and a minus, minus and a minus. So just h is 2, k is 7. So the center is going to occur at 2 comma 7. And the radius is what? Again, don't take 49. This is the radius squared. So you would take 7 because 7 squared is 49. So we'll say the radius is 7. All right, let's change things up a little bit. Now the instructions tell us to write each equation in general form. So looking at problem 4, we have the quantity x minus 16 squared plus the quantity y minus 11 squared is equal to 9. So we're just going to go in reverse of what we just did. So all you have to do is actually just expand this and then just simplify. It's very, very simple. So let's scooch down here a little bit. So to use my formula here, the first guy is squared, so x squared, then minus 2 times this guy times this guy. So 2 times 16 is 32, so this is minus 32, and then times x, and then plus this last guy here, 16 squared. So 16 squared is going to be 256, and then plus, I'm going to use my formula here, so first guy squared, y squared, minus 2 times this guy times this guy. 2 times 11 is 22, and then times y. And then plus this last guy, 11 squared, so that's 121, and this equals 9. Okay, so at this point, all we have to do is simplify a little bit, and I'm just going to give you the general form we talked about in the lesson, but maybe you forgot. You're going to have x squared plus y squared, and then plus cx plus dy plus e is equal to 0. So we want this to match this form here. Let me slide this out of the way. I'll just keep it on the screen so we have it for reference sake. But basically I would write x squared plus y squared first. So x squared plus y squared. And then I would write my minus 32x, so minus 32x, and then minus 22y. And then lastly, I just need this plus e. So just take the 256 and add it to the 121, and that's going to give you 377, and this equals 9. So just subtract 9 away from each side, and 377 minus 9 is going to give you 368. So let me put this as a 0, and let me put this as a 368. So this would be the general form for this circle. You have x squared plus y squared minus 32x minus 22y plus 368 is equal to 0. All right, let's take a look at problem 5. So here we have the quantity x plus 8 squared plus the quantity y minus 3 squared is equal to 44. So again, we're trying to put this into general form. So just expand this, and we're going to simplify. Let me paste in what we're trying to get to. We talked about this in the last problem. So x squared plus y squared plus cx plus dy plus e equals 0. So very simple overall. So I'm just going to square the first guy, x squared, plus 2 times this guy times this guy. So 2 times 8 is 16, so this would be 16x here. And then plus 8 squared would be 64. So that's the first guy. Then plus, so this guy squared, so y squared. Then minus 2 times this guy times this guy. 2 times 3 is 6, so this would be 6 and then y. And then plus the last guy squared, so 3 squared is 9, and this equals 44. Okay, so to match this up, you put your x squared first, and then plus your y squared, and then plus your cx, that's going to be 16x, and then plus your dy, here that's minus 6y, so minus 6y. Let me make this x look a little bit better there. And then lastly, you have your plus e. So this is where you have to do a little bit of work. You're going to add 64 and 9 together. That's going to be 73. So this is plus 73, and this equals 44. And then, of course, to make it match this completely, I'm just going to subtract 44 away from each side of the equation. So this would go away and become 0. And then 73 minus 44, that's going to give you 29. So this right here would be the general form for this circle. So x squared plus y squared plus 16x minus 6y plus 29 is equal to 0. All right, let's take a look at problem 6. So here we have the quantity x plus 10 squared plus we have our quantity y minus 9 squared is equal to 49. Okay, so once again, I'm just going to expand this and do some simplifying. Let me paste this in. This is what we're trying to get to. And let me slide down just a little bit. So to expand this, you got x squared plus 2 times this guy times this guy. 2 times 10 is 20, so this would be 20 and then times x. and then plus 10 squared is 100, and then plus this guy right here, again, y would be squared, and then minus 2 times this guy, 2 times 9 is 18, and then times y, and then plus 9 squared would be 81, and this equals 49. So what I would do here again is just write this in this format here. So it's just a matter of rearranging some things. So you have your x squared and then plus your y squared, and then plus the cx guy is going to be 20x. Let me make this plus a little bit cleaner there. And then you're going to have this plus dy, so that's going to be minus 18y here. Let's write that in. Then we have 100 plus 81, so that's going to be plus 181, and this equals 49. So let's subtract 49 away from each side of the equation. So that's going to give me a 0 over here, and then 132 over here. So this would be my general form for the circle. So x squared plus y squared plus 20x minus 18y plus 132 is equal to 0. All right, for the next few problems, the instructions will change. We want to find the x and y intercepts. So for problem 7, we're given x squared plus y squared equals 49. So let me write out that we want the x intercepts and then the y intercepts. So for the x-intercepts, you plug in a 0 for y and you solve for x. So if I plugged in a 0 for y, this would be gone, and you would have x squared is equal to 49. How do we solve this? Well, you can use the square root property. Again, if x squared is equal to k, then x is equal to plus or minus the square root of k. So here, x squared equals 49, so we could say that x is equal to plus or minus the square root of 49. So the square root of 49 would be 7. So this would be x is equal to plus or minus 7. So we know that for one x-intercept, it would be 7, 0. For the other, it would be negative 7, 0. So those are your x-intercepts. For the y-intercepts, basically it's going to be the same thing in terms of the process. You plug in a 0 for x, and now you solve for y. So you'd have y squared is equal to 49. And again, by the square root property, y would be equal to plus or minus 7. So here you could say that this is 0, 7, and then here this is 0, negative 7. So if you think about your x-intercepts, they're going to occur at 7, 0 and negative 7, 0. And then for the y-intercepts, they are going to occur at 0, 7 and then 0, negative 7. All right, let's take a look at problem 8. So we have x squared plus y squared plus 30x plus 22y plus 342 is equal to 0. So if you want to find the x-intercepts, you plug in a 0 for y and you solve for x. If you want to find the y-intercepts, you plug in a 0 for x and then you solve for y. What you're going to find here is that you do not have x or y-intercepts. I'm just going to write the answer and then I'm going to show you where it's coming from. So the x-intercepts, you're going to put none. And then for the y-intercepts, we're also going to put none. And in case you struggled with this problem, I'm going to show you a few different approaches. So the first way would be to think about this in terms of the general form. Again, if I want the x-intercepts, I'm going to plug in a 0 for y. So each y in the equation. So this would be gone and this would be gone. I'd be left with x squared plus 30x plus 342 is equal to 0. Okay, this is something I would solve with the quadratic formula. So let's put a 1 in there. And let's say that this is A. Let's say that this is B. Let's say that this is C. So for the quadratic formula, it's x is equal to the negative of b. Let me write this out. So the negative of b plus or minus the square root of, you have your b squared minus 4ac. The whole thing is over 2a. So we're just going to plug in. So for b, it's a 30. So plug that in there. And then you can plug that in here. Let me get rid of this. Now you can do this now. 30 squared is 900. So let's just replace this with 900. Then for a, it's a 1. So you could plug in a 1 here and also here. But notice that 4 times 1 would still be 4, and 2 times 1 would be 2. So really, I don't need to plug that in because multiplying by 1 does not change something. So for C, it's 342. So let's put that in there. Now you can go plus negative here if you want. Let's just go ahead and make this easier and go plus negative. So now I'm going to think about this as negative 4 times 342, and that's going to give me negative, so I'll just write minus 1,368. Now you can tell that the result of this operation here is going to be negative. If you punch it into your calculator, you're going to get negative 468. So what does that tell me? Go back to when we talked about quadratic equations. We know that if the discriminant, or the part underneath the square root symbol, the b squared minus 4ac, if that's negative, then basically we have two non-real complex solutions. So this tells me that I'm not going to have any x-intercepts. For the sake of the tutorial, let me just simplify this real quick. I'm actually going to get rid of this square root of -1, that would be I. And for 468, it's 36 times 13. So let's think about this as times the square root of 36 times the square root of 13. And the square root of 36 is 6. So let me put this as 6i times the square root of 13. Now the last thing, if you wanted to simplify this, you could factor out a 2 and then cancel that with a common factor of 2 in the denominator. So let me just show that for the sake of completeness. I know this isn't going anywhere, but let's just go ahead and do it. So we're going to say that this is, let me move this down a little bit, 2 times the quantity -15 plus or minus 3i times the square root of 13, and this is over 2. So let's cancel this with this. Let me get rid of this, and I'm just going to slide this down here. So again, x is equal to -15 plus or minus 3i, again, where I is the imaginary unit, times the square root of 13. So you have two non-real complex solutions. So that's telling me that this graph is not going to intersect the x-axis. So there are no x-intercepts. So get rid of this. Now for the y-intercepts, again, you plug in a 0 for x, you solve for y. It's going to be very similar here. The discriminant is going to be negative, but let's go through it. So we have y squared, and then plus 22y, then plus 342 is equal to 0. So I got rid of this and this because, again, x is 0 here. We're going to solve for y now. So let's put a 1 here. So this is your a, this is your b, and this is your c. So y is equal to the negative of b, so -22, plus or minus the square root of, you have b squared, so that's 22 squared, that's 484, and then minus, you're going to have 4 times a is 1, let me just not even put that in, times c is 342. We already know that, let's treat this as -4. -4 times 342 is going to be negative 1,368. So again, if you're on a test, just stop there. The discriminant is negative, so you know you don't have any y-intercepts. For the sake of the tutorial, I'm just going to simplify this completely. So this is over 2a, a is 1, so just 2. So 484 minus 1,368, that's -884. So let me write I times the square root of 884. And 884, I would write that as 4 times 221. 221 is 17 times 13, so I'm not going to do anything else with that. Square root of 4 is 2. So let's just say this is 2i times the square root of 221. Okay, pull a 2 out, and that would give me y is equal to 2 times the quantity -11 plus or minus I times the square root of 221 over 2. Let's cancel this with this, and actually I'm just going to erase this one. So you see for y, when we plugged in a 0 for each x, we get these two non-real complex solutions. So -11 plus or minus I times square root of 221. So we know that this graph for the circle is not going to intersect the y-axis either. So there will be no x-intercepts and no y-intercepts. Let's go through an alternative approach. And this one is where I'm going to show you the center radius form. So first I'll just show you by plugging in a 0 for x and then also y, how this is not going to work. And then I'll also graph this and show you what's going on there. So if you want to put this in center radius form, collect your x's together. So x squared plus 30x plus blank. I'm going to complete the square. Then plus collect your y's together. So y squared plus 22y plus blank. And this equals, again, just subtract 342 away from each side of the equation. So this would be -342. Okay, we're going to complete the square for this guy and this guy. Now notice that this coefficient is 1 and this coefficient is 1. So really all we have to do is cut this in half and square it. And we're going to add that to both sides. Cut this in half and square it. We're going to add that to both sides. So 30 divided by 2 squared. So 30 divided by 2 is 15. So this is 15 squared, which is 225. So we're going to add that there, and we're going to add that there. Now use that 15 to factor. So this is x plus 15, quantity squared, then plus, here I'm going to cut this 22, the coefficient of y to the first power, in half. So cut it in half and square it. So 22 divided by 2 is 11. So this is 11 squared, which is 121. So put that in there and then add that over here. And again, use that 11. That looks like a 7, so let me make that into a 1. Use that 11 to factor this guy. So this is y plus 11 quantity squared. And this equals, just run through this in your calculator and you're going to get 4, right? So negative 342 plus 225 plus 121, that's going to be 4. Let's say that in this form, I told you to plug in a 0 for x and solve for y. In other words, give me the y-intercepts. So this would be gone. You would have 15 squared, which is 225. And then plus this quantity y plus 11 squared is equal to 4. Now, don't expand this. Just subtract 225 away from each side of the equation. And this would cancel. And over here, you would have negative 221. So let's say this is the quantity y plus 11 squared is equal to negative 221. Now, in the real number system, is there a number that I can plug in for y such that I add 11 to it, I square it, and I get a negative 221? No. Because when we think about squaring a negative, we get a positive. When we square 0, we get 0, and when we square a positive, we get a positive. So in the real number system, this is going to be impossible, okay? So we know that we do not have any y-intercepts, so this is another way to look at it. Now similarly, if we did this with this guy, let's say we write x plus 15 quantity squared plus, plug in a 0 for y now, you would just have 11 squared is equal to 4. Well, this is 121. And if you subtract this away from each side, you're going to get a negative over here on the right. So let me cancel this away. 4 minus 121, that's going to be negative 117. So this would be equal to negative 117. And essentially what's happening is here, you have this guy squared is equal to a negative number. Again, in the real number system, this is not possible. So we can say there are no x-intercepts either. So that's another way that you could have done it. Now, the last thing I'm going to do is show you this graphically, and then it's going to make a lot more sense for you. Let me make this a little bit better here. And what I'm going to do is actually match this up perfectly. So let's say x minus h quantity squared plus y minus k quantity squared is equal to the radius squared. So again, you have to match these signs up. This is minus, this is plus. So x minus a negative 15. Very important. This is quantity squared plus. This is going to be y minus a negative 11 quantity squared. And this equals 4 is the radius squared. So to get the radius, I'm just going to say this is 2 squared. So the radius is 2. So the center would occur at h comma k. So h is negative 15 and k is negative 11. And then the radius is going to be equal to 2. So let's grab this real quick. And I made a little sketch with a computer. So basically, let me paste this in real quick so we have the information. The center of this circle occurs at negative 15 comma negative 11. So from the origin, I'm going 15 units to the left. So that's going to go right there. And I'm going from the origin 11 units down. So that's right there. So from the origin, 15 units left and then 11 units down. That's going to put me right there for the center of that circle. Now the radius is 2. So from the center, I would go 1, 2 units to the right. So that's a point. I would go 1, 2 units up, so that's a point. I would go 1, 2 units down, that's a point. And then 1, 2 units to the left, that's a point. And of course, you could sketch your circle through those points. But the idea here is that you would notice that this does not intersect the x-axis or the y-axis. So a few different ways to think about it. If you get the equation in general form and you plug in and you use the quadratic formula and you end up with a negative discriminant, you can stop and say, hey, I don't have whatever that is. If it's the x-intercept you're trying to find or the y-intercept, whatever it is in that situation, you won't have it. Another thing is if you have it in center radius form and you end up with some quantity squared equals some negative number, again, you can stop and say, well, in that particular case, I don't have that particular intercept, so it could be x-intercept or y-intercept or whatever you're trying to find for that particular equation. All right, for the next few problems, for the instructions, we're going to say that we just want to graph each circle. All right, let's take a look at problem 9. So here we have x squared plus y squared plus 6x plus 8y plus 21 is equal to 0. So I'm just going to put this into center radius form. So let's say this is x squared plus 6x plus blank, and then plus y squared plus 8y plus blank is equal to, I'm going to subtract 21 away from each side of the equation. So this equals negative 21. Okay, so over here, you have a 1 for the coefficient for x squared and a 1 for the coefficient for y squared. So just cut it in half in terms of your coefficient for the variable raised to the first power and then square it. So 6 times a half is 3. 3 squared is 9. So I'm going to add 9 here and add 9 here. 8, if I cut that in half, 8 divided by 2 is 4. 4 squared is going to be 16. So I'm going to add that over here as well. Okay, so negative 21 plus 9, that's negative 12. And then negative 12 plus 16 is going to be 4. Let me slide down here a little bit. I'm going to factor this into x plus 3 quantity squared. And then plus this is going to be y plus 4 quantity squared. And this would be equal to 4. A lot of people will make the mistake and say the center occurs at 3, 4. It doesn't. It occurs at negative 3, negative 4. You have to make sure that you line this up with your formula. So this is x minus h quantity squared plus this is y minus k quantity squared is equal to the radius squared. So you have to match up the signs. This is a minus, this is a plus. You have to change it to minus a negative. So x minus a negative 3 quantity squared plus this is y minus a negative 4 quantity squared, and this equals, so here I have 4, that's the radius squared, so this is 2 squared. So matching things up, I know that h is negative 3, k is negative 4, and the radius is 2. So the center is going to occur at negative 3, negative 4. Let me make that a little bit better. And then we'll say our radius is equal to 2. So let me grab this real quick and just paste this in. I've already pre-drawn this because I'm not good at drawing things. But essentially, you would first find the center. So that's at negative 3, negative 4. So from the origin, 3 units to the left and 4 units down. So that is your center. Now your radius is 2. So you can just go from the center, 2 units to the right, make a point. And then you can go 2 units up, make a point. You can go 2 units to the left, make a point. And then 2 units down and make a point. So once you have your 4 points, just sketch the graph of the circle. Does not need to be perfect. I will try to draw over what the computer did, and that's good enough for me. Again, if your teacher wants it perfect, you're going to have to use something like a protractor, but generally speaking, they're just trying to see that you understand the concept, and so this would be good enough. All right, let's take a look at problem 10. So here we have x squared plus y squared minus 2x plus 6y plus 1 is equal to 0. Okay, so first I'm going to put this into center radius form. So let's go x squared minus 2x plus blank, then plus y squared plus 6y, and then plus blank. I'm going to subtract 1 away from each side, so this equals negative 1. So this is a 1 as the coefficient for x squared, and this is a 1 as the coefficient for y squared. So we're basically good to go. Let me go plus negative here so that's crystal clear. The coefficient for x to the first power is negative 2. So you cut that in half. Negative 2 divided by 2 is going to be negative 1, and then you square that. So negative 1 squared is 1. So we're going to add that here and then also here. Now, when you factor that, you go x minus 1 quantity squared. So taking this guy and dividing it by 2, whatever that result is, that's what you're going to get here. So negative 2 divided by 2 is negative 1. So that's why it's x minus 1 quantity squared. Then plus. Over here, you cut this 6 in half. 6 divided by 2 is 3. And so this would be y plus 3 quantity squared. And then you square 3 and you get 9. So I'm going to put a 9 here and also add a 9 in here. So negative 1 plus 1 is going to be 0. So I'm just left with 9. You want to match things up. So you want to say that we want x minus h quantity squared plus you want y minus k quantity squared is equal to the radius squared. Let me make this 2 a little bit better. So here this matches up. So h is 1. Let me write this again. So x minus 1 quantity squared. And then plus, this does not match up. This is a minus and this is a plus. So you've got to write it as minus a negative. So you're going to say y minus a negative 3 quantity squared. And then this equals, the radius squared is 9, so the radius would be 3. So let's say this is 3 squared. So let's say the center is going to occur at 1, negative 3. And then the radius is going to be equal to 3. And let's come down here. So the center is at 1, negative 3. So from the origin, go 1 unit to the right and then 3 units down. So that's your center. Your radius is 3. So from the center, go 3 units to the right. There's a point. You're going to go 3 units up. There's a point. You're going to go 3 units to the left. So there's a point. And you're going to go 3 units down. So there's a point. So again, once you have your 4 points, you can just sketch your circle. So let me try to trace over what the computer did. Again, this does not need to be perfect. If your teacher does want it to be perfect, then you're going to need to use something like a protractor. Very hard to draw a circle freehand that's going to be perfect. But the main thing is you understand the concept. You can take your equation in general form. You can put it into center radius form. You can extract the center and the radius, and then you can sketch the graph. All right, let's take a look at the practice test. For the instructions, we're asked to determine if each relation is a function. We want to state the domain and range. So for the first problem, we have a relation that's given as a set of 4 ordered pairs. We have -2, 3, 5, -7, -2, 15, and then 1, -1. So is this relation a function? Remember in the lesson we talked about the fact that a relation is a function if for each x value or member from the domain, it's associated with one and only one y value or member from the range. So for this type of problem, all you need to do is look for a duplicate x value. So what you would find is that this x value of -2 occurs here and then also here. So you have a duplicate x value. And if that happens, you don't have a function because this x value here that's a duplicate is associated with more than one y value. Here an x value of -2 is associated with a y value of 3. And here an x value of -2 is associated with a y value of 15. So you can immediately say that this is not a function. So not a function. Let's think about the domain and the range. For the domain, it's the set of all x values from your relation. So let's write out our domain like this. And inside of some set braces, I'm just going to go into this relation and I'm going to grab all the x values. If something is a duplicate, you only want to list it once. So here I have an x value of -2. Then here I have an x value of 5. Again, -2 is already listed, so you don't double list. And then here I have an x value of 1. So the domain or the set of x values, you have -2, 5, and then 1. Now for the range, this is going to be the set of y values. So let me set this up with some set braces. You're going to have a y value of 3. You're going to have a y value of -7, and then a y value of 15, and then lastly, a y value of -1. So again, the range is the set of y values, so 3, -7, 15, and -1. Now, one last thing I'll do, just to drive the point home, some people like to look at this as what we call a mapping diagram. So let me go ahead and write that this is my domain. And this is my range like this. And what you would do is draw. It can really be any shape you want, but typically you'll see something like this. So this is the domain, and let's say this is the range. And maybe that's a little bit too small for what I'm trying to do. So maybe I'll make that like that. Not really the best drawer. And basically what you're going to do is you're going to start with the members from the domain. So let me just list those. We have -2. We have 5, and then we have 1. And then let's list the members from the range. So we have 3, we have -7, we have 15, and then we have -1. What you're going to do is actually just arrow over to things. So instead of having the ordered pair format, you would say, okay, well, an x value of -2 is associated with a y value of 3 here. You can see that with the ordered pair, but you're going to show that visually here by arrowing over. So this x value of -2, or member from the domain, is associated with a y value of 3, or member from the range. But then additionally, you're going to see that you need another arrow because this x value of -2 is also associated with this y value of 15. So let me arrow over like that. And immediately you can see visually that you don't have a function. This one given x value is associated with 2 different y values, so you don't have a function. Now let me do the other ones. So an x value of 5 is associated with a y value of -7, and then an x value of 1 is associated with a y value of -1. All right, let's take a look at problem 2. So again, we're given a relation as a set of 4 ordered pairs. We see we have -1, -5, 9, -3, 7, -5, and then 3, 3. So again, for this type of problem, ask yourself the question, do I have a duplicate x value? Because if I do, for each x value, there's not going to be one unique y value. Here you have an x value of -1. I don't see it again. Here you have 9. I don't see it again. Here you have 7, I don't see it again. And then here you have 3, and I don't see it again. So for each x value, there's one and only one y value. Now, some people are going to get tripped up by this guy right here. You see there's a -5 here and a -5 here. That's a duplicate y value, and that's actually okay. The fact is, if I ask you, what is the y value when x is -1? Well, you can clearly say that it's -5. There's no doubt in your mind. Additionally, if I say, what is the y value when x is 7? Then you immediately know that it's -5. So there's no doubt in your mind. There's a clear association in each case. So you can say that, yes, this is a function. So yes, this is a function. Okay, for the domain, again, this is just the set of x values. So you have -1, you have 9, you have 7, and then you have 3. So that's going to be the domain. For the range, this is the set of y values. So you have -5, you have -3, and then let me make this 3 a little bit better. You don't need to double list things, so you're not going to put -5 in again, and then you're going to have 3. Now again, if you wanted to make a mapping diagram, you can. Let me just do that real quick in case you are interested. So basically, you would write out domain like this. And let me just make something like that. And then let me write out the range like this. And let me make something again like that. Definitely not the best drawer in the world. So let me put the elements or members from the domain or the x values. You have -1, you have 9, you have 7, and then you have 3. And then for the members from the range, you have -5, you have -3, and then you have 3. Maybe that 5 could be a little bit better there. Now, when we think about an x value of -1, it's associated with a y value of -5. So that's going like that. Then an x value of 9 is associated with a y value of -3. So that's going to go like that. Then an x value of 7 is associated with a y value of -5. So that's going to go like that. It's okay that an x value of -1 is associated with that y value of -5, while the x value of 7 is also associated with a y value of -5. That does not violate the definition of a function. If I had something like this, where -1 was linked up with, let's say, -5 and then also 3, well, that's where the definition of a function is going to be broken, so you wouldn't have a function there. But here we're okay. So it's all right that 7 is associated with -5, while -1 is also associated with -5. So then lastly, we have 3 that's going to be associated with 3. All right, let's take a look at problem 3. So here we have a set of 4 ordered pairs again. So 13, 10, -5, -5, 7, 9, and then 11, 2. So once again, I'm looking for a duplicate x value. So 13, -5, 7, and then 11. So there's not a duplicate x value. So here we can clearly say, yes, we have a function. So we'll say, yes, this is a function. The next thing is to think about the domain and the range. So for the domain, again, this is the set of x values. So just grab your x values. So you have 13, and then -5, and then 7, and then 11. Now, for the range, this is the set of y values. So you have 10, you have -5, you have 9, and then you have 2. Once again, if you want to make a little mapping diagram, let's go ahead and set this up. We'll say domain. And let me draw a little shape there. And then range. And let me see if I can make something similar. So for the domain, you're just going to list 13, -5, 7, and then 11. And then for the range, you have 10, -5, 9, and then 2. So real easy here. Everything's very straightforward. An x value of 13 is associated with a y value of 10. An x value of -5 is associated with a y value of -5. And then an x value of 7 is associated with a y value of 9. And then lastly, an x value of 11 is associated with a y value of 2. All right, for the next few problems, we're going to change things up a little bit. I'm going to give you a mapping diagram, so you'll be able to see the domain and range already. So the instructions are just going to change. Now we're just asked to determine if the given relation is a function. All right, for problem 4, it's relatively straightforward. You're going to see something change, and basically instead of using numbers, now we have some cities. So in your book, you'll see at least one example where they don't use numbers just to change things up a little bit. and get you to think a little bit differently. It's the same concept as if you were working with numbers. So don't let this trip you up at all. So basically on the left, again, this is going to be for our domain. Typically, this is going to be the X values, or you could say the inputs, or you could also say the first components. On the right, we have our range. So these are typically the Y values, or again, you can say the outputs, or also you could say the second components. So if I look at this, do I have a function? So in other words, I'm going to go into my domain and say, for each member or element from that domain, is it mapped to, or you could say linked up with or associated with one and only one member from the range? Yes. This domain element of Avalon is mapped to a range element of Newport Beach and nothing else. You have a domain element of Azusa that's mapped to a range element of Bell. Then you have a domain element of Torrance that's mapped to a range element of San Francisco. And then lastly, you have a domain element of Arcadia that's mapped to a range element of Malibu. So for each member of the domain, it's mapped to one and only one member, or you could say element from the range. So this is a function. Let's say this is a function. All right, let's take a look at problem 5. So for this one, again, we're looking at some cities. On the left, you have your domain. Traditionally, the domain, we think about this as the set of X values, but you could also say the inputs or the first components. And then on the right, we have the range. And again, this is traditionally the set of Y values, the outputs, or second components. So looking over here, we can see that the domain element of Chicago is mapped to, or you could say linked up with, or associated with, a range element of Salt Lake City. Then you have a domain element of Seattle that is mapped to a range element of Denver. Then this is the one that's the problem. You have a domain element of Houston that is mapped to a range element of Los Angeles, and then also Memphis. So this guy violates the definition of a function. You would say for each X, there's one Y, or you could say for each domain element, in this case, it's Houston, it's got to be associated with one and only one range element. Here you have Los Angeles and also Memphis, right? So this is not a function. Let me come down here and just say that this is not a function. All right, let's take a look at the practice test. For the instructions, we're asked to find the domain and range. Before we get started, the first two problems are going to involve finding the domain and the range, but then we're going to get into some harder problems that just ask us for the domain. That's typically how this section is going to work. Your easier problems involve finding the domain and the range, and then you start getting into more complicated things and they'll just ask you for the domain. So when we ask for the domain of a relation, or it could also be a relation that's a function, basically what you're asking for is, what real numbers can I plug in for the independent variable, in most cases it's going to be X, that's going to produce real numbers. So you always want to think about this in terms of the real number system. So the first thing is that I would think about when you consider your domain, you can't divide by 0. So you're going to have a lot of fractions that are thrown at you. Always think about, well, what would make my denominator 0? The second thing is, in the real number system, you can't take an even root, so a square root, fourth root, sixth root, something like that, of a negative number. So for example, if I had something like the square root of -9, using only real numbers, there's not a number that I could square that would give me -9, right? Because squaring something gives me a non-negative result. So using real numbers only, the square root of -9, you would say that's not a real number. If we use the imaginary unit I, then of course we can work with that problem and say that it simplifies to be 3i, but we're not on that in this particular case. Then down here we say the absolute value, and then also the squaring operation always gives a non-negative result. So something else you want to consider. All right, let's take a look at the first problem. So here we have y is equal to -3x minus 2. The first thing I'm going to do is just copy this. So y equals -3x minus 2. I'm just going to grab this real quick, and I'm just going to come down here to the graph. I think it's very helpful when you solve these problems to have an idea of what this looks like. So the first thing is, when we consider the domain, we are thinking about what is possible in terms of the real numbers that can be plugged in for your independent variable. In this case, it's going to be x. So you want to be able to plug in some real number here and then go through what's given. So in this case, it would be multiplied by -3, and then that product would have 2 being subtracted away from it. you want to think about, would that give me a real number? So plugging in a real number, would I get a real number? Well, thinking about this, I can plug in a negative, I can plug in 0, and I can plug in a positive, right? You can look at the graph and see that. We have these arrows here that are telling us that this is going to extend indefinitely to the left and to the right. So we would cover the entire set of real numbers. And you can try a few values out. So let's say we tried an x value of, let's say -1, just to use something that's negative. Well, y would be equal to -3 times -1, then -2. So -3 times -1 is 3. So this would be 3 minus 2, which would be 1. So if x is -1, y is 1. So that's going to be this point right here. That's on the graph. Now you could try 0. So that would give you your y-intercept, right? So if you plugged in a 0 for x, let me do that real quick. So y is equal to -3 times 0 and then -2. Of course, -3 times 0 is 0. So this would be 0 minus 2, which is -2. So that gives you this point right here, which is 0, -2. And then lastly, you could try some positive value. So let's just say that we pick an x value of 2. So let's say y equals -3 times 2, and then -2 like this. -3 times 2 is -6. So this would be -6 minus 2, which is -8. So let's go 2 units to the right and then 8 units down. So that would be right there. That would be 2, -8. All right, so we can see clearly that you could plug in any negative that you want, 0, or any positive that you want. So basically for the domain, you would say it's the set of real numbers. So let me actually write that out. So we'll say that the domain is going to be the set of all x such that x, we'll just say, is a real number. Now, if you wanted to write this in interval notation, some people prefer that, you could say it's from -infinity to +infinity. Now, what about the range? Well, given the fact that I can plug in whatever I want for x, that means I can get out whatever I want for y. I can make it as small as I want, I can make it 0, or I can make it as large as I want just by changing the value that I plug in for x. So let's go ahead and say that the range is going to be the set of all y such that y is a real number. And then additionally, you could write this in interval notation. So from -infinity to +infinity. All right, let's take a look at problem 2. So here we have y is equal to the square root of x plus 1 minus 3. So again, I'm going to look at the graph with you. I think it's very helpful for these types of problems. Let me just arrow to this real quick and say that this is y is equal to the square root of x plus 1, and then you have -3 here. Okay, so the first thing is when you consider the domain, if you look at the graph, you can see that the furthest x value going to the left, okay, so this is going to be the smallest x value, that's going to occur where x is -1, right? So this point right here, let me highlight it. This would be -1, -3. So what is causing that? Why don't we have values that go to the left of -1 on the x-axis? Well, basically, again, when you think about the real number system, you can't take the square root of a negative number. So here you would think about the fact that I have the square root of x plus 1. So what can I plug in for x there? What I would say is that x plus 1, or the radicand here, the part underneath the square root symbol, needs to be non-negative. So you would say this is greater than or equal to 0, because it could be 0 or some positive number. So we're going to solve this simple inequality, just subtract 1 away from each side of the inequality. And so let's go ahead and cancel this guy right here, and we'll say that x is greater than or equal to -1. Now you can verify that on the graph. X is -1 at the smallest, and then it's anything larger, right? So going out to +infinity. So you can go ahead and say that for the domain, let me write this up here. So for the domain, it's going to be the set of all x such that x is greater than or equal to -1. Again, you can also write this in interval notation if you prefer that. So you want to put a bracket next to -1 to show that -1 is included. And then you're going to go out to +infinity. Make sure you always use a parenthesis with infinity. And basically, let's think about the range now. So looking at the graph, you can see that the smallest value for y, or the lowest point on that graph for y, is going to occur at -3. Right? So you see this is -1, -3. The y value is -3. So why is that the case? Well, again, if we consider our domain restriction that x needs to be -1 or larger, If I plugged in a -1 for x, -1 plus 1 would be 0. So you'd have the square root of 0, which is 0, and you would just get y equals -3. So basically, that's as small as you can get y to be. Any value for x that you plug in that's larger than -1 is going to produce a larger value for y. And this would be true. You can keep plugging in bigger and bigger values for x as far out to positive infinity as you want, so you can make y as large as you want going out to positive infinity. So you would say that the range is going to be the set of all y such that y is greater than or equal to -3. I think this could be written a little bit cleaner here. Let me make this -3 cleaner in case you're looking at that. And still didn't really get that, so let me make that a little bit better again. So then if you wanted to do this in interval notation, now you're going to put a bracket next to -3, so that's going to be included, and you would go out to positive infinity. All right, for the next few problems, the instructions are going to change. So now we just want to find the domain. We don't need to find the range for these examples. For problem 3, we are given that y is equal to 2x over, you're going to have the absolute value of 3x minus 3, and then -6. So again, when we think about the domain, we're thinking about what real numbers can we plug in for the independent variable, in this case, x. Remember, we can never divide by 0. So I would think about my denominator here, and I would just set it equal to 0, and I would solve, and then those solutions are going to be restricted from the domain because they result in a denominator of 0. So we're going to say that the absolute value of 3x minus 3 and then -6 is equal to 0. So let's solve this real quick. Hopefully you remember how to solve a simple absolute value equation. What you want to do is isolate the absolute value operation on one side, and you want to get a single number on the other. So we're going to add 6 to both sides of this equation. We're going to cancel this away. So now you're going to have the absolute value of 3x minus 3 is equal to 6. So now that we have the absolute value operation isolated, you want to set up a compound equation with OR. So you're going to take this expression inside the absolute value bars, and you're going to say that 3x minus 3 could be equal to 6, or 3x minus 3 could be equal to -6. Because if the result of this was 6, based on what you plugged in for x, well, the absolute value of 6 would be 6. And then if the result of this, based on what you plugged in for x, was -6, well, again, the absolute value of -6 would be 6 as well. So you need these two different equations. All right, so for this one on the left, let's add 3 to both sides. Let's go ahead and cancel this. And we'll say that 3x is equal to 6 plus 3 is going to give me 9. Divide both sides of the equation by 3. And you're going to get that x is equal to, let's cancel this, 9 over 3 is 3. On this side, let's add 3 to both sides of the equation. Let's cancel this away. And we'll say that 3x is equal to -6 plus 3 is -3. Let's finish this up by dividing both sides of the equation by 3. This would cancel. And we're going to say that x can also be -1. So coming back up here, we want to make sense of what we found. We said that x equals 3 or x equals -1. Let's remind ourselves of what we're trying to do. We're trying to figure out where this denominator would be 0. So it's going to be 0 when x is 3, or if x is -1. So those values have to be restricted from the domain because we can't divide by 0. If you plugged in a 3 here, you would have 3 times 3, which is 9, and then 9 minus 3 is 6. So you would end up with the absolute value of 6, which is 6, minus 6, which is 0. Right? So you'd have 0 in the denominator, and again, division by 0 is undefined. The same thing would happen with -1. If you plug that in there, 3 times -1 is -3. -3 minus 3 is going to be -6. And so the absolute value of -6 is 6. So again, you get 6 minus 6, which is 0. Division by 0 is undefined. So let's set this up, and we'll just say that for the domain, it's going to be the set of all x such that x is not equal to, let's put -1, and then also 3. Now, you could also write this in interval notation if you wanted to, but it's going to be a bit lengthy. So basically, you would come from negative infinity and go up to and exclude -1. And then the union with, you would exclude -1 again, and you would go up to and exclude 3. And then the union with, you would exclude 3 and go out to positive infinity. I think this right here using set builder notation is much cleaner, but some people want to answer that way, so that's really up to you. Basically, this covers the whole number line except for -1 and then also positive 3. All right, so to visually see what's going on here, you can always sketch the graph. So I recommend this when you first start doing these problems. You can go to any online calculator and just type in y equals 2x over the absolute value of 3x minus 3 and then minus 6, you're going to see that you get the same result visually that we got from setting the denominator equal to 0 and solving the resulting equation. Basically, when you look at the graph, you see that you have a vertical asymptote at x equals -1 and then a vertical asymptote at x equals 3. So in each case, what's happening is, if you look at this piece of the graph here, this graph is approaching an x value that's going to be -1, but it's never going to actually get there. Same thing coming from this guy, so it's approaching an x value of -1, but it's never actually going to get there. So you can't actually have an x value of -1. Then here, you're approaching an x value of 3, and over here, you're approaching an x value of 3, but you'll never actually get there. So the graph is consistent with what we found, that the domain is the set of all x such that x is not equal to -1 or 3. All right, let's take a look at problem 4. So here we have y is equal to 5x minus 3 over the square root of the absolute value of x squared plus x minus 2 and then minus 4. So when you think about the domain for this type of problem, in the numerator, you're not going to have any issues. You just have 5x minus 3. When we move into the denominator, that's where you have to consider division by 0 and then also this square root operation. So first, let's think about the square root operation. When we have a square root and we're working in the real number system, we can't take the square root of a negative number. So that means the radicand here needs to be non-negative, or you could say greater than or equal to 0. So let's start by saying the absolute value of x squared plus x minus 2 and then minus 4 needs to be greater than or equal to 0. But there's a problem with what I just wrote here. If you're in the denominator, you cannot divide by 0. So let's say I have the square root of 0. Well, that would be 0, and then I'd have division by 0, which is undefined. So you have to make an adjustment here because you're in the denominator. So we would say the absolute value of x squared plus x minus 2, then minus 4 is strictly greater than 0. So before we solve this inequality algebraically, let's look at the graph. So if you take the left side here of this inequality and you type that into Desmos, so the absolute value of x squared plus x minus 2 and then minus 4, you could put y equals in front of that if you want. It's going to give you the same graph. Basically, what you're trying to do is figure out what are the x values that are going to produce y values that are greater than 0. The place I would start here, I would think about the x-axis. So that is the horizontal line, y equals 0. So on the x-axis, we know the y values are 0. So let's look at this point right here to start. So this is an x-intercept, so -3, 0. Again, we're on the x-axis. And this is another x-intercept. So this right here would be 2, 0. Again, we're on the x-axis. So if we think about x values that are to the left of -3, what do we see in terms of the y values? Well, they're going to be greater than 0, right? So we are above the x-axis. Additionally, if I think about x values to the right of 2, or you could say greater than 2, well, we are, again, above the x-axis in terms of the y values. We're greater than 0. Okay, so putting a solution together from the graph, I could really say that this guy is satisfied when x is less than -3, then or when x is greater than 2, right? We can see that. At -3 or at 2, the y value is 0, so that's not going to satisfy the inequality. And then between those two values, the y values are going to be less than 0, right? So that's not going to work. So this is what we would expect for our solution. Let's go ahead and grab this. All right, so let's do this algebraically. What I'm going to do first is think about a rule that we learned a long time ago. Let me write this off to the side. So if you have some algebraic expression, let's call it u. In this case, that's going to be the x squared plus x minus 2 that's inside the absolute value bars. And let's say it's greater than some positive real number. Let's just call it k. Well, the way this sets up is that u is greater than k, or u is less than -k. So we're going to just use that rule here. I'm going to add 4 to both sides of the inequality. So let me go ahead and say that this is greater than 4. And then I'm just going to set this up here, this compound inequality with or. So let's say we have x squared plus x, then minus 2 is greater than 4. And then I'll say or, we're going to have x squared plus x minus 2 is less than -4. Okay, at this point, we don't even need this anymore. I'm going to get rid of this. We know how to solve a quadratic inequality. Basically, you want the right side to be 0, and then you want to get your critical values by replacing the inequality symbol with equals. and then you take those critical values, you set up some regions on the number line, and you're going to use some test points. So let me go ahead and subtract 4 away from each side of this inequality. So let me do that here visibly. So this would be a -6 here, and of course this would be 0 here. And then let me do the same thing here. Let me add 4 to both sides. So this right here would be a 0, and then -2 plus 4 is going to be a 2. Now, you're going to find that this one doesn't have a solution, and I'll get to that one momentarily. Let me start with this one, which is a little bit easier. So let me write x squared plus x minus 6 is greater than 0. So let me grab this real quick, and let me come down here where we have our little number line set up. So the first thing I would do with this is factor it. So let me put a little 1 right here, and I'm going to factor the left side just to make it a little bit easier. So put an x here and an x here. Give me two integers whose sum is 1 and whose product is -6. So you can do a +3 and a -2. So 3 times -2 is -6. 3 plus -2 or 3 minus 2 is 1. Now I'm going to get rid of this version here. I'm just going to stick with the factored form. And basically at this point, you would want to replace the inequality symbol with equals, right? So you would have x plus 3, that quantity, times the quantity x minus 2 is equal to 0. And you're going to use your zero products property. And basically you're going to say that x plus 3 equals 0, or x minus 2 equals 0. Again, this is us finding the critical values or where this guy is going to be 0 on the left side. So what I would do here is subtract 3 away from each side, and so you would get x is equal to -3. Over here, I would add 2 to both sides, and so you would get x is equal to 2. So let's put our -3 here, and let's put our 2 here, and then you can get rid of all of this. You don't need it anymore. Let me rewrite that in. You can get rid of this. Now we're just focused on the inequality. So I like to label this as region A, B, and C. Region A is anything less than -3. B is between -3 and 2, and C is greater than 2. So just pick a value in that region. Okay, it can't be the critical value itself. So for A, I would pick -4. So I'm going to plug in a -4 there, and then a -4 there. And then basically a lot of people will just do a sign analysis. So they'll say, okay, well, -4 plus 3, let me do this off to the side, the little border. -4 plus 3 is going to be -1. And then -4 minus 2 is going to be -6. What they do is say they have a negative times a negative, which is a positive, and a positive is always greater than 0. So they don't need to really evaluate this. They just go ahead and say, okay, well, this is going to be true. But you can go through and say -1 times -6 is 6. And so basically you would have 6 is greater than 0. And so that's a true statement, right? So either way you want to do it. For this one in region B, I would pick 0. So you're going to plug that in there and then also there. So you'd have 0 plus 3, which is 3. And then times 0 minus 2 is -2. Again, a lot of people are just going to say positive times negative is negative. A negative is never greater than 0. So this is false. But you could also say 3 times -2 is -6. And so you would get -6 is greater than 0, which is a false statement, right? So this is false. All right, the last one for region C, I would pick maybe 3, plug that in for x there, and then also there. 3 plus 3 is 6, and then 3 minus 2 is 1. Again, positive times positive is positive, and so that's always greater than 0, so this is true. But again, you can always go 6 times 1, which is 6, and just write out that 6 is greater than 0, right? That's a true statement. Okay, so we've found our solution. Let me get rid of this. This is a strict inequality, so -3 and 2, those are excluded. So basically, you would just say that x is going to be strictly less than -3, or x is greater than 2. So let me come back up here, and I'm going to paste this in right here. This is my solution for this. Let me show you this real fast in case you are interested. So if you go to Desmos, again, only type in what's on the left-hand side. So x squared plus x minus 6, or you can go y equals x squared plus x minus 6. You're looking, again, for the x values for which the y values are greater than 0. So if you see, again, anything that's to the left of -3 would give you a y value that's greater than 0, and anything to the right of 2 in terms of the x values would give you a y value that's greater than 0. So x is less than -3, or x is greater than 2. Now, for this other one, you're going to have a problem. I'm just going to write for right now that there's no solution, and I'm going to prove that to you. So for this one, it's going to be a prime polynomial for the left side. If you think about x squared plus 1x plus 2, if I say, give me two integers whose sum is 1 and whose product is 2, you're not going to be able to do that, right? 2 is a prime number. It's only 2 times 1. And if you're adding 2 and 1 together, you're going to get 3. So this is impossible. So what you would do here is use your quadratic formula. So this is A, this is B, and this is C. So for the quadratic formula, it's x is equal to the negative of b plus or minus the square root of b squared minus 4ac, and then all over 2a. Well, let's plug things in and see what's going on. So for the negative of b is 1, so this is negative 1. Then b squared, well, 1 squared is 1. And then a is 1. You can get rid of it if you want, or you can write it in. It doesn't matter. 4 times 1 would just be 4. And then for c, it's 2. So let's plug in a 2 there. Okay, so you have 4 times 1, which is 4, times 2, which is 8. Let me put this here. So you have 1 minus 8, which is negative 7. And really, I'm just going to simplify this to say that the square root of negative 7 is going to be I times the square root of 7. Down here, you have 2 times a is 1, so just erase that. 2 times 1 is just 2. So when you get this situation where you're trying to find your critical values, in other words, we take this guy, we set it equal to 0, and we solve it. Here we use the quadratic formula, and you get 2 non-real complex solutions. What that is telling you is that you're not going to have any x-intercepts. So that means the graph is never going to cross the x-axis. So it's either always above 0 in terms of the y values, or it's never above 0 in terms of the y values. So it's either always true or never true. So you either get all real numbers for the solution or no solution. So how do you figure out what the solution is? Well, first off, you could graph it, right? So let me do that first. Again, thinking about this, here is x squared plus x plus 2. So you just want to type this, or you can put y equals x squared plus x plus 2 into Desmos. You're going to get this graph here. You see that it does not impact the x-axis. So there are no x-intercepts in this case. So what's happening is you're asking, where are the y values less than 0? Well, they're never less than 0. Less than 0 would be below the x-axis. That's never going to happen, okay? If you flip this around and you said, where are they greater than 0? Well, it's always going to be greater than 0. So where are they above the x-axis? Always. Okay, so the y values are always greater than 0. But here we have a less than, so this is never going to be true, so there's no solution. So if we come back up, we have no solution there. Now, algebraically, if you don't want to make a graph, not that big of a deal. If you see that you get 2 non-real complex solutions when you try to set up your equation and solve for the critical values, all you have to do is pick any number, it doesn't matter what it is, and just plug it in and see if it works. If it does, then all real numbers. If it doesn't, then there's no solution. You could pick 0, it's easy to work with. So you would have 0 squared, which is 0, plus 0, which is still 0, and then plus 2, which is 2. So you would get 2 is less than 0, which is false, right? So there's no solution. So we don't have to worry about this. We only have to take the x is less than negative 3, or x is greater than 2, which we found originally by looking at that graph where we had the absolute value of x squared plus x minus 2 and then minus 4, right? So we looked at that immediately and said, well, where are the y values greater than 0? Where it was where x was less than negative 3 or x was greater than 2. And a lot of you will ask, well, why did you go through all that algebra to come up with the same thing you found in a few seconds from the graph? Well, not everybody's going to be able to graph that stuff, and maybe you have to show this algebraically for your teacher, so it's good to just get some practice with things. Okay, so we're just going to write out the domain. So let's write out the domain. We would say that this is the set of all x such that x is less than negative 3. Then I'll just put a comma. So we're also going to say that x could be greater than 2. So x could be less than negative 3, or x could be greater than 2. Okay, so let's put this like this. Let's get rid of this. And we could write this in interval notation. So coming from negative infinity, going up to and excluding negative 3. So we're going to use a parenthesis there. And then it would be the union with, you would have anything greater than 2. So 2 would not be included, so use a parenthesis there. So this is out to infinity. All right, let's wrap things up and just come to a little graph. And what we see will confirm what we have here. So if we look at y equals 5x minus 3 over the square root of the absolute value, let me make that more clear. So the absolute value of x squared plus x minus 2 and then minus 4, well, what's going to happen is you're going to have a vertical asymptote here at x equals negative 3. And you can see that this guy is going to approach an x value of negative 3, but never touch it. But it could be anything going to the left. So any value that's less than negative 3, you're okay. And then over here, you have another vertical asymptote at x equals 2. So the graph would approach an x value of 2, but never touch it. And again, going this way, it can be anything, right? So going out to positive infinity. So this confirms our domain. We have the set of all x such that x is less than negative 3, or x could be any value that's greater than 2. All right, let's take a look at problem 5. So now we have y is equal to the negative of 7 over x squared minus 4x minus 5. So again, if I'm working with a fraction, I'm thinking about division by 0. And so this denominator here, which is x squared minus 4x minus 5, I would just set that equal to 0 and solve the resulting equation. So the solutions here, we're going to restrict that from the domain because, again, that would just make the denominator 0. So a simple quadratic equation to solve. The first question is, can we factor this? So let's go ahead and try that real fast. I'd put an x here and an x here, and then I want two integers whose sum is -4 and whose product is -5. Well, what I could do is -5 and then +1. So 1 plus -5 would be -4, and then 1 times -5 would be -5. So this is the correct factorization. So this is pretty easy to solve. You would just say x plus 1 is equal to 0, then or x minus 5 is equal to 0. We would subtract 1 away from each side of the equation, cancel that, and get x is equal to -1. Over here, let's add 5 to both sides of the equation, cancel that, and say x is equal to 5. So we would restrict -1 and then also 5 from the domain. So coming back, let's write out that our domain is going to be the set of all x such that x is not equal to -1 or 5. Again, let's do interval notation in case you're interested in that. So you would come from -infinity and go up to and exclude -1. And then the union with, you'd put -1 as being excluded, going up to and excluding 5. And then the union with, you would exclude 5 and then go out to positive infinity. So basically the whole number line, you're just excluding -1 and you're excluding 5. So once again, just coming to the graph, we have y equals -7 over x squared minus 4x minus 5. And looking at this, you can see that x is not going to be -1 or 5 from the graph. Again, you have a vertical asymptote at x equals 5, and then another vertical asymptote at x equals -1. So your graph is going to approach an x value of -1, but never touch it. And your graph is going to approach an x value of 5, but never touch it. All right, let's take a look at problem 6 now. So here we have y is equal to, we have the negative of x minus 2 over x squared minus 5x plus 6. So let's come down here real quick. Now, the trick here is to immediately just set the denominator equal to 0 and solve that. When you have a rational expression, remember, when you think about the domain, it's always going to be in terms of the original rational expression. A lot of you are looking at that and you're going to try to simplify it and you're going to end up with the wrong answer. So let me do it the correct way first, and then I'll show you the common mistake. So first, I'm just going to grab this denominator here and I'm going to set it equal to 0. So I'm going to say x squared minus 5x plus 6 equals 0. So let me slide down here and I'm just going to solve this with factoring. So I'm going to put an x here and an x here and give me two integers that sum to -5 and have a product of 6. So that's going to be -2 and then -3. So by the zero product property, you could just say x minus 2 is equal to 0 or x minus 3 is equal to 0. We could add 2 to both sides of the equation here and cancel that and say x is equal to 2. Over here, I can add 3 to both sides of the equation, cancel that, and then we'll say x is equal to 3. Okay, so x can't be 2 or 3 because that would give us division by 0. So let me go ahead and get rid of this. And let me write out the domain first, and then I'll show you the mistake that a lot of people make. So let's say that the domain is going to be the set of all x such that x is not equal to 2 or 3, okay? And again, you can put this in interval notation if you want. You can just say from -infinity going up to and excluding 2, and the union with, you're going to go from 2 to 3, and you're going to exclude both, and the union with anything larger than 3. So again, I like this form better. It's just cleaner, more concise. This one right here is kind of a mess when you start getting into things of this length. The common mistake, let me just write this. So y is equal to the negative of x minus 2 over, you have x squared minus 5x plus 6. You saw me factor this, and we got the quantity x minus 2 times the quantity x minus 3. So let me set this up as the quantity x minus 2 times the quantity x minus 3. Okay, so what do most people do? They're going to say, okay, well, I can cancel this with this. And so this becomes the negative of 1 over x minus 3. So if I look at this expression right here, well, the domain would be the set of all x such that x is not 3. There's nothing stopping me with this expression right here from plugging in a 2. But in the original rational expression, I can't plug in a 2. So whenever you're working on a domain problem and you have a rational expression that can be simplified, you always go with the original non-simplified version to get the domain, okay? It carries itself over even though you can simplify. All right, so coming to the graph here, there's going to be a lot to explain. First off, I would advise you to go to Desmos and type in 2 different graphs. So the first graph, I would type in y equals the negative of, you have x minus 2 over, and you can put this in factored form or non-factored form. So you can go the quantity x minus 2 times the quantity x minus 3, or you can say x squared minus 5x plus 6, whatever you want to do, it's the same thing. Now, if you were to simplify this, again, cancel a common factor of x minus 2, and write this as y is equal to the negative of 1 over x minus 3, the graph would look exactly the same except for where x is 2. Now you're going to see that if you move your mouse over 2, it's going to say 2 comma 1. Okay, so that's the difference between this form and this form. But again, when you get a rational expression, you always go with the original rational expression, the non-simplified version, if you're asked for the domain. Okay, so I'm just going to get rid of this. And so that's why you have this hole in the graph right there. We're going to talk more about these holes in the graphs later on when we get to rational functions. For right now, we're just thinking about the domain. Okay, so you see that at 2, it's not defined. There's a hole in the graph. Then additionally, this guy that you couldn't cancel away, this x minus 3 that's still going to be in the denominator, you can see that's creating a vertical asymptote here at x equals 3. So basically, the graph is going to approach an x value of 3, going this way and then also going this way, but it's never going to touch it. Okay, so using the graph, you can confirm that the domain is the set of all x such that x is not 2. Again, you've got a hole in the graph there, and then also x can't be 3. Again, you see that vertical asymptote there. All right, let's take a look at problem 7. So here we have y is equal to, we have the square root of x plus 4 over 2x minus 6. Okay, so in this case, you have 2 different things going on. The first thing you have to consider is that in your numerator, you have the square root operation, and your radicand is x plus 4. So you want to make sure that this right here is non-negative. So the first guy, let me just put first, thing that we would consider is that x plus 4 needs to be greater than or equal to 0. That's pretty easy to do. We would just subtract 4 away from each side of the inequality, cancel that, and say x is greater than or equal to negative 4. Okay, so x can be negative 4 or anything larger. But you also have to consider your second guy there, which is that this denominator cannot be 0, right? So you would say, well, 2x minus 6, if that was equal to 0, and you add 6 to both sides of the equation, let me slide down here for a moment, and cancel this, and we would say, let me just drag this over here, 2x is equal to 6, divide both sides of the equation by 2, let's cancel that away, and we'll say that x is equal to 6 over 2 is 3. So we would say that the second condition is that x cannot be 3, right? Because again, if you plug in a 3 for x, well, then you're going to have division by 0. Let me get rid of this, and let me pull this up here. And let's combine these two, and I kind of messed up my border there. Maybe we don't need it anymore. Let's combine these 2 conditions. So first, x has to be greater than or equal to negative 4. And then second, x can't be 3. Okay, so for the domain, let's write out that it's the set of all x such that x is greater than or equal to negative 4. I'm also going to put that x cannot be 3. Okay, so let me close that down. Now, if you want to do the interval notation on this, you put a bracket next to negative 4, and then you're going to go out to a value of 3, and you're going to put a parenthesis next to 3 because it's not included, and then you're going to put the union with, again, the parenthesis goes next to 3 because it's not included, and then out to positive infinity. So that's how you're going to exclude 3. You have a parenthesis here and then a parenthesis here. So basically anything from negative 4 going out to positive infinity with you excluding one number or one value, which is going to be 3. So again, let's take a look at the graph just to confirm what we found. So first off, you would see that we said that x is greater than or equal to negative 4. Okay, well, here's negative 4 right here on the x-axis, and you see that there's no x value to the left of that. So this is your smallest x value, and this point occurs at negative 4 comma 0, right? If you plugged in a negative 4 here, negative 4 plus 4 is 0. 0 divided by something that's not 0 is going to give you 0, so you get negative 4 comma 0. Then you can have any x value that you want going out to positive infinity with one exception. x can't be 3 because, again, if you plugged in a 3 for x, you're going to get division by 0. So that's creating a vertical asymptote here at x equals 3. So the graph here approaches an x value of 3, but again, it will never touch it. And here, the graph is approaching an x value of 3, but it will never touch it. So here, the domain would be the set of all x such that x is greater than or equal to -4, and x is not equal to 3. All right, let's take a look at problem 8. So here we have y is equal to, we have the square root of 3x minus 2. This is over 6x squared plus 8x minus 30. Let me slide down here just a little bit. And again, you're going to have two different things that you have to consider. The first thing is you have a square root in the numerator. And the second thing is you have to consider the denominator and division by 0. So let me start out. I'm just going to put the first thing to consider. The square root of a negative is not allowed in the real number system. So you would take your radicand, which is 3x minus 2. And you would say this needs to be greater than or equal to 0. So let's go ahead and add 2 to both sides of the inequality. We'll cancel this. Let me just drag this over here. We'll say that 3x is going to be greater than or equal to 2. Let me divide both sides of the inequality by 3. This will cancel. And you get x is greater than or equal to 2/3. Okay, let me get rid of this scratch work here. I'm just going to slide this over like this and put that there. And maybe that doesn't line up, so I'll just rewrite first, or you could put number 1 or whatever. Now we have to think about this denominator here. Okay, so this can't be 0. So you're going to say that 6x squared plus 8x minus 30. Let's set that equal to 0 and see what we get. What I would do here, you notice that everything is even. So I would divide everything by 2, just so I'm working with smaller numbers. So let's go ahead and do that real quick. So that would give me 3x squared plus 4x, and then minus 15, and this equals 0. Now, can I solve this by factoring? I don't know because I haven't actually worked this problem yet, but I'm assuming that I can. So let me go ahead and set this up. I'm going to put a 3x here, and then I'm going to put an x here. And then I'm thinking about this guy and this guy. Now, this is a minus 15 here, or a negative 15 if you want to think about it like that. Let me go plus negative there, just so that's a little bit more clear. So that means my signs have to be different, right? I need a positive and then a negative. Now, for 15, forget about the fact that it's negative for a moment. It's only 1 times 15 or 5 times 3. So it's not really that many things to check. If you put a 5 here and you put a 3 here, this is going to be 15, and this is going to be 3. Well, 15 minus 3 is 12. So get rid of that. That's not going to work. Now, if you switch the order and you put a 5 here and a 3 here, well, now you would have 9 and then 5, and 9 minus 5 would be 4. So it looks like that's what we want. Just got to work out the signs. So we would want a plus here and then a minus here. So this right here would be your 9x, and then this right here would be your negative 5x, and 9x minus 5x would be 4x, and then also your negative 5 times your 3 would be negative 15. So this is what we're looking for. Okay, so now that we have the factorization, let me get rid of this, and I'll just move this up here. We will first say that 3x minus 5 is equal to 0. Let's add 5 to both sides of the equation. Get rid of this. We'll say 3x is equal to 5. Divide both sides of the equation by 3. Let's cancel the 3's, and we'll say that x is equal to 5/3. Okay, let me get rid of this. Let me put a comma here and put second. And I'm going to put x is not equal to 5/3. We also have to consider this one. So x plus 3 is equal to 0. Subtract 3 away from each side of the equation. You get x is equal to negative 3. Now, this one is actually not going to be a problem for us, and I'll explain why in a moment. Let me just put a comma here and put x is not equal to negative 3. We're going to get rid of that restriction in a moment because we don't even need it, and I'll explain why right now. So let me get rid of this. You can actually get rid of this one right away. You can't use an x value of negative 3 because of this guy right here. That would give you a square root of a negative number. So you want to just get rid of that one and just say that your domain would be the set of all x such that x is going to be greater than or equal to 2/3. And I'll say that x is not equal to 5/3. Okay, let's close that down. For your interval notation, again, let's use a bracket with 2/3. And then we're going to go up to and exclude 5/3. So I'm going to use a parenthesis there, and then the union with, you're going to use a parenthesis with 5/3 and then go out to positive infinity. Now, again, we can sketch a graph of this guy just to confirm what we found. So if you type in y equals square root of 3x minus 2 over 6x squared plus 8x minus 30, this is what you would get. You can see that the smallest x can be is 2/3. So right there, you get that point where x is 2/3 and then y is 0, right? If you plug in a 2/3 for x, 3 times 2/3 would be 2, and then 2 minus 2 would be 0. Square root of 0 is 0, so 0 over a non-zero number would give you 0, so you get 2/3 comma 0. So the smallest x can be is 2/3. To the left of 2/3, you don't see anything. Then we can have any x value that's larger going out to positive infinity, with the exception of 5/3, because that gives me division by 0. Okay, so you see a vertical asymptote here that's created at x equals 5/3. So the graph is going to approach an x value of 5/3, but never touch it. And the same thing here. It's going to approach an x value of 5/3, but never touch it. So here the domain is the set of all x such that x is greater than or equal to 2/3, and also x can't be 5/3. All right, let's take a look at problem 9. So I'll just tell you in advance, this is the most tedious problem in this practice test. We have y equals the square root of 6x squared plus 11x minus 7. This will be over the square root of. You have the absolute value of 2x minus 5, then plus 4x squared minus 2x minus 13. So we have two things to consider. First, in the numerator, you have the fact that the radicand for this square root guy needs to be non-negative. So in other words, we need to solve 6x squared plus 11x minus 7 is greater than or equal to 0. So that's the first thing we need to do. I'm actually just going to grab this and I'm going to paste this in right here. So let's come back up and let's think about the denominator. So now you have the square root operation. So the radicand needs to be non-negative. But we're in the denominator, so you really can't say that it could be 0, because again, the square root of 0 would be 0. That would give you a 0 in the denominator, and division by 0 is undefined. So you would want to say the absolute value of 2x minus 5, and then plus 4x squared minus 2x minus 13 is strictly greater than 0. So I'm going to grab this and cut this away, come down here, and I'm going to paste this in. And so basically we're solving a compound inequality with the keyword and. Okay, so it has to work in both. So I'm going to start off with this one. It's a little bit easier than this one. So the 6x squared plus 11x minus 7 is greater than or equal to 0. So let me grab this real quick. All right, before we look at this algebraically, I think it's important to look at the graph. So again, you can go to Desmos and just type in 6x squared plus 11x minus 7, or you could also do y equals 6x squared plus 11x minus 7. Don't worry about this part right here. Okay, just type in this on the left. Now, when we look at this graph, we're thinking about where are the x values that produce y values that are either 0, meaning you're on the x-axis, or greater than 0, meaning that your graph is above the x-axis, right? If you're above the x-axis, in terms of your graph, all those points are going to have y values that are greater than 0. So we would first look at the intercepts. So that's right here and right here. So that's where y is going to be 0, because again, you're on the x-axis. So this one right here, you really can't tell from the decimal approximation, but it's going to be negative 7/3 in terms of the x value. And we'll find that in a moment when we do this algebraically. So negative 7/3 comma 0. So that's one x-intercept. The other x-intercept is going to be, you see that's a 0.5. So let's write 1/2 and then comma 0. So we know that this guy would be satisfied where x is negative 7/3 or where x is a half, because you would get 0 is greater than or equal to 0. But it would also be satisfied for any x value that is to the left of negative 7/3, or you could say any x value that is less than negative 7/3. So let me say that x is less than or equal to negative 7/3. Then I'm going to write my keyword or. You could also see that this would be satisfied for any x value that is to the right of 1/2, or you could say greater than 1/2. So let's say x could also be greater than or equal to 1/2. So that's how you could look at this graphically. You could see that any x value that's between negative 7/3 and 1/2, and I'm excluding both of those, you would be below the x-axis in terms of your graph, right? So the y values are all less than 0 there, so you would not satisfy the inequality in that case. Okay, let's do this algebraically. So let me paste this in here. This is something that I would factor. You always want to try to factor these. It just makes your life a lot easier. So I'm going to factor the left-hand side. So I have a 6 here, which is a little bit tricky to factor because 6 could be 6 times 1, but it could also be 2 times 3. Now, given the fact that I have a negative 7 here at the end, let me go plus negative here so that's clear. I'm just going to start with 2 and 3 because I think that's more likely to work. I actually don't remember how this factors. So I'm going to start with 2x and 3x. And then for -7, forget about the fact that it's negative. You need a 7 there, so it's only 1 times 7. So I'm just going to put in a 1 here and a 7 here and just see what happens, and I'll work out the signs if it works. So 2 times 7 is 14, and then 1 times 3 is 3. So 14 minus 3 would give me 11. So at this point, I just need to put a minus here and a plus here. So that's going to give me 2x times 7. That's 14x. So let me show this. This would be 14x. And then -1 times 3x would be -3x. 14x minus 3x, that's 11x. Okay, so that's exactly what we want. All right, so now that we have this guy factored, you can get rid of this form right here. I think it's just easier to work with this form. You are going to find your critical values. So you're going to replace this inequality symbol with equals. So we would have 2x minus 1, that quantity, times the quantity 3x plus 7. And we'll set this equal to 0. Let me slide this down and out of the way. So you would have 2x minus 1 is equal to 0. Or you would have 3x plus 7 is equal to 0. Let me get rid of this. Slide this up. So let me add 1 to both sides of the equation here. That would cancel. You get 2x is equal to 1. Divide both sides by 2. And you're going to get x is equal to 1/2. Remember, we found on the graph that x equals 1/2. That was the x coordinate from one of the x-intercepts. So when x is 1/2, we know y is 0. So let me get rid of this and drag this over here. And the other x-intercept, if we subtract 7 away from each side of the equation, we'll cancel this. We get 3x is equal to -7. Divide both sides of the equation by 3, and you're going to get that x is equal to -7/3. So we saw that point that was -7/3 for the x value, comma 0 for the y value. That was another x-intercept. So let me put x is equal to this -7/3. Okay. So we're going to use this to break our number line up into these regions. So you're going to take -7/3 and put that on the left. And then you're going to take 1/2 and put that on the right. You can get rid of this at this point. You don't need it anymore. And so you're going to say this is A, this is B, and this is C. Now we looked at the graph. And again, we found that anything to the left of -7/3 or anything less than -7/3 would work. And then we found that anything to the right of 1/2 would work. So we are expecting that things in region A would work, things in region B, right, between these two numbers, that's not going to work, and things in region C, that's going to work again. So let's come back down here and verify that. So in this particular case, if I think about -7/3, that's -2 1/3. So let's just pick maybe -3. So let's plug that in there and plug that in there. If you want to go faster here, you can just do a sign analysis. So 2 times -3 is going to be -6. And then -6 minus 1 is going to be -7. Let me write this over here. So this is -7. And then times over here, 3 times -3 is -9. And then -9 plus 7 is going to be -2. So a negative times a negative is a positive, right? So we know this would be true. This would end up giving me 14, and 14 is certainly greater than 0. So get rid of this, and you could say that this is true. And again, we saw that with the graph. So for things in B, they shouldn't work, right? So I would pick 0. It's really easy to work with. So if you plugged in a 0 there, and you plugged in a 0 there, you'd be left with -1 times 7, which is -7. A negative is never greater than 0, and it's not equal to 0, so things here are not going to work. So you could say this is false. All right, in region C, I would just pick 1. So let's plug that in there, and then there. So 2 times 1 is 2, and so I would have 2 minus 1, which is 1, and then times 3 times 1 is 3, and so 3 plus 7 would be 10. So a positive times a positive is a positive, and that's always going to be greater than 0. Or you can just say 1 times 10 is 10. 10 is greater than 0, so this is true. So to get my solution here, consider the fact that you have a non-strict inequality. So your critical values will be included because they will satisfy the inequality. You would have 0 is greater than or equal to 0 in each case, which is a true statement. So we would say that x is less than or equal to -7/3. And then or x is greater than or equal to 1/2. So exactly what we found from the graph. So let me grab this real quick, and I'm going to cut it away. And I'm going to come back up here and paste this in. And I'm just going to arrow over to this. So this is the first solution here. And now we have to figure out this one. And before we go any further, I just want to show you this graphically so we know what to expect. Once again, you can just type the left side into Desmos if you want to get a picture on your own. And basically what you're thinking about would be, what are the x values that are going to produce y values that are greater than 0. So you're looking for the graph to be above the x-axis, right? Because the x-axis, again, that's where y is going to be 0. So here, let me do this in a different color. This is an x-intercept. So we could say that this occurs at -1, 0. And then this is an x-intercept. So that would occur at 2, 0. Where is my graph above the x-axis? Well, anything that's going to be an x value that's less than -1 or to the left of -1, if you want to think about it that way, the y values are going to be greater than 0. So you could say here that x would be strictly less than -1. Remember, -1 is not going to work because this would make this 0. So 0 is not greater than 0. That would give you a false statement. So then you would say, or additionally, we could think about the x values that are greater than 2 or to the right of 2. And so those would produce y values that are greater than 0. You can see your graph is above the x-axis. So here we would say, or x is greater than 2. So this is what we would expect to find. So let's go ahead, and I'm just going to paste this in. Remember how you want to do this. If you have an absolute value expression involved in this problem, what you want to do is split this up into different cases. So first you want to say 2x minus 5. This is equal to 0 where? So I'm going to add 5 to both sides of the equation. I'm going to cancel this and say this is 2x is equal to 5. Divide both sides by 2, and you're going to get that x is equal to 5 halves. Okay, so if x is 5 halves or anything larger than 5 halves, then what I want to do is just drop the absolute value bars. Okay, so I just want this guy right here like this. Let me get rid of that. And then if x is less than 5 halves, what I want to do is drop the absolute value bars, but I want to replace it with its opposite. So the negative of 2x minus 5 like this, and then plus 4x squared, and then minus 2x, and then minus 13 is greater than 0. Okay, let me grab these both and come down here. I set up a little table already. Don't know if this is going to fit. So let me see if I can write it a little bit more neatly. So this one, I'm just going to distribute it. I know it's hard to read right now, but I'm going to write it out here. So negative of 2x minus 5, that quantity, that's negative 2x and then plus 5. And then you have plus 4x squared, and then minus 2x, and then minus 13 is greater than 0. Okay, let me get rid of this, and then let me write this one in here. So this one is 2x minus 5, and then plus 4x squared, and then minus 2x, and then minus 13 is greater than 0. Okay, remember how this works. You're going to solve this inequality, and you're going to think about, in this region, does that fit? Okay, so if you get something outside of that region, you have to reject it. So this one, I'm just going to simplify it first. So it looks like negative 2x minus 2x would be negative 4x. So let's write 4x squared minus 4x, and then you would have 5 minus 13, and that's going to be negative 8, and this is greater than 0. Okay, I'm just going to erase this and slide this up. Actually, instead of sliding this up, if you divide everything here by 4, you're going to have a much easier time working with this. So this would be x squared, and then minus x, and then minus 2, and that is going to be greater than 0. Okay, let me get rid of this, and let me copy this real quick. And I'm just going to paste this in here. So let me put a negative 1 in there. I'm just going to factor this to make it a little bit easier to work with. This is an x and this is an x. You need two integers that sum to negative 1 and have a product of negative 2. So you can go negative 2 and then positive 1. Okay, so I'm just going to say that this is the quantity x minus 2 times the quantity x plus 1 is equal to 0. And so you would say x minus 2, this factor here, is equal to 0, or x plus 1 is equal to 0. So this guy right here, you just add 2 to both sides, and you get x is equal to 2. Over here, you would subtract 1 away from each side, and you would get x is equal to negative 1. So let's put a negative 1 there and a 2 there. Let's get rid of this, and you can just test. We'll say this is A, this is B, and this is C. So if I plug in, let's say, a negative 2, let's try that for region A. Let's see what we get. So plug that in there and there. So negative 2 minus 2 is negative 4. And then here, negative 2 plus 1 is going to be negative 1. So negative 4 times negative 1, we know that's a positive. It would be a positive 4. And so that is going to be greater than 0. Right? So this is 4 is greater than 0, which is true. So we'll say this is true. Okay, so for region B, I would just pick 0. And obviously, that's not going to work. If you plug in a 0 there and you plug in a 0 there, you're going to get a negative times a positive, right? You'd have a negative 2 times a positive 1. That's a negative 2. And a negative is never greater than 0. And specifically here, you would say that negative 2 is greater than 0 is a false statement. Okay, so I'm just going to say this is false. Does not work. All right, for region C, you're going to see things work again. So let's pick 3. So put that in there and then there. So this would be positive and this would be positive. So a positive is always greater than 0. So this is true. But if you want to work this out, 3 minus 2 is 1. And then 3 plus 1 is 4. And of course, this would be 4. And 4 is obviously greater than 0. So it's a true statement. Okay, let's get rid of this. Now, the critical values don't work here because this is a strict inequality. If you plugged in a negative 1 or if you plugged in a 2, you would get 0. And 0 is not greater than 0. That's a false statement. So you would say that x is less than negative 1 or x is greater than 2. You have to make sense of this because, again, I'm in a region where x is strictly less than 5/2. So what you want to do, you can actually get rid of this. You don't need it anymore. You can say x is less than negative 1. So that's okay. Then you could say, or you're going to say x is greater than 2 and less than 5/2, right? Because you can only include things in this interval when you solve things this way. Okay, let me get rid of this. So this is what we call partial solution at this point. I have to look at this guy and then I'll try to merge the two. So for this one, it's going to simplify pretty nicely. 2x minus 2x, that's going to go away. So you're just going to have 4x squared, and then negative 5 minus 13 is going to be negative 18, and this is greater than 0. Let me get rid of this, and let me divide everything here by 2, just to make it a little bit simpler. So this would be 2x squared, and then minus 9 is greater than 0. Okay, let me get rid of this. And let's think about how we could solve this. So I'm just going to grab this and go to a different sheet. So the first thing I'm going to do is replace this inequality symbol with equals. So let's suppose that we had 2x squared minus 9 is equal to 0. We're going to add 9 to both sides of the equation. Get rid of that. You're going to get 2x squared is equal to 9. Let me actually erase things as I go. I'm going to divide everything here by 2. Cancel this with this. And you're going to get x squared is equal to 9/2. You're going to use the square root property here. So if x squared equals k, then x equals plus or minus the square root of k. So x here is equal to plus or minus the square root. I'm going to write this as the square root of 9 over the square root of 2. The square root of 9 is 3. So this would be plus or minus 3 over the square root of 2. So most people will, again, rationalize the denominator. So you multiply by the square root of 2 over the square root of 2. So this would be plus or minus 3 times the square root of 2 over 2. Okay, so those are the critical values. If I plug in 3 times square root of 2 over 2 in here for x, I would get 0. And of course, 0 is not greater than 0. Or if I plugged in the negative of 3 times square root of 2 over 2 in for x, well, then I'm going to get 0, and 0 is not greater than 0. Now, I'm going to put this here. So negative 3 times square root of 2 over 2. And I'm going to put this here, 3 times square root of 2 over 2. If we were solving this as a regular quadratic inequality, then you would need to set up a, b, and c. But here I actually don't need to do that because I'm only working in the interval where x values are greater than or equal to 5/2. This guy right here, if you think about it, is about 2.12, let's say. So really, I could just check things in this region and see if they work. If they do, what I'm going to do is say that that part of the solution is x is greater than or equal to 5/2. So let's just go ahead and check things here. You could pick something like, let's say 3 if you wanted to. So I would have 2 times 3 squared, and then minus 9 is greater than 0. So 3 squared would be 9. So this would be 2 times 9 minus 9 is greater than 0. 2 times 9 is 18, so 18 minus 9 is greater than 0. And this would be 9 is greater than 0, which is true. So I can say that x values that are greater than 3 times square root of 2 over 2 will work in this inequality. Again, you don't need to check this and you don't need to check this because no matter what you get, it's irrelevant to what you're working on. So let me come back up and I'm going to put x is greater than 3 times square root of 2 over 2. And I'm going to merge that with the fact that this is only valid for x values that are greater than or equal to 5/2. So this right here, this 3 times square root of 2 over 2, this is less than 5/2. So what I'm going to actually do is just say, well, this is x is greater than or equal to 5/2. Let me get rid of this. And let me move this over here, okay? So now you're going to merge these two solutions here using the keyword or, okay? So I'm going to say or like this. And basically what that is going to give me is that x is less than negative 1, then or you would have that x is greater than 2, right? Because here x is greater than 2 and less than 5/2, But then you have the keyword or here that connects this one, where x can be 5/2, so that includes that value, or anything larger. So basically you would say x is less than -1 or x is greater than 2. So let me go ahead and grab that real quick. And I'm just going to revisit this where we started, where we said we would expect x is less than -1 or x is greater than 2. So we found that. Let's come back up. All right, let me paste this in here. And I think for the purposes of what we're going to do, I'm just going to work with the solutions. And this is really not that bad. You're using the keyword and to combine things. So first I would think about this in terms of what are my less than statements telling me? So this is a less than or equal to, and this is a less than, but you're thinking about x values going to the left. So what's the most restrictive? Where you're looking for the guy that's the most to the left or the most negative here, because you have an x that is less than or equal to -7/3. Is -7/3 further to the left than -1? Yes, right? So you want to pick the one that is most restrictive so that it covers both of them, because it has to work in both. So I'm going to say that this is x is less than or equal to -7/3. So let me put that like that. Then I'm going to go or. When I think about these greater than statements, you have an x is greater than or equal to 1/2, and then you have an x is greater than 2. Again, if I want it to work in both, I need something that's the furthest to the right. So the bigger number, 2 is bigger than 1/2, so I'm going to use x is greater than 2 here. Okay, so this is what I'm looking for. So I'm just going to grab this. We'll come all the way back up here. So we're ready to write our domain. So the domain is the set of all x such that x is less than or equal to -7/3. Then or x could be any value that's greater than 2. Okay, if you want to write this in interval notation, we'll go ahead and say that coming from -infinity, going up to and including -7/3. So you want a bracket here. And then the union with, it could be anything larger than 2. So 2 would be excluded, anything going out to positive infinity. All right, let's verify what we found algebraically using our graph. So when we look at our graph, again, you can get this on Desmos, y equals the square root of 6x squared plus 11x minus 7. This would be over your square root of the absolute value of 2x minus 5, then plus 4x squared minus 2x minus 13. So we can see that over here, this point is going to be -7/3, comma, 0. So -7/3 is okay for x, and then any value that is to the left of that, or you could say less than that, that would work. Then you can see that there's really no x value here up until we get to a value for x that's greater than 2. 2 itself is going to be excluded. We have a vertical asymptote at x equals 2. So this graph will approach where the x value is 2, but it's never going to actually get there. So we can see that x can be anything that's greater than 2, but not 2 itself. So this verifies the domain. We have the set of all x such that x is less than or equal to -7/3. So anything here are going to the left, or x could be any value that is greater than 2. All right, let's take a look at problem 10. So here we're going to have y is equal to the square root of 35x squared minus 58x minus 9. This will be over the square root of x squared minus 2x plus 1. Okay, so once again, I'm thinking about this square root operation in the numerator, and the radicand here needs to be non-negative. So I would write that 35x squared minus 58x minus 9 needs to be greater than or equal to 0. So we need to solve that. Let me grab this real quick, and I'm just going to paste this right here. Let's go back up and think about the other part here, which is in the denominator. You have a square root operation, so the radicand is x squared minus 2x plus 1. So again, this needs to be non-negative, so let me first start by saying x squared minus 2x plus 1 is greater than or equal to 0, but we're in the denominator here. So if this was equal to 0, you'd have the square root of 0, which is 0, and you can't have division by 0 that's undefined. So you want to tighten that up and say it's strictly greater than 0. Okay, so let me get rid of this, and let me grab this and come down here. I'm going to write the keyword and then I'm just going to paste that in. This one's really easy to solve. The left side here is a perfect square trinomial. We'll do that one last. Let's do this one first. It's a little bit more challenging, so let me grab it, and let's paste this in real quick. Again, you can go to Desmos or whatever online calculator you want to use. Just type in the left-hand side here. So you can go y equals, or you can leave it off and just put 35x squared minus 58x minus 9. So just the left side, okay? Don't put this in. So you're going to produce this graph, and what you're looking for are the x values that are going to produce y values that are either 0, so that means you're on the x-axis, or greater than 0. So that means your graph is above the x-axis, right? That's where your y values are greater than 0. So thinking about on the x-axis itself, the x-intercepts, this point right here is hard to tell because we have some decimals involved, but this is going to be -1/7. So -1/7 and then comma 0. So that's an x-intercept. And this x-intercept here, this is going to be 9/5 and then comma 0. Let me make this a little bit better here. Now, you can tell that basically any x value that's to the left of -1/7, or you could say less than -1/7, is going to work, right? So the y values there, they're going to be greater than 0. Your graph is going to be above the x-axis. Additionally, you can see that x values to the right of 9/5, or you could say greater than 9/5, that's going to work as well, right? So the y values there are going to be greater than 0. Your graph is going to be above the x-axis. So I can already give myself a little solution here. I can say that x could be less than or equal to this -1/7, or x could be greater than or equal to this 9/5. So this is what we're expecting to get. So let me go ahead and grab this real quick and come down here, and we'll just slug it out and do this the algebraic way. I know a lot of people don't like this, but I think it's good to get some practice. Okay, the first thing I'm going to do here is just factor the left side. So really this is not that bad, although it looks kind of terrible. So for 35, you either have 1 times 35. That's unlikely to work, so I wouldn't start there. And then you have 5 times 7. Now, I've already factored this, so I know that 5 times 7 works. But again, if I hadn't factored it, I would start with 5 times 7. So I'm going to go 5x here, and then 7x here. And then I need to think about this position and this position. Now, this right here is a minus, okay? So if the final guy is a minus, that means I have different signs. And when I work things out, I'm going to imagine that this is positive, and I'm going to do a subtraction. So with 9, again, forget about the fact that's negative. I'm going to think about 1 times 9 or 3 times 3. If I use 3 times 3, it's really easy to check. You just put that in there, and you really can't alternate that because it's the same number. Well, when you go to the outer and the inner, again, you want to subtract things. Let me just show you. So 5x times 3 would be 15x. And then 3 times 7x would be 21x. Just think about a subtraction. It doesn't matter what the signs are going to be. Just think about a subtraction. 21x minus 15x would be 6x. And so this isn't going to work, right? You need negative 58x. So let's get rid of this and get rid of this. So it has to be 9 and 1. Now, just for the sake of going through everything, let me put the 9 here and the 1 here. This isn't going to work, but we're just going to go through it. So this right here would be 5x times 9, that's 45x. And this right here would be 1 times 7x, that's 7x. Again, do a subtraction because you're going to have different signs. So 45x minus 7x, that's going to be 38x. So we know this isn't going to work. Okay, get rid of this, and I'm going to switch this up. And now it's going to work. So this right here is going to be 5x, and this right here is 63x. So again, you always want to think about if this is a negative here, do a subtraction and see if you can get to this guy in terms of absolute value. So 63x minus 5x would be 58x. Forget about the fact that it's negative. We don't care about that right now. We can make the signs work by putting a plus here and then a minus here. So the end result here would be 5x, and this would be negative 63x. And then negative 63x plus 5x would give you that negative 58x. Okay, so we found our correct factorization, and now we're pretty much ready to roll. Let me get rid of this. We don't need it anymore. And so I'm going to go 5x minus 9, that quantity, times the quantity 7x plus 1 is equal to 0. Let me slide this down here and out of the way for a second. So we are going to solve 5x minus 9 equals 0, and then or 7x plus 1 equals 0. Let me get rid of this. And this one, I would add 9 to both sides. That would cancel. You get 5x is equal to 9. Divide both sides by 5, and you get x is equal to 9/5. So let me get rid of this. And let me put 9/5 here. And then I'm going to subtract 1 away from each side here. This cancels. We're going to have 7x is equal to negative 1. Divide both sides by 7. You're going to get x is equal to negative 1/7. Okay. Let me get rid of this. And now we can set up some intervals. So A, B, and C. If we go back to what we looked at, we know that in region A, it's going to work, right? So anything that's to the left of negative 1/7, right? Negative 1/7 works, but don't worry about that for right now. Region B, so that's between negative 1/7 and 9/5, that's not going to work, right? These y values are going to be less than 0, right? The graph is below the x-axis. And then in region C, it's going to work again, right? So this is anything that's greater than 9/5. So let's come back down. We know what we should expect. And we're just going to pick some values. So for A, let's pick -1. I think that's easy to work with. And plug that in there and there. So 5 times -1 is -5. And then you'd have -9. And so -5 minus 9 is going to be -14. So this would be -14. And then times 7 times -1 is -7. And then -7 plus 1 is going to be -6. So again, this is a negative times a negative, which is a positive. We don't actually care what the result is because a positive is always greater than 0. So you can just say this is true. Just in case you wanted to know, you could punch that into your calculator and you would get 84. Okay, so 84 is clearly greater than 0. So let's get rid of this. All right, in region B, I'm just going to pick 0. It's very easy to work with. And very quickly, you can see this isn't going to work, right? So you basically have -9 times 1, which is -9. And then -9 is a negative number. So it's not greater than 0. It's certainly not equal to 0. So this is going to be false. Okay, for region C, let's just go ahead and pick 2. I think that would work out pretty nicely. So let's plug that in there and there. So 5 times 2 is 10. 10 minus 9 is 1. So this would end up being 1 over here. And then 7 times 2 is 14. 14 plus 1 is 15. So you'd have 1 times 15, which is 15. Of course, it's a positive number, so it's greater than 0. So this is true. Okay, let me get rid of this. And let's go ahead and write our solution. So because we have a non-strict inequality here, -1/7 and also 9/5 will work. Because again, in either case, you'd have 0 over here. And if you get 0 is greater than or equal to 0, that's a true statement. So let's go ahead and say that x is less than or equal to -1/7, or x is greater than or equal to 9/5. And that's exactly what we found from the graph. So let's go ahead and grab this real quick. And let me slide this down here. And I'm just going to paste this in. And actually, you can get rid of this and just keep this solution here. I'm going to look at the solution for this. So let me cut this away. And I'm just going to come down here. You really don't have to do much work for this one. As you can see, when you think about this, if this was a greater than or equal to 0, then the answer would be all real numbers, okay? And the reason for that is very simple. If you factor this guy, this is a perfect square trinomial, so it factors into a binomial squared. This is going to factor into x minus 1 quantity squared. If you said, where is this greater than or equal to 0? Well, this is true for all real numbers. And that's because of this squaring operation right here. So it doesn't matter what you plug in for x, you subtract away 1. Once you square it, if it's a negative, it becomes a positive. If it's 0, it stays 0. And basically, if it's a positive, it stays positive. So no matter what you plug in there, it will always be either 0 or some positive number. So it will always be non-negative. And you can see that from the graph. The problem is we don't actually have that. We have a strict inequality here because this guy right here was the radicand for your square root, and that was in the denominator. So it can't actually be greater than or equal to 0. It has to be greater than 0 so we can avoid division by 0. So what we actually have to do is just think about where this guy would be 0, and you can see that's going to occur when x is 1. So 1, 0, basically that is your x-intercept there. So you could think about this as just saying, let me go back to the x minus 1 quantity squared. Where is that equal to 0? Well, by the square root property, you could say that x minus 1 is equal to plus or minus the square root of 0. And of course, the square root of 0 is 0, so you can get rid of the plus or minus. So you get x minus 1 is equal to 0, add 1 to both sides of the equation, and you get x is equal to 1. So this is the only value for x that is going to make this guy a false statement. Any other value for x, a negative value, 0, a positive value, whatever you want, if you plug it in, you're going to get something that's greater than 0. Only at x equals 1 will you get a value of 0. And again, you can see that from the graph. So what I would say for this one, to solve this, is to say that x is less than 1 or x is greater than 1. Kind of a weird way to write that, but basically you're saying that x could be any value less than 1 or greater than 1, so it can be anything except 1. So let me grab this, and let's come back up here and put these two together. Okay, so I'm just working on these two solutions, and I have my keyword and. So I'm just going to think about the less than statements first. So here you have x is less than or equal to -1/7, and here you have x is less than 1. So you got to think about which one's going to be more restrictive. Which one, in terms of these values, either -1/7 or 1, is furthest to the left? Well, this one is because it's a negative value. So in my answer, I want to put x is less than or equal to -1/7. Then I'm going to put or. Think about these two greater than statements. So x is greater than or equal to 9/5, and then x is greater than 1. which one is the furthest to the right now? So which number is going to be bigger? That's going to be the more restrictive value. So I'm going to go ahead and say that it's going to be 9/5 because that's 1.8 as a decimal. So I'm going to put x is greater than or equal to 9/5. So you're basically taking this solution here from the first inequality that we solved. So let me go ahead and grab this, come back up and paste this in. Let me slide down here and we'll write our domain. So the domain is the set of all x such that x is going to be less than or equal to -1/7, or you can also have x as greater than or equal to 9/5. Okay, let me close that down. And we'll bring this up here. And basically at this point, you could write it in interval notation. So coming from -infinity, going up to and including -1/7. So I want a bracket there. And the union with, you're going to include 9/5. So I put a bracket there. And then going out to positive infinity. All right, let's confirm what we did using a graph. So here we have y is equal to the square root of 35x squared minus 58x minus 9. This is going to be over the square root of x squared minus 2x plus 1. So looking at the graph, you can see that this point right here, this is an x-intercept, and it occurs at -1/7, comma 0. So we can see that that value is included, and then anything to the left, or you could say anything less than that. So that's this part right here. X is less than or equal to this -1/7. Then over here you have this guy, another x-intercept. So that occurs at 9/5, comma 0. So 9/5 is included as an x value, and then anything to the right, right? So this part right here is x is greater than or equal to 9/5. So this verifies what we found. We could say our domain is the set of all x such that x is less than or equal to -1/7, or x is greater than or equal to 9/5. All right, let's take a look at the practice test. So here for the instructions, we're asked to determine if each relation is a function. So what I'm going to do here for each problem, I'm going to give you a relation, and then I'm going to show you the graph, and you can generate this graph on your own, or you can go to an online calculator like Desmos and just type it in. And then we're going to use the vertical line test to determine if we have a function. So essentially with the vertical line test, you're seeing if any vertical line would impact the graph in more than one location. If it does, well, then you don't have a function, right? Because again, for a function, you have each x corresponding to or linked up with one y. If a vertical line, so x equals some number, if that impacts the graph in more than one location, well, that given x value is going to be associated with more than one y value, and you don't have a function. So let's start off with problem 1. So here we have y is equal to -1/2 x plus 2. So I'm just going to give you the graph, and that's going to be this guy here. And obviously you can see that no vertical line would impact the graph in more than one location. So you can just say that this is a function. Okay, and I can draw a few vertical lines just for the sake of completeness. Let me just draw 3 of them. So you can see that each line I've drawn would impact the graph in only one location. Okay, and that is what we want for a function. So for each x, there's only one y. All right, let's take a look at problem 2. So here we have the absolute value of y is equal to x plus 2. So looking at the graph, we immediately see we would have a problem. Let me just draw a few vertical lines here, and we can analyze what's going on. So this line here, let's say this is x equals -1. Basically, when you look at it, this vertical line impacts the graph here and also here. So this point right here is going to be, let me arrow to it, -1, (1). And this point right here is going to be -1, (-1). So let's go back up. So we have -1, (1), and then -1, (-1). So if I plug in a -1 for x, so we have the absolute value of y is equal to -1 plus 2. So -1 plus 2 would be 1. So if I said the absolute value of y equals 1, well, yeah, y could be 1 or y could be -1. Think about it. If I plugged in a 1 there, the absolute value of 1 is equal to 1, right? This is 1 equals 1. That's a true statement. If I plugged in a negative 1, the absolute value of negative 1 would also be 1, so 1 equals 1, that's a true statement. So for each x, there's not one y, right? So for this x value of negative 1, there's a y value of 1, and then also a y value of negative 1. So this is not going to be a function. Let's come back down here, and let's put not a function. And you can look at this other vertical line. So let me change colors here. So it impacts the graph here and here. So this line is going to be x is equal to 2. So this point right here is 2, 4. Let me arrow to this in a different color. So this is 2, 4. And then this point right here is 2, negative 4. So again, that same x value of 2 is associated with a y value of 4 here and a y value of negative 4 here. Again, going back, let's put 2, 4, and then 2, negative 4. And again, it's just because of the absolute value operation. If you plug in a 2 here, 2 plus 2 is 4, so you would get the absolute value of y is equal to 4. Well, that would be true if y is 4, because the absolute value of 4 is 4, or if y was negative 4, because the absolute value of negative 4 is also 4. So the absolute value operation is what's causing this. So we could just come back here again and just say it's not a function. For each x, there's not one y. Okay, let's take a look at problem 3. So here we're given y is equal to the quantity x minus 6 squared plus 1. So this graph would be a parabola. And so looking at this guy, you would see that no vertical line would impact the graph in more than one location. So you can immediately say that this is going to be a function. And let's go ahead and let me draw a few vertical lines for you, just for the sake of the tutorial. And I think that's good. You can see that no matter how you draw these vertical lines, you're only going to impact the graph in one location. So there, and then this one would be here. Again, you can draw as many as you want. It would only impact the graph in one location. So this is the graph of a function. All right, let's take a look at problem 4. So here we have y equals x cubed minus x. So looking at my graph, I can clearly see that, yes, this is going to be a function. And this one, you might want to graph on your own with Desmos or something like that, but you can see that no vertical line would impact this graph in more than one location. Let me make a few of these here. Let me do one here. So let's say that that's going to hit right there. So only in one spot. Let me do one right there. So that's only going to hit there in one spot. You could do another one maybe right here if you want. And that's only going to hit in one spot. And I'll just do one last one like this. And that's only going to hit right there. So you can see that each vertical line we draw only impacts the graph in one location. So for each x, there's one y. So this relation is a function. All right, let's take a look at problem 5. So here we have the quantity x plus 2 squared plus y squared is equal to 36. Now, most of you realize that this is the equation of a circle. Remember, it's x minus h quantity squared plus y minus k quantity squared is equal to the radius squared. So this circle right here would have a center at negative 2, 0, right? Again, if you put a minus a negative 2 there, that's the same as plus 2, right? So you could write this as x minus a negative 2, quantity squared, plus you could go y minus 0, quantity squared, is equal to, for the radius, it would be 6, right? So 6 squared. So this is the same as this. I'm just writing it in this form so we can extract the information. So the center here would be negative 2, 0, and the radius would be 6. So again, I've already prepared the graph, so we can just come down here. You see your center is at negative 2, 0, and again, your radius is 6. So from here, I would go 1, 2, 3, 4, 5, 6 units to get to a point. Again, I could go up 6 units or to the left 6 units or down 6 units, I would get to a point. All right, so looking at this, clearly it is not a function, right? So basically for each x, there's not one y. So let's look at the vertical line x equals negative 2. And you see it impacts the graph here and also here, right? So that violates the definition of a function. So let me arrow to this and say, this is negative 2, 6. And then down here, this is negative 2, negative 6. So basically, this is not a function, not a function. If you go back up and you plug in a negative 2 for x, let me get rid of this. So let's say I plug in a negative 2 here. Well, negative 2 plus 2 is 0, right? So basically, you'd have 0 squared, which is 0. So what you're left with at that point is y squared is equal to 36. Well, this guy right here, if I solve for y using the square root property, well, y is equal to plus or minus the square root of 36. So the square root of 36 would be 6, so y equals plus or minus 6. because 6 squared would give you 36, but also negative 6 being squared would give you 36. So that's why we don't have a function, right? For each x, there's not one y. Here for an x value of negative 2, we get two different y values of 6 and then negative 6. So coming back here again, we can say this is not a function. All right, let's take a look at the practice test. For the first problem, we're asked to find f of 1, f of 9, and f of 2. So let's go down here and look at what we call a mapping diagram. So if you're studying functions for the first time, you'll probably see something like this. Basically, what this is giving us is a visual representation of the typical function that you're going to see, where it's just a set of a few ordered pairs. On the left side here, you see that we have the x values or the members from the domain. And then on the right side here, we're going to have the corresponding y values or members from the range. So the way this works out is you have an x value of 1 that is linked up with or corresponds to a y value of 3. So let me write this as a set of ordered pairs, so this is crystal clear. So the first value here when you write an ordered pair is the x value, and then the second value is the y value. So it goes like this, x, comma, y. So here the x value or member from the domain is 1, and the associated y value or member from the range is 3. So this would be 1, comma 3. So let's put that in, 1, comma 3. And we're just going to move down and do this for the rest of them. So this would be 5 for the x value. The associated y value would be 20. Then you would have 7 for the x value. The associated y value would be 14. And then you would have 9 for the x value. The associated y value would be 19. And then you would have 11 for the x value. The associated y value would be negative 2. And then you would have 2 for the x value. And the associated y value is negative 4. Okay, let me close that down. And I'm just going to grab this real quick and come back up here. I think these problems are a little bit easier to answer if you have them written as a set of ordered pairs. You can always go off the mapping diagram if you want. So the first thing we're asked to find is f of 1. So what exactly does that mean? It means if the independent variable, which is x in most cases, is replaced with a 1, what is the function's value? So all you have to do with this simple problem is look for a 1 as the x value, so that occurs right there. You just say, okay, well, what's the function's value or the y value in that case? Well, it's going to be 3. So what I would do to write this as my answer is I would say f of 1 is equal to 3. So what's the function's value when x is 1? Well, it's going to be 3. Now looking at f of 9, all I'm going to do is look through here for an x value of 9, just so you see that's there. So what's the associated y value? Well, that's going to be 19. So coming back through here, let's say that f of 9 is going to be 19. And then we have one more to do. It's f of 2. So looking for an x value of 2, that's going to be right here. And then again, the associated y value is going to be negative 4. So let's go ahead and say that f of 2 is going to be negative 4. So f of 1 is 3, f of 9 is 19, and f of 2 is negative 4. All right, for problem 2, we are asked to find f of negative 3, f of 1, and f of 5. Let me write this out. So f of negative 3, we want f of 1, and then we want f of 5. So let's come down here real quick. And what we have is a little graph. And if we ask for f of negative 3, again, we are asking for the function's value when x is negative 3. So what you want to do if you get a graph like this, just go on the x-axis to that value given. In this case, it's negative 3. So I'm going to go right here. And then I'm going to look at that point. So that's going to be right there. So here the x value is negative 3 and the y value is positive 3. So the ordered pair is negative 3, comma 3. So that means f of negative 3 is going to be 3. Now the other one, let me go back up. I'm going to put this as 3. We wanted f of 1. So let's come back down here. So f of 1 is equal to what? Again, just go on the x-axis to a value of 1. So here's a value of 1. I'm going to go down to this point right here. And that is the point 1, comma negative 1. So when x is 1, y is going to be negative 1, or you could say the function's value is negative 1. So let's put a negative 1 there. Come back up here. F of 1 is negative 1. And we want f of 5. So let's come down here. I'll put f of 5. That equals what? So let's come over here and look for an x value of 5. So that's going to be right here. We're going to go up here. That's going to be right there. So that point is going to be 5, comma 3. Okay, so 5, comma 3. So when x is 5, y is 3. So let's put a 3 there and come back up here and say that this is going to be a 3. So f of negative 3 is 3. f of 1 is -1, and then f of 5 is going to be 3. All right, let's take a look at problem 3. So here we're asked to find f of -2 and f of 2. So for f of -2, all I'm doing is I'm plugging in a -2 everywhere there's an x. Now, something that comes up when you do this, whenever you plug in something for a variable, my recommendation is to keep things straight, always wrap it in parentheses. So in other words, I am plugging in for x there and x there, just wrap it in parentheses. So I want a -2. That's my x value that's given. I want to plug that in for x there, and I'm going to wrap it in parentheses because the negative and the 2 both need to be squared. Okay, if you just do it like this and you square it and you put it in your calculator, it's going to give you -4 because of the rules that are associated with this. Okay, remember this is -1 times 2 squared, which is -1 times 4, which equals -4. Again, if you're a little bit confused by that, you can just punch that into your calculator. To keep that from happening, you always want to wrap these guys in parentheses. Now your calculator is going to correctly give you +4. Okay, so then -3 times, you want to put in a -2 there, and then -5. So we're just going to go through and do the calculations here. So this equals -2 squared, again, because this is wrapped, this is -2 times -2, which is 4. And then basically you can go plus negative here. -3 times -2 is 6. So this is +6. And then you have -5. So 4 plus 6 is 10. 10 minus 5 is 5. So this equals 5. Let me get rid of the intermediate steps here and just say f of -2 is going to be 5. Okay, now let's do f of 2. Again, I'm going to plug in here and here. So we'll say f of 2 is equal to, you can again wrap this. It's just a good habit to get into so you don't make sign mistakes. So 2 being squared like this, and then -3 times 2, and then -5. Again, you can go plus negative here if you need to. So let's come down here a little bit and say that 2 squared would be 4. And then -3 times 2 is -6. So you can write plus -6 or -6, whatever you want to do. And then you have -5. So the way I would do this, let me go plus negative here and plus negative here. -6 plus -5 is -11. So you have -11 plus 4, which is going to be -7. So let me get rid of this and just say that my f of 2 is -7. All right, let's take a look at problem 4. So here we want to find f of 1 and f of 6. So let's slide down here. Let's start with f of 1. So this is going to be equal to 1 over, again, everywhere there's an x, you're going to plug in a 1. So I like to wrap this inside of parentheses. Again, when I get negative values, it's going to help to not make sign mistakes. So then -5 times 1, and then -6. Let me extend that a little bit. So 1 squared is obviously 1. So let's put this as a 1. And then you can go plus negative here if it helps you. -5 times 1 is -5. So you can put -5, or you could put plus -5. Let me go plus negative here and plus negative here. So -5 plus -6 is -11. So let me just put this as 1. You can go plus -11, or you can go 1 minus 11, whatever you want to do. 1 plus -11 is going to be -10. So this right here, I will just write as -1 over 10. So that right there would be f of 1. Okay, the other guy, let me slide back up. We wanted to find f of 6. So f of 6 is equal to, again, you have 1 over, let me write this out. So x squared minus 5x minus 6. And let me slide down here. I'm not going to be able to fit everything on the screen. So everywhere there's an x, we're just going to plug in a 6. So you're going to plug in a 6 there, and then you're going to plug in a 6 there. So do you see a problem? Well, if you had factored this, x squared minus 5x minus 6, this equals what? Let me slide down here a little bit more. Well, this is an easier scenario. So you can put an x here and an x here. Give me two integers that are going to sum to -5 and have a product of -6. Well, if you think about it, you could do -6 and then +1, right? So this would give me x squared. My outer would be x. My inner would be -6x. So -6x plus x would give me the -5x in the middle. And then -6 times +1 would give me -6. So if you think about plugging into this form, 6 minus 6 would give me 0. And 0 times anything, no matter what this is, it's going to be 7, but 0 times anything would give me 0. So plugging in a 6 in the denominator is going to give me division by 0, right? So we can see this is going to be undefined from the factored form. But let's just go through this and see what we get. So 6 squared is 36. And 5 times 6 is 30. And so what happens is you can say this is negative 30 plus negative 6, which is negative 36. So you get 36 plus negative 36, which is 0. So you end up with 1 over 0, which is undefined, right? So I would just erase this, and I would come back up here and just write that this guy is going to be undefined. All right, let's take a look at problem 5. Here we want to find f of 10 and then f of negative 2. So let's start with f of 10. So this equals the square root of, you would have 3 times, again, plug in a 10 for x, then plus 6. So 3 times 10 is 30. So this basically is going to be 30 plus 6, which is 36. And this is the principal square root of 36, which is going to be 6. So f of 10 would be 6. The other guy was f of negative 2. So f of negative 2. So this equals, let me just write this out because it's going to get cut off. So the square root of 3x, I'll just put some parentheses here and put negative 2 in for x, and then plus 6. Okay, let me slide down. So this would be equal to what? 3 times negative 2 is negative 6. And then negative 6 plus 6 is 0. Now we can take the square root of 0. It's just going to be 0. So f of negative 2 is going to be 0. All right, let's take a look at problem 6. So here we want to find f of a and f of a plus 1. So these are the problems that really start to give people issues. What happens is if you're used to plugging in a number, it's really not that big of a deal. So let's say I wanted f of 1, and this equals, well, everywhere there's an x, I'm just going to plug in a 1. So this is 1 squared, just plugging in a 1 for x, minus 2 times 1, again, plugging in a 1 for x, then minus 1. This is really easy to do. 1 squared is 1, and then basically 2 times 1 is 2. So you have 1 minus 2 minus 1. Well, 1 minus 1 is 0, so you can get rid of that. And you see f of 1 is negative 2. Well, if I asked you for f of a, so let's say I wanted f of a, well, when I had f of 1, I just plugged in a 1 everywhere there was an x. So for f of a, I just plug in an a everywhere there's an x. So right there, and then right there. In this case, you really don't need parentheses. You can do it just so you form the habit. So a squared like this, then minus 2 times a, then minus 1. You'll see on the next one you do need parentheses. So I just like to do it with students so that they form the habit. So this is just a squared. You can just drop the parentheses. This is minus 2 times a. You can drop the parentheses and then minus 1. You really can't make that any simpler. So this is just how I would give my answer. When you get into f of a plus 1, this is where it gets a little bit more complicated. Let me slide down a little bit. Now you have to make sure that you're using parentheses. So you're plugging in for x there and x there, but you're plugging in this quantity a plus 1. So you want the quantity a plus 1 to be squared. Okay, so that's very important to wrap that with parentheses. Then minus 2 times the quantity a plus 1. Okay, so this has to get multiplied by this entire thing. If you don't put parentheses there, you're going to get the wrong answer. This would be negative 2 times a, then plus 1. So that's different from negative 2 times the quantity a plus 1. Then you have minus 1. So we have to simplify this. So what I'm going to do is first use my special product formula, where basically this quantity here, this binomial, is going to be squared. So this is going to be the first guy squared, so a squared, plus 2 times the first guy times the second guy. So 2 times a times 1. 2 times 1 is 2, then times a is just 2a. So let's write 2a, and then plus the last guy squared, so 1 squared is 1. Then this guy, what I like to do is go plus negative here, and then just distribute that negative 2 to each guy inside. So this would be negative 2 times a, that's going to be negative 2a or minus 2a. And then negative 2 times 1 is going to be negative 2, so let's put minus 2, and then you have minus 1. Okay, from here, you're just going to simplify. So you have an a squared. There's nothing you can really do with that, so a squared. You have 2a, and then negative 2a. So those are going to cancel. So you could line them out if you want. Then here you have 1 and a negative 1. So those are going to cancel. Let me line those out. And you're just left with this negative 2. So you have a squared minus 2. And that would be your final answer for f of a plus 1. All right, for problem 7, we're asked to find f of z minus 1 and f of z squared. So I'm going to actually do this in the reverse order because this one is a lot easier to work with. So let me start with f of z squared. So again, all I'm doing is I'm plugging in a z squared for the x. I would wrap this with some parentheses, and let me put my exponent of 3 up here. So again, z squared is getting plugged in right there. So this is z squared going there, then plus 2. So all you have to do at this point is simplify. And to do that, you use your rules of exponents. Here you have the power to power rule. So z squared is cubed. Z stays the same. You multiply exponents. So 2 times 3 is 6. So this is z to the 6th power, then plus 2. So this is a z and this is a 2. I know I don't have the best handwriting. So this is z to the 6th power plus 2. Let me actually get rid of these steps here and just put our answer like this. And I'm just going to slide this down. Okay, the next one is going to go off the screen because it's going to be very tedious. So let me actually write that we want f of z minus 1. And let me put this as equal to. For my x, I'm just going to put some parentheses in because we're going to plug in for that. And this is going to be cubed and then plus 2. So let me slide down here a little bit because we're not going to keep this on the screen. Again, we're plugging this z minus 1 in for where x was. So let me write z minus 1 in there. Now, what makes this problem a little bit complicated, you're going to take this binomial, this z minus 1, and you're going to cube it. Let me do that off to the side here. And before I do that, let's go back to the formula we learned a long time ago. So you can go x minus a, or you can go x minus y, whatever you want to use. And I'm going to go quantity cubed. This is equal to what? The way I remember this is that you have 4 slots. So 1, 2, 3, and then 4. All right, now because we have a minus sign here, what's going to happen is the signs are going to alternate. So you can think about this as being positive, and then negative, and then positive, and then negative. Now, these signs in your end result can change based on what you're plugging in, but when you set up the formula, this is how you want to do it. Now, the next part's pretty easy. For the first position and the last position, you just go into your binomial and you say, okay, the first guy cubed is what's going here. So this is x cubed. Then you want the last guy, forget about the sign, that's already taken care of with these guys. Just take the last guy here and cube it. So a cubed. Now, for the middle guys here, this is where it gets a little bit complicated to remember. So you always want to put a 3 here and a 3 here, okay? And then what goes here is you're going to go into your guy and you're going to square one of them and you're not going to square the other one. So you're multiplying them together. One is squared, one is not. So here, what I would do is I would square x and not square a. So basically ax squared. Then here, what I would do is not square x and square a. So let's say a squared x. And that's the pattern. All right, let me slide this down a little bit. Let me get rid of that and get rid of that and put my border back in. And you're just going to match things up. So let's say this equals, for this guy right here, again, you're going to have this pattern where you have 1, 2, 3, 4. And then let me put the plus 2 out here. So you know that the signs are going to alternate. So you're going to have a plus, a plus, and then a minus. You know that you're going to take the first guy and cube it. So z cubed is z cubed. The last guy, forget about the sign, you're going to take 1 and cube it. 1 cubed is 1. You could write 1 cubed there for clarity for right now if you want. And then, again, in this position, you start out with a 3. So you're going to put a 3 here and a 3 here. And then you take each guy and you multiply them together, but one's squared and one's not. So the first time through, let's square z and let's not square 1. So you'd have z squared times 1, which is just z squared. And then the second time through, you would square 1, but not square z. So 1 squared is 1, and then times z is just z. Now, if this is too confusing for you, you could just take this, and you could substitute. So I could just change this over to z minus 1 like this. And so everywhere there's an x, I just plug in a z. So there, and then we would do that there, and then we would do that there. And then everywhere there's an a, just plug in a 1. So here you can just erase it. Here you can just erase it. And then here, 1 cubed would be 1. And let me change this 1 cubed into a 1. And everything matches up. So z cubed minus 3z squared plus 3z minus 1. So if you're having trouble, you can just plug into the formula that you've memorized. You could also expand this if you needed to. Okay, so lots of ways to do it. I know it's a very tedious thing and hard to remember, but what we need to do now is just simplify. So what we have is z cubed minus 3z squared plus 3z minus 1 plus 2. So let me write z cubed minus 3z squared plus 3z. And really all you can do is say negative 1 plus 2 is going to be 1. So then plus 1. So this would be my f of z minus 1. All right, let's take a look at problem 8. So here we want to find f of q minus 3 and f of q cubed. So let's look at the first one. So f of q minus 3. So this equals the cube root of, again, for x, just plug in a q minus 3. You could wrap this in parentheses, but here I don't think it does you any good. And then you just have plus 7. Okay, can you simplify this? No. So this is as good as you can do. The next guy is f of q being cubed, and this equals, you would have the cube root of, again, for x, I'm plugging in a q cubed, and then you have plus 7 here. Well, here, the cube root of q cubed is q. So I can say that this is going to be q and then plus 7. So that would be my final answer, just q plus 7. All right, let's take a look at problem 9. So here we want to find f of negative 7 and f of 3. We are given 3x minus 5y equals 20. So this might look a little bit odd because if you're in this section, you're typically seeing f of x equals some expression. In this case, we have the function in implicit form. So what we actually have to do is solve for y first, then replace y with f of x, and then we can go ahead and do f of negative 7 and f of 3. So we're going to solve for y. That means, again, isolating y on one side. So what I would do is just copy this. So 3x minus 5y equals 20. I'm going to grab this real quick. Let me erase this. Let's just come down to this sheet right here and clean up. So what I'm going to do is subtract 3x away from each side of the equation. I'm going to cancel this and say we have negative 5y is equal to negative 3x plus 20. And then I'm going to divide both sides of the equation by negative 5. I'm going to cancel this with this, and we're going to say that y is equal to negative 3 over negative 5. Let's just write that as 3/5. And then times x, and then 20 over negative 5 is negative 4, so minus 4. So now we'll replace y with f of x, and we're basically ready to go. So let me just grab this real quick. So let me bring this back up here. And let me slide down a little bit. So we want to find f of negative 7, and we want to find f of 3. So for f of negative 7, again, just plug in a negative 7 for x. So you have 3/5 times negative 7, and then minus 4. That's pretty easy to do. So negative 7 times 3 would be negative 21. So this would be negative 21, and then over 5. And then you have minus 4. What I would do is get a common denominator. So let's multiply this by 5 over 5. So this would be minus 20 over 5. And negative 21 minus 20 is negative 41. So this would be negative 41 over the common denominator of 5. So that's going to be your answer for f of negative 7. For f of 3, so now you're going to have 3/5 times, plug in a 3 for x, and then minus 4. So this equals, so 3 times 3 would be 9, so this would be 9/5 minus 4. Again, you could write that as 20 over 5. Again, multiply by 5 over 5. So this would be 20 over 5. And so 9 minus 20 is going to be negative 11. So this would be negative 11 over the common denominator of 5. So f of 3 is negative 11/5. All right, for problem 10, we are asked to find f of z plus 1 and then f of z minus 2. So this one, again, is going to be a little bit complicated. This function is in implicit form. So let's write 9x squared minus 3y is equal to 27. Let's grab this real quick. And first, I'm going to solve this for y. And then again, I'll replace y with f of x. So I'm going to subtract 9x squared away from each side of the equation. Let's go ahead and cancel that away. You'll have negative 3y is equal to negative 9x squared and then plus 27. Let's go ahead and divide both sides of the equation by negative 3. Slide down here a little bit. And so let's cancel this with this. We have y is equal to negative 9 divided by negative 3 is 3. So this would be 3x squared. And then 27 divided by negative 3 would be negative 9, so minus 9. So let me erase everything, and I'm going to make one change here. Instead of y, I'm going to put in f of x. We wanted f of z plus 1. So let me start with that. So we want f of z plus 1. So this equals what? Again, where there's an x, you're going to plug in a z plus 1. So 3 times, I'm just going to put some parentheses here. This is going to be squared. So you're going to plug in, again, a z plus 1 there. And then out here, you're going to go minus 9. So this equals, you have 3 times. Be real careful here. You need to expand this using your formula, and then you're multiplying 3 by the result. So the common mistake would be either to say this is z squared plus 1 squared, which is wrong, or to drop the parentheses here do this correctly and then multiply 3 by just the first guy there. Okay, so you need to make sure you wrap this with parentheses. You can even do brackets and then parentheses to be really clear, right? So z plus 1 like this, squared, like that, and then minus 9. I think this would make it a little bit easier to not make a mistake. I'm just going to erase this and put 3, and then put my parentheses here. So I'm going to square z, so z squared, and then plus 2 times z times 1, that's going to be 2z, and then plus 1 squared is 1. And then close that down, and then minus 9. So this equals what? You're going to distribute that 3 to each guy inside of the parentheses. So you would have 3z squared, plus you'd have 6z, and then plus you'd have 3, and then minus 9. At this point, you're just going to simplify. So 3z squared, I can't really do anything with that. So 3z squared, and then plus 6z, I can't do anything with that. And then basically you have 3 minus 9, which is negative 6, so minus 6. So you get 3z squared plus 6z minus 6. So that's going to be your f of z plus 1. Okay, let me come down here and let me paste this in. Let me get rid of that. I'm going to go back up. We want f of z minus 2. So what is f of z minus 2? Again, I'm going to plug in for that x there. So this equals 3 times, set up some parentheses, and this is going to be squared. So we're going to say, we're going to plug in z minus 2 there for x. So then put the minus 9 out here. So again, if you want to use this strategy here, so put the 3, put some brackets, and then put z minus 2 inside of parentheses and square it like that. I think that a lot of students that I've tutored before that have difficulty with maintaining things like this might be a good trick. So if you keep working these problems and you're making mistakes with this is a good trick to remind yourself that, hey, I've got to do this part first and then multiply 3 by each guy. Okay, if you're not having any problems, then you can just do it like this. It's not a big deal. Then minus 9. So let's come down here. And let's go ahead and do this one first. So we would have 3 times z squared, and then minus 2 times z times 2. So 2 times 2 is 4, and then times z, and then plus this 2 being squared is 4. So then you have your minus 9 here. So let's come down, and we're just going to distribute the 3 to each guy inside. So 3 times z squared, that would give us 3z squared. And then 3 times negative 4z, that's minus 12z. And then 3 times 4 is 12, so plus 12, and then minus 9. So this is going to give me as a final answer. The 3z squared, I can't do anything with that, so just 3z squared. And then minus 12z, can't do anything with that, so minus 12z. And then 12 minus 9 is going to be 3, so then just plus 3. So this was f of z minus 2. You can't see it because it's cut off by the screen, but we end up with 3z squared minus 12z plus 3. All right, let's take a look at the practice test. For the instructions, we're asked to graph each and give the x and y intercepts. All right, for problem 1, we're given x plus 3y is equal to 9. Let me slide down here just a little bit. And let's think about how we could sketch the graph of this line. Now, typically, if you're in an algebra course and they're asking you to graph a linear equation in 2 variables, they're going to give you something that's going to work out nicely. So what I mean by that is you're going to have a lot of integer values that you're going to deal with. In the real world, that might not be the case. So you might get some things that have nasty fractions involved. So you need different strategies based on what type of equation you're looking at. So I'm going to give you 2 strategies here, and we talked about this in the lesson. So the first strategy works out nicely for most problems, again, that are coming from a textbook or a teacher in this section. And that's going to be that you're going to solve the equation for y, and you're going to obtain the slope, intercept, form of the line. So this is the y equals mx plus b, where you could say m is your slope. So this is the slope. So that's the coefficient of x. And b is going to be the y coordinate from the y-intercept. So let me put that this right here is your y-intercept, where that's going to occur at 0, b. So thinking about this, what you could do, if it's in this form, you could plot the point 0, b, that's your y-intercept, and then you could use your slope, or the concept of rise over run, to get additional points. So let's just start with this because this is the quickest way in most cases. So I'm going to write x plus 3y is equal to 9. And let me just solve this for y. So I would subtract x away from each side of the equation. And so over here, this is going to cancel away. So we're going to have 3y is equal to, you have negative x plus 9. You have 3 that's multiplying y. So if I want to get rid of that, I'm going to divide everything in this equation by 3. To make this easier to understand, what I'm going to actually do is put a little 1 right here. So this is negative 1x instead of just negative x. Again, that's an implied coefficient of negative 1. And so this is going to cancel. You'll have y is equal to, I'm going to write this as negative 1/3 times x, and then plus 9 over 3 is 3. So again, if you match this up with your y equals mx plus b, this right here, this negative 1/3, that's going to be the slope of the line. And then the y-intercept is going to occur at 0, 3. Again, finding the y-intercept, you want to plug in a 0 for x. So if I plugged in a 0 for x there, this is going to go away, and you have y equals 3. So that's how that works out. So let's go ahead and grab this real quick. And just coming down here, I've already sketched this graph. So the first point you would plot would be your y-intercept, which occurs at 0, 3. So that's going to be this guy right here. Let me change colors so this shows up really well. So this is the y-intercept. This is 0, 3. And again, I am getting that from this value right here. Now, additional points can be found from the slope. So your m, your slope, again, is rise over run. So here, because it's negative 1/3, you could write this as negative 1 over 3, and you could also write this as 1 over negative 3. So thinking about that, what does it mean to have a rise over run where it's negative 1 over 3? Well, a rise of negative 1 means from my point, I'm going to fall by 1, or I'm going to go down by 1. And a run of 3 means I'm going to the right by 3. So from this point, I go down by 1 and to the right 1, 2, 3. And then there's another point on the line. Fall by 1, go to the right 1, 2, 3. And there's another point on the line. Fall by 1, go to the right 1, 2, 3. There's another point on the line. That point happens to be the x-intercept, which is at 9, 0. We'll talk about that in a moment. Now, what does this one mean when we have 1 over negative 3? Well, from a given point, a rise of 1 means I go up by 1. And then a run of negative 3 means I go to the left by 3. So from this point, rise by 1, go to the left 1, 2, 3, back on the line. Rise by 1, go to the left 1, 2, 3, back on the line, so on and so forth. So once you have just 2 points or 3 points if you want a check, you can go ahead and sketch the line. So it's just going to be a line through those points and just put arrows at each end to show that it continues in each direction forever. So this is typically the quickest way to do this, especially if your b value here is an integer. It's going to work out nicely. Now, let me show you an alternative approach. I'm just going to erase everything. So coming back to the equation, when I talk about an alternative approach, typically when you first get to this topic in school, you're going to make a table of values. So you have basically these x, y values or these ordered pairs that work as a solution for this equation. Typically what you're going to use would be the x and y intercepts to start. But again, that doesn't always generate integer values for you. So you have to play around with it based on the numbers in your equation. Okay, here it's going to work out nicely. So if I plug in a 0 for x, which is finding the y-intercept, we already know that this guy is going to be 3, but let's just plug it in. So this is 0 plus 3y is equal to 9. 0 plus 3y is just 3y. So you can get rid of this and just divide both sides of the equation by 3. And we know this would cancel, and you get y is equal to 9 divided by 3 is 3. So if x is 0, y is 3. And again, this is your y-intercept. Then the other one would be your x-intercept. So you plug in a 0 for y there. So that's going to go in right there. So x plus, you'd have 3 times 0 is equal to 9. Of course, 3 times 0 is 0. So you'd have x plus 0 equals 9. And x plus 0 is just x. So you get x is equal to 9. So this would be 9 right here. And we saw that from the graph that at 9, 0, that's your x-intercept. And then you would pick a third point for a check. And how you get that point, a lot of people always ask, well, how did you end up with an integer? Well, what I always do is look at the numbers in the problem and I think about what would work out. And this is just something you need practice doing. But if I look at this, I know that, let's say I plugged in a 3 here for x. Well, that 3 would get subtracted away here and also here, and it would leave me with a 6 here. Well, if I have 3y equals 6, I know that y is going to be 2, so already I have an integer. And that's just something I worked out in my head. Again, you just need some practice doing this. It's just based on the numbers you're given in the equation. So looking at this again, if I plugged in a 3 for x, I'd have 3 plus 3y is equal to 9. Let me go ahead and write a 3 there. And what I would do is subtract 3 away from each side of the equation. That would cancel. You would get 3y is equal to 9 minus 3 is 6. Divide both sides of the equation by 3, and you're going to get that y is equal to 6 divided by 3 is 2. Let me show that as canceling. So this would be a 2. Okay, so at that point, you have 3 ordered pairs. So you have 0, 3. You have 9, 0. And then you have 3, 2. You only need 2 points to make a line, but your book is always going to tell you to get a third point as a check, and that's always a good idea. If you're doing this and you make a mistake, let's say you get a point here and another point that lines up here, but then you get a point somewhere over here, well, that's not a line, right? You made a mistake somewhere, so a third point is always good for a check. So let me go ahead and grab this. And so again, you could just plot these points. So 0, 3, again, that's going to be right there. That's your y-intercept. And then you have 9, 0. That's going to be right there. That's your x-intercept. And then 3, 2. So let's go 3 units to the right and 2 units up. That's going to be right there. So those 3 points would be enough to sketch this line. Again, it's just a matter of getting some nice clean integers. If you get something where you have a lot of fractions involved, it's going to be really difficult to graph that. So you might want to go back and forth between the two different approaches based on the problem you're given. So let me just write out here for the answer that the x-intercept, again, this occurs when we plug in a 0 for y. So this is going to be at 9, 0. And then the y-intercept, again, this occurs when we plug in a 0 for x, and this is going to be 0, 3. All right, let's take a look at problem 2. So here we have 3x plus y equals -4. All right, for this problem, what I'm going to do is just speed the process up. I'm just going to solve for y and put it into slope-intercept form. In most cases, that's the fastest way to get the y-intercept and also to graph the equation. So let me just rewrite 3x plus y is equal to -4. Let me subtract 3x away from each side of the equation. So this right here would cancel away, and you have y is equal to your -3x minus 4. For clarity, let me put plus -4 here. Let me actually rewrite that so it's a little bit more clear. And basically, from this form of the line, the slope-intercept form, the y equals m the slope times x plus b. Again, b is the y coordinate from the y-intercept. We immediately know the slope is -3, and the y-intercept would occur at 0, -4. So you can grab this and go to your coordinate plane, and you could plot 0, -4. That's your y-intercept. So from the origin, just go down by 4 units. So that's right there. So this is going to be 0, -4. That's your y-intercept. And then the slope is -3. So again, to make that make sense, let's write m is equal to the rise over the run. So this is what? You could say -3 over 1, or you could say 3 over -1. So starting at this point right here, I could fall by 3 units and then go to the right 1. So fall 1, 2, 3, go to the right 1. There's a point on the line. Or I could do this one. So I could say I'm going to rise 3 units, so 1, 2, 3, and then go to the left 1, so right there. When you think about a positive value for a rise, you're going up. If it's negative, you're going down. If there's a positive value for the run, you're going to the right. If it's negative, you're going to the left. Okay, so it's pretty easy to do. So that would give you your 3 points on that line, and then you could just sketch it. Okay, so that's pretty quick. Now, the other thing we're asked to do is find the x and y intercepts. We know the y-intercept already from this guy is 0, -4. So let's just write that. So y-intercept would be at 0, -4. But what about the x-intercept? How do we find that? Again, you plug in a 0 for y. So you're going to plug that in, and you're going to solve for x. Now, it's probably easier to do that in this form here. So let's write 3x, and then plus, I'm going to plug in a 0 for y, and this equals -4. Now, 3x plus 0 is just 3x, so you can really get rid of that. How do I solve for x? We'll just divide both sides of the equation by 3. So this cancels, and you get x is equal to -4/3. So coming back down here, I'll say the x-intercept occurs at -4/3. Or that's -1 1/3, and then comma 0. And if you look at your graph here, and it's a little bit difficult to see, but the x-intercept is going to be right there. So you could say that that point right there is -4/3, comma 0. So that's your x-intercept, and then again, your y-intercept is 0, -4. All right, let's take a look at problem 3. So here we have -2x plus 5y is equal to 10. Again, I'm just going to solve for y here. So let me write out -2x plus 5y is equal to 10. Let's go ahead and add 2x to both sides of the equation. So this will cancel. You get 5y is equal to, you're going to have 2x plus 10. What I'm going to do here is divide both sides of the equation by 5, like this. So this would cancel. You're going to have y is equal to 2/5, so 2/5 times x plus 10 divided by 5 is 2. So again, match this up with y equals m your slope times x plus b, again, where b is the y coordinate from the y-intercept. Let's go ahead and grab this. Let's just paste this in. So I know that my y-intercept is going to occur at 0, b, right? So 0, 2 in this case. So that's going to be right there. Maybe I should use a different color so that shows up. So let me go over that again. And then let me arrow to this and say that's going to be 0, 2, which is the y-intercept. So the y-intercept occurs at 0, 2. For the slope, the m, it's 2/5, right? So again, you could say m is equal to the rise over the run. And you can say this is 2 over 5. You could also say it's -2 over -5. Remember, a negative over a negative is a positive. So starting at any point on that line, you can go up by 2 units. So up 1, 2, and to the right, 1, 2, 3, 4, 5. So there's a point on the line. Now you could also start at a point on the line and go down by 2 units and then to the left 5. So from this point, let's go down 2 units, 1, 2, to the left, 1, 2, 3, 4, 5. So there's a point on the line. So that's 3 points where you could sketch your line. Now, in order to find the x-intercept, so the x-intercept, we could see from the graph it's going to be at -5, 0. But again, how could you find that out algebraically? Typically, it's easier to do from this form right here. So I would plug in a 0 for y and solve for x. So you'd have -2x. If you plugged in a 0 there, 5 times 0 would be 0, so this would be gone. So this is just equal to 10. Divide both sides by -2. And so this cancels, and you get x is equal to 10 divided by -2 is going to be -5. So if y is 0, x is -5. So coming back down here, I'm going to put -5 here, comma 0 here. So that's your x-intercept. Again, you verify that from the graph. So this guy right here is -5, 0. So the x-intercept is at -5, 0, and your y-intercept is at 0, 2. All right, let's take a look at problem 4. So here we're given x equals -2. So if you get x equals some number, let's just call it a, then that is a vertical line. Okay, so all you really have to do is go to the x-axis and find -2 and just draw a vertical line. It's basically that simple. So coming down here, we go to the x-axis, and you could make some points here, but basically we know that this line is going to pass through -2, 0, because that's going to be the x-intercept. So this right here would be -2, 0, and that's your x-intercept. Let me write that over here. So the x-intercept is at -2, 0. Because this is a vertical line, it doesn't really matter what the value of y is. X is always -2. You could write this equation as x plus 0y is equal to -2. And then you can plug in any value you want for y. Because it gets multiplied by 0, it basically goes away, and you're just left with x equals -2. So for this point right here, for example, this is an x value of -2 and a y value of 5. Well, if you try that, here you'd have -2 plus 0 times 5 is equal to -2, which is a true statement, right? You get -2 is equal to -2, right? Because 0 times 5 is going to be 0. So basically, when you think about this type of equation, you have an x-intercept, which is whatever that value is. So let's say it's x equals a. So it's going to occur at a, 0. So that's always going to be your x-intercept. Now, in this particular case, you're not going to have a y-intercept. So I'm just going to put that the y-intercept, let's just write none for this particular case. If you have a vertical line, you're not going to have a y-intercept unless you have the line x equals 0, right? So that would be the y-axis itself. Other than that, you're not going to get a y-intercept. All right, let's take a look at problem 5. So here we have -x minus y equals 4. Let's go ahead and solve this for y. So I'm going to say -x minus y is equal to 4. Let's add x to both sides of the equation. Let's go ahead and cancel this and say we have -y is equal to, this will be x plus 4. All you really have to do now is just divide both sides of the equation by -1, or you could multiply both sides by -1. It's really up to you. All you're doing is changing the sign of everything in the equation. Let me write a 1 there so this is more clear. So let me write a 1 there. So this is -1y here. So basically this is going to cancel with this, and you get y is equal to 1 over -1 is -1. So this is -1, or you can just write -x. And then 4 over -1 is going to be -4. Let me write plus -4 here. So this is more clear. And let me write -1 times x here. So this is more clear. And let me grab this real quick. And let me paste this in here and just write y equals mx plus b. So m here, the slope is -1. Again, m is equal to rise over run. So here, if you have -1, you could write -1 over 1, or you could write 1 over -1. And your y-intercept is going to occur at 0, b. Well, b here is -4, so 0, -4. So go ahead and plot that point first. So that's going to be right there. That's your y-intercept. So this is at 0, -4. And then use your slope. So here, your rise is -1 and your run is 1. So I could fall by a unit and then go to the right by a unit. So there's a point. Fall by a unit, go to the right by a unit. There's a point. You could also rise by a unit and then go to the left by a unit. So starting here, I could rise by 1 and go to the left by 1. Rise by 1 and go to the left by 1, so on and so forth. So that's how you can sketch your line. We also need the x-intercept, so the x-intercept. And for that, I like to use the other form. So let's plug in a 0 for y. You'd have -x, and then -0 is equal to 4. Well, -0, you can just get rid of that. So you have -x is equal to 4. Well, you can multiply both sides by -1 or divide both sides by -1. So let's divide both sides by -1. So this would cancel. You get x is equal to 4 divided by -1 is -4. So if y is 0, x is -4. So coming back here, I'll say that this is -4, 0. And looking at our graph, you can see that that's going to be your x-intercept right there. So this is going to be at -4, 0. All right, let's take a look at problem 6 now. So here we just have y equals -8. So if you have something like y equals k, some number k, well, that's a horizontal line where your y-intercept is going to be 0, k, whatever that number is. So here the y-intercept would be 0, -8. So coming down here, basically, you're just going to sketch a horizontal line. Again, I mentioned that this right here, this point, which is 0, -8, that's the y-intercept. So you're going to go through that point. Just find that on your coordinate plane and then draw a horizontal line. That's really all you have to do. Again, you could write this as 0x plus y is equal to -8, so that whatever you plug in for x, it doesn't matter. You're multiplying it by 0, so you end up with y equals -8. So for example, this point right here, where we have 5, -8, well, if you plugged in a 5 for x, you'd have 0 times 5 plus y is equal to -8. Well, 0 times 5 is 0, so you just get y is equal to -8. Okay, so on and so forth. So with the y-intercept, you will have one. Again, it's 0, -8. For the x-intercept, in this case, you're not going to have one, right? So it's going to be none. You would only get one if you had y equals 0, right? So if y equals 0, well, that's going to be the x-axis itself. But other than that, you're not going to have an x-intercept. In this particular case, we'll just say the x-intercept is none. All right, let's take a look at problem 7. So here we have 7x plus 3y is equal to 21. So I'm just going to solve this for y. So 7x plus 3y is equal to 21. Let's subtract 7x away from each side of the equation. So this is going to cancel. We'll have 3y is equal to -7x plus 21. Let's divide both sides of the equation by 3. And we'll cancel this with this. And we'll say y is equal to, we have -7 over 3 times x plus 21 over 3 is going to be 7. So let me grab this. And we'll just paste this in here. Let me write y equals mx plus b for reference. So here m is going to be -7/3 and b is going to be 7. So the y-intercept would occur at 0, 7. Let me write the y-intercept occurs at 0, 7. So always, again, 0, b. So that's going to be right there. Let me label that. This is 0, 7. And then for the slope, the m, that's going to be the rise over the run. In this case, it's -7 over 3. So let's write -7 over 3. And you can also write 7 over -3. So with -7 over 3, the rise is -7 and the run is 3. So from a point, you're going to fall 7 units. So 1, 2, 3, 4, 5, 6, 7. And then you're going to go to the right 3 units. So 1, 2, 3. And that's actually my x-intercept, but we'll show that in a moment. Again, you could do this again. So go down 1, 2, 3, 4, 5, 6, 7 to the right 1, 2, 3. The other way to do that, you're just reversing what you just did. It's 7 over -3. So the rise would be 7. So that means I'm going up 7. 1, 2, 3, 4, 5, 6, 7. And then the run is -3. So I'm going to the left by 3. So 1, 2, 3, and I'm back on the line. So however you want to do that. So that's how you can sketch this line here. And then for the x-intercept, let me actually move this down just a little bit, and I'll write x-intercept. So we can see that it's going to be at 3, 0, right? So you could write it in now. But you could prove that by going back up, and again, just plug in a 0 for y. So this would go away. You'd have 7x is equal to 21. Divide both sides by 7. This cancels, and you're going to get x is equal to 21 divided by 7 is 3. So if y is 0, x is 3, which gives us the 3, 0. Right? So the y-intercept occurs at 0, 7, so right there. And the x-intercept occurs at 3, 0, so right there. All right, let's take a look at problem 8 now. So we have 4x minus 5y is equal to 15. Let's go ahead and solve this for y. So 4x minus 5y is equal to 15. Let's subtract 4x away from each side of the equation. This will cancel. We have negative 5y is equal to negative 4x plus 15. What I would do here is divide both sides of the equation by negative 5 so that I can isolate y. So this would cancel. You get y is equal to negative 4 divided by negative 5. Let's just write that as 4/5. Then times x, and then plus 15 divided by negative 5 is negative 3. So you could put plus negative 3 or minus 3, whatever you want to do. I'm going to write plus negative 3 here for clarity. So let me grab this, and let's paste this in here. And let's write y is equal to mx plus b. And just match things up. So m, the slope here is 4/5, and b is going to be negative 3. So we know the y-intercept occurs at 0, negative 3. So that's going to be right there. So let's say this is 0, negative 3. And let me write out that this is the y-intercept. So the y-intercept, so 0, negative 3. My slope, m, is going to be equal to, again, the rise over the run. So you have 4/5. So 4 over 5, or again, you could say negative 4 over negative 5. Negative over negative is positive. So starting at this y-intercept, I could go up 4 units and then to the right 5. So I'm going to go up 1, 2, 3, 4, to the right 1, 2, 3, 4, 5. So back on the line right there. And then I could also, from a point on the line, go down 4 units and to the left 5. So 1, 2, 3, 4, to the left 1, 2, 3, 4, 5. So back on the line. Okay, so either way you want to do it, it works out. So that's how you can sketch the line. Now, for the x-intercept, it's not going to be an integer value here. So we know we're going to plug in a 0 for y. Looking at the graph, and because of the thickness of the line, it sort of looks like it's going to impact here at 4, but it's not quite there. Okay, so let's go up, and we're just going to plug in a 0 for y. So this is going to go away, right? If I say 4x minus 5 times 0 is equal to 15, well, 5 times 0 is 0, and basically you would have 4x minus 0 is equal to 15. Well, 4x minus 0 is just 4x, so you can get rid of that. You can just divide both sides of the equation by 4, and so this cancels, and you get x is equal to 15 over 4. So it's very close to 4. It's 3.75 or 15/4. And coming back down here, it would hit about right there. And again, because of the thickness of the line, it looks really close to 4. But this right here, in decimal form, you could say it's 3.75. As a fraction, you'd say 15/4. So 15/4, and then comma 0. Okay, so that's your x-intercept. So 15/4, comma 0. So again, y-intercept would occur at 0, negative 3, so right there. And the x-intercept would occur at 15/4, or again, 3.75, comma 0, so right there. All right, let's take a look at problem 9. So here we have 4x plus 3y equals 12. Let's solve this for y. So 4x plus 3y equals 12. Let's subtract 4x away from each side of the equation. So this would cancel. You're going to have 3y is equal to negative 4x plus 12. What I'm going to do from here is divide both sides of the equation by 3. Let's slide down a little bit. I'm going to cancel this with this and say y is equal to, you're going to have negative 4/3 times x plus 12 divided by 3 is 4. So let's go ahead and grab this. Let's paste this in here. And let's say y equals mx plus b. So m here is negative 4/3, b here is 4. So the y-intercept would occur at 0, 4. So right there, that's my 0, 4. Let me write out, this is the y-intercept, 0, 4. And the slope m is equal to the rise over the run. So here we have negative 4 over 3, or you could say 4 over negative 3. So again, what this means is that from any point on the line, let's say right here at 0, 4, you can rise by negative 4, meaning you would fall by 4 units, and then run 3, meaning going to the right by 3. So falling 4, 1, 2, 3, 4, go to the right 3, 1, 2, 3, and I'm right there on my x-intercept. Let me just label that now. That's going to be, and I could use a better arrow there, 3, 0. And we'll prove that in a moment. Then if you want this point here, again, you can fall 4 more units. So 1, 2, 3, 4. Go to the right, 1, 2, 3. And of course, you can reverse this if you want to use this one. So you can go up 4, 1, 2, 3, 4, into the left 3. 1, 2, 3, back on the line. So that's how you can sketch your line. Again, to get this x-intercept, which we can clearly see from the graph is 3, 0. Let's go back up. Just plug in a 0 for y. So we know this is going to go away. 3 times 0 is 0. 4x plus 0 is just 4x. So this would be 4x is equal to 12. Divide both sides by 4. So this is going to cancel here. And you get x is equal to 12 divided by 4 is 3. So if y is 0, x is 3. So coming back, you see you get a y-intercept that's at 0, 4. So right there. And the x-intercept is going to be at 3, 0. So right there. All right, let's take a look at problem 10. So here we have 9x plus 5y is equal to negative 20. So I'm just going to solve this for y. So we have 9x plus 5y is equal to negative 20. Let's subtract 9x away from each side of the equation. Let's cancel this and say 5y is equal to, you have negative 9x minus 20, or you can go plus negative 20. Let's just write minus 20 for right now. We'll slide down here. I'm trying to solve for y. So let's divide everything here by 5. And we're going to go ahead and cancel this with this and say that y is equal to, let's write this as negative 9 over 5 times x. And then you can go plus negative here and say this is negative 20 over 5, which is negative 4. Let me go plus negative 4 here just for clarity. I'm just going to grab this and paste this in here and line this up with y equals mx plus b, where here m is negative 9/5. And b is negative 4. So let me write m, the slope, is equal to the rise over the run. And let's say this is negative 9 over 5 or 9 over negative 5. Again, either way. Let me slide this up here. And I'll put my y-intercept is going to occur at 0, b. b here is negative 4. And for the x-intercept, this is going to occur at something, comma, and then we're going to have 0. So looking at the x-intercept here, it's not going to be an integer value. So we're going to have to do a little bit of work on that one. But for the y-intercept, we already have it. It's at 0, negative 4. So that's going to be right there. So that's your y-intercept, 0, negative 4. And we know, let me make that a little bit cleaner there. We know that the slope is negative 9 over 5. So I could go down by 9 units, but that's going to run off what I have here. Of course, if you're making a graph on your own, you can put numbers going below this negative 10, the last notch I have here. So I'm just going to use this one where I'm going to go up by 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to go to the left by 5. So 1, 2, 3, 4, 5. So that gets me to that point right there. And if you wanted to keep going up by 9 and to the left by 5, again, you would just have to extend the graph a little bit. It's just beyond what I can put here on the screen. Now, if you wanted to use this one, you could start at this point and then fall by 9 units and then go to the right by 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then to the right, 1, 2, 3, 4, 5. So that gets you back to the line. All right, so you can sketch the line from those 2 points or get some additional ones if you want. We just need to figure out what is the x-intercept. And let me make that colon a little bit better there. Let me come back up. So if I plugged in a 0 for y, you'd have 5 times 0, which is 0. So this is going to go away. You're going to have just 9x is equal to negative 20. We would divide both sides of the equation by 9. This would cancel. And you get x is equal to negative 20 over 9. So coming back down here, let's say this is negative 20 over 9. And if I punch that into my calculator, I get negative 2.2, where the 2 repeats forever. So let's go ahead and put that as about right there. And let me arrow to that. I'll use like an orange or something and make that a little bit more colorful there. And let's say that that point, the x-intercept, is negative 20 over 9, 0. So we have our y-intercept, which is 0, negative 4, right there. And the x-intercept, which is negative 20 over 9, 0, which is right there. All right, let's take a look at the practice test. For the instructions, we're asked to find the slope of the line that passes through the given points. All right, for problem 1, we have the point negative 2, negative 5, and then we have the point 5, 3. So to find the slope of the line given 2 points, we have a nice, easy formula that you just plug into. So lowercase m is used to denote slope, and this is equal to, you have your change in y values over your change in x values. The way you remember that is rise over run. Okay, so I'm going to say that this is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And this is just something you need to write down a few times so that you can memorize it. And typically you will see that x sub 2 is not equal to x sub 1, because in this particular situation, if x sub 2 and x sub 1 are the same or they're equal, then you're going to have division by 0, which is undefined. So this is going to happen whenever you have a vertical line. Okay, so what I'm going to do is actually get rid of this, and I'm going to label one of the points as x sub 1, y sub 1, and then the other will be x sub 2, y sub 2. It does not matter how you label things, and I'll even prove that to you in this example. So this is x sub 1, and this would be y sub 1, and then this is x sub 2, and this is y sub 2. So this I labeled as the first point, and this is the second. Again, I'll show you in a moment that you could flip this around and it would still work. So just plug into the slope formula. For y sub 2, I have a 3. For y sub 1, I'm going to have a negative 5. So minus a negative 5, be real careful there. Then you have x sub 2, that's going to be a positive 5. And then for x sub 1, that's going to be a negative 2. Again, minus a negative 2, be very careful there. So I'm going to convert this over. 3 minus a negative 5, that is 3 plus 5. And then 5 minus a negative 2, that's 5 plus 2. So 3 plus 5 is 8, and this is over 5 plus 2, which is 7. So the slope here is 8/7, where basically you think about the rise is 8 and the run is 7. So from a point on that line, I can rise 8 units and then go to the right 7 units, and I'll basically be at another point on the line. Okay, so that's what that's telling me. So another way you could have done this, let me just get rid of this real quick, is to switch the labeling. So I'll just say that this is x sub 2 and then y sub 2, and let's let this be x sub 1 and this be y sub 1. So now this is the second point and this is the first. So again, let me write this out. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and then we're just going to plug in. So y sub 2 is now negative 5, and then y sub 1 is going to be 3, and then x sub 2 is now going to be negative 2, and then x sub 1 is now going to be 5. So what does this give me? Negative 5 minus 3 is negative 8, and this is over. Negative 2 minus 5 is going to be negative 7, but we know that a negative over a negative is a positive, so this is positive 8/7 as well. So either way, you find that the slope, m, is going to be 8/7. All right, let's take a look at problem 2. So here we have the point 0, 3, and the other point 3, negative 3. I'm just going to label the first point as x sub 1, y sub 1, and the second point as x sub 2, y sub 2. Again, like we saw in the last example, you can switch the order. You will get the same answer. So m, the slope, is equal to, we have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I'm not going to write the x sub 1 does not equal x sub 2. You don't need that. Again, you'll know if you have division by 0 if the x guys are the same in each case. So here, y sub 2, it's going to be negative 3. And then for y sub 1, that's going to be 3. Now for x sub 2, you're going to have 3. And then for x sub 1, that's going to be 0. So here we think about negative 3 minus 3, that's negative 6. And this would be over. 3 minus 0 is 3. So this equals negative 6 divided by 3 is negative 2. So the slope here is going to be negative 2. All right, let's take a look at problem 3. So here we have the points 5, 2, and then negative 1, 5. So I'm just going to label this as x sub 1 and this as y sub 1. This will be x sub 2 and then y sub 2, and then just plug into the slope formula. So m, the slope, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, so for y sub 2, we are given 5. For y sub 1, we are given 2. For x sub 2, we have negative 1. And then for x sub 1, we have 5. So here we have 5 minus 2. That's going to be 3. And this is over negative 1 minus 5. That's negative 6. So you can simplify this fraction. First off, positive over negative is negative, so let me just write a negative out in front. And then for 3 and 6, there's a common factor of 3. So 3 divided by 3 would be 1, and 6 divided by 3 would be 2. So my slope m is going to be negative 1/2. All right, let's take a look at problem 4. So here we have the point negative 2, 3, and the point 5, negative 2. So let's label this as x sub 1, and this as y sub 1, and this as x sub 2, and this as y sub 2. And I'm just going to plug into my slope formula. So m, the slope, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So y sub 2 is going to be negative 2, and y sub 1 is going to be 3, and then x sub 2 is going to be 5, and then x sub 1 is going to be negative 2. So be very careful. When you have minus a negative 2, it's plus 2. So negative 2 minus 3 is negative 5, and this would be over 5 minus a negative 2 is 5 plus 2. Let me actually write that out so nobody's lost. So 5 plus 2 there. So this is negative 5 over 5 plus 2 is 7. So basically the m, or the slope, is going to be negative 5/7. All right, let's take a look at problem 5. So here we have negative 5 comma 0 and then 0 comma 3. So let's label this as x sub 1 and y sub 1, and this as x sub 2 and y sub 2. And I'm just going to plug in to my slope formula. So m, the slope, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So for the y sub 2, I have a 3. And then for y sub 1, I have a 0. Then for x sub 2, you have a 0. And then for x sub 1, you have a negative 5. So again, be very careful there because you have 0 minus a negative 5, which is really 0 plus 5. So let's say this equals, again, 3 minus 0 would just be 3. And this is over. This would be written as 0 plus 5. Again, minus a negative is plus a positive. So this becomes 3 over, we know that 0, if we add that to something, it's not going to change it. So 0 plus 5 would just be 5. So the slope m here is going to be 3/5. All right, let's take a look at problem 6. So here we have the point 0 comma negative 3 and the point negative 1 comma 4. So let's let this be x sub 1 and this be y sub 1. And then over here, this will be x sub 2 and then y sub 2. And we'll just plug in. So m, the slope, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So for y sub 2, I have 4. For y sub 1, I have negative 3. So it's minus a negative 3. So be careful. For x sub 2, I have negative 1. And then for x sub 1, I'm going to have 0. So here we have 4 minus a negative 3, which is 4 plus 3. And then over here, negative 1 minus 0. Again, that's just negative 1. So if I divide something by negative 1, I'm just changing the sign of it. So really, you could say that this is going to be 4 plus 3, or 7, over negative 1. Well, I'm just changing the sign of 7, right? If I divide by negative 1, I just change the sign. So this is just going to be negative 7. So m, the slope here, is going to be negative 7. All right, for the next few problems, we're going to change up the instructions a little bit. Now we want to find the slope from slope-intercept form. For problem 7, we're given 2x minus y equals negative 3. So when we talk about the slope-intercept form of a line, so the slope-intercept form, it looks like this. You have y equals mx plus b. So when it's in this form, the m, or the coefficient of x, is your slope. So this right here is the slope. And then in terms of b, this is the y coordinate from the y-intercept. So at 0 comma b, that would be your y-intercept. Now here we're just asked to basically put this in slope-intercept form. So solve for y is what we're trying to do. And then we're going to inspect it and look at our coefficient of x. That will be the slope. We can write the y-intercept even though we're not asked for it. So the first thing you'd want to do if you want to solve this for y, you would subtract 2x away from each side of the equation. Let's go ahead and cancel that away. You'd have negative y is equal to negative 2x and then minus 3. So basically, to get y by itself, you've got to get rid of that negative there. You could really treat that as negative 1, and you could multiply both sides of the equation by negative 1 or divide both sides of the equation by negative 1, whatever you want to do. Let's just divide both sides of the equation by negative 1. And I'm going to go plus negative here to make that a little bit more clear. So this is going to cancel. Negative 1 divided by negative 1 is 1. So now you just have 1y, or just y. So let me write that here. I'll put y is equal to negative 2 divided by negative 1 is going to be 2. So this is 2x. And then negative 3 divided by negative 1 is going to be 3. So then plus 3. So again, comparing this to this, your y equals mx plus b, well, immediately I know that the slope is going to be 2. Right? So the slope of this line would be 2, and the y-intercept would occur at 0 comma 3. So let me write that off to the side here. I'll just put that m, my slope, is equal to 2. And again, we weren't asked for it, but let's just put that the y-intercept is going to occur at 0, comma, again, this is your b value, your 3, so 0, comma 3. That's the y-intercept. All right, let's take a look at problem 8. So here we have 5x plus 2y equals negative 10. So we are going to, again, solve this for y. Let me subtract 5x away from each side of the equation. So this is going to cancel away, and you will have 2y is equal to negative 5x minus 10. If I want y by itself, again, think about what's being done to y. 2 is multiplying y. So I'm just going to divide both sides of the equation by 2. Let me go plus negative here to make that a little bit easier to understand. So we see that this would cancel. And so now I have y by itself. So y is equal to, you'd have negative 5 halves, so negative 5 halves, times x, and then negative 10 over 2, that's going to be negative 5, so let's write minus 5. So if we want to match things up, so y equals mx plus b, again, you can go plus negative here to make that more clear. Your m, the slope, is the coefficient of x, so that's negative 5 halves. Your b, the y-coordinate from the y-intercept, that's going to be negative 5. So from this guy, let me make this a little bit better here so it shows up. From this, you can determine that your slope, m, is going to be negative 5 halves. Again, the coefficient for x when this guy is solved for y. And then the y-intercept, again, didn't ask for it, but I'm just going to give it to you anyway, is going to occur at 0, comma, again, this b value here, which is negative 5. All right, for the next few problems, we're going to change things up a little bit, and we're going to find the slope from the graph. So for problem 9, I've written m, the slope, is equal to, and we're just going to come down to the graph and get this. I'm going to show you 2 different ways to do it. So the first way you could do it is a bit slower. So let's say I think about this point right here, and then this point right here. So this is your y-intercept, and it occurs at 0, comma 4. And then this right here is your x-intercept, and it occurs at 1, comma 0. Well, you could just take these 2 points and plug into the slope formula. So let's just say that this is x sub 2, and this right here is y sub 2. And let's say that this is x sub 1, and this is y sub 1. So you could say m, the slope, is equal to, you have your y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this equals what? Well, y sub 2 here is going to be 4, and then y sub 1 is going to be 0. So minus 0 over x sub 2 is going to be 0, and then minus, for x sub 1, it's going to be 1. So what does this give me? It gives me 4 over negative 1. Okay, you could write that as negative 4, obviously, but I'm going to leave it like this for a moment, just so we can think about something. When we have the slope, we say that m is equal to the rise, or the change in y values, over the run, which is the change in x values. So let's think about how we could have gotten this result using a different approach. So I could start at this point right here. Let me change the color here, and I'll go with something really that's going to stand out. So let's say I started here and I wanted to get to here. How much am I changing vertically? Well, I'm going to fall 1, 2, 3, 4 units. If I fall or go down on the y-axis, that's a negative 4. Okay, so this is a negative 4. If I was going up, let's say by 4 units, that would be a positive 4. I'll show you that in a moment. This would be over. At this point, I'm right here. I've only fallen 4 units. I need to go to the right by a unit to return to the line. Okay, so if I'm moving to the right by a unit, that's a positive 1. So this is over 1. Okay, so here it's 4 over negative 1, and here it's negative 4 over 1. Either way, it's still going to be negative 4 when you do the calculation, right? So 4 divided by negative 1 is negative 4, and negative 4 divided by 1 is also negative 4. Now, let me write this again. So m equals the rise over the run. How can I get this guy right here? So let's say I started at, let me actually erase all this. It's getting a little busy. And let me use a different color. So let's say I start here, and I go here now. Okay, so in order to get from this point to this point, I am going to go up by 1, 2, 3, 4 units. Okay, so that means my rise is now positive 4, and I need to go to the left by a unit to return to that line. So moving to the left by a unit means negative 1 in terms of the run. Okay, so however you want to do this, you can have a rise of negative 4 and a run of 1. So in other words, from here, I can go down 4 units into the right 1 to get back to the line. Or I can have a rise of 4 units and then go to the left by a unit. So from here, go up 4 units and to the left by a unit. So these are telling me that I have the same slope of -4. So let me come back up here and just put m is equal to -4. I'm going 4 units down for every 1 unit that I go to the right, or I could also say that I'm going 4 units up for every 1 unit that I go to the left. All right, let's take a look at problem 10. Here we have m the slope is equal to, and let's look at the graph. Again, I'll show you the 2 different ways. Let's say we look at that point right there. That's your y-intercept. So this is 0, 5. And this point right here, let me do this in a different color so it shows up. That's your x-intercept. So let me go ahead and say that this is going to be -10, 0. Again, you can use any of these points, but working with 0 makes the calculations a little bit faster. So I'm just going to plug into the slope formula. So m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And you can label the points however you want. Let's just say this is x sub 1 and this is y sub 1. And then this can be x sub 2 and then y sub 2. Reversing the order would not change anything. So this equals, for y sub 2, I have 0. And then minus for y sub 1, I'm going to have 5. This is over. For x sub 2, I have -10. And then minus for x sub 1, that's 0. So for this one, you have 0 minus 5, which is -5, over -10 minus 0, which is -10. Negative over negative is positive, and 5 over 10 is a half. So basically, this is telling me that the rise is 1 and the run is 2. So for every 1 unit that I move up, I move 2 units to the right. So here, let's say I move 1 unit up and then 2 units to the right, I'm back on the line. 1 unit up and then 2 units to the right, I'm back on the line. You could also say, if you wanted to, that it's -1 over -2. Remember that -1 over -2 is equal to 1/2, right? Negative over negative is positive. Sometimes you need to write it this way, and all that's telling me is that if I fall by 1 unit, I would need to go to the left by 2 units to return to the line. Fall by 1 unit, go to the left by 2 units to the return to the line, so on and so forth. Now, let me actually get rid of this and put this as 1/2. And then I'll formally say that m is equal to the rise over the run. And again, I'll show you the 2 ways. So let me get rid of this. And actually, let me just start here and say I'm going to go up 2 units. So that's my rise. And then from that point right there, I need to go 4 units to the right to return to the line. So 2 over 4, we know that would simplify to 1/2. Again, rise of 1 unit for every 2 units that I run to the right. Okay. The other way you could have done this, let's go m is equal to rise over run. And this equals, if I start here, I would fall 2 units. So let me put -2. And I need to go to the left by 4 units to get back to the line. So 1, 2, 3, 4 units to get right there. So over -4, again, this is going to simplify to 1/2, right? Or you could write it, if you wanted to, as -1 over -2. Sometimes you do need to write things that way. We'll see that later on in the course. For right now, it's just a general understanding of rise over run and the slope formula. So let's go back up and just say that m is equal to 1/2. Again, rising 1 unit for every 2 units we run to the right. Or you could say falling by 1 unit for every 2 units we run to the left. All right, let's take a look at the practice test. For the instructions, we're asked to write in slope-intercept form and standard form. All right, for problem 1, we're given m, which is our slope, is equal to 1/2. We are given our y-intercept, which is going to occur at 0, -3. So if you get this information and you're asked to write in slope-intercept form, it's going to be really easy because you can basically just plug in. So let me write this out for the first one. So the slope, we'll say intercept form of the line is y is equal to m, your slope, times x plus b, where b is the y coordinate from your y-intercept. Okay, so this is really easy to do. All you would say is that, okay, m is 1/2, so I'm going to plug that in there. So I'm going to plug in a 1/2 there. And then b, the y coordinate from the y-intercept, is -3. So I'm going to plug in a -3 there. So what would that look like? You would have y is equal to 1/2 x, and then instead of plus -3, let's just write -3. So when we inspect an equation of a line in slope-intercept form, we immediately know that the slope is 1/2. is the coefficient of x. We also know that the y-intercept is going to occur at 0, b, where b here would be -3. Okay, so the sign comes with that. You could write that again as plus -3 if you wanted to. So that is the easier guy to get. You also have what's called the standard form of a line, which can be a little bit tricky because the definition is going to vary based on your textbook and also what level of math you're studying. So let me just write out the standard form like this. So this is ax plus by is equal to c. Now, if you're studying math at a high level, typically when we say the standard form, we would say that a, b, and c are just real numbers. So it really wouldn't matter what they are. So just to do that really quickly, let's write out y is equal to 1/2 x minus 3. So I'm just going to subtract 1/2 x away from each side of the equation. Over here, this is going to cancel away. And so this would give me, let me put a little border here, negative 1/2 x, and then plus y, you could write plus 1y if you wanted to, is equal to -3. So you see how things match up here. A here is -1/2, B here is 1, and C here is -3. Typically, you're going to see a stricter definition. So what they're going to say is that A, B, and C need to be integers. There's no common factor between A, B, and C other than 1, and that A needs to be non-negative. Okay, so how can we accomplish this stricter definition? Well, the first thing is you notice that you have a fraction here. So it's -1/2, and also it's negative, right? So we need to take care of both of those things. So what I could do is I could multiply both sides of the equation by -2. So let me do that over here. And let me do that over here. Let me put this as a -2 there. And the reason I'm doing that is because the 2 would clear the denominator, okay, because 2 times 1/2 would be 1. And then by making this negative, a negative times a negative will give me a positive. So I'm going to take care of both of those things, right? So I will have a non-negative value, and I'll also have an integer. So let's go ahead and say that -2 times -1/2, and then times x. Of course, that's going to end up giving me 1x or just x. We'll do that in a moment. Then plus, this is going to be -2 times 1y or just -2y. And this equals -3 times -2. That's going to be +6. Okay, so what I'm going to do here is just cancel this out completely and just say that that's 1. So let's write our answer here in standard form and say it's x. You can go plus -2y, but typically we'd say -2y is equal to 6. All right, let's take a look at problem 2. So here we're given the slope m being equal to 1. And then now we have a point on the line that's not the y-intercept. It's 2, -2. So you saw before that we were given in problem 1 the slope and the y-intercept. So if that happens, you can plug straight into the slope-intercept form of the line. So y equals mx plus b. But we can't do that here because we don't have enough information yet. So what you're going to rely on is another form of the line, which is called point-slope form. So we're going to use point-slope form. And you use this whenever you have the slope and a point on the line that is not the y-intercept. And then you can also use it if you have 2 points, and I'll show you that later on. Okay, so from point-slope form, what you're going to have is y minus y sub 1 is equal to m times the quantity x minus x sub 1. And basically the given point is going to be x sub 1 comma y sub 1. So this is x sub 1 and this is y sub 1. So let's comment down here, and I'm just going to plug in. So we would say that y minus, for y sub 1 you have -2. So be really careful. Minus a negative is plus a positive. So let me write this like here first, and then I'm going to change this over to +2. Then over here for m, it's going to be 1. So you could write it, or you could leave it off because 1 times anything is just itself. So I'm just going to put it here for clarity. And then for x sub 1, that's going to be 2. So let's put that in there. Okay, so all you really have to do is solve this for y, and you're back to the y equals mx plus b, or the slope-intercept form that we're trying to find. So let me get rid of this and slide this down a little bit. And so I think what I could do here is just drop the parentheses, because again, multiplying by 1 is not going to change anything. And then you could just subtract 2 away from each side of the equation. This will cancel away. And what you're going to have is y is equal to, you have x minus 2 minus 2. So -2 minus 2 is going to be -4. So y equals x minus 4. So this right here is now going to be the slope-intercept form of the line. Again, it's y equals m, m here is 1, right? If you have just x by itself, it has an implied coefficient of 1. So y equals mx plus b. So the y-intercept would occur at 0, -4, and the slope is 1. Okay, let's go ahead and put this into standard form now. Let me move this up here. Again, that form is ax plus by is equal to c. And so let me slide this over here a little bit, put a little border. And I'm just going to write that this is the standard form like this. And basically, I'm going to subtract 1x away from each side of the equation. This will cancel away. You'll have -1x, or you could just write -x if you want. And then plus y is equal to -4. Again, depending on the level of math you're studying, this might be acceptable. But typically, you want a, b, and c to be integers, which we have here. And then you also want a to be non-negative. So we don't have that here. Right now, this guy right here is a -1. So what most teachers would ask you to do is to multiply everything by -1. So let me do that over here. So this times -1, and then this side times -1. And so it's just going to change the sign of everything. -1 times -1x would just be x, or you could put 1x if you want. And then -1 times y would be -y, so let's write -y. And this equals -1 times -4 would be +4. So in standard form, we're going to get x minus y is equal to 4. All right, let's take a look at problem 3. So here we're given 2 points on the line. So we have -5, -4, and then we have 4, 0. So what you want to do in this situation is use your point-slope form to get the slope-intercept form, and then from there you can get your standard form. So how do we use point-slope form? Let me write that up here again. Point-slope form. So y minus y sub 1 is equal to m times the quantity x minus x sub 1. Well, we have 2 different points on the line, and we can choose either one to be x sub 1, y sub 1. But what we don't have right now is the slope. So if you're given 2 points, unfortunately, you do have to go through the slope formula and generate the slope. So m, the slope, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let me slide this down here real quick. So I'm just going to label this. Let's say this is x sub 2 and y sub 2. And let's say this is x sub 1 and y sub 1, and just plug in. So for y sub 2, we have 0. For y sub 1, we have -4. Be really careful. Minus a -4 is +4. And then down here for x sub 2, you have 4. And then for x sub 1, you're going to have -5. So minus a -5 is +5. So what do we get? 0 plus 4 is 4. And then 4 plus 5 is 9. So the slope m is going to be 4/9. Okay, I'm going to erase all of this, and I'm just going to drag this down here. And actually, let me write this over here. So m is equal to 4/9, so we don't forget that. And I'm just going to plug in. We can get rid of this. I don't need this anymore. For m, I'm just going to say that this is 4/9. So 4/9, and then times the quantity again, x minus x sub 1. Maybe I can move this up here a little bit, and maybe I can make this a little bit larger. So y minus y sub 1. Now, here's the part that kind of confuses people. You saw a moment ago that I labeled this as x sub 1 and y sub 1, and this is x sub 2 and y sub 2. That is just for the purpose of getting slope. Once that's done, you can use either of these points as x sub 1, y sub 1. It does not matter. When you solve for y, you're going to get the same exact thing. Okay, so I'm just going to pick this one as x sub 1 and then y sub 1. If you want to pick this one, it'd actually be a little bit easier. Actually, I'll just do both of them and just show you that it works out either way. But basically, let's start with this one. So I'm going to plug in for y sub 1. This is -4. Minus a -4 is +4. For x sub 1, it's going to be -5. So minus a -5 is +5. So solve for y. You're going to get y plus 4 is equal to 4/9 times x is 4/9 x. And then plus 4/9 times 5 is going to be 20/9. Okay, let me actually get rid of this. And let's think about solving for y. So all you need to do is subtract 4 away from each side of the equation. We'll get rid of this from over here. And let me write this up here so it's a little bit more clean. Y is equal to, you have 4/9, so 4/9 times x. And then basically you have plus, I would get a common denominator here. So I'd multiply this by 9/9. So we'll say 20 minus 4 times 9 is going to be 36. And this would be over the common denominator of 9. Okay, so let me get rid of this. So 20 minus 36, that's going to be negative 16. So you can go ahead and say that this is minus 16 over 9. Okay, so that's your slope-intercept form. Now, as promised, let's say that you had decided to pick this as x sub 1 and y sub 1. Well, again, just plug in to the point slope form. So you have y minus y sub 1 is equal to m times the quantity x minus x sub 1. So for y sub 1, I'm plugging in a 0. For m, I'm plugging in a 4/9. And for x sub 1, I'm plugging in a 4. So right now it looks different, but again, when you solve for y, you'll get the same thing. So this right here, y minus 0, you can get rid of that. You just have y. Let me slide this down just a little bit. And I'm going to distribute this to each guy here. So y is equal to, you'd have 4/9 times x, which is 4/9 x. And then minus, you have 4/9 times 4, which would be 16/9. So let me get rid of this. And you can compare the two. And you see that you got the exact same thing. This one was less work because there was a 0 involved, but again, either way, you get the same answer. Okay, so this is the slope-intercept form. Now, let's find the standard form. So again, let me put a little border here so everyone's reminded. It's the ax plus by is equal to c. So what I'm going to do is subtract 4/9 x away from each side of this equation. And so over here, it's going to cancel, and that's going to give me negative 4/9 times x, and then plus y is equal to negative 16 over 9. Okay, let me actually get rid of this and scooch this up. Now, if we're going to go with the stricter definition, remember we want a, b, and c to be integers. Here, your a is negative 4/9, so that's a fraction, and your c is negative 16/9, so that's also a fraction. Additionally, you want a to be non-negative. Here it is negative. So how can we fix both of these problems? Well, basically, the LCD is 9. So if I multiplied both sides of the equation by 9, the denominators would get cleared, so you wouldn't have any fractions anymore, but it wouldn't fix the problem of this being negative. So to fix both problems, let me just slide this down here so we have enough room. I'm going to multiply both sides of the equation by negative 9. Okay, so negative 9 times this, and then this times negative 9. Let me slide down here, and let's go ahead and distribute this like this. So you'd have negative 9 times negative 4/9, then times x, then plus negative 9 times y. Let's just write negative 9y. And this equals, you have negative 16/9 times negative 9. We know that a negative times a negative would be a positive, and you can cancel this 9 with this 9. Let me show the negatives as canceling here. So you're left with 4 times x, or just 4x. Then you have plus negative 9y. You could just write that as minus 9y. And this equals, over here, again, negative times negative is positive. Let me show those negatives as canceling and becoming a positive. And so basically here, 9 divided by 9 would be 1. So you're just left with that 16 there. So this is 16 here. So you get 4x minus 9y equals 16. This is going to be your standard form. All right, let's take a look at problem 4. So here we're given 0, negative 4 as a point, and then negative 3, 0 as a point. So we do actually have the y-intercept here at 0, negative 4, but you don't have the slope yet, so you can't immediately plug into the slope-intercept form. You need to get the slope first. So let's say m is equal to, let's label this as x sub 1 and then y sub 1. This is x sub 2 and this is y sub 2. Let me scooch this down just a little bit here. We'll say this is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, just plug in. So for y sub 2, we see we have 0. And then for y sub 1, we have negative 4. Again, minus a negative 4 is plus 4. Then for x sub 2, it's negative 3. And then for x sub 1, it's going to be 0. So negative 3 minus 0 is just negative 3. So get rid of that. And then 0 plus 4 is just going to be 4. So this really is going to be negative 4/3. Let me get rid of this and just say this is negative 4/3. So at this point, you could just plug in to the slope-intercept form and be done. So it's y is equal to m, the slope, which is negative 4/3, times x, and then plus b, which again is the y-coordinate from the y-intercept. So this is negative 4. You can go plus negative 4, or typically we just put minus 4. So that's your slope-intercept form. Additionally, you could have also still used the point-slope form, right? You get the same thing when you solve for y. So y minus y sub 1, let me put the 1 down there, is equal to m times the quantity x minus x sub 1. And let's say that I use this as x sub 1 and y sub 1, or you could use this one, it doesn't matter. If you plug in for x sub 1, you would have a negative 3, and minus a negative 3 is plus 3. If you plug in for y sub 1, this is 0. And then if you plug in for m, it's negative 4/3. So y minus 0 is y. And then you would basically have, let me put the equals down here and get rid of this, negative 4/3 times x, and then 3 times negative 4/3. The 3's would cancel, and you're going to be left with negative 4 there. So you see that you get the same answer. So y equals negative 4/3 x minus 4. Okay, let's get rid of this. And of course, you can plug this one in. You get the same thing. If you want to try that on your own, it's up to you. Let me get rid of this and get rid of this. We don't need this anymore. So now we want to find the standard form. Okay, so let me write that over here again. ax plus by is equal to c. So I'm going to just add 4/3 x to both sides of this equation. Over here, this is going to cancel away. And then I would have 4/3 x plus y is equal to negative 4. Let me change this and make it a little bit better. Again, depending on your class, and I can't say this enough, this might be okay. But mostly, you want to make sure that you don't have any fractions, so you're dealing with integers for a, b, and c. There's no common factor other than 1, and this guy right here is non-negative. Right now, it's a positive value, so we're okay there, but we do have a fraction, and to clear that, you can just multiply both sides of the equation by 3. So let me distribute that in like that, and then basically, you would have 3 times 4/3 x plus 3y is equal to negative 4 times 3. Let me put a multiplication sign there so that's clear. That's going to be negative 12. So this right here is going to cancel. And then basically you would end up with 4x plus 3y is equal to negative 12. So that's the standard form of the line. All right, let's take a look at problem 5. So here we're given m, our slope, being negative 2. And then we're given a point 1, 0, which happens to be the x-intercept, but not the y-intercept. So if we had the y-intercept, we could plug straight into the slope-intercept form, but we don't have that. So I'm going to label this as x1 and this as y1, and I'm going to plug in to the point-slope form of the line. So y minus y1 is equal to m, the slope, times the quantity x minus x1. So for m, we know that's negative 2. For y1, that's going to be 0. And then for x1, that's going to be 1. Okay, so y minus 0 is just y, so get rid of that. Let me slide this down a little bit. And then this is going to get distributed to each guy here. So you'd have y is equal to negative 2x and then basically plus 2, right? Negative 2 times x is negative 2x. And then negative 2 times negative 1, you can go plus negative here to make that clear. That's going to be positive 2. Okay, so y equals negative 2x plus 2. That's going to be your slope-intercept form. So the slope here is negative 2. We know that. And the y-intercept will occur at 0, 2. Okay, let's get rid of this. And let's go ahead and put this one in standard form. So this one's actually going to be really easy. So ax plus by equals c. If I add 2x to both sides, I'll basically be done. So let me add 2x over here and add 2x over here. And so this is going to cancel away. And you're going to end up with 2x plus y is equal to 2. So I have a, b, and c. Those are integers. And a is non-negative. And there's no common factor between a, b, and c other than 1, right? So you have a 2 here and a 2 here, but this is a 1 here, right? So you basically can say that this is in standard form using your stricter definition. So 2x plus y equals 2. All right, let's take a look at problem 6. Here we have m, the slope is 3/2. And we have a point on this line that's 2, 4. Again, I'm going to use the point slope form here. So x1 and then y1 is how I'm going to label this. Let me slide down here a little bit and say we want y minus y1 is equal to m times the quantity x minus x1. And just plug in. So m is 3/2. Y1 is 4. And then x1 is going to be 2. So I'm going to distribute this first. Let me slide down here a little bit and say we have y minus 4 is equal to 3/2 times x is just 3/2 x. Let me go plus negative to make this clear. You're going to have plus 3/2 times negative 2. So we know that 2's would cancel, and basically you put a negative 1 there. So negative 1 times 3 would be negative 3. So let's just go ahead and say that this is y minus 4 is equal to 3/2 x. And then again, this would be negative 1 times 3 or negative 3. You can put minus 3 here. And to finish this up, I'm just going to add 4 to both sides of the equation. I'm going to cancel this away from over here. And we'll just say our slope-intercept form is y is equal to 3/2 x. And then negative 3 plus 4 is going to be 1. So plus 1. So here I know my slope m is 3/2. Again, the coefficient of x and the y-intercept occurs at 0, 1. All right, so putting this in standard form, let me write this out over here again. So ax plus by equals c. So I'm going to subtract 3/2 x away from each side of the equation. Let's cancel this away. And then I'm going to say that we have negative 3/2 x plus y is equal to 1. So for the stricter definition, again, we want this to be non-negative. Right now it is negative. And then we also want it to be an integer. Okay, so what I would do to accomplish both of those at the same time, I would multiply both sides by -2. Okay, because the 2 would cancel with the 2 there, and then negative times negative would be positive. So let me do that over here so that it's legal. And so this is going to get distributed to each guy here. So -2, let me write this out. So -2 times negative 3/2 times x. And then plus, you're going to have -2 times y. And this equals, let's just do 1 times -2 now. We know that's -2. So here your 2's would cancel. And basically the negatives would cancel. So negative times negative is positive. So this is just going to give me 3x here for that part. And then you have plus -2y. Let's just write -2y. And this equals -2. So that's your standard form for the line. All right, let's take a look at problem 7. So here we have 0, 3 and 5, 0. So we do have the y-intercept that occurs at 0, 3, but we don't have the slope. So I'm just going to generate the slope real quick. So this is x sub 1, y sub 1. This is x sub 2, y sub 2. Again, you could change the labeling, whatever you want to do. Let's say m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and just plug in. So y sub 2 is going to be 0, and then y sub 1 is going to be 3. And then here x sub 2 is going to be 5, and then x sub 1 is going to be 0. So 0 minus 3 would be -3, and 5 minus 0 would be 5. So this gives me a slope m, which is equal to -3/5. So the fast way to do this is just to use the y-intercept here, which is 0, 3, and just plug in, right? So y is equal to m, the slope. We have that. That's -3/5 times x, and then plus b. That's the y coordinate from the y-intercept. So 0, b. In this case, b is 3. So plus 3. Okay, so that's all you really need to do. If you wanted to use the point slope form, you can label either of these points as x sub 1, y sub 1, and then just plug into the y minus y sub 1 equals m times the quantity x minus x sub 1, solve for y, and you're going to get the same thing. So let's slide down here. I'm just going to put this in standard form. Let me put this over here so nobody's lost. So ax plus by equals c. We're going to add 3/5 x to both sides of the equation. I'm going to cancel this away, and then we're going to say that we have 3/5 x plus y is equal to 3. In some classes, this is enough. But in most classes, especially if you're in high school, they're going to ask you to get rid of this fraction here. Okay, so you can just multiply both sides of the equation by 5 to clear that denominator. So let's go ahead and do that real quick. And we'll say that this is going to be multiplied by this and this. So 5 times 3/5, let me write that out so nobody's lost. And then times x, and then plus you have 5 times y. And this equals 3 times 5 is 15. We know that this is going to cancel with this. And so you end up with 3x plus 5y is equal to 15. So that's the standard form for the line. All right, let's take a look at problem 8. So here we're given 2 points. One point is 0, 0, which is the origin, and the other point is -1, -3. Now, if your line passes through the origin, it's going to look like this in slope-intercept form. So y is equal to mx, because the y coordinate from the y-intercept is 0, right? So plus 0, you can just leave that off. Additionally, if you looked at it in standard form, it would look like this. ax plus by is equal to 0. Okay, so we're going to see this in a moment. So what I would do here is, again, just find the slope, and you can label this as x sub 1, and this is y sub 1, and this is x sub 2, and this is y sub 2, and then just plug into the slope formula. So m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So y sub 2 is -3, and then y sub 1 is going to be 0, and then x sub 2 is going to be -1, and x sub 1 is going to be 0. So basically, you can get rid of the -0 in each case. You have -3 over -1, which is basically going to be 3. So that's your slope. Let me write that over here. So m is equal to 3. And then writing this in slope-intercept form is really easy. You're just going to say y is equal to m the slope, which is 3, times x, and then again, you would go plus b, but b here is 0, so you don't need to put plus 0 because that's not going to do anything. So it's just y equals 3x. Now, to put this in standard form, you would just subtract 3x away from each side, right? Because again, let me write this out so nobody is confused. You want the ax plus by is equal to c. So we would say that this is going to cancel and become 0, okay? Because nothing else is on this side, I need to make sure I write a 0. A lot of times people will cancel that out and put nothing, and then they get lost in terms of what to do next. So this is gone, and I'm going to put a 0 there. So now I have negative 3x plus y is equal to 0. Okay. Now I don't want this to be negative if I'm using the stricter definition, so I'm just going to multiply both sides by -1. So this is going to get distributed to each guy, and multiplying by -1 just changes the sign. So you're going to end up with -1 times -3x, that's just 3x. Then -1 times y is just -y. Let's just put minus y like this. This equals 0 times anything is 0, so let's just put 0 there. So 3x minus y equals 0. That's going to be your standard form for the line. All right, for the next few problems, the instructions are going to change. We're asked to find an equation of the line. So here for problem 9, we have a 0.5 comma -4, and then another 0.5 comma 3. So immediately what you should notice is that the x value is the same in each case. So if you try to get the slope here, you're going to get an undefined slope, because when we have the slope formula, m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, well, the x values are the same, right? Typically with the slope formula, you write off to the side that x sub 2 is not equal to x sub 1. But here they are equal, right? Because if I do 5 minus 5, I'm going to get 0, and division by 0 is not defined. So when you see this, you know that you have a vertical line, right? So it's just x is equal to whatever that x value is that occurs here and here. So in this case, it's going to be 5. So this is just a vertical line, x equals 5. All right, now we're looking at problem 10. And here, m, the slope is 0, and we're given a point 0 comma -4. If you have a slope of 0, that means you have a horizontal line, and basically, you can just take that y coordinate from that point that you have and say that y is just equal to -4. So it doesn't matter the value of x in this particular case. When you graph this guy, y is always equal to -4, so it's just a horizontal line. All right, let's take a look at the practice test. For the instructions, we're asked to determine if parallel, perpendicular, or neither. For the first problem, we're given 10x minus 2y equals -6, and we're given 5x minus y equals 12. So when you're in this section, basically what you're trying to do is figure out the slope of each line and then compare those slopes and figure out, well, do I have the same slope, or do I have slopes where the product is going to be -1? If neither of those is true, you just put neither down on your test. When you have two non-vertical lines and the slopes are the same and the y-intercepts are different, you're going to have parallel lines. Basically, they have the same steepness, so on the coordinate plane, you're going to see that they're never going to touch. If you graph them, you'll see that they would never touch no matter how far out you go. Then in terms of perpendicular lines, if neither line is vertical, well, then the slopes, if you multiply them together, you're going to get a result of -1. So now that we know that, let's think about the biggest challenge here, or the most tedious part of this, is just getting the slope or extracting that information from the equation. So I'm just going to take my time on this first one. It's going to be a little bit long because I'm going to go through some different strategies you can use, and then on the next ones, we'll just blow through them. So the first thing is we know that for the slope-intercept form of a line, it's y is equal to mx plus b. So m is the slope. This is the slope. So immediately if I have a line in this form, I can just grab the coefficient of x and say, hey, that's my slope. And then the y-intercept would occur at 0 comma b. So we would say 0 comma b is going to be the y-intercept. Okay, so we're immediately going to have that information. Now, if I'm given the equation in standard form, or let's just say the form of ax plus by is equal to c, what information can I get from that? Well, what I could do is I could solve this guy for y. So I could say that I subtract ax away from each side of the equation, and let's cancel this away, and we'll say that we have by is equal to -ax plus c. Let me get rid of this and this and this. I want to keep this here. So let me put this here, and I'm just going to put a little border there, okay? And then arrow down to this, solving for y. We're going to divide everything by b here. And so this is going to cancel, and you're going to get, if you solve this for y, that y is equal to, you have negative a over b times x plus c over b. So matching this up with the slope-intercept form, you can see that the slope is negative a over b. So let me write that out. The slope is negative a over b. And then the y-intercept is going to occur at 0, c over b. So you can get the information from the standard form of a line as well. You just have to know how to extract it. Thinking about this top one here, what I would do is actually make that a little bit simpler. We have 10x minus 2y is equal to negative 6. I would divide everything here by 2. So divide by 2, and then 2, and then 2. And put this into 5x minus y is equal to negative 3. Okay, so just dividing everything by 2. 10 divided by 2 is 5. Negative 2 divided by 2 is negative 1. And then negative 6 divided by 2 is negative 3. Okay, let me get rid of this and put this here. I can solve this for y if I want, and I can figure out what the slope is, or again, I can extract it this way. I'm going to do it both ways, just so that nobody is lost on the first one. And again, on the future ones, I'm just going to fly through it. So I'm going to solve this for y. So let me subtract 5x away from each side. So minus 5x and then minus 5x. This would cancel. You'd have negative y is equal to negative 5x and then minus 3. Okay, let me get rid of this. And you could multiply both sides by negative 1 or divide everything by negative 1, whatever you want to do. Basically, you're going to end up with y is equal to, you would have 5x and then plus 3. Okay, so that's your slope-intercept form. Could I have gotten that using this right here? Yes. And it doesn't matter if you have this one or the one where we divided everything by 2, it's going to work the same. So 10x minus 2y is equal to negative 6. So here, a is 10, b is going to be negative 2, and c is going to be negative 6. So the slope, m, is going to be what? It's negative a is 10, over b is negative 2. So negative 10 over negative 2 is 5. What do we see here? The slope is 5. The y-intercept would occur at 0, c over b. So c is negative 6, b is negative 2. So negative 6 over negative 2 is going to be positive 3. And what do we see from this equation? The y-intercept would occur at 0, 3. Okay, so again, you can extract the information this way using this formula, or you can solve for y, whatever you're more comfortable with. Let me go ahead and get rid of this. All right, let's look at this one now. So we have 5x minus y is equal to 12. Again, I'm going to do this the slow way. I'm going to subtract 5x away from each side of the equation, cancel this away. Negative y is equal to negative 5x plus 12. Let me get rid of this, and then just divide everything by negative 1. And you're going to get y is equal to 5x and then minus 12. Again, if you had used the shortcut, you'd have 5x minus, let's go ahead and put plus negative 1y equals 12. Well, here a is 5, b is negative 1, and c is 12. So the slope, m, is equal to negative a, so negative 5, over b, so over negative 1, and that's going to be 5. So exactly what we have here. Then your y-intercept would occur at 0, c, which is 12, over b, which is negative 1, and 12 over negative 1 is negative 12. So again, it's exactly what we have here. Okay, so you can use this formula or you can go the slow way, whatever you want to do. Let me get rid of this. So if we have the same slope in each case and different y-intercepts, well, yeah, we're going to have parallel lines. We're going to have parallel lines. Now, let me grab this real quick. And I made some graphs for us to look at. You can always type this into Desmos if you want to make your own. It's kind of up to you. So this first one, you have y equals 5x plus 3. So the y-intercept occurs at 0, 3. So that's right here. And the slope is 5. So you can go up 1, 2, 3, 4, 5 units, go 1 unit to the right. So that's another point. So that's how you can sketch that line. This one is y equals 5x minus 12. So the graph's going to cut off, so you can't really use the y-intercept of 0, negative 12 here, but you can get other points. You could plug in something like, let's just say 1 for x. So 5 times 1 would be 5, and then 5 minus 12 would be negative 7. So go 1 unit to the right and then 7 units down. So that would be right there. So that's a point. And then again, your slope is 5. So you go up 1, 2, 3, 4, 5 units and then to the right 1. So there's a point. And again, you can make as many points as you want. The idea here is you could sketch these two lines and you can see that they're going to be parallel. They're going to have the same slope or steepness. So they're never going to intersect in this coordinate plane. All right, let's take a look at problem 2. So here we're going to go a lot quicker. We have 7x minus 3y equals 15. And then here we have 3x plus 7y equals 147. So again, how can we quickly get the slope if this is an ax plus by equals c? Your m is equal to negative a over b. So a here is 7. B here is going to be negative 3. And c here is going to be 15. You really only need a and b, so don't even worry about c, but I'm just going to label it for completeness. So for a, that's going to be 7. So you want negative 7 there. And then for b, that's going to be negative 3. So the slope here is 7/3. Then for this one, your slope m is going to be, again, negative a over b. So this is your a, and this is your b, and again, this is your c. So a is 3, so negative 3 over b is 7. And so this is 7/3, and this is negative 3/7. Are those slopes the same? No. Would they multiply together to give you negative 1? Yes, they would. If you take this guy right here, 7/3, and you multiply it by negative 3/7, you're going to get negative 1. So these lines are perpendicular. Let me write this out. So these lines are perpendicular. So just like in the last example, I went ahead and made a simple sketch with a computer. You can see that when these two lines intersect, they're going to do that at a 90-degree angle, or you could call that a right angle. So you see that right angle symbol there. Again, if you want to do this on your own, you can just go to Desmos and make a sketch. All right, let's take a look at problem 3. So here we have negative 3x minus 3y equals 19. And then we have negative 6x plus 6y equals 38. So here I'll say that m is equal to negative a over b. And then I'll do that here as well. So m is equal to negative a over b. So this is going to be your a, that's negative 3. This is going to be your b, that's also negative 3. And I'm just going to put this for completeness. This is your c, although you don't need it. Then here, this is going to be your a, this is going to be your b, and this is going to be your c. Now, you could make this equation simpler by dividing everything by 2. So maybe we'll do that real quick and say that if I divide this by 2 and this by 2 and this by 2, I would have negative 3x and then plus 3y is equal to 19. So let me actually just move this down here, slide down just a little bit and say that here a is negative 3, b is 3, and c is 19. Again, it would work if you use the initial values. It's not going to matter. But just for completeness, I went ahead and labeled this. Okay, so up top here, the negative of negative 3. Be very careful. So the negative of negative 3. Let me plug that in. Over negative 3. So the negative of negative 3 is 3. And then over negative 3, this is going to give me negative 1. Down here, you have the negative of negative 3. And then here you have over 3. So the negative of negative 3 is 3. So this is 3 over 3, which is 1. Would the product of the slopes be negative 1? Yes. You'd have negative 1 times 1, which is negative 1. Let me show that. So 1 times negative 1 equals negative 1. So we can say that these lines are perpendicular. I'll just write that out. So these lines are perpendicular. So I did make a sketch, again, a computer-generated one. You can see where these lines intersect. You're going to have a 90-degree angle or a right angle. You see that right angle symbol there. Again, you can go to Desmos and just make a sketch on your own if you want to see it. All right, let's take a look at problem 4. So here we have 15x plus 19y equals 21. And we have 3x plus 26y equals 28. So here, let's say this is A, let's say this is B, and let's say this is C. So your m is equal to the negative of A is 15, over B is 19. So just negative 15 over 19. Then here, m is equal to the negative of A. So A here is 3, B here is 26, and C here is 28. So the negative of A is 3, so negative 3, over B, and that doesn't look like a B, so let me make that a little bit better. So B here is 26, so over 26. So you can see this is obviously going to be neither. If I look at the slopes, they're not the same, so they're not parallel lines. And if I look at the product of the slopes, if you have negative 15 over 19, and I multiply that by negative 3. Let me push this negative over here a little bit closer. Over 26, well, this is not going to be negative 1. I'm not even going to do this because we know it's not going to be equal to negative 1. I'm just going to put it's not equal to negative 1, and so they're not perpendicular either. So we'll just say that they're neither. So neither, and that's going to be our answer. Now, once again, a good way to confirm this, if you're a little bit lost, is to make yourself a little sketch. Go to Desmos, type in your equations, and take a look. You can see that these two lines do intersect, so they can't be parallel lines. And you can look at where they intersect and ask yourself, do I have a 90-degree angle that's being formed? No, absolutely not, right? If you think about this guy and this guy, those are definitely not 90 degrees. And then this angle right here and this angle right here, those are not 90 degrees either. So obviously these lines are not going to be parallel or perpendicular lines. All right, for the next few problems, the instructions are going to change. Now we're asked to write in standard form. So for problem 5, we're given a point, which is negative 2 comma negative 4. So that's a point on the line. And then we're told that it's parallel to 4x minus y equals 5. So the first thing is, we know from a previous lecture that if we have a point in the slope, we can use what's known as the point slope form. So let me write that out. So point slope form. And that looks like this. Y minus y sub 1 is equal to m times the quantity x minus x sub 1. So x sub 1 and y sub 1, that's coming from the point that you're given. So I can label this now as x sub 1 and y sub 1. All we need really is to get the slope here. And you're going to get that from this part right here where it says parallel to. We know that parallel lines have the same slope, so I can just find the slope of this, and that would be the slope for this. So let's go ahead and say, in this form right here, that I can get the slope m as being equal to negative a over b, where again, this is a. Let me go plus negative 1 here. That's going to be b, and this is going to be c. So negative 4, if I plug in a 4 for a, over negative 1, if I plug in a negative 1 for b. So the slope here is going to be 4. So all you have to do now is just plug in. You plug in a 4 for m, you plug in a negative 4 for y sub 1, so minus a negative 4 is plus 4, and then you're going to plug in a negative 2 for x sub 1, so minus a negative 2 is plus 2. Once you have this set up, don't worry about any of this information anymore. I'm just going to grab this and come to a fresh sheet so we can work on this. So the first thing you would do is solve this for y and get the slope-intercept form. So let me get rid of this. I'm just going to solve for y. So we'd say y plus 4 is equal to, go ahead and distribute this to each guy. So 4 times x is 4x, and then plus 4 times 2 is 8. Now let me subtract 4 away from each side of the equation. That would cancel away. And you're going to end up with y is equal to 4x, and then plus 8 minus 4 is 4. Okay, so this is the slope-intercept form. What we want is the standard form. So again, that's the ax plus by equals c. If you're using the stricter definition, a, b, and c need to be integers. And you would say that there's no common factor other than 1 between a, b, and c. And a needs to be non-negative. So quite a lot of things that you need to do. Here I would subtract 4x away from each side of the equation. Let's go ahead and cancel this and say we have negative 4x plus y is equal to 4. Because this is a negative 4, I need to fix that because of the stricter definition. So what I would do is either multiply both sides by negative 1 or divide everything by negative 1. I'm just going to divide everything by negative 1. I think that's the simplest path. And I'll go ahead and say that my answer here, negative 4 divided by negative 1 is 4. So this is 4x. And then you basically have a 1 divided by negative 1, which is negative 1. So let's go minus y. And this equals 4 divided by negative 1 is negative 4. So this right here would be your answer in standard form. All right, let's take a look at problem 6. So now we're given a point, which is 2 comma negative 5. And again, parallel to, we have 4x plus y equals negative 3. All right. If we have a point and we have the slope, we use point slope form. So point slope form. So y minus y sub 1 equals m the slope times the quantity x minus x sub 1. All right, so this right here, this is x sub 1 and this is y sub 1. So you're just going to plug in. But we need to get the slope, and again, parallel lines have the same slope. So all we have to do is figure that out from here, and this is in the form of ax plus by equals c. So this is my a. Let's go ahead and say 1 is my b, and this is my c. Again, you don't need c for this, but I like to write it for completeness. So let's go ahead and say that m is equal to the negative of a over b. So a here is 4, and b here is 1. So basically this is negative 4 over 1, which is negative 4. So let's plug in. M, the slope is negative 4. We have x sub 1 is going to be 2. And we have y sub 1, which is negative 5. Minus the negative 5 is plus 5. Again, once you have this set up, go ahead and just take it and move it to a new sheet. Forget about the information you were given. You don't need it anymore. Just coming over here and we're going to solve for y. I'm going to get rid of this. I'm going to solve for y. So I'm going to distribute this here. So I'm going to be getting my slope-intercept form. So y plus 5 is equal to negative 4 times x is negative 4x. And then let me go plus negative here. Negative 4 times negative 2 is plus 8. Let me subtract 5 away from each side of the equation. This would cancel away. And you're going to get y is equal to negative 4x. And then plus 8 minus 5 is going to be 3. Let's write that like that. So if you were asked for slope-intercept form, you'd be done. But we were asked for standard form. That means we have one additional step. Again, we want the ax plus by equals c. So to get that here, you just add 4x to both sides of the equation. And so that would give me 4x plus y is equal to 3, right? So this right here, you could show that as canceling away. Now this is going to be okay because a, your coefficient of x, is non-negative and it's an integer. So you have a, b, and c are integers. There's no common factor other than 1. And again, this guy is non-negative. So basically you're good to go. This would be your answer in standard form. You have 4x plus y equals 3. All right, let's take a look at problem 7. Now we're given a point of 1, 3, and then parallel to 3x plus 2y equals negative 8. So again, I'm going to set up my point slope form. So my point slope form, y minus y sub 1 is equal to m times the quantity x minus x sub 1. So this here, let's label it as x sub 1, and this is y sub 1. And then we need the slope. So m is equal to, again, negative a over b, if this is in the form of ax plus by equals c. So this is a, this is b, and this is c. Again, you don't need c here, but I'm putting it for completeness. So a is 3, so just plug that in. So you'll have negative 3 there. And then b is 2, so let's put that there. So the slope is negative 3 halves. So now we have all the information we need. So this is negative 3 halves. Your y sub 1 is 3, and your x sub 1 is going to be 1. So go ahead and grab this real quick, and we'll paste this in. We'll solve for y, and then we will put it in standard form. So let's distribute this to each guy here. And let's go ahead and say that we have y minus 3 is equal to negative 3 halves x. Let me go plus negative 1 there. Let's get a little bit messy there. So let me change this up a little bit and make that plus sign legible and make this negative 1 legible and then drag that over there like that. So you have negative 3 halves x, and then negative 3 halves times negative 1 would be plus 3 halves. So what I would do now is just add 3 to both sides, cancel this away. So you get y is equal to negative 3 halves x, and then plus, for this, you need to get a common denominator. So let me multiply this by 2 over 2. So this would be 3 times 2, or 6 over 2. So 6 over 2. So 3 plus 6 would be 9 over the common denominator of 2. So this is our slope-intercept form. For standard form, again, I'm going to want the ax plus by equals c. So let me add 3 halves x to both sides of this equation. This will cancel away. We're going to have 3 halves x plus y is equal to 9 halves. Depending on your class, you may have a definition for standard form where a, b, and c are real numbers. If that's the case, you can stop. You have standard form. If you're in a class where they use the stricter definition, which is most classes, you're going to want to do some additional work here. You don't want fractions. You want an integer here, here, and here. So you got to clear these fractions, and it's real easy to do. You would just multiply everything by 2 because that's the LCD, right? You have a denominator of 2 and a denominator of 2. So I'm just going to multiply both sides of the equation by 2. And so distribute this in here. You're going to have 2 times 3 halves x plus 2 times y is equal to 9 halves times 2. So the 2's would cancel. You have 3x plus 2y is equal to, the 2's would cancel, you get 9. So 3x plus 2y is equal to 9. That's going to be the standard form for the line. All right, let's take a look at problem 8. So here we're given a point, which is 4, negative 1, and we're told that it's perpendicular to, we have y equals 5 halves x minus 2. Okay, so let's start out, again, by saying that we're going to use the point slope form. So point slope form. And we have y minus y sub 1 is equal to m the slope times the quantity x minus x sub 1. So again, the point given, you say this is x sub 1 and this is y sub 1. So that's pretty easy. But how do we get the slope here? So this is in slope-intercept form. So I know the slope of the line that's perpendicular, the m is 5/2. So we have 5/2. Now, we know that perpendicular lines have slopes whose product is -1. So that means this guy right here, the missing m value, let's say I just multiply this by m, the result here would be -1. Okay, so all I have to do is solve this simple equation. And so basically what I would do is multiply both sides by 2/5 like this. And so this right here is going to cancel away. And so m would be equal to -2/5. And that would make sense because if I think about the slope of this line right here, if it's perpendicular to this guy, well, -2/5 times 5/2, that would give me -1. And so those two lines would be perpendicular. So now I can just plug in here and say this is -2/5. And then I can plug in for x sub 1. That is going to be 4. And I can plug in for y sub 1. That's going to be -1. So this is +1, right? Minus the -1 is +1. Again, once you have this information, leave the other stuff behind. I've seen students just get confused by it. So we're just going to a fresh sheet. And I'm going to distribute this and just solve for y. So we have y plus 1 is equal to -2/5 times x is -2/5 x. You can go plus negative here. And we'll say that -2/5 times -4 would be +8/5. Okay. Thinking about this now, I would subtract 1 away from each side. To get a common denominator, let's write 1 as 5/5. This would cancel away. You get y is equal to -2/5 times x plus 8 minus 5 would be 3. So this is 3 over the common denominator of 5. If you want slope-intercept form, you're done. If you want standard form, there's a little bit more work you need to do. So let's add 2/5 x to both sides of the equation. And let's show this as canceling. And let's say that we have 2/5 x plus y is equal to 3/5. What I would do here, because I want integers, right? I want an integer here and here and here. I would clear those denominators by multiplying everything by the LCD, which is 5, right? The denominator here is 5 and also here. So really easy. Just multiply both sides of the equation by 5. And so that's going to give me, let me distribute this here and here. You would have 5 times 2/5. We know that would be 2. So this is 2x plus 5 times y is just 5y. And this equals 5 times 3/5. The 5s would cancel and you just get 3. So this would be your standard form. Your 2x plus 5y equals 3. All right, let's take a look at problem 9. So here we have a point that's given, which is -3, -2. Let me just label this now. So this is x sub 1, and this is y sub 1. Let me write a 1 as the coefficient for x for clarity. So my perpendicular line is going to have a slope of 1. So basically, this guy is going to have a slope of -1. I think you can do that in your head. If not, again, you can always say, okay, this is the slope that I have, which is 1. If I multiply that by the unknown slope, let's just call it m, it has to be equal to -1. Well, basically, m times 1 is just m. So m is just equal to -1, right? Obviously, if you multiply -1 times 1, you would get -1. So let's say we plug into the point slope form of the line. Let me write here that m is equal to -1. So you have your y minus y sub 1 is equal to m the slope times the quantity x minus x sub 1. So for y sub 1, it's -2. So minus the -2 is +2. For m, it's going to be, again, -1. You could write -1 or you could just put a negative out in front. It's up to you. Maybe I'll just write -1 there for clarity. For x sub 1, it's going to be -3. So minus the -3 is +3. Okay, let me grab this and let's paste this in here. And again, I'm just going to start things off by solving for y. So we'll have y plus 2 is equal to, basically you're going to distribute that -1 to each guy. It's just going to change the sign of each term. So instead of x, you'd have -x. Instead of 3, you'd have -3. And so to solve for y, let's subtract 2 away from each side of the equation. That would cancel from over here. You're going to get y is equal to -x. And then -3 minus 2 is -5. And then if you want to put this in standard form, in this particular case, it's not that much work. Just add x to both sides of the equation, and you're going to get x plus y is equal to -5. So this is your standard form right here. All right, let's take a look at problem 10. So here we're given a point, which is -3, 2, and we're told it's perpendicular to y equals 1/2 x minus 4. All right, so we know the slope here is 1/2. And again, if I'm thinking about my point slope form, let me write it out. So y minus y sub 1 is equal to m times the quantity x minus x sub 1. Well, again, I know that this is x sub 1 and this is y sub 1. The unknown is the slope. So I know the slope here is 1/2. So let me put m, which is the unknown from here, times 1/2. Again, if these are perpendicular lines, it has to be equal to -1. So how do we solve this? You can multiply both sides by 2. And so if I do that, if I multiply over here by 2 and over here by 2, this is going to cancel with this. Let me show that. And so you'd have m is equal to -1 times 2, which is -2. So of course, -2 times 1/2 would be -1. So our slope here is going to be -2. All right, let me erase this and put a -2 in. And then for x sub 1, I want a -3, so minus a -3 is +3. And then for y sub 1, it's going to be 2. All right, let's grab this real quick and let's paste this in here. And what I want to do is distribute this into each guy. So y minus 2 is equal to -2 times x is -2x. And then -2 times 3 is -6, so minus 6. Let's add 2 to both sides of the equation. That cancels. You get y is equal to -2x. And then -6 plus 2 is going to be -4. All right, to put this in standard form, it's pretty easy. We're just going to add 2x to both sides of the equation. And so this is going to cancel. And we're going to get 2x plus y is equal to -4. So this would be the standard form for the line. All right, let's take a look at the practice test. For the instructions, we're asked to graph each, state the domain, and range. All right, for problem number 1, we're going to start off with the identity function. And we have f of x is equal to x. Now, I've already pre-drawn everything for us. Let me just write in this is f of x is equal to x. But again, you want to be able to draw this on your own. So if you haven't seen the graph before, of course we saw it in the lesson, but if you haven't seen the graph before, then how would you sketch the graph? Well, realize this is a linear equation in 2 variables. You could write this as y is equal to x. So this is in the form of y equals mx plus b. You could put +0 out here if you want to make that crystal clear that the y-intercept is going to occur at 0, 0. So this guy right there. Let me make a little t-table. So x and then y, and let me put 0 and then 0 there. And of course, if you look at this, the slope is 1. So that means I can go up 1 to the right 1. So this point right here would be 1, 1. I'm not going to put that in there because we have some points already there. But notice that whatever I plug in for x, I get that for y. That's why it's called the identity function. So it pairs every real number with itself. So something like 6, 6. 6 for x and then 6 for y. And then something like -6, -6. So -6 for x and then -6 for y, so on and so forth. We know that 2 points make a line. So once you have your points there, you can just draw your graph like this. Okay, let me get rid of this. And let's write down the domain. And then let's write down the range. And I don't know if I can fit it there, so let me scooch it down here. Let me put the range. In each case, it's going to be all real numbers. When you think about f of x equals x, well, I can plug in anything I want for x. I can plug in a negative, 0, positive, whatever I want. So in interval notation, we would say from -infinity to +infinity. And then for the range, well, since I can put in whatever I want for the domain, I'm going to be able to get out whatever I want for the range. So that would be all real numbers as well. Because again, whatever I plug in for x, I get that for y. So this is -infinity to +infinity, or again, all real numbers. All right, for problem 2, let's take a look at the squaring function. So this is f of x equals x squared. So let me come down here again and just write out f of x equals x squared. I've already pre-drawn the graph. So this is a shape called a parabola that we really need to understand. This is something we're going to work with a lot in this course. And when we start doing graphing transformations, we really need to understand the basic shape of this guy, also the domain and the range. So what I would do here is just think about the fact that this guy is going to pair every real number with its square. So we know that when we square something, we get a result that's non-negative. Let me actually start with the domain and the range, and then we'll do the points in a moment. Let me write out that the domain here is all real numbers. I can plug in whatever I want for x. So from -infinity to +infinity. But when I square something, again, the result is non-negative. If I square 0, I'm going to get 0. If I square a positive number, I'm going to get a positive number. But when I square a negative number, again, a negative times a negative is a positive, so I'm going to get a positive number. So what we would say is the range is going to be non-negative. So from 0 going out to positive infinity. And you can see that by looking at the graph. The smallest y value here is going to be 0, and then it goes up to positive infinity. Now, in terms of getting some points here, these are just some things that, again, you can plug in with a t-table. Some of these you would have memorized at this point, or hopefully you would have. But something like 0, 0, and then something like -1, 1. So -1, 1. Again, if you plug in a -1 for x and you square it, you get positive 1. But then you would also have 1, 1, and then you would have something like -2, 4. And let me move this out of the way so I can keep going here. And you would have something like 2, 4. And of course, you can keep going. You have something like -3, 9. And then 3, 9. So that's enough points to sketch the graph. All right, let's take a look at problem 3. So now we have the cubing function. So we have f of x equals x cubed. So once again, this is already drawn for us. So f of x is equal to x cubed. Now, let's start off with the domain and range for this one. Again, when we looked at f of x equals x squared, we know that if we square a negative, we get a positive. We know if we square 0, we get 0, and if we square a positive, we get a positive. But when we cube a negative, we keep a negative. Something like -1 cubed, well, that's still -1, because an odd number of negative factors is going to still be negative. When we cube 0, we get 0, and when we cube a positive, we're going to get a positive. So really here we can see that the domain is all real numbers. I can plug in whatever I want for x, and the range is also all real numbers because I can get anything out for y. And you can see this from the graph. The y values here extend from -infinity to positive infinity. So let me write for the domain, again, the set of allowable x values, you can plug in whatever you want for x. So this is all real numbers. So from -infinity to positive infinity. And then for the range, well, again, I can get anything out for y. And so that's going to be all real numbers as well. So from -infinity to positive infinity. Again, looking at this graph right here is just one that you want to know. You can always use a t-table to set things up. So you have your x and your y. So something like, let's say, -2, -8. So 2 units to the left and 8 units down. So -2, -8, and then something like -1, -1. This 0, 0, I didn't highlight that as a point, but of course that's going to be on there. And then, of course, you can go through and then make this positive and this positive and this positive and this positive. In other words, you can just say that this would be 1, 1, so that point right there, and then you would have 2, 8, and so on and so forth. This is enough for me to be able to find this shape. All right, for problem 4, we have the square root function. So f of x equals the square root of x. So again, I have that pre-drawn here. So let's write out f of x equals the square root of x. Remember that we have different notation for whether or not we want the positive number that when squared gives us the number, or the negative number that when squared gives us the number. Something like the square root of 4, by definition, this is the principal square root, so this is 2. 2 is the positive number that when squared gives me the radicand 4. If you wanted the negative number that when squared gives you that number 4, well, you put the negative out in front. So this is the negative square root of 4, and this is -2. So you just want to make sure you understand the notation here. So let me get rid of this. So when we look at the domain, remember that in the real number system, we cannot take the square root of a negative number. Of course, we can use the imaginary unit I, but we're not talking about that here. So when we think about the domain, it's always in terms of the real number system. And so what you would do is say that you can take the square root of 0 or any positive number. So from 0 and including 0, going out to positive infinity. And you can see that in the graph, starting at 0 and then going to the right out to positive infinity, but you don't have anything over here to the left of 0. Then in terms of the range, it's going to be the same thing, because I can take the square root of 0 and get 0, or I can take the square root of any positive number as large as I want. So I can make this as large as I want going out to positive infinity. So this is from 0 going out to positive infinity. In terms of these points, again, you just need a few of them to get the general shape. So something like, let's say x and then y there. So we know 0, 0. Of course, if you think about perfect squares, you would do 1 and then 1. Square root of 1 is 1. And then you can do 4 and then 2. Square root of 4 is 2. And then you can do 9 and then 3. Square root of 9 is 3. You could do 16 and 4. So the square root of 16 is 4. But of course, if you have a standard piece of graph paper, it's kind of hard to do those bigger numbers. So I would just stick to these points. Again, just sketch this as a smooth curve, and you're basically good to go. All right, let's take a look at question 5. So here we have f of x equals the cube root of x. So this is the cube root function. So let me write out f of x is equal to the cube root of x. And of course, the domain here would be all real numbers, because I can take the cube root of a negative, I can take the cube root of 0, and I can take the cube root of a positive. So let me start by just saying that the domain is all real numbers. So from negative infinity to positive infinity. Then in terms of the range, again, it's just going to be the same thing, because I can plug in whatever I want for x, a negative, 0, a positive. So I can make this as large as I want or as small as I want. I can make it 0. So this would be all real numbers as well. So from negative infinity to positive infinity. So you don't need too many points to get this general shape. So what I have here, let me make a little t table. I have x and then y. So this point right here is negative 8 comma negative 2. So negative 8 comma negative 2. The cube root of negative 8 would be negative 2, because negative 2 cubed would be negative 8. Then something like 0 comma 0, which I don't have that shown here. I can just put it in real quick. But the cube root of 0 would be 0. And then something like 8 comma 2. Again, the cube root of 8 would be 2, because 2 cubed would be 8. So I think that's enough to get the general shape here. All right, let's take a look at the practice test. For the instructions, we're told for the given piecewise-defined function, find f of negative 3 and f of 3. So coming down here to problem 1, again, let me write this down so we don't forget. So we want to find f of negative 3 and then f of 3. So this is our piecewise-defined function. Again, we have a different rule based on where we are in terms of x. So f of x is equal to, if x is greater than or equal to 0, we want negative 5x minus 3. If x is less than 0, we want x squared minus 3. Well, if we're trying to find f of negative 3, well, where is negative 3? Well, negative 3 would be less than 0. So if x is less than 0, like this case here, we want to use x squared minus 3. So this would be equal to, you're going to plug in a negative 3 for x right there. That would be squared, and then minus 3. So this would be equal to, negative 3 squared is 9. So you have 9 minus 3, which would be 6. So f of negative 3 would be 6. For the next one, we have f of 3. So that falls in the category where x is greater than or equal to 0. So you want to use this right here. This negative 5x minus 3. So this equals negative 5. Again, I'm just going to plug in a 3 for x, and then minus 3. So this equals negative 5 times 3 is negative 15, and then minus 3. So this equals negative 18. So f of 3 is negative 18. F of negative 3 is positive 6. All right, let's take a look at problem 2. So here for the instructions, we're told for the given piecewise-defined function, find f of negative 5, f of 1, and f of 7. Let's write these out. So f of negative 5, f of 1, and then f of 7. Okay, let's come down here to problem number 2. So here we have our f of x equals, you'll see if x is greater than or equal to 2, we have this quantity x minus 2 cubed plus 1. Then if x is greater than or equal to 0 and less than 2, we have this x to the 4th power minus x minus 5. And then lastly, if x is less than 0, we have negative 2x squared minus 7. So this first one, and this doesn't look so good, but this is f of negative 5. Let me rewrite that so it's more clear. This guy would follow this rule right here, because it's if x is less than 0, well, negative 5 is less than 0. So let me start with negative 2, and then I'm going to plug in a negative 5 for the x there, and this is being squared, and then minus 7. So following the order of operations, you would want to square this first. So this is wrapped. So negative 5 being squared is 25. So let's say this is equal to negative 2 times 25, and then minus 7. So negative 2 times 25 is negative 50. So this would be negative 50. And then you have minus 7. So to finish this up, negative 50 minus 7 would be negative 57. Now we don't need all this scratch work. I'm just going to erase this and put that this is going to be negative 57. Now moving on here to f of 1, if we look, that's going to fall in this category here. So where x is greater than or equal to 0 and less than 2. So we would take this guy right here. So x to the 4th power. Again, you're just plugging in for x. So this is 1 to the 4th power. And then minus, you're plugging in a 1 for x. And then minus 5. So 1 to the 4th power is 1. So you would have 1 minus 1 minus 5. So this becomes 1 minus 1 is 0, and then minus 5, and 0 minus 5 is negative 5. Let me erase this and just put that we have negative 5 there. And then the last one is f of 7. So that's going to go into this case right here. So x is greater than or equal to 2. So we would plug in for x there. So this is a quantity. So you'd have 7. Again, just plugging in for x there. Minus 2. And then this would be cubed. And then plus 1. So if we think about 7 minus 2, that's 5. So you have 5 cubed. And then plus 1. 5 cubed is 125. And then plus 1. So this would give me 126. Again, let me just erase this and put that this is 126. So here we have f of negative 5. That's going to be equal to negative 57. F of 1 is equal to negative 5. And then f of 7 is equal to 126. All right, for the next problem, we have the instructions where we're asked to find f of negative 2.3 and f of 7.6. So here is f of negative 2.3, and then here is f of 7.6. And come down to problem 3. So again, you have your greatest integer function here. The notation may vary, but again, what you're trying to say here is that the greatest integer function is going to pair every real number x with the greatest integer less than or equal to x. So remember, it's less than or equal to x. So what that means is that if you plug in an integer for x, so let's say, for example, I wanted f of positive 2. Well, it's just that number. But if I wanted something like, let's say, f of 2.5, I'm not going to go to 3. If you look at this in terms of the number line, I'm always going to go to the left to my nearest integer. So let's just say this is 2.5 here. Well, I'm not going to go up to 3. I want to go down to 2. Again, that's a movement to the left on the number line. I'm going to go to that integer right there. So this would be 2 as well. So if you have an integer that you're plugging in, it's just the integer. If you have something that's not an integer, you can put it on a number line if you need to, but you're going to the left to the nearest integer. You could say you're going down to the nearest integer, however you want to think about that. So what we wanted to find, let me erase this, f of negative 2.3 and f of 7.6. So here, negative 2.3, if we want to draw that on the number line, let's just say it's about right there. That wouldn't be perfect, but let's just say that's negative 2.3, just for reference. Again, this is not an integer, so what you want to do is go to the left. You want to go to the left to the nearest integer. So the nearest one's going to be negative 3. Again, always go to the left, don't go to the right. You're going down. So I'm going to say that this right here would be equal to negative 3. And let me actually erase all this so the answer is clear. And I could do this in a different color. So this would be negative 3. This one is f of 7.6. So let's say that 7.6 is about, let's just go right there. It doesn't really matter. So let's just put it in right there. And again, it's not an integer. So I want to go down to the nearest integer. I want to go this way to the left. Let me use a different color here. To the left, and I'm going to hit 7 there. So f of 7.6, that's going to be 7. So that's really all it is. Once you get used to working with this function, it's really not that bad. But the first few times you try to evaluate something, you might make a simple mistake or something like that. Just think about the definition. If you need to, pull out a number line and do what I did here. All right, for the instructions now, we're going to change things up and graph the given piecewise-defined function. And for problem 4, you have f of x is equal to the square root of x if x is greater than or equal to 0, and then the absolute value of x plus 2 if x is less than 0. So let's start with this part right here. We know what the square root of x looks like. And coming to the graph, again, this right here is your square root function. Now, the square root function, if you look at f of x equals the square root of x, well, we know the domain of that is from 0 and including 0 going out to positive infinity. So you wouldn't have anything over here to the left of 0 anyway. So that's this graph right here. And I can put in specifically that x is greater than or equal to 0 just to make that crystal clear. And then this graph over here is going to be f of x is equal to the absolute value of x plus 2. And we're going to specifically say that x is less than 0. So if you plugged in a 0 here, 0 plus 2 is 2. The absolute value of 2 is 2. So you see if you go right here, you have 0, 2, you have an open circle there. So we're going to exclude that because x is strictly less than 0. So you don't want that point in there, but you can put that in there for reference to make this graph. Now we know the absolute value function. If you just graph f of x equals the absolute value of x, that's a V shape. But this guy right here, we're going to learn later on, it's been shifted 2 units to the left. You might know that from algebra 2. If you don't, it's not that big of a deal. You can just make some points to get this. So something like this point right here, which is negative 2, 0, again, if you plug in a negative 2 for x, negative 2 plus 2 is 0. Absolute value of 0 is 0. So that's how you get that point there. Something like this point right here, which is negative 6 comma 4. Again, if you think about it, negative 6 plus 2 is negative 4. The absolute value of negative 4 is 4. So that's how you get that point right there, negative 6 comma 4. And then another point that we put in, so this is negative 8 comma 6. Negative 8 plus 2 is negative 6. Negative 6, if you take the absolute value of that, you get positive 6. So that's how you get this negative 8 comma 6. So that's how you can sketch this part right here. Again, this is the main thing to realize, is that you're going to have an open circle right there. And this right here is just your regular square root function. All right, let's take a look at problem 5. So here we have f of x is equal to, you've got your x minus 4 if x is greater than or equal to 2. You've got 3 if x is greater than negative 2 and less than 2. And then you've got 2x minus 1 if x is less than or equal to negative 2. Pretty easy to do overall. I would actually start with this one right here in the middle, just because it's the easiest. So you're just going to have a horizontal line y equals 3, where x is greater than negative 2 and less than 2. Let me show you that part real quick. So coming down here, again, that is the line y is equal to 3. And we are drawing this where x is greater than negative 2 and less than 2. You see you have an open circle here at an x value of negative 2 and an open circle here at an x value of positive 2. That's all it is. In terms of this part and this part, let me go back up. You have x minus 4 if x is greater than or equal to 2. So let's put y equals x minus 4. And we're going to put where x is greater than or equal to 2. That's going to be this right here. So this is in slope-intercept form. So we know that immediately one point would be 0 comma negative 4. But the problem is that this is only valid for x is greater than or equal to 2. So this point right here will not be, and let me show this in a different color, this would not be on the graph because, again, you want where x values are 2 or larger. But you could use it to make a graph. You could just cut it off after. So in other words, put that point in, and then your slope is 1. So you can go up 1 to the right 1, up 1 to the right 1. There's a point that's going to be there. That's going to be 2 comma negative 2. Then you go up 1 to the right 1, up 1 to the right 1, so on and so forth. This right here would be your x-intercept. And of course, you could have done it that way as well to get a point. So you could put a 0 in for y there and solve for x. So if you did that, 0 is equal to x minus 4, add 4 to both sides, you get x is equal to 4. So that point 4 comma 0 would be your x-intercept. And so you could use that. And then again, the slope is 1. So however you want to get these points, that's really up to you. Of course, once you've done that, you're going to delete that from there. You're going to put this point in. Again, this is a filled-in circle because x here can be 2. 2 or anything larger, starting from here and then going this way. Now this one, you're going to use the same thought process. You have when x is less than or equal to negative 2, 2x minus 1. So let's write out y is equal to 2x minus 1. And I'm going to put for x is less than or equal to negative 2. That's going to be this guy right there. Again, you can use the fact that the slope is going to be positive 2, and the y-intercept would occur at 0 comma negative 1. 0 comma negative 1 is not going to be on this graph, but you could just use it for making the graph. So you can put this in. The slope is 2. So that means I can go down 2 and to the left 1. In other words, you could say that the rise over the run is negative 2 over negative 1 because that's equal to 2 over 1. So I can go down 2, 1, 2, to the left 1. Down 2, 1, 2, to the left 1. So there's a point. Down 2, 1, 2, to the left 1. So there's a point. So on and so forth. So you can see that this point right here, which would be negative 2 comma negative 5, that would be on the graph, and then you could just use this to get additional points. So that's one way you could do this. Of course, there's other ways. You could make a t-table if you want. It's really going to be up to you what you want to do. Let me erase that stuff. So this part right here would be your y equals 2x minus 1, or you could say f of x equals 2x minus 1, where x is less than or equal to negative 2. Then this part right here would be y equals 3, where you could say f of x equals 3, where x is greater than negative 2 and less than 2. And then this part right here would be y, or again, f of x is equal to x minus 4, where x is greater than or equal to 2. All right, let's take a look at the practice test, where the instructions were asked to find the intervals where the function is increasing, decreasing, or constant. All right, let's take a look at the first problem. So when we look at the graph here, again, if you're trying to find the intervals where it's increasing, decreasing, or constant, you're thinking about what happens to the graph or the y values as the x values increase, or as we're going from left to right. In other words, as I go this way, what's happening to the y values? Well, they're increasing. They're increasing, increasing, increasing until I get to an x value of negative 5, and then they're going to be decreasing, decreasing, decreasing. So really, I could say this is increasing, increasing on. And you're always going to put this in terms of the x values. You don't want to include the y values here. That's a common mistake. So from this guy, we're going to increase basically from negative infinity to -5. And neither will be included there. You always use the open interval notation when you're doing this. And then we're going to be decreasing. So decreasing on the interval. So we're going to go -5 out to +infinity. If it helps you, you can always draw a stick figure. I think it's pretty obvious that we're increasing here and decreasing here, but for some people, they need it. So you could always draw a stick figure like this, like that. So that's your guy walking. And just think about, is he walking up or is he walking down? Well, this guy's walking up, right? So he's going up. That means I'm increasing in terms of the y values until I get to this x value of -5. And then if you draw a picture here, let me see if I can get this guy in here. So now, and maybe the legs could be better. So let me do that again. Now he's going to be walking down. So we're increasing from negative infinity coming up to -5. And then we're decreasing from -5 going out to +infinity. All right, for problem 2, when we look at this graph here, what we see is that, again, coming from negative infinity up to where we get to an x value of -1, let me arrow to that and say this is -1. Let me arrow to this and show that this is +1. So from negative infinity going up to -1, we are decreasing. Again, if you want to draw the stick figure, you can, just to make that crystal clear. So this guy is going this way, and maybe I messed up the legs a little bit. Let me try to draw that again. Not the best drawer in the world, but I'll do my best. We are decreasing. This guy is going downhill. So until we get to an x value of -1. So let me put that we are decreasing on. So this is from negative infinity up to -1. Again, we're not including anything here, so we have a parenthesis here and then also here. Then you would say we're increasing. So we're increasing on what interval? Well, we increase where the x value is 1 going out to +infinity. Again, here you would be walking up. Let me put this like that. This guy's walking up. So let's say that this would be +1 going out to infinity. Well, what's happening between -1 and 1? Well, you see that you're flat there, right? So this is where it's constant. So you would say it's constant on. This would be between -1 and +1. I think it's going to be kind of hard to draw somebody there, so let me use a different color. Maybe I'll use red so it really shows up. So this is your guy, and he's just walking flat. So this guy is decreasing from negative infinity, going up to this -1. Then between -1 and +1, it's going to be constant, or you could say flat. And then you're going to be increasing for any x value that's greater than 1. So this guy, again, is walking uphill. All right, let's take a look at problem 3. Let me slide down here a little bit. So this one, again, if you look at coming from negative infinity, going up to this right here, which would be -1. Let me arrow to that and say this is -1. We're decreasing. Again, if you want to draw a stick guy in there like that, you can see he's coming down. So we're going to say decreasing on. Maybe this could be better. So the E and the A. And you're going to have another place where you're decreasing. So I'm going to put this first interval in, and I'll add on to it. So from negative infinity, going up to this -1. Again, it's always in terms of the x values. So from negative infinity to -1. You're decreasing until you get to this right here. So this right here. And then you're going to be increasing. So if you think about your stick figure guy, at this point, he is now walking up, right? So this is increasing right here. So this is from -1 to, this would be +1. Let me write this down here. So increasing on -1 to +1. Again, everything's excluded here. Now, when you look at anything to the right of 1, you're decreasing again. So if you want to draw another guy here, just to show this, here's your little stick guy. He's walking down. And we're just going to put this other interval in here. So 1 out to +infinity. Okay, let's take a look at problem 4. So this one's pretty easy. When you look at it, you're immediately going to say, okay, if I draw a stick figure guy here, let me say that's his legs like that. He is always walking up. So he's going to go this way, this way. He's always going up. This function is always increasing. So over its entire domain. So really we would just say that it's increasing on. We're going to go from negative infinity to +infinity. And that's all it is. All right, let's take a look at problem 5. So we see that coming from negative infinity up to where we have an x value of -4. So this right here, let me actually mark it right there. This x value is -4. Let me mark this right here. This x value is +4 because we're going to need that in a moment. But essentially coming from -infinity, going to where the x value is -4, we are decreasing. So the y values are getting smaller. So let me go ahead and put this stick guy in here. He's walking down. Then when we get to an x value of -4, between -4 and 0, this guy would be walking up, right? So the y values are increasing, so this function is increasing. Let me go ahead and put this guy in there like that. He's going up, and then from 0 to +4, we're decreasing again. So this guy would be walking down. And then lastly, from 4 going out to +infinity would be increasing, right? Your guy would be walking up. Let me use a different color here. So this guy would now be walking up like that. Again, this should be pretty obvious. I think once you do a few of these, it's very easy to get. The main source of confusion is people listing the intervals with the y values instead of the x values. Once you get that straight, it's really not that bad. So I'm going to put increasing on. And so we have this interval right here. So between -4 and 0. So -4 and then to 0. Again, nothing's included here. And then again, you could put a comma or you could put an and in there. You don't want to use a union symbol. And then we're going to say from 4 out to +infinity. So 4 out to +infinity. So we're increasing here and we're increasing here. Then if we think about where we're decreasing, so let's write decreasing on. So the intervals there, you're going to have this guy right here. So from -infinity going to -4. And then I'm going to put and, again, you could use a comma if you want. This would be 0 to +4. So 0 to +4. So if you think about this in terms of the entire number line, well, from -infinity to -4, you're decreasing. So that's this part right here. Then from -4 to 0, you're increasing. There's your -4 to 0. And then from 0 to 4, you're decreasing. There's your 0 to 4. And then from 4 out to +infinity, you're increasing. So that's that guy right there. All right, let's take a look at the practice test. For the instructions, we're asked to find the transformation from f of x to g of x. All right, for problem 1, we have f of x equals the absolute value of x, and then g of x equals the absolute value of 1/3 x. So when I see a problem like this, the first thing I would try to do is rewrite my g of x in terms of f of x, and then just think about the formulas that we learned in the lesson. So I see that for this guy right here, I have the absolute value of 1/3 x. And then for this guy right here, I just have the absolute value of x. So this right here, this 1/3 x is being plugged in for x in this function f of x. So in other words, I could say that g of x is equal to f of 1/3 x. Now that we've written it like this, we can use our little formula that we talked about in the lesson. So when you have something that's on the inside of the function, remember, these are the harder ones to think about. They're a bit counterintuitive. You have to think about, how could I undo what's being done to x? In this particular case, you have 1/3 that is multiplying x. So how do I undo multiplication by 1/3? Well, I would want to multiply by 3. 3 times 1/3 is 1, and then 1 times x is just x. So when you multiply by 3, you're getting a horizontal stretch, again, because it's on the inside, by a factor of 3. Again, don't think about that 1/3 and just take it as a given. You have to undo what's being done to x on the inside. So let's say that there's a horizontal stretch by a factor of 3. All right, a good way to think about this, if you're struggling with it, is to go to an online graphing calculator like Desmos. I have a link that's provided to you for every problem. So you just click on that and everything's already labeled for you. So you'll just be able to work with the points. What I'm going to do is label this first. So this graphing, let's just call it green. This is f of x is equal to the absolute value of x. This graphing, let's call it red. This would be your g of x is equal to the absolute value of 1/3 x. Let me make this 3 better here. When we think about a given point on this function, let's just pick this one. I think it's easy to work with. This right here is 3, 3. So in other words, f of 3 would give me 3 because the absolute value of 3 is 3. Now, where is this point going to go on this function g of x? Well, I said that there's a horizontal stretch by a factor of 3. In other words, what I am saying is that for a given y value, in this case, the y value is 3 for this point right here, the x value now needs to be multiplied by 3 when compared to this f of x equals the absolute value of x. So you have a 3 here, multiply that by 3, you're going to get 9. So this point right here is going to be 9, 3. See how this right here is being horizontally stretched. And you can plug in and see what's going on. You're basically going to undo the multiplication by a third to get yourself back to where you have the absolute value of 3, which would give you 3. In other words, g of 9 would be equal to the absolute value of 1/3 times 9. This would be equal to, well, this, again, would cancel with this and give me a 3. So I'm right back to that 3 that I plugged in the original function. So g of 9 would be equal to the absolute value of 3, which is 3. See how I had to take this x-coordinate and multiply by 3 to get this x-coordinate that would give me the same y value. Here the y value is 3, here the y value is 3, but the x-coordinate here had to be multiplied by 3 to produce that. So you can use that link on Desmos to play around with this a little bit more if you want. I really suggest that if you're struggling. Now, let me address something else. This is something I talked about in the lesson. So quite a few people leave questions about this and they'll say, hey, I saw your answer was a horizontal stretch by a factor of 3, but when I look at the graph, it looks like it's vertically compressed. Well, remember that you can algebraically manipulate this. You could say that g of x is equal to the absolute value of 1/3 times the absolute value of x, that's completely legal, which would be equal to 1/3 times the absolute value of x. Well, if I write it in this manner, let me move this over here like this, well, now I would use a different formula. I would say that in this case, your g of x is equal to 1/3 times f of x. And when we see it like this, we would say there's a vertical compression by a factor of 3, or again, there's different ways to say it, different terminology. Your book might say that there's a vertical shrink by a factor of a third. It doesn't really matter how you say it. It's personal preference. It's really just understanding that for a given x value, now the y value is going to be 1/3 of what it was or divided by 3. So for example, let's just take this point right here. And let's think about it that way. So this point right here is 9, 9. So it's 9, 9. So for that given x value, now the y value would be 1/3 of what it was, or again, you could divide it by 3. So 9 times a third is 3, or 9 divided by 3 is also 3, however you want to think about it. So you look at that point right there, this would be, again, the same x value of 9. The y value is now divided by 3, so this is 3. So if you had thought about it this way, and you gave an answer where you said it's vertically compressed by a factor of 3, or you said it's vertically shrunk by a factor of a third, again, different terminology, same meaning, well, essentially you would also have the right answer. But what I would do is I would stick to in this section, just going with the way that the problem is presented. So in this particular case, we get this on the inside, so that's how I would answer. I would give the answer as a horizontal stretch by a factor of 3. All right, let's take a look at problem 2. So here we're given f of x equals the square root of x, and g of x equals 1/2 times the square root of x. So again, I'm just going to go with the way that the problem is presented, and I'm going to rewrite g of x in terms of f of x. So I'm going to say that g of x is equal to 1/2 times f of x. So what is this doing? For a given x value, the y value has now been multiplied by half, or you can say divided by 2. So you can say that there's a vertical compression by a factor of 2, or again, you might want to say there's a vertical shrink by a factor of a half. Just different terminology, it means the same thing. Just go with your personal preference, or if you're in a class and you're following a teacher, just use their terminology. I'm just going to put that there is a vertical compression by a factor of 2. So for a given x value, the y values are being divided by 2. Again, if you want to come to the graph, this guy in green, this is going to be our f of x is equal to the square root of x. And then this guy in red, this is going to be our g of x is equal to 1/2 times the square root of x. In other words, it is 1/2 times f of x. And again, for a given x value, the y value has now been divided by 2 or multiplied by half. So this point on the original square root function, you have 4, 2. So 4, 2. And again, if you look at the point here on your g of x equals 1/2 times the square root of x, well, now the x value is the same. So it's still going to be 4, but we are dividing the y value by 2, or again, multiplying it by half. So 2 divided by 2 is 1, or 2 times a half is 1, however you want to think about that. So this would be 4, 1. And again, you can see that with this point right here, this is 9, 3. And then this point right here, this is 9, this would be 1.5, just taking 3 and dividing it by 2, or you could say 3 halves if you want. So again, for a given x value, the y value has been multiplied by a half, or divided by 2. So you could say that there's a vertical compression by a factor of 2, or again, a lot of people say a vertical shrink by a factor of a half, however you want to answer. All right, for problem 3, we have f of x equals x cubed, and then g of x equals 1/3 x, and this is being cubed. So again, we're just going to go with the way the problem is given to us. So I'm going to say that g of x is equal to, this is on the inside, so I'm going to say it's f of 1/3 x. Again, how do I undo what's being done to x? This is 1/3 on the inside that I need to undo, so I would multiply by 3. So this is another one where you're going to have a horizontal stretch by a factor of 3. So in other words, if you want to come down to the graph, and this one right here, f of x is equal to x cubed, and then this guy right here, this is your g of x is equal to, so this would be inside of parentheses, this is 1/3, and then x, and then this would be cubed. Let me fix that 3 there. So for a given y value, let's just take this one of positive 8 here. Well, on the original function, your f of x equals x cubed, you can see that that is going to be 2, 8. So this is 2, 8. Well, how do I get that same y value in my g of x function? Again, I've got to undo what's being done to x. How do I undo multiplication by a third? I've got to multiply by 3. So this guy right here, you would need 2 times 3, that would give you 6. So now this point is going to be 6, 8. Again, if you were to plug that in, and you did, g of 6, well, that's going to be your 1/3 times 6. You're plugging that in. This would be cubed. So what is 1/3 times 6? Well, that's going to be 2. It gets me right back to this x-coordinate here. So let's cancel this and show this. You would have 2 cubed, which would give me 8. So that's all it is on the inside. You need to undo what's being done to x. And in this case, you would multiply by 3 to do that. So it gives me a horizontal stretch by a factor of 3. All right, for problem 4, we have f of x equals, this is my greatest integer function with x as the argument, and then g of x is equal to 3 times. This would basically be, again, the greatest integer function with x as the argument. We can see that we can really rewrite g of x as being equal to, you just have 3 times f of x. And so this is just a vertical stretch by a factor of 3. That's all it is. So a vertical stretch by a factor of 3. All right, so graphically, if you want to look at this, again, in computer science, we really call this the floor function, but you can also say it's the greatest integer function, so f of x is equal to, the notation for this is going to vary, so I'm going to just use this. Kind of hard to draw it, but I'll just say it like that. So this is your greatest integer function. I want you to remember how this works. So let's just pick any of these. So let's say that, I'll do x and y here. I'll just do a few of them. If your x value, so x is greater than or equal to, let's say 1, and strictly less than 2, well, the y value is going to be 1. So that's what produces this right here. Again, the x value is from 1 and including 1, going up to and excluding 2. You get a y value of 1 always there. Then you're going to step up. So if the x value was including 2, going up to and excluding 3, well, now you get a y value of 2. Let me put this one in. So x is greater than or equal to 2 and less than 3. Now it would be 2. You can keep going. So x is greater than or equal to 3 and less than 4. Now you would get 3. So on and so forth. So when we look at this guy right here, it's just 3 times this guy. So in other words, this right here, your g of x is equal to, just put a 3 out in front. So 3, and then we'll make that little notation there, which I'm not so good at doing. But basically, you're just vertically stretching by a factor of 3. So if you look at this over here, well, now if x is greater than or equal to 1 and less than 2, the y value would be 3. So you see that. This is an x value including 1 going up to and excluding 2. Now the y value is 3. If you looked at this one right here, so we did an x value of 2 and including that going up to and excluding an x value of 3. Well, again, the y value here is 2. Well, you've got to multiply by 3. So you're going to go up here to where the y value is 6, so on and so forth. Again, I gave you a link for it if you want to play around with it on Desmos. This one's a little bit harder to think about because it's not a function that we're used to working with, but just spend a few minutes with it and I think it will make sense for you. All right, let's take a look at problem 5. So here for f of x, we have 1 over x. And for g of x, we have 1 over 2x. Again, this one is kind of tricky to think about. Well, am I doing g of x as being equal to 1/2 times f of x? Or am I doing g of x as being equal to f of 2x? Again, how you want to answer is up to you. Both answers would be correct. It's just how you want to interpret the problem. I'm just going to go that g of x is equal to f of 2x like this. And I'll probably give both answers when we get to the graph, just showing you an alternative way to think about it. But this right here would give me a horizontal compression right? Because again, if it's on the inside, I have to undo what's being done to x. So 2 is multiplying x there. To undo that, I need to multiply by 1/2, or I can divide by 2. So it's a horizontal compression, you could say by a factor of 2, or again, some people will say a horizontal shrink by a factor of 1/2. I don't care about your terminology, just understand that for a given y value, you're now going to have to divide that x value by 2 or multiply by 1/2 to get that. So let's say that this is a horizontal compression by a factor of 2. Let's go to the graph. Okay, so for this one, the points are a little bit smaller, just for how close things are. But again, you can go to Desmos if you need more detail. The graph in green, this is f of x is equal to 1 over x. And then the graph in red, this is g of x is equal to, you have 1 over 2x. So think about for a given y value, the x value has to be, again, you could say multiplied by 1/2 or divided by 2. So let's go right here. This point is 1, 1. And I did that terribly. So let me redo that. So 1, 1. For that same y value, again, on this function right here, g of x equals 1 over 2x, notice that the x value has to be divided by 2 or multiplied by 1/2. This point right here, let me arrow to it. Again, these notches here are in terms of 1/2. So this is 0.5, 1, 1.5, so on and so forth. This x value right here is 0.5. So this is 1/2, 1. So to get that same y value of 1, when I work with g of x, the x value that produces that is going to have to be 1/2 of what it was here. So again, you can play around with more points if you want. Now, another way to think about this, let me erase all this. You could have really written this g of x as being equal to 1/2 times f of x, because that would really be 1/2 times 1 over x. Let me write that out. So you could really say that this is 1/2 times 1 over x. And at the end of the day, that's still going to be 1 over 2x. So if you viewed it like this, again, it's just going to be a vertical compression by a factor of 2. So if you want to think about it that way, you could say that, okay, for this given x value, you see that here, this is 1, 1. Well, when you look at that point here, well now, for that same x value, the y value has been cut in half. The y value is now 1/2 or 0.5. Again, an alternative way to think about it. Which answer is more correct? Well, whichever way you want to view it. In this particular case, I just chose to go with thinking about things horizontally. But in this case, if you wanted to do a vertical compression by a factor of 2, or again, a vertical shrink by a factor of 1/2, if you want to say it that way, that would be a correct answer as well. All right, for problem 6, we have f of x equals x cubed, and then g of x equals 1/4 x cubed. All right, so again, thinking about this is on the outside. So let me just write this as g of x is equal to 1/4 times f of x. And again, there are other ways to think about it and other answers that you can get, but I'm just going to go with this because that's the way it's presented to us. So this right here is going to give me a vertical compression by a factor of 4, or again, you could say a vertical shrink by a factor of a 4th if you want to do that. Basically, for a given x value, you're going to get a y value that has been divided by 4 or multiplied by a 4th. So I'm going to say there's a vertical compression by a factor of 4. So again, if you want to look at this graphically, this guy in green, this is f of x is equal to x cubed. And this guy in, let's just call it red again. So this is g of x is equal to, let me make this better here. This is 1/4 x cubed. So all we're saying is that for a given x value, the y value is either divided by 4 or multiplied by a 4th. However you want to think about that. You can just take this point right here, which is going to be 2 units to the right, 8 units up, so 2, 8, 2, 8. Well, if I want that same x value, so of 2, on this g of x equals 1/4 x cubed, well, now the y value has to be divided by 4, or you could say multiplied by a 4th. Well, 8 divided by 4 is 2. So now I get that 2, again, same x value, comma, 2. Again, 8 divided by 4 is 2, so 2, 2. So that's why we say it's a vertical compression by a factor of 4. All right, for problem 7, we have f of x equals x squared, and g of x equals this 3x, again, this is inside of parentheses, being squared. Again, we're going to go with the way that it's given to us. And so this is on the inside. Again, it's being plugged in for x there. So in other words, we can say that g of x is equal to f of 3x. Again, there's other ways to look at this. I'll do that on the graph. You could say g of x is equal to 9x squared, but again, that's not how it's presented to us, so we're going to go with it this way. This is on the inside of the function, so we need to undo multiplication by 3, and to do that, we can divide by 3 or multiply by a third. So I would just say that there's a horizontal compression by a factor of 3. Again, if you want to use different terminology there and say there's a horizontal shrink by a factor of a third, that would be right as well. Let's come down here and let's label this. So this guy right here in green, this is our f of x is equal to x squared. So we know the points here. You have 0, 0, you have 2, 4, we have 3, 9, so on and so forth. And let me just label this point right now because we're going to use it. So this is 3, 9. And then this graph right here, again, let me arrow to that. That is going to be your g of x is equal to, we had this 3x inside of parentheses being squared. Now, I know a lot of you are going to say, well, that's the same thing as g of x equals 9x squared. So you really could say that g of x is equal to 9x squared. So I'm going to give the answer as a horizontal compression. You could also look at this as a vertical stretch by a factor of 9, but I'm going to do that at the end. So right now, let's just focus on this point and this point. So this point right here, maybe I'll arrow to it from all the way over here. So this is going to be 1, 9. So 1, 9. So to get that same y value of 9, notice how this x value here of 3 got divided by 3, or you could say multiplied by a third. So that gave me this x value of 1. So you get 1, 9. And again, it's just all about undoing what's being done to x when you're on the inside. If I did g of, let's say we plug in a 1 here, this is going to be, well, you have this 3 times 1 squared, which would be what? Well, 3 times 1 is 3. So this becomes 3 squared, which gives me 9. So the x value of 1 is now giving me a y value of 9, whereas in the original function, the x value of 3 is giving me a y value of 9. Now, let's look at it the other way. So some of you are going to look at that graph and say, hey, this is being vertically stretched by a factor of 9. And again, if you want to give that as an answer, it's fine, but I would just go with the way that it's presented. So if it's given to you this way, well, then you could take a given point. So let's say we take something like this right here, which is 1, 1. And I take that same x value of 1, and now I multiply the y value, which is 1, by 9. So that's going to put you up there. So you have that same x value of 1 corresponding to a y value that's been multiplied by 9. So 1, 1, that's going to go to 1, 9. If you want to give the answer as vertically stretched by a factor of 9, it's not wrong. But again, I always try to stay consistent with the formulas that are given in the book. So if I see something plugged in the inside, that's how I answer. All right, for problem 8, we have f of x is equal to the cube root of x, and then g of x is equal to the cube root of 2x. So what I'm going to do here is say that g of x is equal to f of 2x. So it's going on the inside. So how do I undo what's being done to x? Well, I would multiply by half or divide by 2. So I'm going to say there's a horizontal compression by a factor of 2, or again, if you want to say a horizontal shrink by a factor of a half, that's fine as well. So once again, this guy in green, this is my f of x is equal to the cube root of x. And then this guy in red, this is my g of x is equal to the cube root of 2x. Now, if you think about a given point here, so let's say we look at this one right here, which is 8, 2. So the cube root of 8 would give me 2. If I look at that point over here, well, again, now the x value is going to have to be cut in half, or you can say divided by 2 to get that same y value. So instead of an 8, divide that by 2, you would get 4 to get that same y value of 2. So this would be 4, 2. Again, if you plugged in a 4 there, where you're multiplying it by 2, that gives you 8. So you're right back to where you would be here, and then the cube root of 8 would give you 2. You have to be able to undo what's being done to x. And here, when we're multiplying by 2, if we want to undo that, we need to divide by 2 or multiply by half. All right, for the next few problems, the instructions are going to change. Now we want to find the transformation from f of x, this is going to be the graph in blue, to g of x, this is going to be the graph in orange. So this will be for problem 9. So this is the graph in orange. This is our g of x function. And this is the graph in blue. This is our f of x function. Now, first off, it's pretty easy to identify the function. So if you look at this one right here, you should know from previous lessons, this is the square root function. You have a point that's 0, 0. You have 1, 1, 4, 2, 9, 3. So this is f of x equals the square root of x. So now when you think about this right here, well, notice that for a given x value, the y values are multiplied by 3. In other words, if I look at this point right here, this is 1, 1. Well, this point right here, this is 1, 3. Same x value, y value has been multiplied by 3. This point right here is 4, 2. This point right here is going to be, again, same x value. Y value is multiplied by 3, so 2 times 3 is 6. Then for this one right here, you have 9, 3. So 9, 3. And then for this one right here, you take that same x value, so that's 9, and you multiply the y value by 3, so 3 times 3 is 9. So we could write this g of x function as being equal to 3 times your f of x, or just 3 times the square root of x, like that. In other words, we have a vertical stretch by a factor of 3. So a vertical stretch by a factor of 3. In other words, for a given x value, the y value has now been multiplied by 3. Here it's 1, 1. Here it's 1, 3. Same x value, y value is multiplied by 3. Here it's 4, 2. Here it's 4, 6. Same x value, y value has been multiplied by 3. Here it's 9, 3. Here it's 9, 9. Same x value, y value has been multiplied by 3. All right, let's take a look at problem 10. All right, this one, you might not know the graph of it, but I've done it a lot in the various lessons that we've talked about at this point. This graph in blue, again, this is your f of x. So this is f of x is equal to, this is x cubed minus x. Then this graph in, let's just call this orange. So this is going to be your g of x here. And I just want you to look at the points here so you can get an idea of what's going on. So this right here is 2, 6. So 2, 6, if you need to plug in, 2 cubed would be 8, minus 2 would be 6. In other words, f of 2 is equal to 2 cubed minus 2. So that is 8 minus 2, which is 6. So that's where that point's coming from. If you look at the point over here, you'll notice that the y value of 6 is the same, but the x value is now 6. So this point right here is going to be 6, 6. So at first glance, we see that this guy right here, the x value has been multiplied by 3. So that's a horizontal stretch by a factor of 3. Horizontal stretch by a factor of 3. Let's look at this point and this point. So here you plug in a 1 and you get a 0. In other words, f of 1 is equal to 1 cubed minus 1. That 3 could be a lot better. 1 cubed is, of course, 1. So you get 1 minus 1, which is 0. Over here, you see that you get 3, 0. So again, the x value has been multiplied by 3 to get the same y value. This right here is 1, 0. And then this right here is 3, 0. And you could do these points over here if you want. It's the same thing. Maybe we'll do this one. We could just skip that one. Let's just do this one. So on this guy right here, it's negative 2, negative 6. And over here, you just multiply that x value by 3. So negative 2 times 3 is negative 6. So that point becomes negative 6, negative 6. So same y value of negative 6, the x value has been multiplied by 3. So that's a horizontal stretch by a factor of 3. All right, let's take a look at the practice test. For the instructions, we're asked to describe the transformation from f of x to g of x. All right, let's take a look at the first problem. So here we have f of x equals x squared, and then g of x equals negative 3x squared. Now what I'm going to do to make this a little bit easier, I'm going to come down here and just look at some graphs with you. I think if you're struggling with this concept, looking at this on a graphing calculator like Desmos or something like that can really help you understand what's going on. So I'm just going to go real slow here, especially for the first few. We have f of x equals x squared. That's going to be this graph in green. And then we have this h of x. You might be saying, well, where does that come from? It's just something I'm going to use to show you the different transformations that are happening. You don't need it, but it's there to be helpful. So h of x is in blue. That's going to be equal to 3x squared. So let's just first start by thinking about, well, if I'm going from f to h, what happens? Well, I'm just going to say that if I think about h of x in terms of f of x, h of x is really equal to 3 times f of x, because you just have 3x squared there, and this is x squared, so it's 3 times f of x. Well, we know from the last lesson that this produces a vertical stretch by a factor of 3. So in other words, if I look at a point on this f of x equals x squared, again, this is in green, so this right there, that's an easy one. So this is 1, 1. Well, if it's vertically stretched by a factor of 3, that means for this given x value of 1, the y value here of 1 will be multiplied by 3. So let's go to 1, 3. So that's going to be right there. Let me arrow to that. So now that's 1, 3. And you can do that with more points if you want on your own. So let me put here that this is vertically stretched by a factor of 3. So we did that. So now we want to go from h to g. So what's going to happen there? Well, now I'm going to say that my g of x is equal to the negative of h of x. because if you notice, this is negative 3x squared, and again, this is 3x squared. So it's the negative of h of x. Well, what does this mean when I have this negative out in front here? It reflects it across the x-axis. So across the x-axis. So if you look at that right there. So if we look at this point 1, 3, and I reflect it across the x-axis, well, now you're going to have the same x value of 1, but the y value is going to be its opposite. So it would be 1, negative 3. So you're going to come down to right there. So this right there would be 1, negative 3. So let's say that this is reflected. I'll just abbreviate that. So reflected across the x-axis. So you would just put these together. Again, you don't need h once you really get going. I'm just breaking it up that way so it's easier to understand. And so what you would do is say that to go from this f of x equals x squared to the g of x equals negative 3x squared, you're going to vertically stretch by a factor of 3, and then you're going to reflect across the x-axis. So again, you can take this point, so from 1, 1, you go up here to 1, 3, and then you reflect across the x-axis, and you have this 1, negative 3. All right, for problem 2, we have f of x equals the square root of x, and then g of x equals the square root of a negative 2x. So again, we can look at this graphically. We have this guy in green, that's f of x equals the square root of x. We have this guy in blue, which is h of x equals the square root of 2x. Again, you don't have to have this, but it gives us a nice little middle step to work with. And then this guy in red, this is going to be g of x equals the square root of a negative 2x. The first question we're going to do is, how do we go from f to h? And again, there's different ways you can write this, but this is going to be on the inside. That's the way I'm going to look at it. So I'm just going to say that h of x is equal to f of 2x. So when this is on the inside of the function, again, this is going to be counterintuitive. You want to undo what's being done to x. Here, x is being multiplied by 2. How do I undo that? I would divide by 2 or multiply by half. So in other words, if you think about a point on f of x equals the square root of x, let's say we take this guy right there. This is 4, 2. Obviously, if you take the square root of 4, you get 2. Well, where's that point going to go to on my h of x equals the square root of 2x? Again, because I'm multiplying by 2 here, I need to undo that. So I need to divide by 2. In other words, this x value here, 4, I now need to divide that by 2, which is going to give me 2 to produce the same y value of 2. So that's going to go here. So this point is going to be 2, 2. So hopefully that makes sense, because when I plug in a 2 there, well, 2 times 2 will give me 4. And then the square root of 4, again, I'm right back to 2. So to get that same y value of 2, the x value had to be cut in half or divided by 2, however you think about that. So I'm just going to write this as a horizontal compression by a factor of 2. Again, a lot of teachers will say a horizontal shrink by a factor of a half. The terminology here is just personal preference. Just realize that for a given y value, you're taking that x value and you're dividing it by 2 or multiplying it by half. Now, the next thing you would notice is that you have a reflection across the y-axis here. So if you look at a given point on this h of x equals the square root of 2x, what's going to happen is the same y value is now going to correspond to the opposite x value. So this is going to end up going over here. So that's going to be your point now. So you're going to have negative 2, 2. So that's a reflection again across the y-axis. So let me put here that we're going to go from h to g. And we can really write, again, because of this negative right there, actually, let me do this with a highlighter so that's a little bit more clear. You could say that your g of x can be written as h of negative x. And so, again, we know this rule here is going to be a reflection across the y-axis. So I'm just going to put reflected across the y-axis. And that's pretty much all it is. Basically, to go from your f of x equals the square root of x to your g of x equals the square root of negative 2x, you're going to horizontally compress by a factor of 2 and then reflect across the y-axis. So again, you could just take a point like 4, 2, again, horizontally compressed by a factor of 2. So take this x value of 4, divide by 2, that gives you 2. You have the same y value. So this is 2, 2. Then reflect across the y-axis. So you're going to go over here. So again, you have the opposite x value. So now it's negative 2. And then the y value is the same. So that's 2. So this is your point negative 2, 2. Okay, let's take a look at problem 3. So here we have f of x equals the absolute value of x. And then g of x equals the negative of the absolute value of 5x. Okay, so once again, I have everything set up for us. this graph in green is f of x equals the absolute value of x. And then in blue, we have h of x equals the absolute value of 5x. And then in red, we have g of x equals the negative of the absolute value of 5x. So what I'm going to do first is just think about going from f to h. So what's happening here? Well, h of x, you can see this is on the inside. And again, I know you could rewrite these things in different ways, but let's just go with the way the function is given. So this is on the inside. So let's go ahead and say that h of x is equal to f of 5x. So again, you could think about this as a horizontal compression by a factor of 5 because I have to undo what's being done to x on the inside. How do I undo multiplication by 5? I need to divide by 5 or multiply by a fifth. So again, if you want to say a horizontal shrink by a factor of a fifth, that's fine as well. So let's go through and find a point here. And let me find a good one. So let me take this point right here, which is going to be 5, 5. So if I do a horizontal compression by a factor of 5, again, the same y value here of 5 is now going to correspond to this x value here that's been divided by 5. So 5 divided by 5 is 1. So we'll come right here. And so that point is going to be 1, 5. Let me write this. So this is a horizontal compression by a factor of 5. And of course, if you want to say there's a horizontal shrink by a factor of a fifth, that's fine as well. So we're going to now think about what's going on from h to g. So you can look at this and see that this is reflected across the x-axis. So this right here, if you want to highlight that, you don't have to, but maybe it makes it easier to see. So this would be reflected to this guy right here. So you have the same x value, so it's still going to be positive 1, but the y value is changed into its opposite. So now it's negative 5. So again, if you think about this, your g of x can be written as the negative of h of x, because this is negative absolute value of 5x. So it's just the negative of h of x. So that's what's giving me this reflection across the x-axis. So again, you can just start with one of these points. So 5, 5, we would horizontally compress by a factor of 5. So that brings me to this point right here. So we get 1, 5, and then reflect across the x-axis to where I have 1, negative 5. So let's put here that we're going to reflect. Again, I'm just going to abbreviate, and then across the x-axis. All right, for problem 4, we have f of x equals the cube root of x, and then g of x equals the cube root of negative 8x. Okay, so once again, my f of x function is going to be in green. This is the cube root of x. My h of x function is in blue. This is the cube root of 8x. And then my g of x function is going to be in red. So this is the cube root of negative 8x. So let's say that we're going to go from f to h, just to get things started. If I look at this, this is the cube root of x, and this is the cube root of 8x. So we can say that h of x is really f of 8x. So that's all it is. And so once again, this is giving me a horizontal compression by a factor of 8. I have to undo what's being done to x on the inside. If I'm multiplying x by 8, to undo that, I need to divide by 8 or multiply by an eighth. Another way to say that, again, if you want to, you could say there's a horizontal shrink by a factor of an eighth. If you want to use that terminology, that's up to you. So for example, something like the point, which here is, let me arrow to it like this. This would be 8, 2. So you plug in an 8 here, you take the cube root, you get 2. Well, if I'm horizontally compressing by a factor of 8, that same y value of 2 is now going to correspond to an x value that's been divided by 8. So 8 divided by 8 is 1. So let's come this way. And so that point's going to go right there. So this point right there would now be 1, 2. Now you'll notice that this has been reflected across the y-axis. Again, you can highlight this if you want, not necessary, but I'm just going to do it. So if you look at this point, it's going to go over here. And so this is going to be negative 1, 2. So the opposite x value and then the same y value. So that's what we get when we reflect across the y-axis. Let me first write that this is a horizontal compression by a factor of 8. And then let's go from h to g. And I'm going to go ahead and write this because the negative's on the inside. Let's say that g of x is equal to h of negative x, like that. And of course, this gives me a reflection across the y-axis. So let me just put that this is a reflection across the y-axis. Now, if you look at this point again, you can just follow it. So you have 8, 2, and then I'm going to horizontally compress by a factor of 8. So I'm going to have this 1, 2, and then I'm going to reflect across the y-axis. So I'm going to have this negative 1, 2. All right, let's take a look at problem 5. So here we have f of x equals 1 over x, and then we have g of x equals the negative of 5 over x. All right, so coming down here, again, I have f of x equals 1 over x. This is going to be in green. And h of x equals 5 over x. That's going to be in blue. And then g of x equals the negative of 5 over x. That's going to be in red. Now, again, for a lot of these, it's depending on how you want to set things up. What I'm going to choose to do is say that when we're going from f to h, I'm going to say that h of x is equal to 5 times f of x. Again, like we've talked about before, there's other ways you could think about this. With a lot of these functions, you can algebraically manipulate them in different ways and get different answers, but this is what I'm going to choose to do. So for this one right here, you see there would be a vertical stretch by a factor of 5. Because for a given x value, this 5 here is going to multiply your y values from that original function f of x. So in other words, if you look at something like, let's say 1, 1, so this right here, it's going to be hard to arrow to it. Maybe I'll do it like that. So this would be 1, 1. Well, for the same x value, now the y value has been multiplied by 5. So instead of 1, 1, you're going to get 1, 5. So let's come up here and just say that that point would now be 1, 5. So that's your vertical stretch by a factor of 5. Vertical stretch by a factor of, let me make that O better, 5. Now, to go from h to g, again, like we touched on in the lesson, we haven't officially talked about odd functions, but we did touch on this topic. There's different ways to, again, algebraically manipulate things. Because the negative is on the outside right there, that's how I'm going to apply the formula. So I'm just going to say to go from h to g, we're going to say that g of x is equal to the negative of h of x. So that's how we're going to do it. Of course, you could do it a different way, but this is how we're going to do it. So that means that we're going to reflect across the x-axis. So we're going to reflect across the x-axis. So that means I'm going to take this point right here, so this point right here, and I'm going to keep the x value the same and change the y value into its opposite. So I'm going to come down here to this point right here, and I'm going to say that, well, the x value is still 1, and the y value is now its opposite, so it's negative 5. Again, for this problem, there's lots of different ways that you can answer, but that's how I'm going to give mine. So I'm going to go ahead and say that this is reflected across the x-axis. And we're going to get into more detail on this when we talk about odd functions here shortly. So if we take this point right here, this 1, 1, and we start off with that on the f of x function, and we vertically stretch by a factor of 5, you get 1, 5. So that's going from f to h. And then to go from h to g, we're going to reflect across the x-axis. So this 1, 5 is going to become 1, negative 5. All right, for problem 6, we have f of x equals x cubed minus 2x squared minus x. And then for g of x, this equals negative 1/2 times this quantity x cubed minus 2x squared minus x. So you really have negative 1/2 times your function f of x. So that's all it is. That's why I didn't distribute it. I left it in this format so it was crystal clear what was going on. Let me just highlight that real quick. So this right here is a match of this right here, just so that's clear. All right, so let's look at the graph. This one is one you might want to go to Desmos for. Maybe it's a little bit hard to see all the things that are going on, but I'll do my best to show things. If you're on a smaller screen, you might need that. So this graph, again in green, that's your f of x equals x cubed minus 2x squared minus x. Then h of x is just going to be 1/2 times f of x. So it's just like I wrote h of x as being 1/2 out in front times the quantity x cubed minus 2x squared minus x. And you don't need to distribute that in. You could just leave it like that. We're just doing this for the purpose of figuring out what's the transformation, so we don't need to get too into detail in terms of the function itself. But let me just write h of x right now as being 1/2 times f of x. So if I think about going from f to h, what's going to happen? Well, again, if you multiply a function here by a half, that's giving me a vertical compression by a factor of 2, or again, a lot of people will say that as a vertical shrink by a factor of a half. So for a given x value, the y value now is going to be half of what it was when you compare f of x to h of x. So in other words, let's say if we could pick some point here, maybe this one right here. So this is 3, 6. This right here is 3, 6. Well, what we're doing is for the same x value of 3, the y value is now multiplied by a half or divided by 2. So 6 divided by 2 would be 3. So that means that I'm going to come down here and that's going to be this point right here. Again, I know this is a bit hard to see, but you can just go to Desmos if you need a little bit more detail. You can scroll in and really get a good look at what's going on. So that point right there is going to be 3, 3. So 3, 3. So again, for the same x value, the y value has now been cut in half or divided by 2 or multiplied by half, whatever you want to say there. 6 divided by 2 or 6 times a half is 3. So let's put that there's a vertical compression by a factor of 2. Now, when we think about going from H to G, I think this is pretty obvious. We're going to have a reflection across the x-axis. So again, you can just highlight this if you want. Here's your x-axis. And you just think about this point right here. This, let me use a different color here, is going to come down here to right there. So that point, and I should probably use a darker color there so it shows up really well. That point is going to be the same x value, so 3, comma, the opposite y value, so negative 3. Where does that come from? You could say that g of x is equal to the negative of h of x. So that is giving me a reflection across the x-axis. So let me put this is reflected across the x-axis. So in other words, you could start with a point like 3, 6. So that's on our f of x equals x cubed minus 2x squared minus x. You could vertically compress by a factor of 2. So that gives me this point right here. Again, same x value of 3. The y value has been cut in half, so now you have 3. So this is 3, 3 now. Then you're going to reflect across the x-axis. So you're going to get the same x value of 3. The y value is its opposite, so it's negative 3. So vertically compress by a factor of 2, and then reflect across the x-axis. All right, let's take a look at problem 7. So here we have f of x equals the square root of x, and g of x equals negative 1/2 times the square root of negative x. So I'm going to just start with f of x, the original function. F of x equals the square root of x. So let's just start with that. And then let's think about h of x equals 1/2 times the square root of x. I think that's the easiest way to do it. So basically to go from f to h, what are we going to do? Well, you'll notice that you just have a 1/2 that's multiplying this function. So you could say that h of x is really 1/2 times f of x. So what is that doing? It's giving me a vertical compression, maybe that v could be better, by a factor of 2. Or again, a lot of people like to say a vertical shrink by a factor of 1/2. That's fine if you want to do that. But essentially for a given x value, you're multiplying the y value by 1/2 or you're dividing it by 2. So let's take this point right here, which is going to be 4, 2. So the principal square root of 4 would give me 2. Well, now for that same x value of 4, the y value has been cut in half. So instead of 2, you're going to get 1. So this right here is going to be 4, 1. Okay, now let's think about this guy over here. So w of x, if I think about that in terms of h of x. So now what you'll see is that we've introduced this negative on the inside. So in other words, if you think about w of x, this is really equal to h of negative x. So what this is doing is it's giving me a reflection across the y-axis. So if you take this point 4, 1 and you reflect across the y-axis, you're going to come over here and you're going to get this negative 4, 1. So you have the opposite x value. So now it's negative 4. And then you're going to have the same y value. So negative 4, 1. So to go from h to w, we're going to reflect across the y-axis. Maybe that s could be a lot better there. All right, the last thing we're going to do is we need to get to this g of x. And you'll notice in terms of the w of x, well, now I just put a negative out in front of that. So if we think about to go from w to g, well, all we're really doing is reflecting across the x-axis now. So we're going to reflect across the x-axis. And that's coming from the fact that if you think about g of x, this is really equal to the negative of w of x. Because you're just taking this function right here and putting this negative out in front. That's all you're doing. So what you're going to end up with is this point right here, which is negative 4 comma 1. You're going to reflect it across the x-axis. So you're going to get this point right here, which would be the same x value, negative 4, comma. The y value has now been changed into its opposite, so it's negative 1. So quite a lot going on here. That's why I introduced this other function. I know that a lot of people, when you put all this stuff in there, it gets a little bit confusing, but just go one step at a time. You might want to pause this video right here, go to the link on Desmos, and just take this point right here, which is 4 comma 2, and just follow it along its trail. So we're going to vertically compress by a factor of 2. So again, same x value. Now the y value has been cut in half, so we've got 4 comma 1. Then we're going to reflect across the y-axis. So we go over here. So the x value has been changed to its opposite. So now it's negative 4. The y value is the same, so it's positive 1. Then we're going to reflect across the x-axis to get down here to our final destination. So we have negative 4 comma negative 1. So again, the x value is the same. The y value has been turned into its opposite. All right, for problem 8, we have f of x equals x cubed minus x. And then g of x is equal to, we're given f of negative 1/4 x. So coming down here, we have our graph in green. That's going to be the f of x equals x cubed minus x. We have this guy in blue. This h of x equals f of 1/4 x. And then we have our guy in red, which is going to be g of x equals f of negative 1/4 x. Now, you could plug in if you wanted to figure out h of x and g of x, but it's not really necessary here. We're just trying to describe the transformation, so this is good enough. So looking at going from f to h. Well, here, this is described as f of 1/4 x. So again, if it's on the inside, you want to undo what's being done to x. Here, x is being divided by 4, or you could say multiplied by 1/4. So to undo that, you're going to multiply by 4. So here, I'm just going to say that we're going to have a horizontal stretch by a factor of 4. In other words, if I look at a point on this, f of x equals x cubed minus x, the one we always use is this 2 comma 6. So 2 units to the right, 6 units up. So let's say that's right there. So that would be 2 comma 6. Well, if I look at this h of x function, again, compared to the f of x function, it's been horizontally stretched by a factor of 4. So that means to get the same y value of 6, I've got to multiply this x coordinate of 2 by 4. Well, 2 times 4 would give me 8. So if you go over here, you're going to slide to this point right there. So that's my horizontal stretch by a factor of 4. And you'll notice that this point right here is going to be 8 comma 6. So again, the y value is the same. In each case, it's 6. The x value here got multiplied by 4 to go here. So now the other thing we're going to look at is we're going to say, how do we go from h to g? And I could write here for clarity that h of x is equal to f of 1/4 x. But I think we know that because it's given right here. So in all the other problems we did that. So I'll just stay consistent and put that right there. So now we want to go from h to g. So if I look at h of x being equal to f of 1/4 x, and then g of x being equal to f of negative 1/4 x, well, what I can do is say that my g of x is really equal to h of negative x. That's all it is. You have this negative right here. That's not here. So basically, this is going to give me a reflection across the y-axis. Now, I know a lot of you are looking at it and going, hey, wait a minute, couldn't I reflect this down here and get this point, which would be 8 comma negative 6? Yes, you could, and that's because this is, again, an odd function, which we're going to talk about in more detail later on. For right now, we're just going to take things as we see them. So this is going to be on the inside here, so that's how we're going to answer. So we're going to reflect across the y-axis here because of the formula we're using. And so we're going to take this point, which is 8 comma 6. We're going to reflect over here, and we're going to say now this is going to be negative 8 comma 6. So the opposite x value is going to produce the same y value. So looking at going from f of x to g of x, you're going to horizontally stretch by a factor of 4. And so after that, you're going to reflect across the y-axis. Again, you could follow this point. So 2 comma 6. When we horizontally stretch by a factor of 4, you multiply the x coordinate by 4. So you get 2 times 4 is 8, and then comma 6. The y coordinate is going to be the same. Then you're going to reflect across the y-axis. So your y coordinate is going to stay the same. You're just going to come over here, and you're going to have the opposite x value. So instead of positive 8, you're going to have negative 8. So that point becomes negative 8 comma 6. All right, let's take a look at problem 9. So here we have f of x equals x cubed, and then g of x equals negative 2x, so this is inside of parentheses, being cubed. All right, so once again, in green, we have f of x equals x cubed. In blue, we have h of x equals this in parentheses 2x being cubed, and then g of x is equal to, again, in parentheses, negative 2x now being cubed. So just going from f to h. So we can see that h of x is really f of 2x. And again, I know that you could really say this is 2 cubed, which is 8 times x cubed. So you could have written this as h of x is equal to 8x cubed. And I know that causes a lot of confusion because when you look at it this way, you would say that it's vertically stretched by a factor of 8. But when we look at it this way, as it's given where this is going on the inside, well, we need to undo what's being done to x. And to undo multiplication by 2, we would divide by 2 or multiply by half. So we're going to say that this is going to be a horizontal compression by a factor, let me make that a better, of 2. So remember that when we work on these problems, there's different ways you can algebraically manipulate. Some of these, you can get different answers that would still be correct. But this is what we're going to go with. So if you take a point, let's just take 2 comma 8. So that's on your f of x equals x cubed. So 2 comma 8. Well, if we're horizontally compressing by a factor of 2, for that same y value of 8, now I need to take the x value, which is 2, and I need to divide by 2, or again, multiply by half. So 2 divided by 2 is 1. So that's going to go right here. And so that point would be 1 now. Again, 2 divided by 2 would be 1, comma 8. So same y value. Then when we think about going from h to g, well, really all this is a negative that's here, right? So this negative has been put on the inside. So I could say that g of x is really equal to h of negative x. This is just giving me a reflection across the y-axis. So this 1 comma 8, again, the 8 would stay the same, but the x value here of 1 would go to its opposite. So let's do this point right here. So now we have negative 1, again, changing this x value into its opposite, comma positive 8. So the y value is still the same. So let's say this is a reflection across the y-axis. So we're going to horizontally compress by a factor of 2 and then reflect across the y-axis. So starting with 2 comma 8 on the original function f of x equals x cubed, if you horizontally compress by a factor of 2, you're getting here. So this 1 comma 8. That same y value corresponds to an x value that's been cut in half or divided by 2. So now you have a 1 there. Then I'm going to reflect across the y-axis. So the x value turns into its opposite. So you get negative 1 comma 8. The y value is still the same. All right, let's take a look at problem 10. So here we have f of x equals x cubed minus x, and g of x equals, we have negative 2 f of 1/2 x. So to make this easier to understand, I broke this up quite a bit. So we have our f of x equals x cubed minus x. That's going to be in green. We have in blue, h of x equals f of 1/2 x. And then in orange, we have w of x equals 2 f of 1/2 x. And then finally in red, we have g of x equals negative 2 f of 1/2 x. So I'm just going to start by saying to go from f to h, what are we doing? Well, we have that h of x is equal to f of 1/2 x. Again, if it's on the inside, we need to undo what's being done to x. So here, since we're multiplying x by half or dividing by 2, to undo that, you want to multiply by 2. So that's going to give me a horizontal stretch by a factor of 2. So we've been using this point for f of x equals x cubed minus x. That's 2 comma 6. So these numbers are kind of small. So you might want to click that link on Desmos to follow more closely. But 2 units to the right and then 6 units up, that's going to put me right there. So let me actually arrow to that. Maybe I'll do that over here since there's lots of room. So this is 2 comma 6, just so that's clear. Let me make that better. Now, if I have a horizontal stretch by a factor of 2, well, what I'm going to do is I'm going to take this x coordinate of 2 and I'm going to multiply by 2. So now I'm going to have 4 comma 6. So the y coordinate will not be changed at all. So this coming over here is going to be right there now. So that's 4 units to the right and 6 units up. So that point goes there. So it's 4 comma 6. All right, so now we're going to talk about going from h. So from h to w. Now w of x is listed as 2 times f of 1/2 x. So basically you could write that w of x is equal to 2 times h of x, because that's all it is. So this gives me a vertical stretch by a factor of 2 compared to when I look at the h of x. So this point right here, that's 4 comma 6. Well, the x value of 4 is going to stay the same. Then the y value of 6 is going to get multiplied by 2. So I'm going to go up here to this right there. So that point is going to be 4, 12. So let me put that there's a vertical stretch by a factor of 2. Now the last thing we're going to do, let me make this w better, is go from w to g. And if we look and we compare w of x, which is equal to 2 f of 1/2 x, to g of x, which is equal to negative 2 f of 1/2 x, well, really you could just say that g of x is equal to the negative of w of x. So all this is going to do is give me a reflection across the x-axis. So I'm going to put that this is going to reflect across the x-axis, and that's all it is. So if you look at this point right here, which is 4, 12, I'm going to reflect across the x-axis. So I'm coming down here. So the x value of 4 is the same. The y value will be its opposite. So we're coming down here. This is going to be my 4, negative 12. And that's all it is. So to go from this f of x equals x cubed minus x to your g of x, which equals negative 2 f of 1/2 x, you're going to horizontally stretch by a factor of 2. You're going to vertically stretch by a factor of 2. And then you're going to reflect across the x-axis. So you could take this point here, which is 2, 6. Again, horizontally stretch by a factor of 2. That's going to put you here at 4, 6. You keep the y value the same. You multiply the x value by 2. So 2 times 2 is 4. The y value stays as a 6. Then you're going to vertically stretch by a factor of 2. So the x value now stays the same. It's going to be 4. And the y value is multiplied by 2. So 6 times 2 is 12. So you're coming up here to 4, 12. Then you're going to reflect across the x-axis. So you're coming down here. Your x value will be the same, so it's still 4. And the y value, which is 12, will turn it to its opposite. So it's negative 12. So we end up right there at 4, negative 12. All right, let's take a look at the practice tests. For the instructions, we're asked to determine if even, odd, or neither. All right, let's take a look at the first problem. So here we have f of x equals 2x cubed minus 5x minus 1. So the first thing you would check for is to see if it's even. Now there is a shortcut for this type of problem. You can really just look at the exponent here and the exponent here. So if the exponent on your variable that you're plugging in for is odd, the sign is going to change. In other words, if I do f of negative x here, the long way, so 2 times, again, if I'm plugging in a negative x, that's really like plugging in negative 1 times x like that, and this is cubed, and then minus 5 times, let's go negative 1 times x like that, and then minus 1. Well, basically, let's split this up. This is 2, and then times you'd have negative 1 cubed, and then times x cubed, and then minus, you have your 5. Let's go plus negative 5 there. Let's treat this as times just negative 1, and then times x, and then minus 1. Well, again, notice that because this exponent is odd here, you have negative 1 cubed, which gives you negative 1. This exponent is odd here, so you have just negative 1. So you're getting a sign change in each case. So the quick way would be to look at it and say, the sign here is going to change, so I'll just put a minus. The sign here is going to change, so I'll just put a plus. And so immediately I know this is not going to be an even function because this is not going to match, right? Let me actually go through and simplify this. This would be, again, negative 1 cubed is negative 1, so negative 2x cubed. And this, negative 5 times negative 1 is positive 5, so plus 5x, and then minus 1. And move this up here. And hopefully you understand this shortcut. You don't need to. You can plug it in and do it the long way. This is a 3. It's an odd number, so I'm going to get a sign change. This is a 1 for the exponent. It's an odd number, so I'm going to get a sign change. So I immediately know that the sign change is here, so this is negative 2x cubed. The sign change is here, so this is plus 5x. And then this is just a constant, right? Just minus 1 here. So that just stays the same. So this function is definitely not even. Now, if you think about if it's odd, well, it must be true that negative of f of x would be equal to this right here. So just put a negative out in front. So negative, and then you have this 2x cubed minus 5x minus 1. A lot of people like to just factor the negative out and see if it matches. I like to just distribute it in. It doesn't really matter. You could do it that way as well. But this is going to get distributed in to each guy. So you're just changing the sign. So this is negative 2x cubed, and then plus 5x, and then plus 1. So does this match? No, it does not, because this sign right here is not a match. So if we come up here, that's not a match. So this would actually be neither. It's not even, and it's not odd. So I'm just going to put it is neither. Now, a good way to confirm things if you're just starting out and you want to see this visually, I gave you links for everything on Desmos, so you can click on those. You can just look at the graph of this guy. Again, if it was even, it would be symmetric with respect to the y-axis. So in other words, if I took this point 2, 5 and reflected it across the y-axis, well, that would be negative 2, 5. So here's 2 units to the left and 5 units up. You would have that point there on the graph. That's not there, so this is obviously not an even function. If it's symmetric with respect to the origin, then you would be able to reflect across the y-axis and then the x-axis, and then you would have that point. In other words, you'd be able to reflect over here and be at negative 2, 5, and then reflect down here and be at negative 2, negative 5. That point is not on the graph. So what I did was I put negative 2, negative 7 just to show you that. So for an odd function, if you have x, y, on the graph, you're going to have negative x, negative y. So you would look for that for an odd function. So this one, again, is going to be neither. All right, let's look at problem 2. So here we're given f of x equals 3/4 x squared minus the absolute value of x plus 2. So most of you, again, once you get good at these problems, you can immediately tell it's an even function. How can you tell? This guy right here, the exponent is 2. So if I plug in a negative x there, well, that negative 1 squared is going to be positive 1, so the sign is not going to change. So this term will be the same. This right here, if you plug in a negative x, because you have absolute value bars, that's going to, again, get rid of that negative. So I'm just going to have the absolute value of x. And then you just have plus 2. So let me actually show you this the long way. I'm just going to plug in. So 3/4, again, for x squared, plug in, you can just do this as negative 1 times x like that. This is squared minus the absolute value of, let's go negative 1 times x like that, then plus 2. Okay, let me slide down here a little bit. So this one right here, again, make sure to wrap this in parentheses if you're using a calculator. This is 3/4 times. You'd have negative 1 wrapped in parentheses being squared, then times x squared, and then minus. By rule, you can split this up into the absolute value of negative 1 times the absolute value of x, and then plus 2. So this becomes what? 3/4 times negative 1 being squared. Again, this is wrapped in parentheses. That's positive 1. So you really don't have to write it. You can just say times x squared. And then basically you have minus. The absolute value of negative 1 is 1. You don't have to write that. So then you just have your absolute value of x and then plus your 2. So once you get good at this, you do not have to go through and plug all that stuff in. Really, you'll be able to answer these questions very quickly. You just have to get used to some basic rules of simplifying. I know most of you are already pretty good at it. So you see f of x and f of negative x are the same. So we can conclude that this is an even function. Again, if you want to look at the graph of this, here's your f of x equals, I put 0.75, but you could put 3/4 if you want, x squared minus the absolute value of x plus 2. You can see that the graph here is symmetric with respect to the y-axis. So this point right here, which is 2, 3, again, if you reflect it across the y-axis, you get negative 2, 3. So the same y value of 3 is corresponding to the opposite x value. Here it's 2, here it's negative 2. Okay, let's take a look at problem 3. So here we have f of x is equal to x times the cube root of x minus 1. So we could start by just doing f of a negative x, and this would be what? Well, this right here would become negative x, and then for clarity, let me put times. You would have the cube root, let me make that 3 better there, and then this x right here would become negative x, and then you have minus 1. So this does not match this. Now you could also check, it's not going to work, but you can go, what is the negative of f of x, and see if this one matches this one. We already know that since these two don't match, it's not even. But if this one and this one matches, well, then we have odd. But here, you would just put a negative out in front. So a negative out in front of this, well, that's just negative x times the cube root of this x minus 1. So this does not match this. So it's not even and it's not odd. It's going to be neither. So this one is neither. Again, if you come down to the graph, you can see obviously that it's not going to work for either one. It's not symmetric with respect to the y-axis, and it's not symmetric with respect to the origin. Here I'm showing you a point, which is 2, 2. Again, if it was an even function, well, then you could reflect this across the y-axis, and you would have a point here, which would be negative 2, 2. But you don't. So here, the x value of negative 2 is corresponding to a y value that's about 2.884. So obviously this is not odd or even. It's going to be neither. All right, let's take a look at problem 4. So for this one, again, immediately you can use your trick. So this exponent here would be 1, and this would be 2. So this is an odd exponent, so the sign would change. This is an even exponent, so the sign would not change. So in other words, f of a negative x, again, the shortcut here, this would change, so it would just be negative x, and this would not change. It would just stay 2x squared minus 3. If you want to plug in, you can. But if you have the negative of x, again, wrapped in parentheses being squared, well, that's just going to be x squared. Negative 1, that being squared would be 1, so it's not going to change anything. So this right here, if you wanted to, you could pull this out because it's a fraction. Let me move this over here like this, and put that out in front. Well, if I asked you for the negative of f of x, what would that be? The negative of f of x, well, I could just put a negative out in front of this. So that would be x over 2x squared minus 3. So we can conclude that this is an odd function. So this guy right here would be odd because f of negative x is the same as the negative of f of x. All right, so coming down here to look at the graph, again, you can go to Desmos if you need more detail, but you have a point here which is 2, 0.4. Now, if you reflect that across the origin, again, you're going to get the opposite of this and the opposite of this. So you would get the point -2, negative 0.4. You would reflect over here and then over here. So reflect across the y-axis and then the x-axis. Again, that's origin symmetry. If this point is a comma b, and this point is negative a comma negative b. Then you have the same thing here. So you have it -1, 1. Again, the opposite of -1 would be +1. The opposite of +1 would be -1. So -1, 1. Again, reflect that across the origin. You get 1, -1. So again, this is going to be an odd function. All right, for problem 5, we have f of x is equal to 9x over the absolute value of x. Let's slide down here a little bit. I think most of you can see immediately this is going to be an odd function. And so to prove that, here's f of negative x. So what is that going to do? Again, if this guy right here is an odd exponent, you know it's going to change the sign. Because 9 times negative x, that's the same thing as if I said, we'll have 9 times, might as well say -1 times x. Well, that's just negative 9x. So it's going to change the sign. So this is negative 9x. Now down here, because you have absolute value bars, you can really just keep this as the absolute value of x. Why? If you had the absolute value of negative x, this is equal to the absolute value of -1 times x like that, which is equal to the absolute value of -1 times the absolute value of x, and the absolute value of -1 is 1, so this is just equal to the absolute value of x. So this right here would just stay as the absolute value of x. Now, if you think about, let me just do this over here, if you did the negative of f of x, well, what is that? That's just me putting a negative out in front of this, so that's 9x over the absolute value of x. Does this match this? Yes. So we can say here that we have an odd function. So this is odd. So coming down to the graph, it's a little bit strange looking, but if you think about the function, it should make sense. So you have f of x equals 9x over the absolute value of x. So here we see that the domain would exclude 0. And the reason for that is if you plug in a 0 for x, well, the absolute value of 0 is 0, and you can't have 0 in the denominator, so we would have to exclude that from the domain. But anything if you're to the right of 0 in terms of your x value, well, this would be positive, and of course the absolute value of some positive real number would be positive, so you would have those numbers canceling, and so you would just have positive 9. So you have something like 5, 9, you'd have 1 trillion, 9, so on and so forth. But then down here what you're getting is you have a negative value for your x that you're plugging in, so this is going to be negative, and then because this down here, once you take the absolute value, it becomes positive, well, you're going to end up with -9. So -5, -9, again, you'd have -1 million, -9, so on and so forth. So you see that anything to the left of 0 is going to produce a y value of -9, and then anything to the right of 0 is going to produce a y value of +9. But you can see this is an odd function. So something like 5, 9, when you look over here, it's -5, -9. So this right here, again, if it's an odd function, then if a comma b is on the graph, then you're also going to have -a comma -b. So you could pick any point if you wanted to. You could do something like, let's say 2, 9. So that is 2, 9. And then over here, you would have -2, -9. So that's also there. So this is -2, -9. Again, you could play around with this more in Desmos if you want, but this is going to be an odd function. All right, let's take a look at problem 6. So here we have f of x is equal to x to the 4th power times the square root of 1 minus x squared. And again, for this one, you can see immediately that when you have f of negative x, it's going to be a match. This is a 4 and this is a 2. So the sign will not change and the sign will not change. So this is going to be a match. If you did f of negative x, this would be equal to, again, you can do this. You can say this is negative x to the 4th power times the square root of 1 minus, you'd have negative x being squared. But again, this is really just -1 to the 4th power, which is 1, times x to the 4th power, which is just x to the 4th power. So this is x to the fourth power, and then times the square root of, you'd have 1 minus. This right here, again, this is, you could write it as -1 being squared, which is going to be 1, times your x squared. So this is just x squared right there. So this x to the fourth power times the square root of 1 minus x squared, that is a match with this. So this function is even. So again, if you want to come down to the graph and verify this, you can see that this is symmetric with respect to the y-axis. So you have this point right here, which is -1, 0, and this point, which is 1, 0. So again, the same y value is produced from opposite x values. Plug in a -1, you get 0. Plug in a +1, you get 0. Again, this is symmetric with respect to the y-axis, so this is going to be an even function. All right, let's take a look at problem 7. So here we have f of x is equal to -3 x to the 5/3 power. So this one's pretty simple overall. I think a lot of you can see it's going to be odd right away, but in case you can't, let's just plug in. So what is f of -x here? Well, this is -3, and then you're going to have -x here raised to the 5/3 power. So this one might be a little bit tricky for you to simplify. So what you could do is just break it up and say that this is -3, and then times, you'd have -1 raised to the power of 5/3, and then times, you'd have x raised to the power of 5/3. And so what does this give me? Well, really, let's just think about this off to the side. Let me come down here and put a little border real quick. Well, what is -1 to the 5/3 power? Well, this is -1 to the power of 1/3, and then you can raise this to the power of 5. Well, this right here, this is the cube root of -1, which is -1. So this is -1 to the 5th power, which is -1. So this right here is -1, so you get -3 times -1, and then times x to the 5/3 power. Okay, let me get rid of this, and now let's simplify. So -3 times -1 is 3, and then you have x to the 5/3 power. Okay, we can get rid of this, and you can see immediately, if you look at the negative of f of x, you're going to get a match. So the negative of f of x would be what? Well, you just multiply this by -1. So -1 times -3 x to the 5/3 power, which would equal -1 times -3 is 3. So of course you get 3x to the 5/3 power. Again, you can erase this if you want. Make this a little bit cleaner and just move this down here like that. And so you can conclude that since f of -x is equal to the negative of f of x, this is going to be an odd function. So again, if you want to look at this graphically, here's f of x equals -3x to the 5/3 power. You have this point -1, 3. So that's right there. Again, if you reflect across the origin, well, you're going to end up with opposite signs on each coordinate, right? So -1 becomes +1, and then 3 becomes -3. Any point a comma b will turn into -a comma -b, and that's what we mean by origin symmetry. You can also reflect this across the x-axis if you want first. So that would bring me down here. So at this point, you would have -1, -3, and then you can reflect across the y-axis. So now you'd have +1, -3. So that's what we mean by origin symmetry. Again, if a comma b is on the graph, then -a comma -b is on the graph. So -1, 3, and then 1, -3. So this is an odd function. Okay, for problem 8, we have f of x is equal to 1/3 x to the 6th power minus 3x squared. All right, let me slide down here a little bit. Again, if you notice this right here is even, and this right here is even. If I plug in a -x there for x, well, the sign's not going to change, and the sign's not going to change. So I know already this is an even function, right? I don't have to do much work here. So f of a -x would be equal to 1/3. And again, this is not going to change. It would just be x to the 6th power minus 3. Again, this is not going to change, x squared. So this is going to be even. So coming to the graph, you can clearly see that this guy is symmetric with respect to the y-axis, but you can look at this point or any point you want, and you can see something like 1.316. Again, if I reflect that across the y-axis, now that x-coordinate is -1.316, and the y value is the same in each case. So here it's -3.464, here it's -3.464. Again, these are all approximations, but you can see it's showing me that I have symmetry with respect to the y-axis, so this is an even function. All right, let's take a look at problem 9. So here we have f of x is equal to the quantity x minus 2 squared minus x. So here's where you have to be really, really careful. This exponent is a 2 here. This exponent is a 1. Is the sign going to change if I plug something in here? Well, remember, this right here has to be expanded. This really is x squared minus 2 times this guy times this guy. So 4x and then plus 4. Remember, this is not x squared minus 4 like you might be thinking. So you have to expand this, and when you expand it, you can really understand what's going on. So I would simplify it to that first so you can really see how it's going to change things. So let's say that this is equal to x squared minus 4x plus 4, and then minus x, and you can combine like terms here. So negative 4x minus x, that would be negative 5x. So this is x squared, and then minus 5x, and then plus 4. So if you think about something like f of negative x, well, this is equal to, this here would not change, right? This is x squared. So this is still x squared. Then this would change. Again, if you plug in a negative x there, well, I'm going to change the sign. So negative 5 times negative x, that's going to be plus 5x. And this here is just plus 4. So this right here does not match this right here. Let me actually get rid of this right here. And let me put a little border. So if I think about the negative of f of x, this is going to be equal to, you just put a negative out in front of this guy right here. So x squared minus 5x and then plus 4. And you're just changing the sign of everything. So this becomes negative x squared. This becomes plus 5x. This becomes minus 4. So again, because f of x, which is x squared minus 5x plus 4, once we simplified, does not match f of negative x, which is x squared plus 5x plus 4, this is not even. And then because f of negative x, which is x squared plus 5x plus 4, doesn't match the negative of f of x, which is negative x squared plus 5x minus 4, this is also not going to be odd. So I'm going to say that this is neither. All right, so coming down to the graph, again, just because you see a parabola does not mean it's an even function. You're looking for something that's even to be symmetric with respect to the y-axis. This is your y-axis right here. This graph is not symmetric with respect to the y-axis. If you look at this point right here, 5, 4, if it was symmetric with respect to the y-axis, we'd have a point over here, which would be negative 5, 4. But you don't have that. You have 5, 4 and 0, 4, so it's not symmetric with respect to the y-axis, so it's not an even function. Obviously, it's not symmetric with respect to the origin, so this one's going to be neither. All right, let's take a look at problem 10. So here we have f of x is equal to x plus 1 over x. So let's look at this one real quick. So f of negative x would be equal to, the sign would change here and the sign would change here. So you'd have negative x, and then basically you could write this as minus 1 over x if you wanted to. Again, because this would be negative x and this would be negative x, but you could put the negative out in front. So if you have a positive over a negative or a negative over a positive, you're going to have a negative overall. So you can just write it like this. And if you think about the negative of f of x, well, again, all I'm doing is I'm putting a negative out in front of this x plus 1 over x. And of course, this becomes negative x minus 1 over x. So f of negative x is the same as the negative of f of x. So here we have an odd function. So this right here is an odd function. And again, if you want to look at this, here's your f of x equals x plus 1 over x. I have a point here. Again, if you want more points to work off of, you can just go to the graph on Desmos. So you have something like 1, 2. Again, with origin symmetry, you're going to have another point on the graph, which is negative 1, negative 2. Again, with origin symmetry, if a comma b is on the graph, well, then you're going to have negative a comma negative b on the graph as well. You could also reflect this across the y-axis first. So that would give you this point right here, which would be negative 1, 2. And then you would reflect it across the x-axis, which would give you this point right here, which is on the graph. So that's negative 1, negative 2. So if you can take a point and reflect it across the y-axis and then the x-axis, and it's on that graph, and that's true for all your points, well, then you have origin symmetry, which is what we have here. So this is an odd function. All right, let's take a look at the practice test, or the instructions were asked to describe the shift of g of x based on f of x. All right, let's take a look at the first problem. So we have f of x equals x squared, and then we have g of x equals the quantity x minus 7 squared, and then plus 5. So recall that when we're dealing with a horizontal shift, it's counterintuitive. In other words, I want to go on the inside of this guy and say, how do I undo what's being done to x? Here you have on the inside of this function, x minus 7. So to undo this minus 7 here, I need to add 7, and that's going to give me a shift to the right by 7 units. So I'm going to say that we're going to shift right 7 units. Now, if you're still a little bit confused by this, what you can do, let me put a little border here. You can go to Desmos, and I want you to graph f of x equals x squared. And I want you to graph something like h of x is equal to this quantity, x minus 7 squared. Don't worry about this for right now. We'll deal with that in a moment. And you're going to see that you have this basic graph here, which you recognize, and then this graph right here is the same graph as this. It's just been shifted 7 units to the right. And we can just do a few points real quick. We're going to have a graph for this one, so we'll look at that in a moment. Let's say you go x and then f of x here, and then over here, let's say you go x and then h of x. Let's say you take something like -2. Let's say you take something like 0. Let's say you take +2. And you can do as many as you want, but this is pretty good. So -2, we know if we square that, we get 4. 0 squared is 0. 2 squared is 4. Well, for this one right here, what I need to do is actually add 7 so I can undo what's being done to x so that when I square it, I still get 4. In other words, -2 plus 7 is going to be +5. So if I put a 5 in there, notice that 5 minus 7 would get me back to -2, and then if I square that, I'm back to this 4 here. So to get that same y value of 4, the x value needed to be 7 units larger. So that's what's giving me the shift to the right by 7 units. Now here, instead of 0, I'm going to want 7. Again, 7 minus 7 would be 0. 0 squared is 0. Here, instead of 2, I'm going to want 2 plus 7, which is 9. Go back in there. 9 minus 7 gets me back to 2. 2 squared is 4. So hopefully, if you didn't get this in the lesson, and I know it's a little bit challenging the first few times you do it, this will make sense for you here. You can always pause the video, go to Desmos, and just play around with stuff and think about why this is the case. Now, let me erase this, and let's think about the other scenario here. You have this +5, so this right here is on the outside, and this is very straightforward. So this right here is going to give me, let me actually erase this real quick. This is going to give me a shift up by 5 units. So let me just put and up 5 units. I don't think anyone has trouble with this, but in case you do, you can always write your h of x as being equal to, again, forget about this part right here, just write x squared plus 5 and think about it that way. Well, now, let's say we have x and then f of x, and then we have h of x. For a given x value, let's just say you pick something like -1, the y value is just increased by 5. So this right here, -1 squared is 1. And then if you add -1 squared, that's 1, but then plus 5, now it's going to be 6. If this was 0, this would be 0, but this would be 5. So 0 squared is 0, plus 5 is 5. If you had something like, let's say 4, well, 4 squared is 16, but then here, if you square 4, you get 16, but then plus 5, now you're going to be at 21. So it's just a shift up by 5 units. Again, on the outside of the function, it's very straightforward. On the inside, it's a bit counterintuitive. So you always want to think about, how do I undo what's being done to x? And so we have our answer. So it's just shift right 7 units and up 5 units. All right, so coming to the graph of this guy, again, this is not necessary. Once you start doing these problems, they'll become very, very easy, and you don't need to look at a graph. But if you're struggling, you can click that link on Desmos that I gave you and just look at these points. You can make some tables, whatever you need to do for this to make sense. You can just take this f of x equals x squared, which is this guy in red, and then look at your g of x equals the quantity, x minus 7 squared plus 5. That's this guy in green. I have a few points for you, so just think about how things are moving. So this guy right here, which is 0, 0, well, think about the fact that we're shifting 7 units to the right and then 5 units up. So that's going to this 7, 5. If you look at this point right here, which is -2, 4, again, you're going 7 units to the right. That's going to put me right here, where the x value would be 5 now. And then I'm going 5 units up, so that's going to put me right here at 5, 9. If I start at 2, 4, and I go 7 units to the right, that's going to give me an x value of 9. And then I go 5 units up, now I have a y value of 9 as well. So that's 9, 9. All right, let's take a look at problem 2. So here we have f of x equals x cubed, and then g of x equals the quantity, x plus 1 cubed, and then -2. Okay, so at this point, it should be very straightforward. Again, on the inside here, you're asking, how can I undo what's being done to x? You have this +1 here, so to undo that, you need to subtract away 1. That's going to give me a shift to the left by 1 unit. So I'm just going to put shift left 1 unit, and then and this right here, this -2, that's on the outside. Again, that's very straightforward. That's just telling me I'm going to shift down by 2 units. So I'm going to put and down 2 units. Once again, I do have a graph for you on all of these. So in red, you have f of x equals x cubed. In green, you have g of x equals the quantity, x plus 1 cubed -2. We can just look at 1 point. So on this red graph, you have this 2, 8. So you know if you cube 2, you get 8. And so we know that the shift is going to be 1 unit to the left and then 2 units down. So if I go 1 unit to the left, I'm now going to have an x value of 1. And then if I go 2 units down, I'm now going to have a y value of 6. So you see how that point now would be 1, 6. Again, I have the other points labeled for you if you want to look at those on your own. All right, let's take a look at problem 3. So here for our function f of x, this is going to be the greatest integer function. Let me slide down a little bit. And then g of x, so now you have the greatest integer of x plus 2, and then outside of that you have plus 1. Okay, so all this is going to do, again, if this is on the inside, I need to undo that. So how do I undo adding 2? Well, I want to subtract away 2. So that tells me that I want to shift left 2 units. And this part on the outside, again, that's your vertical shift. If it's plus 1, you're just going up 1 unit. So and up 1 unit. So coming to the graph, this guy right here, so you have this green right there. This is your f of x equals, again, this would be the greatest integer of x. And then your g of x, that's going to be in red. This is going to be equal to the greatest integer of x plus 2 and then plus 1. This one's a little bit tricky. It's not a graph that we work with a lot, but you could just take something like this guy right here and just imagine, just focus on this right here and say, okay, I'm going to move this 1, 2 units to the left, and then I'm going to go up 1. So that would give me this piece right here. And that's all you have to do with each one of these. Again, you can click that link on Desmos if you want to see it in more detail. All right, for problem 4, we have f of x equals the square root of x, and then g of x equals the square root of x minus 2, and then plus 1. Okay, so again, this right here is on the inside. So how do I undo that minus 2 there? Well, I need to add 2. So that means I'm going to shift right 2 units. This plus 1 on the outside, again, that's a vertical shift. We're just going up by 1 unit. So and up 1 unit. Again, if you want to look at the graph, f of x equals the square root of x, that's going to be in red. So you know the points here, something like 0, 0, 4, 2, 9, 3. If it went further out, it would be 16, 4, so on and so forth. Then in green, you have your g of x equals the square root of x minus 2, and then plus 1. So just take a point. Let's just say we work with 9, 3. So we're going to shift 2 units to the right. So now I'm going to be right here. So the x value would be 11. And then I'm going to shift 1 unit up. So now it's going to be here. So it's going to be 11, 4. And again, you could do this with the other points. So 4, 2, you're going 2 units to the right, and then you're going 1 unit up. So you go to 6, 3. This 0, 0, again, you're going 2 units to the right and 1 unit up. So you end up at 2, 1. All right, for problem 5, we have f of x equals the cube root of x, and then g of x equals the cube root of x minus 3, and then plus 2. So if we think about, again, what's going on the inside, you have that minus 3 there. How do I undo subtracting away 3? I need to add 3. So that means I'm going to shift right 3 units. This right here is on the outside, so it's plus 2. Again, that's my vertical shift, and that one's straightforward, so we're just going to say and up 2 units, and that's all it is. Let me fix that A. Once again, coming down here, we have f of x equals the cube root of x, that's going to be in red, and then we have g of x equals the cube root of x minus 3, and then plus 2, that's going to be in green. So any of these points you want to work with, so let's say we take something like 8, 2, again, the cube root of 8 would be 2, so we're going to shift 3 units to the right, so we're going to go 1, 2, 3, so that's going to give me an x value of 11 now, and then we're going to go 2 units up, so I'm going to go up 1, 2, so now I'm going to be at 11, 4. Again, if you had 0, 0, you're going to go 3 units to the right and 2 units up, so I'm at 3, 2. If you're at negative 8, negative 2, I'm going to go 3 units to the right and then 2 units up, so I'm going to be at negative 5, 0. All right, let's take a look at problem 6. So we have f of x equals the absolute value of x, and then g of x is equal to the absolute value of x minus 4, and then minus 5. So once again, thinking about what's on the inside right here, you have that minus 4. How do I undo subtracting away 4? I just need to add 4. So that means I'm going to shift right 4 units, and then and this right here is on the outside. That minus 5, that's just going to shift me down by 5 units. So down 5 units. Again, thinking about the graph, we have f of x equals the absolute value of x in red. We have g of x equals the absolute value of x minus 4, and then minus 5 in green. So any of these points you want to work with, let's say you take 4, 4. Of course, the absolute value of 4 would be 4. I'm going to go 4 units to the right. So I'm going to go over here to where we have 8 for the x value. And then I'm going to go 5 units down. So that's going to bring me down here to where the y value is negative 1. So this is 8, negative 1. If you took something like 0, 0, again, if I go 4 units to the right and then 5 units down, I'm at 4, negative 5. If I took something like negative 4, 4, and I go 4 units to the right and then 5 units down, I'm going to be at 0, negative 1. All All right, let's take a look at problem 7. So here we have f of x equals 1 over x, and then we have g of x equals 1 over x minus 2, and then plus 3. Okay, so what I'm going to do here is look at this minus 2 here. Again, you think about if I plugged in x minus 2 for x there, this is what I would have right there. I'd have 1 over x minus 2. And then the plus 3 here, again, you could just think about that separately. This is on the outside. So we'll deal with that later. That's for the vertical shift. But in terms of the horizontal, I want to think about what's being done to x on the inside. And so here I'm subtracting away 2. So I want to undo that by adding 2. So this is going to shift right 2 units. And again, this is on the outside, so it's very straightforward. You have plus 3, so you're just going up by 3 units. So and up 3 units. That's all it is. Once again, looking at the graph, in red you have f of x equals 1 over x, so this guy right here. And then in green you have your g of x equals 1 over x minus 2, and then plus 3. So starting at this point, again, if you go 2 units to the right, so 1, 2 units to the right, now the x value is going to be 3. And then you go 3 units up, so 1, 2, 3, now the y value is 4, so I'm at that point 3, 4. If you took, let's say this point right here, again, you're going to go 2 units to the right, 1, 2, and then 3 units up, so 1, 2, 3. You're going to end up at 1, 2. All right, for problem 8, we have f of x equals x cubed minus x, and then g of x is equal to the quantity x minus 1 cubed, and then minus the quantity x minus 1, and then plus 2. So this one is not too bad. Just think about the fact that if I had f of x minus 1, forget about this plus 2 for a moment, I would produce this part right here. In other words, if I plugged in x minus 1 there, I'd have the quantity x minus 1 cubed. And then minus, if I plugged in x minus 1 there, I'd have this x minus 1 here. You have the plus 2, but again, I'm going to deal with that later. This is going to be on the outside, so just circle that for now, forget about it. So what we want to do is think about, how do I undo this minus 1 that's on the inside of the function? Well, I need to add 1. So if I'm adding 1, that's shifting me to the right by 1 unit. So I'm going to say we're going to shift right 1 unit, and then I'll put and. What about this plus 2 on the outside? Again, that's just going to shift me up by 2 units. So up 2 units. And that's all it is. All right, so coming to the graph, again, we've seen this a lot of times now. So in red, we have our f of x equals x cubed minus x. And then we have this g of x, and I just went ahead and wrote it as being equal to f of x minus 1, and then plus 2. So when you write it like this, it's very easy to see that, again, on the inside there, you need to undo that. So that's shifting me to the right by 1 unit. And on the outside, it's just straightforward. You're going up by 2 units. So if I start with 2, 6, and I shift to the right by 1 unit, well, now that x value is going to be 3. And then if I shift up by 2, so that's 1, 2, now the y value is going to be 8. So for 2, 6, I'm going to go 1 unit to the right, 2 units up, and I'm going to be at 3, 8. If you wanted to look at this, which is 0, 0, again, I'm going to go 1 unit to the right and 2 units up, I'm going to be at 1, 2. If you looked at negative 2, negative 6, I'm going to go 1 unit to the right, and then 2 units up, I'm going to be at negative 1, negative 4. All right, now we're going to change things up a little bit. So for the instructions, we're asked to give the parent function f of x, the transformed function g of x, and describe the transformation. All right, so this is going to be problem 9, and we're looking at this guy right here. So obviously the parent function, let's call that f of x, is going to be the square root of x. This guy, let's call it g of x, and let's just think about what was done. So if you take a point that's on your f of x equals the square root of x, let me get a different color going. You know you have this point right here, which is 0, 0, and then you have the point 1, 1, you have the point 4, 2, and put that one in there. You have the point 9, 3, so this one right here. So it would look something like that. I'm not a good drawer, but I'll do the best that I can. Something like that. So if you take this point right here, which is, let me arrow to it over here, 9, 3, well, what is this point right here? This is going to be 8, 6. So this point right here is 8, 6. So the x value has been decreased by 1, and the y value has been increased by 3. So for the y value being increased by 3, that's very straightforward. Just put a plus 3 on the outside. For the x value being decreased by 1, again, you've got to do the opposite of what you're thinking. It's not going to be the square root of x minus 1. It's going to need to be the square root of x plus 1. That's going to give me a shift to the left by 1. If you look at this point right here, which is going to be 3, 5, and you compare it to this point right here, which is going to be 4, 2, Again, that's consistent with what we found because you're going to shift 1 unit to the left and then 3 units up. Again, you could plug this stuff in. You could say if I plug in a 3 here, 3 plus 1 is 4, the square root of 4 is 2, and then 2 plus 3 is 5. If you want to plug this one in, the square root of 8 plus 1 is the square root of 9, and the square root of 9 is 3. 3 plus 3 is 6. And then you could look at this point right here, which is 1, 1. Let me make that better here. And then look at this point right here, which is going to be 0, 4. Again, you can see that this guy has been shifted 1 unit to the left and 3 units up. And if you plugged in a 0 here, 0 plus 1 is 1, square root of 1 is 1, then plus 3 is 4. And then lastly, you have this point right here. So this is going to be negative 1, 3. So negative 1, 3. And then this point, of course, is at the origin. So this is 0, 0. And you're being shifted 1 unit to the left and 3 units up. Again, if you plug in a negative 1 here, negative 1 plus 1 is 0. Square root of 0 is 0. And then plus 3 is 3. So hopefully that makes sense for you. So f of x equals the square root of x, and then g of x equals the square root of x plus 1, and then plus 3. And I'm just going to put here that this is going to be a shift left, okay, because of the plus 1. So we're shifting left 1 unit, and then let me make this a better. We'll say up 3 units because of that plus 3 there. All right, let's take a look at problem 10. So here when we look at this graph, immediately you should be thinking about your squaring function. So the parent function here, your f of x is just going to be equal to x squared. And then your g of x is going to be equal to, you'll have some quantity squared, and then you're going to have some vertical shift here. For right now, let's just leave this blank. But let's think about what does the squaring function look like? Of course, we know the points. So this right here would be 0, 0. Let me just arrow to this as I go. So this is 0, 0. If you look at this right here, this is negative 6, negative 1. So this is negative 6, negative 1. So just based on the fact that you know that point's there and it's going to go there, well, I'm going 6 units to the left and then 1 unit down. So I know if I'm going 6 units to the left, again, that has to be undone to produce that. So what you want inside here is not x minus 6, you want x plus 6. Because again, you would look at this and say, how do I undo what's being done to x? To undo the plus 6, I need to subtract away 6, so it gives me a shift to the left by 6 units. And then the shift down by 1, that's just minus 1 right here. So in other words, if I took a negative 6 and I plugged it in there, negative 6 plus 6 is 0. So I'm right back to 0. 0 squared is 0. And then I subtract away 1, and I get that negative 1. So you have that negative 6, negative 1. So that's going to be your g of x. And if you want to, again, trace this out for clarity to get more points, you can. Of course, you can just do this on Desmos instantaneously. That's what I would recommend. So this point would be 1, 1, and then you would have 2, 4. So that's going to be right there. And then you would have 3, 9. Let me see if I can line this up properly. So this right here would be 1, 1. This right here would be 2, 4. And then this right here would be 3, 9. And we'll do some over here. So this is negative 1, 1. This is going to be negative 2, 4. Let me make sure I go up and line this up there. And then you have negative 3, 9. So that's going to be right there. I'm not going to label this side. I think it would get in the way too much. I'm not really that good at drawing anything, but I'm just going to try my best here. So let's say it would look something like that. And let's just do this one right here. So again, something like that. Again, visit Desmos if you want something more accurate. But you can see a point, let me just do this in a different color, something like, let's say, 1, 1. Again, if I'm shifting 6 units to the left, well, I'm going to go 1, 2, 3, 4, 5, 6. So I'm going to be right here where the x value is negative 5. And then I'm going to go 1 unit down, so it's going to be this point right here. So this point would be negative 5, 0. And again, you can do this with more points on your own if you want. Just go to Desmos and you can type both of these in and just play around with the different points that you know. Let me fix that. It doesn't look so good. So let me rewrite negative 5, 0 there. Okay, so let me just write out here to finish things up that we are going to shift 6 units left, and then I'll put and 1 unit down. And that's all it is. Let me fix this E here and make that better. All right, let's take a look at the practice test. For the instructions, we're asked to find f plus g of x, f minus g of x, and state the domain. All right, for problem 1, we're given f of x equals x squared plus 5x minus 1, and then g of x is equal to negative x minus 3. All right, so the first thing I'm going to do here is just look at f plus g, and then of x. All this is I'm going to take this right here and add it to this right here. That's all it is. So I'm just going to wrap this in parentheses for clarity. You don't need to do this. I'm just going to say x squared plus 5x minus 1. Then plus, again, I'm just going to wrap this in parentheses for clarity. So this is going to be negative x minus 3. So that's my g of x. So this is me adding those two guys together. Again, that's all you're really doing. So I'm going to drop the parentheses. So I'm going to say this is equal to x squared plus 5x minus 1, and then minus x minus 3. And here we're just combining like terms. So to make this crystal clear, let me write x squared out in front. I'm going to put plus 5x and then minus x. I'll put those guys next to each other. And then I'm going to go minus 1 and then minus 3. All right, so to finish this up, I'm just going to have x squared and then plus 5x minus x would be 4x. And then negative 1 minus 3, you can say that's going to be negative 4. So that's going to be your answer for f plus g of x. Now, in terms of the domain, let me get rid of all this. And let me just slide this up here like that. In terms of the domain, let me just arrow to it. Remember that it's going to be the intersection of the two domains. So when I look at my f of x equals x squared plus 5x minus 1, the domain is all real numbers. I can plug in whatever I want for x. There's no restriction. When I look at g of x equals negative x minus 3, again, I can plug in whatever I want for x. There's no restriction, so it's all real numbers. So the intersection here would be all real numbers. So I'm just going to say that it's the set of all x such that x is an element of the set. I'm just going to use this r here. I know there's a different r in the textbook, but it's hard to draw. So this just means is an element of the real numbers. Again, if you want to use interval notation, you could also just say that it's going to be from negative infinity to positive infinity, whichever one you prefer. A lot of people like to use set builder notation, so I'm just showing that here. If you want to use the interval notation, that's fine as well. Let me actually grab this, and I'm just going to drop this off right here. We don't need it anymore. You can pause the video and write that down if you want. And let me come back up. And now we want to do this f minus g of x, and that's just as simple. So I'm just going to take my f of x equals x squared plus 5x minus 1. So let me just write that. So x squared plus 5x minus 1. You can wrap it in parentheses if you want. Let me go ahead and do that for consistency. Then I'm going to go minus. Now here's where you need to wrap this in parentheses because you're subtracting this whole thing away. So you have to think about the sign changes that would be involved. So make sure you wrap this whole thing in parentheses. So minus x and then minus 3. Let me come down here real quick, and I'm just going to distribute the negative in. So we're going to say that this is, you could drop the parentheses here. So x squared plus 5x minus 1. Then this, again, if you want to go plus negative 1 like that, just to remind yourself of what you need to do. So negative 1 times negative x, that's going to be plus x. And then negative 1 times negative 3, that's going to be plus 3. Again, if you want to take the time to rearrange things, you can. I'm just going to say that we would have x squared, and then 5x plus x would be 6x. And then we would have negative 1 plus 3. That's going to be plus 2. So this would end up being x squared plus 6x plus 2. Let me get rid of this like that. And I'm just going to drag this up here just so we can see our answer. And we move that up a little bit higher. And then again, for the domain, we already know that it's the intersection of these two domains. We know this one is all real numbers and this one is all real numbers because we did it earlier. So again, for the domain, for this one, it's going to be the same as the other one. Let me make that a better there. And I'm just going to say, again, if you want the set builder notation, the set of all x such that x is an element of the real numbers. Or if you want, again, you could just use interval notation. So you can go from negative infinity to positive infinity. Again, whichever one you want to use. All right, for problem 2, we have f of x equals 7 minus x squared, and then g of x equals x squared minus 4. Let me slide down here a little bit. So let's just start again with f plus g of x. And again, I'm just going to add these guys together. I'm going to skip the wrapping them in parentheses. It's unnecessary, but you can do it if you want. So I'm just going to take this 7 minus x squared here, and then I'm going to add to that this x squared minus 4. And then I'm just going to combine like terms. So if I look, I see that I have negative x squared plus x squared. That's 0. So you can just show these as canceling. So I'm just going to line them out. And then basically at that point, you have 7 minus 4, which is just going to be 3. So f plus g of x is just going to be 3. So really, you could graph that if you wanted to. No matter what you plug in for x, you're just going to get a y value of 3. So that's a horizontal line. That's just like if you graphed y equals 3. Okay, in terms of the domain, we're going to have what? In terms of this guy and this guy, is there anything that I can't plug in for x? No, I can plug in a negative, 0, positive, whatever I want. So the domain here is all real numbers. The domain here is all real numbers. So the intersection, if you look at that, is going to be all real numbers. So again, you can write this like this. So the set of all x such that x is an element of the real numbers. Or you can use interval notation if you want. So from negative infinity to positive infinity. Okay, let me get this out of the way. So I'm just going to paste that there and come back. And now we're going to do our f minus g of x. Now here you do need to use parentheses. This is where people usually make a mistake. So for your f of x function, again, that comes first. So you have f minus g, so this guy's going to be first. So you can put parentheses there if you want, but I'm just going to leave them off. Here's where you need to use parentheses because you're subtracting away this function g of x equals x squared minus 4. So you want to put minus, again, this quantity here. So x squared minus 4. So here's where you need a set of parentheses in order to not make a sign mistake. So again, you can just go plus negative 1 here and just distribute this. So we would say that this is equal to 7 minus x squared. And then negative 1 times x squared is negative x squared. And then negative 1 times negative 4, that's going to be plus 4. So negative x squared minus x squared, that's negative 2x squared. And then 7 plus 4 is 11. So this is just plus 11. Again, you can just erase all this scratch work here. And so we get negative 2x squared plus 11. Now, if you're thinking about the domain, once again, it's just the intersection of these two. So it's the same as before. It's just going to be all real numbers. So let me write for the domain here. Let me fix this in. The set of all x such that x is an element of the real numbers. Or again, an interval notation from negative infinity to positive infinity. All right, now we're going to change things up in terms of the instructions. We want to find fg, which is just f times g of x. We want to find f over g of x and state the domain. For problem 3, we're given f of x equals negative 4x minus 1 and g of x equals 2x squared minus x. So let's start with this fg, and this is just multiplying them together. So of x, what is this going to be? It's going to be this guy times this guy. So I'm just going to wrap these guys in parentheses and use FOIL. So negative 4x minus 1, so that quantity times the quantity 2x squared minus x. So this one might take a little bit of time, but it's not that bad. So we're going to do first, so negative 4x times 2x squared. So negative 4 times 2 is negative 8. And then x times x squared is x cubed. And then we're going to do our outside. So negative 4x times negative x. Negative times negative is positive. You have a 4 there. Let me just write plus 4. And then x times x is going to be x squared. Then on the inside here, you have negative 1 times 2x squared. That's just negative 2x squared. Then for the last, you have negative 1 times negative x. That's just going to be plus x. So here you would just combine like terms. And so what you're going to be looking at is this guy and this guy. So the plus 4x squared minus 2x squared, that's going to be plus 2x squared. So this is going to be equal to negative 8x cubed, and then plus 2x squared, and then plus x. So that would be your answer. Now, in terms of the domain, again, it's going to be the intersection of these two domains. Here it would be all real numbers, and here it would be all real numbers. So when you look at this guy right here, the domain is also going to be all real numbers. So for the domain, we can, again, use set builder notation. So the set of all x such that x is an element of the real numbers, or you can use interval notation, again, from negative infinity to positive infinity. So however you want to write that. Let me get this out of the way. Again, I'm just going to paste it here. We don't need it anymore. All right, now let's move on and go to our f over g of x. So again, this is very straightforward. You're going to take your f of x, which equals negative 4x minus 1. So we're going to go negative 4x minus 1. And you're going to put that over your g of x, which is equal to 2x squared minus x. So this is 2x squared minus x. So if you want to leave it like that, that's fine. What I would suggest doing here is just writing it a little bit differently because we're going to deal with the domain in a moment. So I'm just going to factor in the numerator. Again, this is completely optional. I'm going to pull out the negative 1. So I'm going to say this is negative 1 times the quantity. This would now be positive 4x, and this would be plus 1. Again, if you distribute this, negative 1 times 4x is negative 4x. Then negative 1 times 1 would be negative 1. Let me fix this here, make it better. This would be over. Down here, I'm just going to pull out an x. So this would be x times the quantity, 2x minus 1. Let me get rid of this. And I'm actually going to move this. Instead of the negative 1 times this quantity, I'm going to just put a negative out in front. And then I'm going to get rid of these parentheses here. And this is how I'm going to write my answer. Maybe I could slide this over into the middle a little bit. But again, different forms would be acceptable as well. So when you get to the domain step, this is the one where it trips people up a lot. You want to think about, again, the fact that it's the intersection of these two domains. So this, again, is all real numbers, and so is this. But when you're dealing with a quotient, you have to remember that you can't divide by 0. So there's an additional step here where you would say that x times the quantity 2x minus 1, we want to set this equal to 0 and solve that equation. So the solutions here would have to be restricted from the domain because, again, you cannot divide by 0 that's undefined. Let me slide down here and let's just solve this real quick. So by the zero product property, we know that, first off, x is equal to 0, so that's a solution. Then or 2x minus 1 is equal to 0. So let's add 1 to both sides. And so this would cancel. You get 2x is equal to 1. Divide both sides by 2. And this would cancel. So now you're going to end up with another solution that is x is equal to 1/2. So let me put here that x is equal to 1/2. So if I plugged in either a 0 for x or a 1/2 for x, I get division by 0, which is undefined. So what I need to do when I write out the domain is say that in set builder notation, it's going to be the set of all x such that x is not equal to 0. And then also, it can't be equal to this positive 1/2. So you could write it like that if you want. Again, if you want to use interval notation, you can. Just keep in mind that it's going to be a little bit longer here. So you want to exclude 0 and you want to exclude 1/2. So coming from negative infinity, going up to and excluding 0, and then the union with, again, you're going to exclude 0 and you're going to exclude 1/2. And then it's going to be anything larger than 1/2. So going out to positive infinity. So that's how you could write it if you wanted the interval notation. Again, either form there would be acceptable. All right, for problem 4, we're going to have f of x is equal to the square root of x minus 2, and then g of x is equal to x over x plus 11. All right, let's start with the multiplication. This one's pretty straightforward. So just f and g of x like that. And there's not a whole lot I can do. I'm just going to show these guys as being multiplied together. Let me slide this down so I have a little bit more room. This is just going to be x times the square root of x minus 2 over x plus 11. Okay, let me actually grab this real quick. Come down here and just paste this in. In terms of the domain, let me go back up. Remember, for this one, it's going to be the intersection of the two domains. So if you look at the domain right here, so let me just say for f, so for f, your domain is what? Well, we know that in the real number system, we can't take the square root of a negative number. So this right here would have to be non-negative. You would say that x minus 2 is greater than or equal to 0. You add 2 to both sides of that inequality, and you're going to get that x needs to be greater than or equal to 2. So for this one, let's say that it's going to be the set of all x such that x is greater than or equal to 2. Again, you could also write that in interval notation and say that it's from 2 and including 2 going out to positive infinity. Now, in terms of this right here, g of x equals x over x plus 11, well, now you want to think about where would I be dividing by 0? So you would take that x plus 11 and set that equal to 0, subtract 11 away from each side of the equation, and you get x is equal to negative 11. So in this particular case, you could say that for g, the domain, is the set of all x such that x is not equal to negative 11. Again, if you plugged in negative 11 there, negative 11 plus 11 is 0. You'd have a division by 0, which is undefined. And of course, if you want this in interval notation, this is from negative infinity going up to and excluding negative 11. And then you have the union with anything larger than negative 11. So these two guys right here, you want the intersection of them. So it has to work in both. If I think about this one right here, it's going to cover both because this is anything that's 2 or larger. This one right here only excludes negative 11. Well, if I'm working with numbers that are 2 or larger, this is already out of the picture. So this is the one I want to use when I look at the domain of fg of x. So I'm going to come down here and just say that my domain is going to be the set of all x such that x is greater than or equal to 2. And again, to write that in interval notation, we're going to include 2 and then go out to positive infinity. All right, let's come back up here. And now we're going to do the other guy, which would be your f over g of x. So this guy right here that you're dividing by is going to be a fraction. So I'm just going to change this into multiplying by the reciprocal. So keep this one the same. Let's just say it's the square root of x minus 2. You could put it over 1 if you want. And then I'm going to multiply by, again, the reciprocal of this. So I'm going to say this is x plus 11 over x. So let me actually grab this real quick. And let me paste this in here so we have room to work. You could do this different ways. One way is you could just say, I'm going to wrap this as a quantity, so x plus 11, that quantity times the square root of x minus 2, and then this would just be over x. So you could do it that way. Or if you wanted to, you could distribute this. It's up to you. You could say this is x times the square root of x minus 2, and then you could go plus 11 times the square root of x minus 2, and this is all over x. So either one would be acceptable. It's just going to be a matter of your preference. Now, in terms of the domain, remember that if we go back up, we already figured out that the intersection of those two domains from your function f and g would be this guy right here. So let me grab this real quick as the starting point, and let me come down here and paste this in. So thinking about this, would this domain apply here? Well, all we have to do is consider where the denominator would be 0. And the denominator would be 0 here at 0, right? Because you just have x there, so it would just be, I can't plug in 0. Remember that this domain here already excludes 0. So in other words, it's the set of all x such that x is greater than or equal to 2. Well, 0 is not included in that, so you can use this domain for this as well. So just pay close attention when you're doing the division. That's where you have to take an additional step. You want the intersection of the two domains, and then you also need to make sure that the new function that you're creating, you don't have division by 0 there. So here the domain is the set of all x such that x is greater than or equal to 2. Again, an interval notation from 2 and including 2 going out to positive infinity. All right, let's change things up again. So for the instructions, we're going to find 4f minus 5g of x and state the domain. So for problem number 5, let me write this out. So we want 4f minus 5g, so of x, like this. We have f of x equals 9x minus 1. We have g of x equals 5x squared minus x minus 2. So if you're given a problem like this, all you're doing is you're taking 4 and you're multiplying it by your function f of x. In other words, if I want 4f, this is equal to 4 times f of x, which is equal to 4 times this quantity, 9x minus 1, which would be 4 times 9x is 36x, and then minus 4 times 1, that's going to be 4. That's all it is. And then 5g, so 5g, so this is equal to 5 times your g of x, and this is equal to, you would have 5 times this quantity, 5x squared, minus x minus 2. So this would be 5 times 5 is 25. And then x squared, and then minus 5 times x is just 5x, and then minus 5 times 2 is 10. So all we're doing, if we're asking for this 4f minus 5g, well, you're just going to take, this is your 4f, this is your 5g, you're just going to take this one minus this one. That's all you're doing. So let me slide down here a little bit, and let's put this together. So if you want 4f minus 5g, let me make this like this, so of x, this equals your 36x minus 4, and then minus, again, wrap this in parentheses because you're subtracting the whole thing away. So 25x squared minus 5x minus 10. So let me come down here and just say this is equal to, again, just go ahead and put plus -1 here so you don't forget about the sign change for all the guys inside. So I'm going to write that we have 36x minus 4. So 25x squared times -1 is negative 25x squared. And then negative 5x times -1 is plus 5x. And then negative 10 times -1 is plus 10. Okay, so looking at this, we have negative 25x squared. And then I have 36x plus 5x. That is going to be plus 41x. And then you have negative 4 plus 10. That's going to be plus 6. So this 4f minus 5g of x is going to be negative 25x squared plus 41x plus 6. So not too bad overall. Now we just need to figure out the domain. And in this case, it's going to be very, very simple. So let me move that up there. And actually, let me grab this real quick. And let me just put this right here. And I'm just going to arrow to it and say that the domain is going to be all real numbers. I'll go back and explain where this is coming from. So it's just the intersection of the two domains. And so for both of them, it's going to be all real numbers. So this is the set of all x such that x is an element of the real numbers. Or again, you can go from negative infinity to positive infinity like that in interval notation. Again, just coming up here, just looking at the functions. So 9x minus 1, there's nothing I can't do there. 5x squared minus x minus 2, there's nothing I can't do there. So I can plug in whatever I want for x here and also here. So this is going to be all real numbers and all real numbers, and the intersection of that is all real numbers. So that's how we got our domain. All right, let's take a look at problem 6. So here we have f of x equals 3x minus 2 over 2, and then g of x equals x minus 1. Again, we want 4f minus 5g of x. Let me actually just bring this down here, and I'll just paste this in. So again, the way I would do it is, I would first figure out, well, what is 4 times f of x? And that's going to be 4 times this 3x minus 2 over 2. What I'd do is cancel this 4 with this 2, and that would give me a 2. And then this has to be distributed. So in other words, this is like saying I have 2 times the quantity, 3x minus 2. So this has to be multiplied by each of these guys. So this would end up giving me 2 times 3x is 6x, and then minus 2 times 2 is 4. So that's going to be 6x minus 4. So let me just write that this is 6x minus 4 here. Let me get rid of this, just scratch work here. And we're going to be subtracting away. Let me open up some parentheses here. Again, for the 5g, let's write 5 times g of x. This is equal to 5 times the quantity x minus 1, which is, we're just going to distribute this to each guy. So 5 times x is 5x, and then minus 5 times 1 is 5. So just put this in here. So 5x minus 5. Let's get rid of this. So all we have is the 6x minus 4, and then minus the quantity 5x minus 5. Again, don't forget to distribute this. You can go plus -1 here and distribute that -1 in. So this is 6x minus 4, and then -1 times 5x is minus 5x, and then -1 times -5, that's going to be plus 5. So to combine like terms, 6x minus 5x is x, and then -4 plus 5, that's going to be plus 1. So this is x plus 1. Now, thinking about, again, the domain for each, it's going to be all real numbers. So when you look at the domain of this guy right here, again, it's the intersection of the two, so it's still going to be all real numbers. So the domain is going to be the set of all x, such that x is an element of the real numbers. Let me make this better here. And then when we think about interval notation, again, this is from -infinity to positive infinity. All right, let's change things up once again. So for the instructions, we're asked to find f plus g of x, fg of x, and state the domain. Then we want to find f plus g of 5 and fg of -1. So I would recommend actually doing this one right here, and then you do this one right here, and then you can do this one right here and this one right here. So let me do that in a different color. So these two right here would be matched up. So let's slide down here and look at problem number 7. So we have f of x equals the square root of 7x plus 1, and then g of x equals 3x plus 5. Okay, so first and foremost, again, let's do f plus g of x. So this is, for f of x, the square root of 7x plus 1, and then plus, for g of x, you have 3x plus 5. Can I do anything else with this? No, that's as good as you can do. In terms of the domain, again, you want the intersection of the two. Well, the domain for the g of x equals 3x plus 5, that's all real numbers. The domain for f of x equals the square root of 7x plus 1, we've got to think about, again, in the real number system, you cannot take the square root of a negative. So we're going to say, where is that radicand, 7x plus 1, greater than or equal to 0? Subtract 1 away from each side of the inequality, and so this would cancel. You get 7x is greater than or equal to -1. Divide both sides by 7, and let's cancel this, and we'll say that x is greater than or equal to -1/7. So when you think about the intersection of the two, you're going to need for x to be greater than or equal to -1/7 for things to work in both. So let's just say that the domain for this guy would be the set of all x such that, let me just move this over here, so x is greater than or equal to -1/7. So that's all it is. Again, in interval notation, you could put a bracket here to include -1/7, and then you're just going out to positive infinity. So let me actually grab this and paste this in right here. Now, it also told us that we want f plus g of 5. This is my f plus g of x. If I want f plus g of 5, I'm just going to plug in a 5 everywhere there's an x. So this would be the square root of 7 times 5 plus 1, and then plus 3 times 5, and then plus 5. So again, all I did was I plugged in a 5 here and here. That's it. That's all I'm doing. So then this equals the square root of 7 times 5 is 35, and then plus 1 is 36. And then you have plus 3 times 5 is 15, and then plus 5 would be 20. So we know the square root of 36 is 6, so this is 6 plus 20, which equals 26. So let me get rid of the scratch work here and just say that this f plus g of 5 is 26. Okay, now let's talk about the other scenario, which was f g of x. And again, all you're doing is multiplying these guys together. You can just do this as the quantity 3x plus 5 times the square root of 7x plus 1. Of course, if you wanted to, you could do it like this. You could say it's 3x times the square root of 7x plus 1, and then plus 5 times the square root of 7x plus 1. So this one or this one, either way you want to write it, it's fine. I'm just going to keep it like this because it's a little bit simpler. If you think about, again, the domain is just the intersection of the two. So it's just what we found earlier. So it's going to be, let me write the domain, same as before. So the set of all x such that x is greater than or equal to -1/7. Again, because this radicand needs to be non-negative. And let's go ahead and close that down. Again, if you want the interval notation, you just put a bracket with -1/7, and then you're going out to positive infinity. Okay, let me grab all of this, and let's paste this in here. When we look at the next part of this, it tells us to find fg of -1. Can I do that? Well, this is your fg of -1. If you look at the domain, it specifically says that your x needs to be -1/7 or larger. If you think about -1, it's smaller than -1/7. So this is not in the domain, so you would just say it's undefined. So this right here, you could just write is undefined. What's going to happen is if you're working in the real number system, and of course you can do things with the complex number system with the square root of -1 being I, the imaginary unit, but we're not involving that here. If you're working in the real number system, if you try to plug in a -1 there, where you're going to end up with a negative number for your radicand, and again, in the real number system, you cannot take the square root of a negative. So that's why we're going to say this is undefined. All right, for problem 8, we have f of x equals the square root of x plus 1 over 2, and then we have our g of x equals 9x minus 5 over x. So let's think first about our f plus g of x. Again, we're just going to add these guys together. So you have your square root of x plus 1 over 2, and then plus you have your 9x minus 5 over x. Now, depending on your teacher, they might actually let you give this as an answer. I would get a common denominator and combine them like that. But again, a lot of this is just personal preference in terms of how you want to answer things. It's really meant for you to be able to plug things in and get an answer. But in terms of this guy right here, I'm just going to go ahead and say that I'm going to multiply. Let me just slide this over a little bit like this. I'm going to multiply this by x over x, and I'm going to multiply this by 2 over 2, just so I can get a common denominator, because you have a 2 here and an x here, so the least common denominator would be 2x. So this would be equal to x times the square root of x plus 1, and then plus, you need to multiply this 2 by each guy here, so let's wrap this 9x minus 5 inside of parentheses. Let's make that 5 better. And then, of course, you could write this over the common denominator of 2x. So this becomes what? If we slide down, we have x times the square root of x plus 1, and then plus, you're going to distribute this to each guy, so 2 times 9x is 18x, and then minus 2 times 5 is 10. So this right here would all be over 2x. So that's how I would give the answer. In terms of the domain, let me get rid of this. Let's come back up and think about it. For this one right here, you think about, you have a square root. And so again, the radicand needs to be non-negative. So you would first say that x plus 1 needs to be greater than or equal to 0. Subtract 1 away from each side. This cancels. You get x is greater than or equal to -1. So in terms of the domain for this guy, x would need to be -1 or larger. In terms of this guy right here, what can't you do? You can't divide by 0. So in other words, this x here cannot be 0. So x here cannot be 0. Well, if x is greater than or equal to -1, well, that does not cover this. So you would need to put these two guys together. In other words, x needs to be something that's greater than or equal to -1. So let's write this out. We would say that it's the set of all x such that x is greater than or equal to -1. And then also, let me fix this. So, and also, x cannot be equal to 0. So that's how you could write it like that. Let me go ahead and grab this. We'll come down here and paste this in. So this is going to be for your domain. And if you want to write this in interval notation, you would say coming from -1, so that's going to be included, going up to and excluding 0. So you're going to put a parenthesis there, and then you want the union with, again, anything larger than 0 is okay, out to positive infinity. Now, we also want to find f plus g of 5. So how do we do that? Again, everywhere there's an x, so here, 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 and here, you're just going to plug in a 5. So this is going to be 5 times the square root of 5 plus 1 would be 6, and then plus 18 times 5. You can do that now, it's 90. Let me just erase this. I'll just say that's 90. And then minus 10, and then this would be over 2 times 5. Again, that's just going to be 10, so let me just write that in there now. Okay, let me slide down here a little bit. We can simplify some, so 90 minus 10 is going to be 80. And then if you wanted to, you could leave this as your answer, but if you wanted to, you could factor out a 5 from the numerator. This is 5 times 16 like that. So you could say this is 5 times the quantity square root of 6 plus 16. And then this would be over, you could go 5 times 2 just to break that up. So this would cancel. And then let me move this 2 over here. This would be equal to the square root of 6 plus 16 over 2. All right, now let's do our fg of x. All you're going to do is just multiply these guys together. So you're going to have square root of x plus 1 over 2 times, you'd have this quantity 9x minus 5 over x. Pretty straightforward overall for this one. You could, again, write this as 9x times the square root of x plus 1, and then you can go minus 5 times the square root of x plus 1 all over 2 times x is just 2x. So you could write it like that. Or if you wanted to, you could also write it like this. You could just say the quantity 9x minus 5 times the square root of x plus 1 over 2x. I think I would write it like this, but again, if you want to write it like that, it's fine. So that would be your answer for that. In terms of the domain, again, you're just going to take that domain that we found earlier. It's just the intersection of the two. So we're going to say, let me slide down here a little bit, that the domain is going to be the set of all x such that x is greater than or equal to -1, and also x cannot be equal to 0. So that's what we want for the domain. In interval notation, once again, you could say from -1 going up to and excluding 0, and then the union with anything larger than 0. So this is going out to positive infinity. All right, we want to find our fg of -1. So if I want fg of -1, well, everywhere there's an x, I'm just going to plug in a -1. I think you can eyeball that and immediately see it's going to be 0, because when you plug in a -1 there, -1 plus 1 is going to be 0. Square root of 0 is 0, and then 0 times anything is 0. But let me just plug this in here. So you'd have 9 times -1, and then minus 5. You can wrap this, and then times the square root of -1 plus 1, and this is over 2 times -1. Again, this right here is going to become 0, and 0 times anything is 0, so you can just get rid of this and say this is 0, and 0 over any non-zero number, which this would end up being -2. Of course, this is going to end up being 0. So this right here, this fg of -1 is 0. All right, we're going to change the instructions again. So we want to find f minus g of x, f over g of x, and state the domain. Then we want to find f minus g of 1 and f over g of 2. So again, you would take this one and this one together, and you're going to take this one and this one together. So let me slide down here, and we'll start with, again, problem number 9. We have f of x equals the square root of x minus 1, and g of x equals the square root of 5 minus x squared. So when you think about something like f minus g of x, that's very straightforward. So this is the square root of x minus 1. That's your f of x. And then your g of x is the square root of 5 minus x squared. So I'm just going to subtract that away. So this is basically the answer for that part. Very straightforward. Let me go ahead and grab this real quick and come down here and paste this in. Now, when you think about the domain, this is where it gets a little bit tricky. First, you want to think about the domain of this one. So this guy right here, for the domain, again, in the real number system, you cannot take the square root of a negative number. So you would want x minus 1 to be greater than or equal to 0. So let's just solve that real quick. So x minus 1 is greater than or equal to 0. You add 1 to each side of the inequality. You get x is greater than or equal to 1. So the domain for that guy is going to be the set of all x such that x is greater than or equal to 1. What about this guy? It's a little bit more complicated. Again, we have a square root. So this 5 minus x squared needs to be non-negative. So let me arrow to this down here. So for the domain, well, we want to say that it's the set of all x such that, well, we want 5 minus x squared to be greater than or equal to 0. That is a little bit of work. So let me do that over here. So 5 minus x squared is greater than or equal to 0. If you want to solve a quadratic inequality, again, one way you can do this is with the test point approach. So I'm going to solve the related equation. So what if I had 5 minus x squared is equal to 0? You would subtract 5 away from each side. So let's put this as negative 5 over here. Divide both sides by negative 1. And so you would say x squared is equal to positive 5. So this has a solution by the square root property, where we say x is equal to plus or minus the square root of 5. Okay, so that gives me the critical values. If you want, again, you can make yourself a little number line. You don't have to. Let's say I draw a little sample number line. Does not have to be perfect. Let's just say that 0 is right here. Let's just say the square root of 5 is here. And then over here, let's just say this is the negative of the square root of 5. The square root of 5 is about 2.2, let's say 4. And then the negative of the square root of 5 is about negative 2.24. So anything to the left of the negative of the square root of 5, let's call that region A. Anything between negative square root of 5 and square root of 5, let's call that region B. And anything to the right of square root of 5, let's call that region C. I think that without even plugging things in, you can tell that things in A and C are not going to work. If you pick something, let's just say you pick negative 4, for example, that's in region A. If you plug that in, negative 4 squared is 16. Well, if you did 5 minus 16, is that greater than or equal to 0? This would be negative 11 is greater than or equal to 0. That is false, right? So this does not work. You can put an F right there. Using a similar thought process, if you plugged in, let's say a 4, which would be in region C, well, 4 squared is again 16. 5 minus 16 is negative 11. That's not greater than or equal to 0. You get a false statement, so you can put an F here for false. Okay, so let's get rid of this. Would things work in region B? Yes, if you plugged in a 0 there, 0 squared is 0. 5 minus 0 is 5. 5 is greater than or equal to 0. So this guy right here, this would be true. So your solution that you're looking for is that your x would be greater than or equal to, this would be included here because it's a non-strict inequality, the negative of the square root of 5, and less than or equal to the square root of 5. So let's grab this. So let me bring this up here like that, maybe a little bit higher, and close that down. So you want the intersection of these two. So really when I look at this, what I want is x to be greater than or equal to 1 and less than or equal to the square root of 5. So let me come down here. So for your domain, you're going to say that it's the set of all x, let me make this better here, such that your x is greater than or equal to positive 1 and less than or equal to the square root of 5. So let me close that down like that. So this would be for your f minus g of x, again, the intersection of those two domains. Your x values have to work in both. Then additionally, if you want to do this in interval notation, let's say this is going to be from 1 going up to and including the square root of 5. So just like that. All right, if we want to find f minus g of 1 here, it's pretty straightforward. You're just going to plug in a 1 right there and then also right there. We know 1 minus 1 is 0. Square root of 0 is 0. Then minus. 1 squared is 1. 5 minus 1 is 4. Square root of 4 is 2. So you get 0 minus 2, which is going to end up being negative 2. So that's going to be your answer there. All right, now let's look at our f over g of x. And let me make that better. This is going to be equal to, again, your f of x equals the square root of x minus 1. So that's going to go in the numerator. So just the square root of x minus 1. This is over. The g of x is equal to the square root of 5 minus x squared. So that's going in the denominator. So the square root of 5 minus x squared. That 2 could be better there. Let me make it like that. Okay, let me grab this real quick and let me paste this in. So the first thing I would start with here is, what is the domain? So let me arrow to this and say, what is the domain? A little while ago, we found the intersection of our domain from f of x and g of x to be the set of all x such that x is greater than or equal to 1 and less than or equal to the square root of 5. Now, does that domain work for this problem here? No, because we have a quotient. And when you have a quotient, you have to guard against division by 0. The issue is the square root of 5 is no longer able to be included, because if you were to plug that in for x right there, so in other words, if you plug that in for x there, well, square root of 5 squared is 5. 5 minus 5 is 0. The square root of 0 is 0, and division by 0 is undefined. So what you have to do for this particular case is make a little modification to what you found earlier. And now you would say the domain for this f over g of x is going to be the set of all x such that x is greater than or equal to 1, so that's still included, and strictly less than the square root of 5. So this is excluded. In other words, in interval notation, we want to include 1, so we're going to put a bracket there, and we're going to go up to and exclude the square root of 5. So this right here would be a parenthesis. Now, let me talk about rationalizing the denominator for a moment. Let me go ahead and grab this real quick, and let me paste this in. So this right here can open up a can of worms. It can lead to a level of complexity that a lot of books don't like to cover. So usually they'll just leave the answer this way. And for myself, I would just say that I think that's acceptable. A lot of times we stress that you always want to have a radical free denominator that's considered simplified. So if you want to do it here, you can, but you have to understand the domain that's going to be involved. Because what can happen, and I just want to show you this graphically real quick, is you could end up with something that is not the same as your f over g of x by rationalizing the denominator. So here you have your y, which you could write f over g of x if you want. This is equal to the square root of x minus 1 over the square root of 5 minus x squared. And basically this follows the domain that we found. So from 1 and including 1, going up to and excluding the square root of 5. So I'm going to leave a link for you on Desmos where you can just click on that and you can hover over things and verify what I'm saying. Let's say you rationalize the denominator and you don't do any analysis of the domain, you don't think about things, and you come up with something that looks like this. So y equals the square root of your quantity x minus 1 times the quantity 5 minus x squared over 5 minus x squared. So you still have this piece right here, but now, out of nowhere, you have this piece right here. So this right here should not be on the graph of your f over g of x, but yet by rationalizing the denominator, we came up with it. So what's happening is when this gets multiplied by this, now something that shouldn't work, so for example, something like, let's say, plugging in an x value of -3 that should be undefined, now it's going to work because you have a negative times a negative, which gives you a positive. So this point right here, which is -3 comma -1, again, if you want to plug in and see where that's coming from, in the original, again, you have y equals the square root of x minus 1 over the square root of 5 minus x squared. Well, if you plug in -3 there, -3 minus 1 is -4. Again, in the real number system, I can't say that enough. In the real number system, the square root of -4, you're not going to be able to do that. Again, you can do it with a complex number system, but we're not working with that right now. So in the real number system, the square root of -4 is undefined, so you're not going to have this piece over here. You're just going to have this right here. Now, when we go to this part right here where we multiply these guys together, well, now you can do that. Because -3 minus 1, that's -4. So you'd have your square root of -4, and then times, here you'd plug in a -3. -3 squared is 9, so 5 minus 9 is -4. So that's going to be the same thing down here. So this would be -4. So -4 times -4 is 16. So you get the square root of 16 over -4, which becomes 4 over -4, which equals -1. So that's how you end up with this point, -3 comma -1. And this piece right here of this graph for this guy right here, that's how these guys are being generated versus the original one where you couldn't do that. So you have to keep that in mind when you're rationalizing the denominator. You might come up with something that has been modified in such a way that it's no longer accurate. So you want to make sure you're using a domain restriction. Let me come back up and let me show you how to do that. So the first thing is, I'm going to go piece by piece. When you look at rationalizing the denominator here, you're going to multiply by the square root of 5 minus x squared over the square root of 5 minus x squared. I'm going to do these separately. We're going to end up putting them together, but keep in mind that the domain for this guy right here has to hold. But when we do these separately, so let's say you do the square root of x minus 1 times the square root of 5 minus x squared, well, you can say that this is equal to the square root of this quantity x minus 1 times the quantity 5 minus x squared. But as we've learned already, you have to take the intersection of this domain and this domain. So this right here, you'd want to put a comma here and say that x is greater than or equal to 1, and less than or equal to the square root of 5. Now again, this is going to get modified because we have a quotient involved, but for right now, if I multiply this guy times this guy, this is what I'm going to come up with, and this is the domain that I want to work with. Now, let me come back up, and let me write that. So now, we have the square root of this quantity x minus 1 times this quantity 5 minus x squared. I'm not going to write any domain for right now because I'm going to need to merge them in a moment. So I'm going to put this over. I'm going to multiply these two together. So let me come down, and let me say that if I have the square root of 5 minus x squared times the square root of 5 minus x squared, well, what most people are going to do is say, well, I have the square root of the quantity 5 minus x squared, close that down, and this would be squared. And so this is equal to, by definition, the absolute value of 5 minus x squared. You have to keep in mind that when I multiply this guy times this guy, again, what's the domain? Here, x needs to be greater than or equal to negative square root of 5 and less than or equal to square root of 5, and it's the same thing for this one. So for this, you'd really have to say that, well, this is going to be non-negative. It's either going to be 0 or some positive number. So really, you can just drop the absolute value bars. So you can drop that here. And you're going to list that specifically x is greater than or equal to the negative, let me move this down. So x is greater than or equal to the negative of the square root of 5 and less than or equal to the square root of 5. And again, when you look at this stuff, now you're going to start saying, okay, I want the intersection of this one, and then also I can't divide by 0. So that brings us back to that other domain where x was greater than or equal to 1 and strictly less than the square root of 5. So let me come back up and put 5 minus x squared. And again, if you get a problem like this and you're not asked for the domain and you want to list this as your answer, if you list this as your answer, you're okay. You can get the domain. But if you list this as your answer, you've lost information through the process of rationalizing the denominator. So you want to make this crystal clear that here x needs to be greater than or equal to 1 and strictly less than the square root of 5. You can end up with something that doesn't work if you're really not paying attention to the domains here. Okay, the other part was to figure out what is f over g of 2, and that's just equal to, let's just use this one right here. So you have the square root of 2 minus 1 would be 1 over the square root of 2 squared is 4, 5 minus 4 is 1, so this would be square root of 1. So we know the square root of 1 is 1, square root of 1 is 1, so 1 over 1, which is 1. All right, for problem 10, we have f of x equals the cube root of x minus 8, and then g of x equals the cube root of 8 minus x. So sliding down here a little bit, we have f minus g of x, and this equals, we have the cube root of x minus 8, so that's coming from this guy right here, and then we're going to subtract away this guy right here, so the cube root of 8 minus x. Okay, let me just grab this, and we'll come down here to this fresh sheet of paper here. What I would do is realize that if you look at 8 minus x and x minus 8, you should be thinking about factoring here. So in other words, I'm just going to keep this one the same. So we're going to go cube root of x minus 8, and then minus, let's write this as the cube root of, the reason I say factor is, let's say I pull out a negative 1. So inside now you would have negative 8 plus x, which I could write as x minus 8. And what you're going to see is now this right here matches this right here. Remember that this right here, the cube root of negative 1, you could simplify that. So what you could do is break this up and say it's the cube root of x minus 8, and then minus, let's go the cube root of negative 1, and then times the cube root of x minus 8. Well, this, the cube root of negative 1, is negative 1. So I'm just going to say that this is the cube root. Well, actually, let me start this on another line. So this is the cube root of x minus 8. So then you have minus, and then this would be negative 1 times the cube root of x minus 8. Well, we know that this would end up being minus a negative, so you can just change this over into plus a positive. So you can just write this as plus like this, and now the cube root of x minus 8 plus the cube root of x minus 8 would be 2 times the cube root of x minus 8. Okay, let me get rid of all of this scratch work here. Bring this up here like that. Now, in terms of the domain, if we come up, this is a cube root, so you don't have to worry about the radicand being non-negative like you do with a square root. You can plug in whatever you want for x. You can plug in something that's negative, 0, positive, whatever you want here or here. So it's all real numbers for each one. So when you think about the intersection or the domain for this guy, it's just going to be all real numbers. So your domain is going to be the set of all x such that x is an element of the real numbers. or again, an interval notation from negative infinity to positive infinity. So let's find f minus g of 1. So that is 2 times the cube root of 1 minus 8. So this equals 2 times the cube root of 1 minus 8 is negative 7. Now you could pull the negative out if you want. So you could just say that this is negative 2 times the cube root of 7. Let me actually get rid of these intermediate steps here and just move this down here so we can show our answer. So again, negative 2 times the cube root of 7. All right, now what I want to do is look at f over g of x. And so this is fairly straightforward. I'm just going to take my f of x, which equals the cube root of x minus 8, put that in the numerator. So the cube root of x minus 8, this would be over my g of x, which equals the cube root of 8 minus x. So that's going in the denominator. So the cube root of 8 minus x. Okay, let's go to another page. And let me paste this in here. Now, a lot of you will see that this is going to simplify to be negative 1. But before you do that, I want you to consider the domain. Again, you always start with the intersection of the domain from f of x and g of x. So that's all real numbers. But when you have a quotient, you have to think about division by 0. So you would take this denominator, which is the cube root of 8 minus x, and say, where's that equal to 0? You could cube both sides. So let me do that real quick. And so this would undo this, and you'd have 8 minus x is equal to 0. You could then add x to both sides, and you would get x is equal to 8. So I think you can eyeball that and see if you plugged in an 8 there, 8 minus 8 would be 0. The cube root of 0 would be 0, and so you'd have division by 0, which is undefined. Everywhere else, you would actually get negative 1, and I'll show you that in a moment. But basically what you'd want to do is say that for your domain here, it's going to be the set of all x such that your x is not equal to positive 8. An interval notation, if you want to do it that way, so coming from negative infinity, going up to and excluding this 8 here, and then the union with anything that's larger than 8. So you're going out to positive infinity. Let me make this better. Okay, so now that we have that out of the way, we can simplify this. Again, we're going to end up with negative 1, but just be really careful about listing this. If your domain is not required for your question, make sure you put a comma and say that x can't be 8. And I'll show you that at the end. So let's just simplify this real quick. So I'm going to write this as the cube root of x minus 8 over, you could write this again as the cube root of negative 1 times the cube root of x minus 8. And that's just me doing some factoring like we did earlier. So then this would be equal to, this is the cube root of x minus 8 over, this is negative 1, and then times the cube root of x minus 8. And let me redo that real quick. And so when we look, this right here is going to cancel with this right here. So I'm just going to line these out like that. And basically you could put a 1 there. So it's like having 1 over negative 1, which is negative 1. Let me actually erase this scratch work here. And I'm just going to put that this is equal to negative 1. But again, you have to be very careful when you list this. So if you just put your answer, pretend like this wasn't listed here, and you just said f over g of x, and maybe the question didn't ask you for the domain, and you say, okay, this is equal to negative 1, be sure to put a comma there and list this restriction where you're going to say specifically for x that is not equal to 8. Because again, if x was 8, this would be undefined. It would not be negative 1. So you have to put that down when you're listing this. So be really, really careful. And then the other guy we were asked for was f over g of 2. And of course, as long as this is not equal to 8, this is going to be negative 1. So this is just negative 1. You can plug it in if you want and see on your own, but it's always going to be negative 1 as long as the x value is not 8. So this is what we want for the answer. All right, let's take a look at the practice test where the instructions were asked to find the difference quotient. All right, for the first problem, we're given f of x is equal to 5x minus 3. Again, we're trying to find the difference quotient. So I have that written out for us already. Again, this is f of x plus h minus f of x over h. So what I'm going to do is just come back up here and figure out what is f of x plus h first. Again, if you want to just jump right into the formula, you can, but I find this to be a little bit helpful if you're struggling. So this is equal to, again, everywhere there's an x, in this case there's just 1, you're going to plug in that x plus h. So let's say this is 5 times the quantity 5x plus h, and then minus 3. I make this 3 better here. And we're just going to distribute this into each guy. So this would be equal to 5 times x, which is just 5x, plus 5 times h, which is just 5h, and then minus 3. Let me get rid of these middle steps here. And let me just move this up. And let me copy f of x real quick. So f of x is equal to 5x minus 3. So these are the two things we need. Let me go ahead and grab this real quick. And I'm just going to come down here to where we have our formula. So basically, I'm going to say this is equal to your f of x plus h, which is this guy right here. Well, that's just going to be 5x plus 5h minus 3. So I'm just going to erase this now. You don't need it anymore. And then you're subtracting away f of x. Now you got to be real careful here. Let me move this down so it fits. You got to be real careful here because you're subtracting the whole thing away. So you're going to go minus, and you're going to open up some parentheses, and you're going to throw this in here. So the quantity 5x minus 3. When people make a mistake on this problem, this is usually where it's coming from, just not paying attention to the signs. So you want to put a minus out in front of some parentheses, and let's put this over your h. And so now you're going to distribute that negative into each guy. Again, I like to go plus -1 here to make that obvious. So this will end up being 5x plus 5h minus 3. And then you have -1 times 5x, that's -5x. And then -1 times -3, that's going to be plus 3. And this is all over h. So a lot of stuff's going to cancel here. You see that you have 5x and -5x. You see that you have -3 and +3. So what you're left with here is going to be 5h over h. And when you look at that, again, you can do some canceling. So h over h, that's going to be 1. So you end up with just 5 as your answer. All right, for problem 2, we have f of x is equal to 3x minus 7. And again, we want to find the difference quotient. So this guy right here. So we want to start with finding f of x plus h. So what is f of x plus h? Well, this is 3 times, let me make this 3 better. Again, where there's an x, you're just plugging in this x plus h. That's all you're doing. So this is the quantity x plus h here, and then minus 7. So now we're going to use our distributive property. So we're going to multiply this 3 by this x and then by h. So let's say that this is 3 times x, which is 3x. And then plus, we're going to have 3 times h, which is just 3h. And then you have minus 7. So you can get rid of this and just move this up here like that. And then, of course, I'm just going to copy f of x is equal to 3x minus 7. So let me grab these and come down here to where we have our formula. And let's just go equals. We can keep this simple. I'm just going to erase this. This is your f of x plus h. So we're going to put this out in front. So this is going to go right there. And then we're subtracting away, again, your f of x. So I'm subtracting this whole thing away. So you want to make sure you have parentheses here. Again, when people make a mistake, that's where it's coming from. So let me move this up here and let me get rid of this. We don't need this anymore. And I'm just going to close this down. So then you want to put this all over h. So we're going to distribute this negative into each term. Again, you can go plus -1 and just do it like that. I think that's the easiest way. So this is going to end up being, you have 3x plus 3h minus 7. And then -1 times 3x is -3x. You have -1 times -7, that's plus 7. This is all over h. Again, you're going to see a lot of stuff canceling here. So you have 3x and -3x. Then you have your -7 and 7. So -7 plus 7 would be 0. So that's all gone. All you're left with here is just 3h. So 3h in the numerator over h in the denominator. And the h's are going to cancel away. And so what we're left with here is just going to be 3. All right, for problem 3, we have f of x is equal to 3x squared minus 5x minus 1. So now we're getting into problems that are more tedious. Again, coming down here, I would just get the f of x plus h first. So let me come back up here. So f of x plus h. So this right here, again, everywhere you see an x, you're going to plug in the x plus h. So this is going to be 3 times the quantity x plus h squared, then minus 5 times the quantity x plus h, and then minus 1. So let me come down here a little bit. And again, what you want to do is expand this. So don't make the mistake of saying that this is x squared plus h squared. We know that we have to expand this, and we're going to say this is 3 times, so inside of parentheses, the first guy squared, so x squared, plus, you need 2 times this guy times this guy, so 2xh, 2xh, then plus the last guy squared, so h squared. So close that down, and then this right here, let's treat this as a -5 times this quantity. So I'm just going to use my distributive property and say this is -5 times x, that's minus 5x, and then you would have -5 times h, that's minus 5h, and then minus 1. Okay, let's keep going here. So we're going to distribute the 3 into each guy inside the parentheses. So let's go ahead and do that real quick. So 3 times x squared is just 3x squared. And then 3 times 2xh is going to be plus 6xh. And then 3 times h squared is going to be plus 3h squared. And then you have minus 5x minus 5h minus 1. So I realize this is long, but this is what we have here. So let me go ahead and grab this. And let me come down here. So this is going to be for the f of x plus h. So let me go ahead and paste that in and just put that right here. So now we need to subtract away f of x. So let me come back up here and I'm just going to write this out. So f of x, again, is equal to 3x squared minus 5x minus 1. So we'll grab this, come back down and paste this in. So let me get rid of this right here. We're going to be subtracting this whole thing away. So again, you want to make sure you use some parentheses. Let me see if this is going to fit or if I need a new line. It looks like it'll fit. So let me move this up like that and just wrap it in parentheses to make sure you're subtracting the whole thing away. So this whole thing is going to be over h. So let's say this equals, we'll slide down here a little bit. We have our 3x squared plus 6xh plus 3h squared minus 5x minus 5h and then minus 1. So this negative needs to be distributed to each guy. So I'm going to go plus -1 and just distribute this to each term inside of the parentheses here. So -1 times 3x squared is -3x squared. -1 times -5x is plus 5x. And then -1 times -1 is plus 1. So this right here is all over h. Well, I see that I have 3x squared and -3x squared. So those are going to cancel. Then I have -5x and 5x, so those are going to cancel. I have -1 and +1, those are going to cancel. So it looks like what I have here that's left is this, let me put equals, 6xh plus 3h squared minus 5h over h. Now you're going to notice that there's a common factor of h in the numerator. So you've got it here, you've got it here. There's just going to be one that you're going to pull out because this is squared, and then you've got it here. So what I'm going to do is I'm going to factor that out from the numerator, and that's going to allow me to cancel out that h in the denominator. So we're going to have an h out in front, and so inside you're going to have 6x plus 3h minus 5, and this is over h. And of course, this is going to cancel with this, and so now what you have is 6x plus 3h minus 5, and that's going to be your answer. All right, for problem 4, we have f of x equals x squared minus 25. Again, we have this right here. So let me start with the f of x plus h. So f of x plus h is equal to, again, I'm just going to plug in x plus h where there's an x. So this is the quantity x plus h squared, then minus 25. Again, we know we need to expand this. So we're going to say, using our formula, this is x squared plus 2 times this guy, so 2xh plus this guy squared, so that's h squared. And make this plus sign better here. And then we have our minus 25. So we can just copy this, and let me put equals here. And I'm just going to drop this in. So this is the first part. This is your f of x plus h. Now we want to subtract away, let me make this equal sign better, this f of x. So let me go up and get that. So that is x squared minus 25. I'm not going to write it down. I think we can remember that. So let me come down here. Again, you want parentheses because you need to subtract away the whole thing. So this is x squared minus 25. Close that down and then put this all over h. All right, now what I'm going to do, again, is just put plus -1 right here and distribute this into each guy inside of the parentheses. So let's say that this is equal to, you have x squared plus 2xh plus h squared minus 25, and then -1 times x squared is minus x squared, and then -1 times -25 is plus 25, and this is all over h. When we look at things, again, a lot's going to cancel. So you have x squared and -x squared, you have -25 and positive 25, and what you're left with, let's say this is equal to 2xh plus h squared over h. Again, you'll notice that you have an h here and you have an h here. Of course, this is h squared, but you have an h here as well. So you can go ahead and factor that out. So we'll say this is equal to, so we'll have h times the quantity, 2x plus h, and this would be over h. And now we can cancel this with this, and we'll say that our answer here is going to be 2x plus h. All right, for problem 5, we're given f of x is equal to x cubed plus 1. Coming down here again, we're just going to start with the f of x plus h. Let's come up here. Let's say I want f of x plus h. So this equals, again, where there's an x, you're just going to plug in this x plus h. So x plus h, this quantity is cubed, and then plus 1. So this is something you would use a formula for. Let me go ahead and grab this real quick. And let me come down here. I already have this written out for us. So we talked about this formula earlier on in the course. Some of you will remember it. For some of you, you won't remember it. But it goes like this. We have the quantity a plus b cubed. This equals a cubed plus 3a squared b plus 3ab squared plus b cubed. So basically all you're going to do is everywhere there's an a, you're going to plug in an x. And everywhere there's a b, you're going to plug in an h. Because here a is first, here x is first. Here b is second, here h is second. So you're just going to follow that formula. So let's say this is equal to, instead of a cubed, you'd have x cubed. And then plus, you'd have 3, and then for a squared, that's x squared. And then for b, that's going to be h. Then plus, you have 3. Instead of a, you're going to use x. Instead of b squared, you're going to have h squared. And then plus, instead of b cubed, you're going to have h cubed. Now you have this plus 1 here, so don't forget about that. Let's put plus 1 in a different color so that's crystal clear. I'm just going to grab this and come up here and put equals, and I'll just paste this in right here. So this is the f of x plus h part. We want to subtract away the f of x. Again, in case you forgot, f of x is equal to x cubed plus 1. So let me wrap that in some parentheses. So this is x cubed plus 1, and then we're going to put this all over h. So let me put equals here. And then I'm going to write x cubed plus 3x squared h plus 3xh squared plus h cubed plus 1. And then again, let's go plus -1 and just distribute this to each guy inside the parentheses. So -1 times x cubed is minus x cubed. And then -1 times 1 is minus 1. Okay, so this is all going to be over h. Let me make this x look a little bit better here. And so if I go through and look, you see a lot of stuff's going to cancel. So you have x cubed and negative x cubed. You're going to have this +1 and -1. So what you have here is this 3x squared h plus 3xh squared plus h cubed over h. Now, what you'll notice is that you have an h here. You have h squared here, but you have an h. And then you have h cubed here, but again, you have an h. So I can pull out an h from the numerator. And when I pull that out, I'll be able to cancel it with that h in the denominator. So let's go ahead and write this as h times the quantity. This would be, if I pull out an h, 3x squared, and then plus, if I'm pulling out an h here, well, this would be 3xh. So 3xh. And then plus, if I pull out an h from here, now this would be h squared. So this would be over h like that. So let me go ahead and cancel this h with this h. And now we're going to have the difference quotient. So here's where we'll get the answer. Let's put equals here, and we'll just say this is going to be 3x squared plus 3xh plus h squared. All right, let's take a look at problem 6. So we have f of x is equal to -2x cubed minus x minus 7. So again, when we look at our difference quotient, we know we need f of x plus h. So let's just start with that. So let's do f of x plus h. So this is equal to, again, everywhere where there's an x, so here and here, you're plugging in that x plus h. So let's go -2 times the quantity x plus h cubed, and then minus, you have the quantity x plus h, and then you have minus 7. So let's just bring this down here and paste this in. So again, we have this quantity a plus b being cubed as being equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. All you have to do is replace the a in this formula with x and the b in this formula with h. That's it. Because a is the first guy here, x is the first guy here, b is the second guy here, h is the second guy here. That's all you have to do. So let's say this is equal to, we're going to put -2 times inside of parentheses. Again, we're just going to match things up. So instead of a cubed, you're going to have x cubed. Then plus, you're going to have your 3. And then instead of a squared, you'd have x squared. Instead of b, you'd have h. Then plus, you can have 3. Instead of a, you're going to have x. instead of b squared, you're going to have h squared. And then plus, for your b cubed, again, that's going to be h cubed. Close that down. And then you might as well distribute this negative in now. So let's go plus -1 and just distribute that in. So this would be minus x and then minus h, and then you'd have minus 7. Okay, so let's say this equals, this is going to be distributed to each guy. So all of these guys, all 4 of these terms inside of the parentheses. So -2 times x cubed is -2x cubed. Let me make this 3 better here. Then you're going to have -2 times 3x squared h. That is -6x squared h. Then -2 times 3xh squared would be -6xh squared. Then -2 times h cubed would be -2h cubed. Then you have your minus x, minus h, and then minus 7. Okay, let me go ahead and grab this, and let's come down here, and let's just paste this in. So this is going to be for the f of x plus h. So we want to subtract away this f of x. Again, you want to do this inside of parentheses. Let me go back up and grab this. I'm going to write it real small so we can fit it. So -2x cubed, and then minus x, and then minus 7. Let me make this 7 better here. Come down here and paste this in, and let me put that right there, and then close that down. So this would all be over h. So what I would do here first is go plus, again, -1, distribute that into each guy inside. So you got 3 terms there. So essentially, let's say this is equal to -2x cubed minus 6x squared h minus 6xh squared minus 2h cubed minus x minus h minus 7. Let's make that h better there. And then -1 times -2x cubed is plus 2x cubed. -1 times -x is plus x. -1 times -7 is plus 7. Then this would all be over h. Now let me see what we can cancel here. So looking through, we see that we have -2x cubed and we have 2x cubed. We see we have -x and plus x. We have -7 and plus 7. So what do we have left? We have this right here, and then we have this right here, so don't miss that. And what we're going to do is just factor out an h. I should probably rewrite it first so it's more clear. So let me write this is equal to -6x squared h minus 6xh squared minus 2h cubed, and then minus h. So this would all be over h. Again, you have an h everywhere. So here, this is h squared, this is h cubed, this is h. So we're going to pull that out, and then we're going to cancel with that h in the denominator. Let me slide down here and say this is equal to, pull out the h. Inside you have -6x squared minus 6xh minus 2h squared, and then minus 1. Again, because I'm pulling out an h, make sure you put a 1 there. If you need clarity, you can always go times 1 there, just so that's easy to understand. So this would all be over your h there. And again, this would cancel. So now that's going to leave me with my difference quotient. So this is what I'm looking for. So -6x squared minus 6xh minus 2h squared minus 1. Let me fix this x here, and this is going to be our answer. All right, for problem 7, we're given f of x is equal to 7 over x minus 1. So once again, we want to find this f of x plus h first to get things started. So let me write out f of x plus h here. So this equals, we have 7 over. In the place of x, you just want x plus h, that's all it is, then minus 1. Let's say this equals, so I'm going to just paste that in like this. Hopefully you can remember that f of x was just 7 over x minus 1. Again, if you can't, we just come back up here. F of x again is just going to be 7 over x minus 1. So I'm just going to put minus, you have 7 over x minus 1. Then this whole thing is over h. Now, this is a complex fraction. There's lots of ways to work with it. What I would recommend is just multiplying the numerator and denominator of the complex fraction by the LCD. So the LCD here, if you look, you have a denominator of x plus h minus 1 and a denominator of x minus 1. So it's just the product of those two. So let me put times here, and I'm just going to wrap this for clarity, just so it's clear what's going on. So this is times, you're going to have this quantity x plus h minus 1 times the quantity x minus 1 over, again, the quantity x plus h minus 1 times the quantity x minus 1. So again, this by definition is going to be 1. It's just a complex version of that. And so I'm multiplying the numerator of the complex fraction by this and the denominator of the complex fraction by this in order to simplify. And let's put equals. So this is going to get multiplied by this. Let me write it all out, and then I'll cancel some things and make it a little bit shorter. So 7 over x plus h minus 1. Let me wrap that. And I'm just going to say this is times the quantity x plus h minus 1 times the quantity x minus 1. So what's going to happen is this is going to cancel with this, and you're left with 7 times this quantity x minus 1. So let's just do that as 7 times the quantity x minus 1. And you can distribute that now, or you can wait. I'm just going to wait. I'm going to leave it in that form for right now. Then you would have minus. You have this 7 over x minus 1. Again, let me wrap this times. You have this quantity x plus h minus 1 times this quantity x minus 1. So now this is going to cancel with this, and you're going to have this 7 times this quantity. So let me get rid of this. And again, I'll distribute this later. Let me move this up here like this. And this will be over. Now you're going to have h times this right here. Now, I would not distribute this. When you look at these problems, you realize that your goal is to cancel the h in the denominator. So just leave it out in front. So I'm just going to say this is h times this quantity x plus h minus 1 times this quantity x minus 1. So that's all you need to do. So let me slide down here a little bit, and let's just simplify. So I'm going to distribute the 7 into each term inside the parentheses. So you'd have 7 times x, which is 7x, and then minus 7 times 1, which is 7. And then you're subtracting this whole thing away, so be very careful. I would put some brackets here to make that crystal clear, just so you don't make a sign mistake. So let's put minus. You're going to distribute this into each guy inside the parentheses. Let me put my brackets there. And so 7 times x is 7x. Then you have plus. 7 times h is 7h. And then you have minus. 7 times 1 is 7. Now let's close that down. And again, this needs to be distributed to each guy, so you can go plus -1 here, just to make that crystal clear in terms of what's going on. You're just going to change the sign of everything. So we can do this right now. We don't need another line. So let's just go ahead and say that this is going to end up being a negative, this will be a negative, and this will be a positive. So let's get rid of all of this. Just change the signs of everything. So again, this is going to be a negative, this is a negative, and this is a positive. So let's put this over. We have our h times the quantity, x plus h minus 1. Let's make that a little bit better there. And then times the quantity x minus 1. Let's slide down here a little bit, and let's look at what we can cancel. So you have 7x and -7x. You have -7 and 7. So what you have left is this -7h. So what you're trying to do is get rid of that h from the denominator. So what you're going to say is this is equal to -7h over h times the quantity x plus h minus 1 times the quantity x minus 1. Let me make this better here. And I'm just going to cancel this with this. And so now we're going to have our final answer here. So we're just going to end up with -7 over, you have this quantity x plus h minus 1 times the quantity x minus 1. And I would just leave it like that. So this is the difference quotient. All right, for problem 8, we have f of x is equal to 4x over x minus 5. And again, we're trying to figure out this difference quotient here. So let's start with f of x plus h. So let me slide down here. So if we want f of x plus h, this would be equal to, well, you're going to have an x here and also here. So you're going to say this is 4 times the quantity x plus h over, you're going to have x plus h minus 5. So this I would distribute in. So you'd have 4 times x, which is 4x, plus 4 times h, which is 4h. So this is 4x plus 4h. So 4x plus 4h. Let me go ahead and grab this. Let's come down here and paste this in right there. Then we're going to subtract away. Again, f of x, if we come back up, is 4x over x minus 5. So we want 4x over x minus 5. Again, this whole thing is going to be over h. So what you're going to do, just like in the last example, you're going to look at the denominator here, and you're going to look at the denominator here. And again, you're going to multiply the numerator and denominator of this complex fraction by the least common denominator, which is the product of these two denominators. So for clarity, let me just go ahead and wrap this, and we're going to multiply by the quantity x plus h minus 5 times the quantity x minus 5. So we're going to do that to the numerator and the denominator. me make these better here. Let me slide down here a little bit, and let's see what we have. Again, I'm just going to take this piece by piece. So this equals, I'm just going to write this out. So 4x plus 4h over, you have x plus h minus 5. So this is times, you have this quantity, x plus h minus 5, times the quantity, x minus 5. So this right here is going to cancel with this right here. So what you're left with is the quantity 4x plus 4h times the quantity x minus 5. So we will do that later. Don't worry about it for right now. Let's just slide this over here like that. And again, don't worry about it for right now. So then we're going to go minus. We're going to have this multiplied by this. So you have your 4x over x minus 5. Again, multiplied by this, so times your quantity x plus h minus 5 times your quantity x minus 5. Let me wrap this for clarity, and we're going to cancel this with this. And so now you have 4x times this quantity here. Again, we're not going to do that just yet. I'll leave it for a moment. So let me move this over here like that. And then let me put this all over. Now you have h times this. So h times the quantity, x plus h minus 5 times the quantity x minus 5. Okay, let's go through and do some distributing here. So let's start with the 4x times x, that's 4x squared. Then we're going to do 4x times negative 5, that's minus 20x. Then 4h times x, that's plus 4xh. And then 4h times negative 5, that's going to be minus 20h. Then again, you're subtracting this whole thing away. You can put brackets there to make that crystal clear. Let's go minus. We'll put our brackets in here. 4x times x is 4x squared. And then we have plus 4x times h, that's 4xh. And then we have minus 4x times 5, that's going to be 20x. So again, if you're removing this, just change the sign of everything. So I'm going to drop this. And so this is a minus, this is a minus, and this is going to be a plus. Don't forget to do that, otherwise you will get the wrong answer. So let me go ahead and move this down here, and let's put this over. We have h times a quantity, x plus h minus 5 times the quantity x minus 5. Okay, so looking through what we have here, you have 4x squared and negative 4x squared. You have negative 20x and 20x. Then we can also cancel this 4xh with negative 4xh. And what we're going to be left with is just going to be this negative 20h over h times the quantity, x plus h minus 5 times the quantity x minus 5. Let me extend this a little bit. So you'll notice that this h would cancel with this h, and sliding down here, now we're going to have our difference quotient. So let's say this is negative 20 over, you have the quantity x plus h minus 5 times the quantity x minus 5. All right, for problem 9, we have f of x is equal to the square root of x minus 4. Again, coming down here, looking at the difference quotient, we know we need this f of x plus h, so let's start with that. So going back up, what is f of x plus h here? Again, where there's an x, you're just going to plug in x plus h. So this is the square root of x plus h, and then you have minus 4. So let's just grab this. We can remember that f of x equals the square root of x minus 4. No need to come back here, so let's go equals. I'm just going to paste this in. So again, this is the f of x plus h. And then minus for f of x, it's just the square root of your x minus 4. So this would all be over h. Now, with this particular problem, you have to take an additional step and rationalize the numerator because you want to get rid of h from the denominator. So I talked about this in the lesson. So basically, you just want to remember, if you have something like, let's say, a plus b, so this quantity, times the quantity a minus b, this equals a squared minus b squared. So this is something we learned very early on in the course. This is multiplying conjugates, and that's the formula. So basically, you're going to treat this as though you have this a minus b here. So this is your a, and this is your b. What you'd want to do is multiply by, you're going to keep this the same and this the same, you're just changing the sign. So you want the square root of your x plus h, and then minus 4. And then instead of a minus, again, you want a plus, and then you want the square root of x minus 4. Let me get rid of this. We don't need it anymore. This would be over, again, to make this legal, you would say the square root of x plus h minus 4, and then plus the square root of x minus 4. You can just use your formula. You can use FOIL too if you want. Let me wrap this stuff so this is crystal clear what's going on. But you can go through and use FOIL. Just realize that when you do the outer and the inner, that's going to cancel away. So all you really have to do here is take this first guy and square it. So we're just going to say that's x plus h minus 4. Then we're going to go minus. So here's where you have to be really, really careful. You're subtracting away this guy being squared. So that's going to give me this x minus 4. Again, I've got to subtract the whole thing away. That's why I'm putting a minus in front of these parentheses. Again, I can distribute this now. Just get it out of the way and go plus -1 here and distribute this in. Usually when someone makes a mistake, it's because they forget to wrap that in parentheses, so they make a sign mistake. So make sure you do that. So this becomes -x plus 4. So let me write minus x plus 4, and this is all over. Again, my goal is to get rid of the h in the denominator, so don't distribute it in. Just write h times the quantity, the square root of x plus h minus 4, and then plus the square root of x minus 4. Close that down like that. Let me extend this a little bit. And then all we're going to do at this point to finish this up is look at this canceling with this. So x minus x is 0. And then you have -4 plus 4. So that's gone. And so you just have this h right here that's going to cancel with this h right here. So let's put equals here. And I'll just come down here and say that this is going to be h over. We have the h times the quantity, the square root of x plus h minus 4. And then plus the square root of x minus 4. Make that a little bit longer there. And then let me close this down. Okay, so this h is now going to cancel with this h. And I'm going to put a 1 up here. And so let's say this is equal to, so this will be our difference quotient here. So this will be 1 over, we have the square root of x plus h minus 4, and then plus the square root of x minus 4. So that's going to be our answer. All right, for problem 10, we have f of x is equal to the square root of 7 minus x squared. Again, just to start off, we have our difference quotient here, and we know we're going to need f of x plus h. So let's put our f of x plus h here, and this would be equal to the square root of 7 minus, in the place of x, you want to plug in the x plus h. So we want x plus h as a quantity here, and this is going to be squared. So be really, really careful here because you are subtracting this guy away. So if you're going to simplify, keep that in mind. For right now, I'm just going to leave this as it is. We're going to end up simplifying it later. I'm just going to copy this real quick. I just want you to remember that your f of x is equal to the square root of 7 minus x squared, just so we don't have to come back up. And so we'll come down here and say this is equal to, I'm just going to paste this in. So this is for my f of x plus h. And then minus, again, for the f of x, we just said that's the square root of 7 minus x squared. And this would all be over this h right here. So again, with this type of problem, just like we saw in the last problem and also in the lesson, we know we want to rationalize the numerator because we want to get rid of this h in the denominator. So we're going to multiply here by the square root of 7 minus the quantity x plus h squared. And then what's going to happen is this sign is going to change. Instead of a minus, you want a plus, and then you want this guy right here. So you have the square root of 7 minus x squared. And this would all be over. Again, you're just going to copy this. So you want the square root of 7 minus, again, the quantity x plus h squared, and then plus the square root of 7 minus x squared. So all I'm really doing here is multiplying by a complex form of 1. So I'm not really changing anything. I'm just going to change the way it looks. And this is going to allow me to eliminate h. Again, for the formula here, just like we talked about in the last example, this is really just a plus b times a minus b. So this quantity times this quantity, this gives you a squared minus b squared. So this is again known as multiplying conjugates. So here, this would be your a. So this one and this one, those are going to match. This is your b. So this one and this one, those are going to match. And notice that the sign here and the sign here, those are different. So when you go through and you crank this out, all you're going to do, again, you don't have to use FOIL here because the outer and the inner, those are going to cancel. So really all you have to do is just take this guy right here and square it. So that's just going to give you the radicand. So we're going to write 7 minus the quantity x plus h squared. Then here's where you have to be very careful. It's very easy to make a sign mistake. You are going to subtract away this guy times this guy. So in other words, I'm just going to square this, and I'm going to get my radicand. So I'm going to put some parentheses there because I want the whole thing subtracted away. So 7 minus x squared. Close that down. Then this would be over. I'm going to have h times the quantity. So this guy's going to go in there. So you have your square root of 7 minus the quantity x plus h squared. And then we'll have plus our square root of 7 minus x squared. Let me make this a little bit longer. Let me close this down like that. Okay, so now this is where I would simplify this right here. Again, down here, you're not going to have to worry about it. I would just leave it in that form. So let's say this is equal to, this is 7 minus this guy right here. I would use some brackets or parentheses, whatever you want. Let's just use brackets. So if you expand this, again, it's x squared, and then plus 2 times x times h, and then plus h being squared. So close that down. And then this minus has to be distributed. Again, you can go plus -1 like that and just distribute it to each guy. Let me make this better here so it looks a little bit cleaner. And so this would give me -1 times 7 is -7. And then -1 times -x squared, that's going to be plus x squared. So you can do the same thing here and go plus -1 and then distribute that to each guy inside, just like that. Let me put this all over your h times the quantity, the square root of 7 minus the quantity x plus h squared, and then plus the square root of 7 minus x squared. And let me close that down. So I'm going to write this result here on another line. Let me come down here. And so this would be 7, and then again, this -1's multiplying by each guy. So -1 times x squared is -x squared. -1 times 2xh is minus 2xh. And then -1 times h squared, that's minus h squared. And then you have -7 and then plus x squared. So all over this h times the quantity, you have the square root of 7 minus the quantity x plus h squared. And let me make that a little bit longer. And then plus, you have your square root of 7 minus x squared. And let me close that down. So in the numerator, you can have a lot of stuff cancel. So you have this 7 and then -7. You have -x squared and x squared. And what you're going to be left with is this -2xh minus h squared. Now notice you can factor out an h from that. I'm just going to do that now just to speed this up just a little bit. So let me pull out an h. And inside you'd have -2x. So -2x. Let me just highlight the h here. And I know this is h squared, but let me just highlight the h there. So this is clear what I'm doing. Just pulling out an h. And then basically you'd have minus, you still have an h left there. Close that down. This would be over. Again, you have your h times the quantity. This is the square root of 7 minus the quantity x plus h squared. And then you have plus the square root of 7 minus x squared. Let me just make this longer like that. And let me close that down. Okay, at this point, now you can cancel this h with this h. And we're ready to present our answer. So I'll go ahead and say this is -2x minus h over, I'm going to say this is the square root of 7 minus the quantity x plus h squared. So you could simplify that if you want. I would just leave it as it is. Then I'd say plus, this is the square root of 7 minus x squared. So that's going to be our difference quotient. All right, let's take a look at the practice test. For the instructions, we're asked to find f of g of x, f of g of 2, and f of g of x plus 1. All right, for problem 1, we have f of x is equal to 2x minus 1, and then g of x is equal to 5x plus 1. So for the first part, we were asked for f of g of x. So all that means is that we're going to take this g of x here, so that is 5x plus 1, and we're going to plug it in for x in f of x. So here again, this is going to be 2x minus 1, so that's going to get plugged in right there. In other words, this right here is going to go right there. So we're going to have 2 times the quantity. Again, this gets plugged in for x, so 5x plus 1, close that down, and then you have this minus 1. So that's all it is. So for this one, remember we have to distribute. So this would get distributed here and then also here. So let's say this is equal to 2 times 5x is going to be 10x. And then 2 times 1 is just 2. So plus 2 and then minus 1. And so this is equal to, let's just write 10x here. And then 2 minus 1 is just 1. So plus 1. So your f of g of x is going to be 10x plus 1. So I'll move this up here like this. We were also asked to find f of g of 2. So all we're going to do is we're going to take our f of g of x and we're going to plug in a 2 for x. That's all it is. So this equals, again, where there's an x, you're just going to plug in a 2. So we're going to say this is 10 times 2 and then plus 1. So this equals 10 times 2 is 20. 20 plus 1 is 21. So this would be 20 plus 1, which equals 21. Again, you can get rid of those middle steps if you want and just put this as 21. Now the last one was to find the f of g of x plus 1. So again, all I'm going to do is look at my f of g of x, and where there's an x, so right there, I'm just going to plug in x plus 1. You have to be really careful because when you're plugging in there, that 10 is multiplied by that x, so 10 now needs to multiply by the quantity x plus 1, so just like that. So we have a little bit of additional work here. We want to distribute the 10 into each guy. Let's go ahead and say this is equal to, so we'll put this as 10 times x, which is 10x, and then plus 10 times 1, which is 10, and then we have plus 1, which is going to be equal to 10x plus 10 plus 1 is 11. So your f of g of x plus 1 is going to end up being this 10x plus 11. So let me put that up there like that. So there are your 3 different answers. So f of g of x is equal to 10x plus 1, f of g of 2 is equal to 21, and then f of g of x plus 1 is equal to 10x plus 11. All right, now we're going to change up the instructions. We want to find g of f of x, g of f of negative 3, and g of f of a minus 1. So for problem 2, we have f of x is equal to 2x squared minus 5, and then g of x is equal to x over 7. So let's start out with our g of f of x. So all we're going to do here is take this function f of x, again, this is equal to 2x squared minus 5. So this guy right here is going to get plugged in for x in my g of x function. So this x over 7. So I'm going to take this right here and just plug it in for x right there. That's all we're doing. So we're going to say this equals, up top here, plug this in. So you can have your 2x squared minus 5, and then this is over 7. And that's all it is. Now the other one, we were asked to find g of f of negative 3. So all you have to do here is plug in a negative 3 right there for x and simplify. So let's go ahead and say that this is equal to, we're going to have 2, and then put this inside of parentheses. So we're going to have negative 3 here being squared, and then minus 5, and this is all over 7. Just simplifying here, we have negative 3 squared. Again, this is wrapped, so that's going to be positive 9. So you would have 2 times 9, and then minus 5, and this is over 7. So this would be equal to, 2 times 9 is 18, and then you have minus 5 up here, and then over 7. And then lastly, this equals, you do 18 minus 5 in the numerator, that's going to be 13, and then you're going to put this over 7. So 13 over 7 is going to be the answer. So let me just rewrite this here. So 13 over 7. Okay, the last one we wanted to find was g of f of this a minus 1. Again, all you're doing is you're taking a minus 1 and plugging it in for x there. So a real simple concept, but this one's easy to make a mistake on just because of the simplification that's required. So I'm going to put a 2. You could open up some parentheses or brackets or whatever you want. I'm just going to use brackets. And then for this guy right here, the x, again, it's this quantity a minus 1 that's being squared. So remember, you have to expand this. So that's very important. Then we have minus 5, and this is all over 7. Let me slide down here. It's going to take a little bit of time to simplify. I'm going to start with this right here. So what is this a minus 1, this quantity squared? Remember, we have our formula for that. So that's going to be a squared, so the first guy squared, and then minus, you have 2 times a times 1, so that's just 2a, and then plus this last guy 1 squared, so plus 1. So let me write 2 times, and you can keep brackets there, or you can use parentheses, it doesn't matter. You just need to make sure that you're distributing the 2 to each guy inside the parentheses. Then we have minus 5, and this is all over 7. So this would be equal to, let me show this as being distributed to each guy, so that's crystal clear. You're going to have 2 times a squared, which is 2a squared, and then minus 2 times 2a, that's 4a, and then you have plus 2 times 1, which is 2, and then you just have this minus 5 here, so let me write minus 5, and this is all over 7. Okay, let's put equals here, and I can simplify a little bit, so we're going to have this 2a squared, nothing I can do with that. You have minus 4a, nothing I can do with that. But then you have 2 minus 5, so that's negative 3, and this is all over 7. All right, so just coming back here to go over everything again, the g of f of x is equal to 2x squared minus 5 over 7. I can get rid of this highlighting. We don't need it anymore. G of f of negative 3, that's going to be equal to 13 over 7. And then g of f of this a minus 1 is going to be 2a squared minus 4a minus 3 all over 7. All right, now we're going to change the instructions again. We want to find f of g of x and f of g of x squared. So for problem 3, we have f of x is equal to x squared minus 7x minus 3, and then g of x is equal to 2x over 3. All right, so let's start with, again, f of g of x. And so, again, all I'm doing is I'm taking this right here. So g of x is equal to this 2x over 3, and I'm going to plug it in everywhere there's an x in this f of x. So right here, and then also right here. That's all it is. So let's go ahead and say that this is going to be, for x squared, now you're going to have this 2x over 3 being squared. And then minus, you have 7. And then again, for x, you're plugging in this 2x over 3. So let's go 2x over 3 like that. And then we're going to have minus 3. So let's put minus 3. Let me slide all the way down so I have enough room to simplify. So we're going to square the numerator. So this is 2x like this squared over the denominator squared. So that's 3 squared. And if we do that, 2 being squared is 4, and x squared is just x squared. So this is 4x squared. 4x squared. 3 squared is obviously 9. And then we have minus. Here I would just multiply 7 by 2x. That's 14x. And this is over 3. And then you have minus 3. Now, you could leave it like this, but I like to get a common denominator. This is optional. So if you want to do that, let me move this down a little bit. What you would do is say, I'm going to multiply this by 3 over 3 and multiply this by 9 over 9. And so that's going to give you 4x squared minus 14x times 3 is 42x. And then minus 3 times 9 is 27. This would all be over the common denominator of 9. Okay, let me get rid of these middle steps here. And I'm just going to move this up here like this. Now, we were also asked for f of g of x squared. So all you're going to do is, again, where there's an x, plug in x squared. So I'm going to say that this is 4. And then right here where there's an x, I'm going to plug in an x squared. And this is going to be squared. Then minus 42. Again, where there's an x, plug in x squared. And then you have minus 27. This is all over 9. Well, really, for this one, you could just drop the parentheses. I just put them in there for clarity. And then for this one, I put the parentheses there to show you that you need to use your power to power rule. This is x squared squared, which is x to the 4th power, right? The base here, x stays the same. You multiply the exponents, 2 times 2 is 4. So this would be 4x to the 4th power. Let me tighten that down a little bit. And then you have minus 42x squared minus 27 over 9. So once again, your f of g of x, you'd have this 4x squared minus 42x minus 27. So all of this over 9. And then your f of g of x squared, this would be equal to 4x to the 4th power minus 42x squared minus 27, all of this over 9. All right, for problem 4, we have f of x is equal to x cubed minus 2x, and then g of x is equal to x minus 2. So the same thing here, we just want to find f of g of x, and so this would be equal to, well, I'm just going to take this right here, my x minus 2, that's my g of x, and plug it in right here and also right here. So for each x in this function f of x. So this first part is going to be a little bit tedious to simplify. So you have x minus 2. This is quantity cubed. And then minus 2 times the quantity x minus 2. So let me slide all the way down for this one. I'm hoping that you remember the formula. Again, if you have something like, let's say, a minus b, quantity cubed, this is equal to the first guy, which is a cubed, and then minus, you're going to have 3a squared b. And then you can have plus, you're going to have 3, and then ab squared, and then minus, you're going to have b cubed. Okay, so following this, really everywhere there's an a for this formula I wrote out, you're just going to put in an x, and everywhere there's a b, you're going to put in a 2. So this would be equal to, and again, I'm just working on this first part, forget about this for right now. This is going to be, instead of a cubed, you would have x cubed, and then you have minus, you can have 3, instead of a squared, it's x squared. Instead of b, you're going to have 2. So let me put times 2. And of course, you can just do that now. So 3 times 2 would be 6. So let me put that right there. And then you're going to have plus 3. And then you have your a, which is x. And b squared would be 2 squared. So times 4. And 3 times 4 is going to be 12. So let me put that in there like that. And then lastly, you have minus your b cubed. And here b is 2. 2 cubed is 8. Okay, so now we're going to deal with this part. You can get rid of this if you want. Don't need it anymore. We're going to put plus and then negative 2 like that. and then just distribute that to each guy inside the parentheses. So negative 2 times x is minus 2x, and then negative 2 times negative 2 is plus 4. So anything we can simplify, yeah, we have this 12x and negative 2x, so we can combine those. And then you have negative 8 and plus 4, so those can be combined. So let's start by just writing our x cubed, and then minus 6x squared, and then 12x minus 2x, that's going to be plus 10x, and then negative 8 plus 4, that's going to be negative 4. Okay, let me get rid of all these middle steps here. So now we want to find our f of g of x squared. Let me make this g a little bit better here. So this equals, again, everywhere there's an x, you're just plugging in x squared. So let's go x squared. This would be cubed, and then minus 6 times. Again, in the place of x, you want x squared, and then this would be squared, and then plus 10 times. Again, you could just put parentheses here, so I'm plugging in x squared for the x there, and then minus 4. Again, the parentheses here, they don't really change anything. I'm just going to erase them. I'm just putting it there for clarity. So this x squared squared, we know that x stays the same, multiply the exponents. So that is x to the 4th power there. And then here, x squared cubed, that is x to the 6th power. Again, x stays the same, multiply exponents, 2 times 3 is 6. So once again, the f of g of x is equal to x cubed minus 6x squared plus 10x minus 4. And then f of g of x squared is equal to x to the 6th power minus 6x to the 4th power plus 10x squared minus 4. All right, let's change things up again. So now for the instructions, we want to find f of g of x, g of f of x, and state the domain for each. All right, for problem 5, we have f of x equals x squared, and then g of x equals the square root of x minus 1. So let me first start by just saying we're going to figure out what is f of g of x, and then we'll talk about the domain. So this right here is, again, your g of x. So this is going to get plugged in right there. That's all we're doing. We'll have the square root of x minus 1, again, getting plugged in for x right there, and then that's going to be squared. And make this a little bit better here. So this would undo this, and you just have the radicand. So we're going to say that this is equal to x minus 1. So now, once we have that, let's figure out what is the domain. When you think about the domain of a composite function, you want to think about, well, what is the domain of the inside function? So in other words, what is the domain for g of x? And then what is the domain for f of g of x, the composite function that we come up with? So once you simplify that, and then you want the intersection of those two. So if I look at the domain for this, so what is the domain here? Well, I see that I have x minus 1 as the radicand. And again, in the real number system, we can't take the square root of a negative. So you want to say that x minus 1 needs to be greater than or equal to 0, or non-negative. Just add 1 to each side of the inequality. So you're going to get that x needs to be greater than or equal to 1. So when we write the domain for g of x, we'll say that it's the set of all x such that x is greater than or equal to 1. Now, when I think about this f of g of x, if I look at it, I just have x minus 1. So just looking at this as it is, the domain is all real numbers. But again, it's going to be the intersection of this domain and this domain. So when I get that, it's just going to be this one right here. So the domain for the f of g of x, which equals, again, x minus 1, let me slide down here a little bit. I'm just going to use this domain and say that the domain would be the set of all x such that x is greater than or equal to 1. And let me just paste this here. I'm not going to come back to it, but I'll just put it here if you want to stop and write it down for your notes. That's the answer for the first part. Okay, for the second part, what we want is g of f of x. So this one is, I'm taking this right here, so this x squared, which is my f of x, and I'm going to plug it in right there, so for x in the g of x. So this is going to go right there. So I would have the square root of x squared minus 1. And make that a little bit better, like that. And so again, when I think about the domain of the inside function, so now the inside function is f of x, well, that's going to be all real numbers. So the domain here is going to be, you could say the set of all x such that, let's just write x as an element of the real numbers. I'm just going to use a regular r. I know there's a fancy r in the textbook, but that right there is just for the real numbers. So then this right here, when I look at g of f of x, well, now I need this radicand to be non-negative. So that is a little bit of work because you have to solve a quadratic inequality. So you want to solve x squared minus 1 is greater than or equal to 0. Let me grab that real quick. And let me come down here and paste this in. So for this one, you want to find the critical values. So you say x squared. Let's go ahead and say minus 1 equals 0. You can add 1 to each side of the equation there. And so you get x squared is equal to 1. Well, by the square root property, you can solve that and say that x is equal to plus or minus the square root of 1, which is 1. So that means I'm going to have -1 as a critical value and +1 as a critical value. And both of those would work because we have this greater than or equal to here. But let's just test to see where else it's going to work. So we're going to say A, that region is anything that's less than -1. We'll say B is going to be between -1 and 1, and we'll say C is anything greater than 1. So pick anything in region A. Let's just pick -2. If you pick -2 and plug it in, you'd have -2 squared minus 1. Is this greater than or equal to 0? Yeah, -2, again, this is wrapped. So -2 squared is 4, then minus 1. This is that greater than or equal to 0, so this is 3 is greater than or equal to 0. So this is a true statement. So that means that things in region A would work. Let me put a T for true. If you want to try things in region C, you can just use +2. So get rid of the negative sign there. You're going to get the same thing. So that would work as well. So let me put a T for true here. If you look in region B, you could pick something like 0. You're going to see that doesn't work. So 0 squared is 0. So then 0 minus 1 would be -1. You get -1 is greater than or equal to 0. So this is a false statement. So things in B do not work. So I'm going to put an F there for false. So if you want the solution for this inequality here, you would say that x is less than or equal to -1, or x is greater than or equal to 1. So let me grab this and let me come down here and paste this in. So basically for the domain here, let me write out the domain. We would say it's the set of all x such that x is less than or equal to -1, or x is greater than or equal to 1. You could put a comma here. You don't have to put the keyword or. You can if you want. Let me move that down. I think that's a little bit better. And then basically this is going to be the domain here because, again, it's the intersection of the domain from this guy, the inside function, where you have f of x equals x squared. The domain is just all real numbers. And then this guy right here, where the domain is the set of all x such that x is less than or equal to -1, or x is greater than or equal to 1. So the intersection will be this one right here. So this is the domain for this problem. All right, let's take a look at problem 6 now. So we have f of x equals 1 over x plus 2. And then g of x equals 3 over x minus 1. So this one is going to be a little bit tricky to fit on the screen. Let me maybe do it over here. So f of g of x, this would be equal to, you're going to take, again, this is your g of x. You're going to plug that in right there for x in your f of x. So all of this is going right there. This is a little bit tricky. So let's go 1 over, so you have 3 over x minus 1, and then you have plus 2. So let me grab this real quick. I'm just going to go to another page because there's no way we're going to fit this here. I'll just come right here where it's nice and easy to fit everything, and I'll move this over here. And then basically you can just simplify this. So I'll say this is equal to, I'm going to go ahead and say that I'm going to multiply, actually let me remove this. I'm going to multiply this top and bottom by x minus 1. So the reason this is legal is because when you look at the domain of the inside function, so your g of x, this right here, this 3 over x minus 1, the domain is where you have any x that's not 1. You can see that if you put a 1 right here, so in other words, if you plugged in a 1 there and a 1 there, well, 1 minus 1 is 0. So you'd have 0 over 0, which is undefined. So as long as x is not 1, this is okay to do. And we're going to be removing 1 from the domain in a moment when we look at that. So just keep that in mind. So I'm just going to go ahead and multiply this by this, and this would get multiplied by this, and then by this. So this would be equal to 1 times anything is itself. So this is just x minus 1, and this is over. Here you're going to have, let me write this out. So x minus 1 times you have 3 over x minus 1. Let me extend this like that. And then plus you're going to have this 2 times the quantity x minus 1. Okay, so this right here is going to cancel with this right here. And then this needs to be distributed. So let's see what we end up with here. We're going to get x minus 1 over, you're going to have 3 plus 2 times x is 2x, and then 2 times -1 is minus 2. You could just say 3 minus 2 is going to be 1. So this right here, let's write the denominator as 2x plus 1. Okay, so let me write this more neatly. I'm just going to get rid of all this. So we have f of g of x is equal to x minus 1 over 2x plus 1. Now again, for the domain, let me write for the domain. Let me start with the domain for g of x. Let me go back up. So for this one right here, again, like we were just talking about, the domain, you don't want to divide by 0. So you have x minus 1. Of course, it's a very simple thing you could do in your head. But x minus 1 equals 0. Add 1 to each side. This cancels. You get x is equal to 1. So that means we can have any value for x, any real number other than 1. So we would say it's the set of all x such that x is not equal to 1. Okay, for the domain for the other guy, let me just come down here. If you look at it, now you can't have this be 0. So you would have 2x plus 1 is equal to 0. subtract 1 away from each side, this cancels. You get 2x is equal to -1, divide both sides by 2, this cancels, and you get x equals -1/2. So both of those have to be restricted, so x cannot be 1, and then x cannot be -1/2. So let me put that the domain for this guy, we're going to say the set of all x such that x is not equal to, we don't want +1, and then we don't want -1/2. So those have to be excluded from the domain. Okay, the other scenario is going to be g of f of x. So this equals, again, I'm just going to take this right here. So this would be the inside function now. This is the f of x. And I'm going to plug it in right there. So this right here is going to go right there. That's it. So we're going to have 3 over. In the place of x, we have 1 over x plus 2. And then we have our -1. And let me come down here to this fresh sheet of paper. Let me get rid of that. Again, we're going to find out in a moment that x can't be -2 because that's going to give me a 0 denominator in that inside function, my f of x. We'll deal with that in a moment. For right now, I'm just going to simplify this by multiplying by x plus 2 over x plus 2. Again, as long as x is not -2, we're okay, and that will be restricted in a moment. So going through, this 3 needs to multiply by this quantity. So you can have 3 times the quantity x plus 2 over, this needs to be multiplied by this, and then also this. So x plus 2, let me write this out. So let me go 1 over x plus 2, and then times x plus 2. And let me wrap this stuff so that's clear. And then you have -1 times this quantity x plus 2. Okay, let's see what we have here. We need to do a lot of distributing. So this is going to go in here and then there. So 3 times x is 3x, and then plus 3 times 2 is 6. This is over. This cancels with this, and you just have 1. And then this -1 would multiply by each guy. -1 times x is -x. And then -1 times 2 is -2. So at the end of the day, we end up with 3x plus 6 over, we have -x, and then 1 minus 2, that's going to be -1. Now, what I ended up doing for the answer for this, I ended up factoring the 3 out in the numerator. This is optional. You don't have to do it, but it makes it look a little bit cleaner. So let's say this is 3 times the quantity x plus 2 over. I factored out the negative. So let's go, this is -1 times the quantity x plus 1. And then you can move this up legally and say you put the negative out here, and then you can drop these parentheses. And so this is a cleaner version of this. Again, if you want to answer this way, it's not wrong. This is just a little bit cleaner. Okay, let me erase everything. And let me just move this up here. And for the domain, again, first I want to start with the inside function, so f of x. And when I look at this, again, I'm thinking about division by 0. So you have x plus 2. Again, if you set that equal to 0 and solve, you subtract 2 away from each side, you get x is equal to -2. So we know here we need to restrict -2 from the domain. We talked about that a moment ago. So for the domain for this one, it would be the set of all x such that x is not equal to -2. So we need to carry that over to when we're looking at this guy. So let me put here that the domain for this guy, again, we're going to say, let me redo this. We're going to say the set of all x such that x, let me just put in is not equal to -2. And then also here, I don't want to divide by 0. So I have this x plus 1 in the denominator. So again, you could just say x plus 1 is equal to 0, subtract 1 away from each side, this cancels, you get x is equal to -1. X can also not be equal to -1. So we can just list it that way. So the set of all x such that x is not equal to -2, and then it also can't be -1. All right, let's change things up again. So now for the instructions, we're going to find f of g of h of x and state the domain. So this really isn't that bad. If you get a problem like this, it's just the same process. It's just one additional step. So for problem 7, we get f of x equals x minus 1, and then g of x equals the square root of x, and then h of x equals x minus 1. So the end goal is to find f of g of h of x. Let me make sure I have 1, 2, 3, and then 1, 2, 3. Before you do this, I would just break it up into a simple step first. So just take this part right here, so g of h of x, and just figure out what that is. So what is g of h of x? So just like that. And so basically that is just me taking this h of x here and plugging it in for x in g of x. In other words, this right here is going to go right there. So you would just have the square root. Instead of x, you would have x minus 1. Okay, so now I know that this right here, this g of h of x is the square root of x minus 1, and that's going to get plugged in for x in my f of x. So this right here, let me get rid of this, is going to go right there. That's it. So instead of x minus 1, you're going to have the square root of x minus 1 and then minus 1. That's it. Let me get rid of this. I think we can remember that. So this is equal to the square root of x minus 1. And then outside of this symbol, let me make this a little bit smaller here, you're going to put minus 1. And that's all it is. Now, finding the domain is not that much more complicated. You just need to think about the two inside functions that you have. So you need the domain of each of those, and then the domain of the final composite function you're coming up with. So when I think about the domain of h of x, so that's my first inside function, this is all real numbers. So let me just put an r here for all real numbers, just shorthand. Then we're not looking at g of x. We want to look at g of h of x. So it's really important because it's not g of x that's an inside function, it's g of h of x. So this one again was the square root of x minus 1. So when we think about this one, we need for this guy to be non-negative. So we just say that x minus 1 is greater than or equal to 0, add 1 to each side, and we get x is greater than or equal to 1. So that's all it is. So let me put here that x is greater than or equal to 1. Okay, when I look at this guy right here, I see that it's the same domain as this guy right here. So the intersection of these, if you think about all real numbers, x is greater than or equal to 1, and this would be x is greater than or equal to 1, you're just going to get x is greater than or equal to 1. So let me get rid of this. We don't need this anymore, just scratch work. And let me get rid of this highlighting. And I'm just going to arrow to this and say that the domain is going to be the set of all x such that x is greater than or equal to 1. All right, let's take a look at problem 8. So this one is the one that's a little bit complex. So we have f of x equals 1 over x. We have g of x equals the square root of x plus 2. And then we have h of x equals x over x minus 1. So our goal at the end of the day is to find f of g of h of x. So 1, 2, 3, 1, 2, 3. Make sure I close that down. And we also want to find the domain. So I'm going to start with this right here. So what is g of h of x? That's very easy to find. So I'm just going to take, again, here's my h of x. So it's this x over this x minus 1. I'm going to plug that in for x in this g of x. So it's going to go right there. So if I ask you for g of h of x, this would be equal to, you would have the square root of, again, in the place of x, you're just plugging in x over x minus 1. And then you have plus 2. Now, before I go any further, when I go to simplify this, I'm going to multiply this by this x minus 1 over x minus 1, so we have a common denominator. I want you to notice that when we look at this function h of x, where it's x over x minus 1, we know that the domain here would need to exclude 1, because that would give me division by 0, which is undefined. So we're going to need that in a moment. Let me go ahead and grab this. We'll come back to this page in a moment. We're going to need a lot of different pieces of paper. So let me put this right there. And to simplify, as I was just saying, I'm just going to end up multiplying this by the quantity x minus 1 over the quantity x minus 1, just so I can have a common denominator. I'm just going to do that right now. So times the quantity x minus 1 over x minus 1. And again, this is fine as long as x is not 1, because again, if x was 1, you'd have division by 0, which is undefined. Okay, so let's come through here and say this is the square root of. This would simply be x plus, this gets distributed, so I can actually get rid of the multiplication symbol there. So 2 times x would be 2x. And then 2 times negative 1 would be minus 2. We could just combine like terms now. So x plus 2x would be 3x. And then this would all be over. You have a common denominator of x minus 1. Let me actually shorten this like that. And so this would be our g of h of x. Now, before we go any further, let me actually erase this and move this up here. I want to find the domain for this, and I also, let me come back and grab this. Again, the h of x equals x over x minus 1. Forget about this for right now. That's pretty easy to find. Let me go h of x is equal to x over x minus 1. So I want to find the domain for each of these because we're going to need them. And this is probably the longest part of this problem, particularly this one right here. For this one, it's very simple. So if I just look at this, I can say, well, the domain here is what? It's the set of all x such that x is not equal to 1. Because again, you just take this denominator, x minus 1, you set it equal to 0, we'll add 1 to each side, this cancels, and you're going to get x is equal to 1. So of course that needs to be excluded from the domain. Now for this one, it's a little bit more complicated because you need to solve a rational inequality. And those do take a little bit of time. So you want this radicand here to be non-negative. And so basically we're going to say that 3x minus 2 over x minus 1, we want to know where that's greater than or equal to 0. Now, when we grab this, I'm going to take it to another page. Before I continue, I want to stop you if you're trying to rationalize the denominator. When you're working on this problem, you're going to see particularly rationalizing the denominator can end up giving you a different result if you're not careful. So you want to do that at the very, very end of the problem, if you even do it at all. So we'll get to that later. Let me go down here and let me come here and paste this in. So hopefully you'll remember how to do this. Basically, you're going to take this guy right here. It's already a single fraction. So you're going to say 3x minus 2. You're going to take that numerator. You're going to set it equal to 0. So what value of x is going to make the numerator 0? Let's add 2 to each side. This cancels. You get 3x is equal to 2. Divide both sides by 3. This cancels. So you have x equals 2/3. So that is one critical value. And I'm going to put it right here because I already know that the next one's going to be 1. Because I'm going to take that x minus 1, we just did this a moment ago, set that equal to 0, and find where the denominator would be 0. So what x value causes that? We add 1 to each side. This cancels. Again, you get x equals 1. So this is a 1 here. Now, we remember that, again, even though this is a greater than or equal to here, we cannot have division by 0. So the 1 would be excluded in your solution, and the 2/3 would be included. Okay, so just keep that in mind. Now, all you have to do at this point is just test. So just pick something that's less than 2/3. We'll call that region A. Something between 2/3 and 1, we'll call that region B. And then something greater than 1, we'll call that region C. So something less than 2/3, again, you could pick anything. I think 0 is pretty easy to work with. So let's say you plug that in. So 3, and then you'd have a 0 there. So 3 times 0, and then minus 2 over. This would be a 0 down here, and then minus 1. Is that greater than or equal to 0? Well, this becomes 0. 3 times 0 would be 0. So you basically just have -2. And let me put that back in here. 0 minus 1 is just -1. -2 over -1 is +2. Is +2 greater than or equal to 0? Yeah, 2 is greater than 0. So this is a true statement. So I'm just going to put T here for true. So things that are less than 2/3 would work. Now we're going to look at between 2/3 and 1. And that's a very small window. So I would just pick something like 0.75, or you could do 3/4, depending on if you want to work with a decimal or a fraction. And I'm just going to punch this into the calculator. So let's say we did something like 3 times. We can go 0.75 and then minus 2 over. This would be 0.75. And then minus 1. So you can see already that this is going to be negative. It's not going to work, but we can go through it. So 3 times 0.75 would be 2.25, and then 2.25 minus 2 would be 0.25. So up here, this is going to be a positive 0.25. Then down here, 0.75 minus 1, well, that's going to be a negative 0.25. And so basically, you have 0.25 divided by negative 0.25. That is going to be -1. So really the statement you get is -1 is greater than or equal to 0, which of course is false. So things in region B are not going to work. So I'm going to put an F here for false. What about in region C? Would things work? Well, here I could just plug in a 2. So let's say we have 3 times 2 and then minus 2 over, we're going to have 2 minus 1. So 3 times 2 is 6, and then 6 minus 2 would be 4. And of course, 2 minus 1 would be 1. So you get 4 over 1, which is 4. So we get 4 is greater than or equal to 0, which is a true statement. So I'm going to go ahead and put that this is a T for true. Okay, so putting the solution together, again, this would be included, this would be excluded. So x is less than or equal to 2/3, or x is greater than 1, strictly greater than 1. 1 is not included. Okay, let's grab this and let's come back up here and paste this in. So let me write out the domain for this one. Maybe I need a lot of room, so I'll just arrow to it like that. So the domain for this one is going to be the set of all x such that, let me slide this down a little bit. And instead of using the word or, I'm just going to put a comma. You can put or in there, it doesn't matter. But I think this is a little bit cleaner. So the set of all x such that x is less than or equal to 2/3, or you could also have x being greater than 1. Now, because this is strictly greater than 1, this is already excluded, so you don't need to worry about that. So when you look at the intersection of this one and this is the one you want to take. Now, we're going to look at this f of g of h of x now. So let me write that f of x is 1 over x. I can just erase this from here. We can answer on another page. So f of x is 1 over x. So let me put f of g of h of x. That's 3, so 1, 2, 3. And this equals 1 over, again, for x, we're going to come up and we're going to grab this guy right here. And we're just going to paste that in. Let me get rid of this. And let me make this look a little bit nicer. So like that. So that is your f of g of h of x. Now, we're going to rationalize the denominator in a moment, and that's going to take quite a lot of time because I have to explain some things. But basically, at this point, you would just look at the fact that this guy's in the denominator and we don't want to divide by 0. So let me go back up and let me grab this domain here. Remember that this one and this one, when we looked at the intersection, it was this one. So we're going to grab this one. We don't have to worry about this one anymore. And we're going to come down here and paste this in. And now we're going to be looking at the intersection of this one, which was from g of h of x, and then this final guy right here. So how would the domain be additionally restricted here? Again, you don't want to divide by 0. So now we know that this would be 0 when x is 2/3, right? We know it can't be 1. We already have restricted that. But if x was 2/3, remember that makes this numerator 0. And so 0 over something that's not 0 would give you 0. So the square root of 0 would be 0 and 1 over 0 would be undefined. So what you have to do is make an adjustment to this like that, and that would be the domain for this guy. Now, what we're going to do is look at rationalizing the denominator. Before I go through this, I'm just going to tell you that for this type of problem, typically a book will not do this. They'll just leave this as the answer. And that's what I would suggest to you. Just leave it and move on. But some people are insistent on rationalizing the denominator. So I'm going to show you how to do that if you want to. All right, let me come down here and paste this in. And I want to remind you that when you do something like rationalize the denominator, you want to make sure that even though the form of your answer is going to change, you want to carry that domain through the process. In other words, when you report your answer, even though it looks different than this, you still want to have the same domain from the original. So before you rationalize the denominator. So let me once again write out the domain so we're reminded of that. So the domain here would be the set of all x such that x is strictly less than 2/3, or it could be an x that is strictly greater than 1. So the first thing I would do here is I'm just going to multiply by the square root of, I'm just going to flip this. So we'll have x minus 1 over 3x minus 2. And then over, we're going to have the square root of x minus 1 over 3x minus 2. Okay, so up top, this is really easy. 1 times the square root of x minus 1 over 3x minus 2 is just going to be the square root of x minus 1 over 3x minus 2. 1 times anything is just itself. Then this is over. Now, when I multiply these guys together, I'm going to go back to my product rule for radicals. So basically, this right here would be a real number, and this would be a real number if I'm following this domain. So again, if x is strictly less than 2/3, or x is greater than 1. So I know I'm going to have a real number here and a real number here. So that allows me to simplify by saying that I have the square root of, and I'm just going to multiply these radicands together. So I'm going to go the quantity 3x minus 2 times the quantity x minus 1. And this is over. You have the quantity x minus 1 times the quantity 3x minus 2. Okay, so this right here is going to cancel with this right here. This would cancel with this right here. So this would give me a 1. And the square root of 1 would be 1. So now I have the square root of x minus 1 over 3x minus 2. And this would be over 1. So you can just get rid of this because dividing by 1 leaves something unchanged. So let me put this like this. And actually, if you want to copy these steps down, you can. I'm just going to erase this so I can just stay right where I am. So I don't have to keep rewriting that domain or even copying it. And let me slide this down here. Not too much more to do. What I'm going to do is actually, let me get rid of this temporarily. I'm going to wrap this and wrap this. I'm going to multiply by the quantity 3x minus 2 over the quantity 3x minus 2. Okay, let me put a big square root symbol there. So this would be equal to what? So the square root of, so this would be in the numerator, the quantity x minus 1 times the quantity 3x minus 2. You could use 4 for that if you want. I'm not going to, but you can if you want. So this is over. Down here, I'm going to write this as the quantity 3x minus 2 squared. So now I'm finally going to break this up. So I'm going to say this is equal to, we'll have the square root of this quantity x minus 1 times the quantity 3x minus 2. And this would be over the square root of this quantity 3x minus 2 squared. So at this point, let me clean things up. I'm just going to get rid of this. So let me move this up here and say this is equal to, so I'm going to have the square root of, again, this is the quantity x minus 1 times the quantity 3x minus 2. And then this would be over, let me make this better here. So we have the square root of the quantity 3x minus 2 squared. Remember, for this, we're going to use absolute value bars. So we're going to say this is the absolute value of 3x minus 2. Now, this is the problem that comes up. A lot of people will just say, well, this is going to be 3x minus 2. If you do that, let me show you the different graphs. So this is what you want to achieve. Here's your y. You could use f of g of h of x, but y is a little bit simpler. We have y equals 1 over the square root of 3x minus 2 over x minus 1. So we found this is going to be our composite function that we want. If you graph this on Desmos, and I left a link for you, this is what it's going to look like. So you see that 1 is excluded, so anything greater than 1, that's this piece right here. And then 2/3 is excluded, so anything less, we're going this way. So you have this piece and you have this piece. Now, if I don't use absolute value bars, what I come up with is something like this. So this piece right here, again, I'm going to exclude 1 from the domain because that's got to carry itself over. But this piece is still the same. It's okay. But when I get to where x is less than 2/3, I have this going the wrong way, right? It should be up here, right? If I go back, that piece should be up here. But now it's down here. And the problem is because I didn't use absolute value bars here, when this guy, this 3x minus 2, so when 3x minus 2 is less than 0, you've got an issue because you're going to have a negative sign, whereas with absolute value bars, you would have had a positive sign. If you add 2 to both sides and cancel this, you get 3x is less than 2, divide both sides by 3, and we see that when x is less than 2/3, which is, again, this piece right here, that's going to happen. So we fix that by using these absolute value bars here, and that's just following the rule that if you have something like the square root of, let's just say, the quantity a plus b squared, this is the absolute value of a plus b. That's all it is. That's a basic rule. Let me get rid of this. And so this would be how we would write this. So we're going to say that f of g of h of x is going to be equal to this square root of the quantity x minus 1 times the quantity 3x minus 2 over the absolute value of 3x minus 2. So again, keep the same domain, even though we changed the way it looks. So again, it's going to be the set of all x such that x is less than 2/3, or x could be anything greater than 1. All right, let's change up the instructions again. So now we want to find f of x and g of x. I put here your answer may vary. For these types of problems, there's sort of a natural intuition, an answer that most people will come up with. So for problem 9, we have f of g of x is equal to the quantity x minus 3 squared minus 5 times the quantity x minus 3 plus 1. So when I decompose this, I'm going to say that my f of x is going to be x squared minus 5x plus 1. And I'm getting that from the fact that this right here and this right here gets repeated. So basically I could plug that in for x. So I could plug it in there and then there. So my g of x, or the inside, would be equal to this x minus 3. So again, if I just plug this in here and here, I'm going to have this. So I come up with f of x equals x squared minus 5x plus 1, and then g of x equals x minus 3. So this is going to be the answer that I give. This is the one that I feel is the most natural. Keep in mind that you could come up with another answer, and it could be still correct. All right, for problem 10, we have f of g of x is equal to 1 over x squared minus 3x plus 2. Let me slide down here a little bit. So again, all I'm going to do is say, if I had 1 over x, so let's say f of x is equal to 1 over x. Well, this right here, this x squared minus 3x plus 2, that could just be g of x, what I'm plugging in for x. So it would be x squared minus 3x plus 2. And again, that's one way that you could decompose this. There's other acceptable answers. So I'm going to go with f of x equals 1 over x, and then g of x equals x squared minus 3x plus 2. In this lesson, we want to talk about combining graphing transformations. So up to this point, we have individually studied the graphing transformations such as a vertical stretch or compression, a horizontal stretch or compression, a vertical shift, a horizontal shift, something like a vertical reflection, which is a reflection across the x-axis, and then a horizontal reflection, which is a reflection across the y-axis. But what happens when you have multiple transformations? What is the correct order? How exactly does that work? All right, so I'm just going to start off with the easiest scenario, which is the order of vertical transformations. So if I look at something like f of x equals the square root of x, and then I look at something like g of x equals 3 times the square root of x minus 5, the first thing I would do is write g of x in terms of f of x. You see you have this square root of x here and square root of x here. So I'm just going to say that g of x is equal to 3 times, again, for this right here, it would just be f of x, because f of x is equal to the square root of x, what I have right there. And then you have this minus 5. So individually, we know how this works. If I mark this part out right here, what is 3 times f of x? Well, that's giving me a vertical stretch by a factor of 3. And then if I was to mark out this right here, what is f of x minus 5? Well, that's giving me a shift down by 5 units. But what do we do when we have both of them? What's the correct order? Well, it turns out it's just going to follow the order of operations. So you would multiply first, and then you would subtract. So in other words, you would want to do this vertical stretch by a factor of 3 first, and then you would want to do this one second, which is the shift down by 5 units. So that would be the correct order here. If you want to see this in action, what you can do, let me get rid of this. You can just plug in. So let me just get rid of this as well. And you could just take a few ordered pairs. I have a graph for you, which I'm going to go down to in a moment, and I have a link for you on Desmos if you want to follow that. Let me just show you that real quick. So this is what we're going to be working with, and we're going to go through these points. So let's just start with 0, 0 and 0, -5, and I'll show you where that's coming from. So let's say you have f of 0. This is equal to the square root of 0, which is equal to 0. So we know f of 0 is 0. Well, for that same x value of 0, what is the y value going to be? A lot of you know it's going to be -5. You can eyeball that. But again, g of 0 would be equal to, now you have 3 times 0 and then -5. Well, all I had to do was replace this right here with the y value that I know that would be produced from that same x value here. So 3 times 0 would be 0, and then -5 would be -5. So this becomes 0 minus 5. This is -5. Again, you're just following the order of operations. 3 times whatever the y value was, in this case it was 0, and then -5. So you do them in the same order as when you're doing the order of operations. So this is -5. Again, just to show you this on the graph, here is your 0, 0. Here is your 0, -5. So we have 1, 1 and 1, -2. So let me get rid of this and just put in a 1 here. And basically, if you put in a 1, you would have the square root of 1, which is 1. So if you did g of 1, again, for that same x value, you don't actually have to plug in because you know the result of this part right here is going to match this part right here. If I plug in a 1, I get a 1. So I can just start with that y value of 1 and say, okay, well, 3 times 1 minus 5. That's what I'm going to end up with if I plug in there. So I would just follow the order of operations. Multiply by 3 first. That's going to give me 3, and then subtract away 5 second. So 3 minus 5, that's going to be -2. So that's how you get that point, 1, -2. Again, coming back, this is your 1, 1. That's going to go to 1, -2. Let's do this one and this one. So 4, 2, that's going to go to 4, 1. So let's do f of 4, and we'll do g of 4. So for f of 4, again, it's just the square root of 4, which is going to be 2. Let's put a 2 right there. And then for g of 4, again, I don't need to plug in a 4 there because I know that the result of that is going to be 2. So I can just take this y value that I know and just put it right there. So it would be 3 times 2 and then -5. Again, just following the order of operations, 3 times 2 is 6, and then 6 minus 5, that's going to be +1. So you would get 4, 1. So this one is 4, 2, it goes to 4, 1, again, so on and so forth. A lot of times you'll see in the textbook that they'll write things where they say, well, for this x, y, that's going to be on your graph of f of x equals the square root of x. What's going to happen is, as you go to this g of x equals 3 times the square root of x minus 5, the x value stays the same, but the y value, again, first you're multiplying by 3, so you can say 3 times whatever y is, and then you're going to subtract away 5. So that's going from this one to this one. Again, if you want to take, let's say, this one right here, and you would have the same x value of 9, so you see that here and here, and all you'd have to do is take that y value of 3 and plug it in there. 3 times 3 is 9, 9 minus 5 is 4, so that's how you get that 9, 4. So this is a good way to do it if you want to check your work. All right, so just to go through the order of vertical transformations, let's say you had something like g of x is equal to a times f of x, and then plus some k. Well, your a here, again, that's going to be your vertical stretch or compression, along with any reflection across the x-axis if that's negative. So I have the order listed to where a is done first. So basically, you could do perform any vertical stretch or compression if the absolute value of a is greater than 1, we have a vertical stretch. If the absolute value of a is greater than 0 and less than 1, we have a vertical compression. Again, some people use the term shrink. Then I have for number 2, perform any reflection across the x-axis. So that's your vertical reflection. So this is when a is less than 0. You can switch 1 and 2. It does not matter. As long as you do it before 3, you're okay. Typically, when they list the procedure in a book, these will be different depending on the resource, or they might even put them together and say do any vertical stretch or compression along with any reflection. So these you could just consider as one step or just switch the order, whatever you want to do there. It's just important that the third thing or the last thing you do if you're doing vertical transformations is that you perform any vertical shift. That would be last, again, because of the order of operations. So up k units if k is greater than 0, so if this is positive, and down by the absolute value of k units if k is less than 0, so if this is negative. All right, let's look at an easy example here. So we have f of x equals the cube root of x, and then g of x equals negative 1/2 times the cube root of x minus 3. So one thing that might be helpful for you, you don't have to do it all the time, especially once you get good at this, but you want to write things in terms of f of x. So g of x is equal to, you have this negative 1/2, and then times, again, this is f of x right here, so the cube root of x, and you have that right there. So I'm just going to say times f of x, and then you have this minus 3. So we can slide down, so we have enough room. We don't need that on the screen anymore. And basically, if you want, you could just go left to right. So that's what I typically do. Again, this one right here and this one right here, you can do that in any order. Just make sure you're doing the multiplication before you do the subtraction. So in other words, I could say that this right here is number 1, this one right here is number 2, and this one right here would be number 3. Again, it would not be incorrect if you said that this was 1 and this was 2, but I like to list it this way because you're just working left to right. It's easy to remember. So that negative that's out in front, that's giving me a vertical reflection or a reflection across the x-axis. So let's say reflected across the x-axis. Let me fix that. The second thing, you have this 1/2 here that's doing a multiplication by f of x. Again, that's giving me a vertical compression by a factor of 2. Let me put vertical compression by a factor of 2. Now, let me stop here. Again, a lot of books, a lot of teachers have different terminology for this. You might see in a book where they say there's a vertical shrink by a factor of 1/2. So if that's what you want to use, it's equally correct. Whatever terminology fits the way that you like to study, it's okay. You're just taking the y coordinate and you're either, you could say multiplying it by negative 1/2 or you're dividing it by negative 2. So that's where these two steps are coming from. So the third thing here, we have this minus 3, and that's just going to shift me down by 3 units. So let's say we're going to shift down by 3 units. And that's basically it. You're reflecting across the x-axis. You have a vertical compression by a factor of 2, and then you're going to shift down by 3 units. So if you had some x comma y that's on the graph of your f of x equals the cube root of x, well, when you get to g of x equals negative 1/2 times the cube root of x minus 3, what is going to happen to the y coordinate? So the x would be the same here. For the y coordinate, again, you're just going to multiply it by negative 1/2. You could say that's negative y over 2, and then you're going to subtract away 3. So that's how you can check it. You can just go to the graph. Again, I've got a link for you on Desmos if you want to follow along with me here. And so you could just pick something like, let's say this 0, 0. So if you had 0, 0, what is that going to go to? Well, the x is the same, still going to be 0. The y value is, you plug it in right there. So the negative of 0 is still 0. 0 divided by 2 is 0. Then you subtract away 3, you get negative 3. So this 0, 0, that's going to go to 0, negative 3. Let's do another one. So you have this 8, 2. So 8, 2. Where is that going to go to? Again, the x value stays the same. The y value of 2, you plug that in there. So you have negative 2 divided by 2, that's negative 1. And then negative 1 minus 3, that's negative 4. So you see down here, you have 8, negative 4. You could do this one as well. Turns out that once you go through it, you're still going to have negative 8, negative 2. So you have negative 8, negative 2. That's going to go to what? So the x value is still negative 8. And then you plug in a negative 2 here. So this one's tricky. Let me do it. So you have the negative of, you plug in for y. This is over 2, and then minus 3. You have to be very careful when there's a negative right there. A lot of people will make a mistake and not plug in another negative. They'll just say that it's negative 2 because the negative's already there. But what you want is the negative of negative 2. So be very, very careful. There's a negative out in front there. So the negative of negative 2, that's positive 2. So this becomes positive 2 over 2 minus 3. And this is 1 minus 3, which ends up being negative 2. That's why you get that negative 8, negative 2. So that is going to be no change in that particular case. All right, now let's cover the more challenging scenario, which is the order of horizontal transformations. We're going to see that this follows the reverse of the order of operations. But where does that come from? Well, let's start off with f of x equals the square root of x, and then g of x equals the square root of negative 1/2 x minus 1. The procedure that I'm going to give you might be different in your textbook or your resource, and this is based on whether you factor or you don't factor. So if you don't factor like I'm about to do, you need to go with a different order. You would just check your resource for that. So first off, let me write this g of x in terms of f of x, and I'm going to factor. So I'm going to say that this is f of this right here is just being plugged in for x right there. That's all it is. So I'm going to say that I have negative 1/2, and again, I'm going to factor that out. So I'm going to put some parentheses right here. So we know that this would be x. A lot of people get confused about what goes here. Again, just think about how to undo stuff. So I'm going to end up multiplying by negative 1/2. So how do I undo that? Well, I would want to multiply by negative 2. So take this negative 1, multiply by negative 2, you're going to get positive 2. We're going to close that down and then close this down. Now, why did I take the time to do that? Well, you're going to see in a moment when I get to function composition, this is going to allow me to say that this is going to go this one first. So I'm going to undo that. And how do I undo multiplication by negative 1/2? I'd want to multiply by negative 2. So the negative part is giving me a horizontal reflection. So that's a reflection across the y-axis. And then the 2 part, that's giving me a horizontal stretch by a factor of 2. Again, I know it's counterintuitive because you're seeing the negative 1/2, but again, you have to undo that. So you multiply by negative 2. Then this would actually be second. So we have plus 2 on the inside. We're going to undo that by subtracting 2 away. And so this is going to shift me 2 units to the left. Let me show you this with function composition. Okay, so for the function composition approach, let's say we have, again, f of x equals the square root of x. We're going to have this middle step here. So we're going to have this h of x equals f of negative 1/2 x. So if I was to write h of x right here, so h of x is equal to, well, all it is I'm taking this right here and plugging it in for x right there. So this would be the square root of negative 1/2 x. So that's all it is. Let me slide down. And basically we know that if we see h of x equals the square root of negative 1/2 x, again, comparing that to f of x, well, I have a horizontal stretch by a factor of 2, and I have a reflection across the y-axis. So I want a horizontal reflection there. So those two things would be done. We've talked about that previously. Well, now, if I look at g of x being equal to, I have this h of x plus 2. So that just means I'm going to plug in the quantity x plus 2 right there. So I need some parentheses. So I'm going to say this is the square root of negative 1/2 and then times the quantity x plus 2. And what is that going to do now? It's going to shift me to the left by 2 units. Again, I have to undo this plus 2 here. Everything on the inside is the reverse. You have to undo things. So what's going to end up happening is when we look at this compared to f of x, again, we saw that we did this one first and this one second. So I had a horizontal stretch by a factor of 2, a reflection across the y-axis. The last thing I did was a horizontal shift to the left by 2 units. All right, let me come back up here and I'm just going to show you this using a tedious method of just plug and chug. But I hope it'll make sense for you because a lot of times when you first see this, it's very confusing because you're undoing things, you're going in reverse order. And a lot of times it's just not so straightforward like it is with vertical transformations. But if you plug things in and just keep going back and forth, it will make sense. So if I do something like, let's say f of 4. So we know f of x equals the square root of x. I know it's cut off, but this would just be the square root of 4, which equals 2. You see, this is the graph right here. This is your f of x equals the square root of x. You have this point, which is 4, 2. So we know this graph. This is going to end up going over here to negative 10, 2. So let me show you that real quick. And first, I'm just going to plug in. Let me put a little border here. So I'm going to say, what is g of negative 10? Well, we're going to find that it's 2. So we're going to say that this would be the square root of, you have your negative 1/2. Again, this is in factored form, times the quantity, negative 10 plus 2. Let's close that down. So this would be equal to, what do you do first here? Well, you have parentheses, so you're going to do negative 10 plus 2 first. That's going to give you negative 8. So now you would have the square root of negative 1/2 times this negative 8. And then when you do that, you're going to have the square root of negative 1/2 times negative 8. Well, that's positive 4. So at this point, this matches this. So once I do this final step, I'm going to say this is 2. The issue is that I'm used to working with f of x equals the square root of x. I know there's a point 4, 2. I'm not used to working with g of x equals the square root of negative 1/2 times the quantity x plus 2. So I don't know about this point negative 10, 2. So what I would want to do is take that known x value of 4 and reverse the steps here so that I can get to negative 10. That way I know there's negative 10, 2 on the graph. In other words, if I reverse this, let me put another border here. So let's say we're going to go in reverse. So the first thing is to undo the multiplication by negative 1/2. To do that, we multiply by negative 2. So we're going to multiply by negative 2. The second thing is we want to undo this addition of 2. So that means we want to subtract away 2. So what does that look like? Again, if I start with 4, let me slide down here a little bit more. Well, that would be 4 times negative 2 and then minus 2. Well, 4 times negative 2 is negative 8. And then negative 8 minus 2, that's going to be negative 10. Well, notice that gets me right there. Again, I had to start with what I knew. I know that point 4 comma 2 is on that graph of f of x equals the square root of x. Start with that x value that you know, and then go in reverse. So first multiply by negative 2. Again, that gives me the horizontal stretch by a factor of 2 and a reflection across the y-axis, and then subtract away 2. That's giving me a shift to the left by 2 units, and I'm going to end up with negative 10. So I know negative 10 comma 2 is on the graph right here. In other words, if you have some x comma y on this f of x equals the square root of x, when you go to g of x equals the square root of negative 1/2 x minus 1, well, you could really say that, again, the first thing I want to do is undo the multiplication by negative 1/2. So that's multiplying by negative 2. So you have negative 2 times whatever the x value is. And then next, I want to undo the addition of 2. So I want to subtract away 2. So it's just negative 2x minus 2, and then comma, the y value would not be changed. So if you took this x value of 1 here, well, if you went through the process, negative 2 times 1 minus 2, negative 2 times 1 is negative 2, and then minus 2, that gives me negative 4. Well, notice that over here, you have this x value of negative 4 that corresponds to that same y value of 1. And I'll let you do the other points on your own. Again, all we're doing is we're going in the reverse of the order of operations. Now, if you don't factor, you would have a different order of operations, and so you're going to get a different reverse order of the operations. So that's why if you're in your textbook and they don't factor, they'll tell you they want to do the horizontal shift first, and then followed by the horizontal stretch or compression along with the reflection. Again, we're not going to do that here. We're always going to factor. All right, so just to put this together, let's say that we had g of x is equal to f of, let's say, bx minus h, something like that. Well, we would factor this first. So we would say g of x is equal to f of, pull out the b, inside you'd have x minus h over b, close all that down. And so looking at this, again, in factored form, if it's not in factored form, again, you're going to get a different order of operations. And so when you reverse the order of operations, it will be different. So if you're in a book and it says to do the horizontal shift first, it's because they did not factor. Okay, so I want to make that crystal clear. So the order given below is for the factored form only. So you're going to begin by factoring out the coefficient of x, which we did. Coefficient of x was b, we pulled it out. Then you're going to perform any horizontal stretch or compression. So if the absolute value of b is greater than 1, we have a horizontal compression. Again, some people say a shrink. Remember, you're trying to undo things. If the absolute value of b is greater than 0 and less than 1, we now have a horizontal stretch. Then you want to perform any reflection across the y-axis. Again, that's your horizontal reflection. So this is if b is less than 0. Again, this one right here and this one right here, you can do them together. You can switch the order. As long as, again, when it's in factored form, you do it before you do the horizontal shift, you are okay. So we're going to then perform any horizontal shift. So we're going to go right by h over b if h over b is positive. Again, this is minus some positive number. That means you're going to the right by h over b. It's left by the absolute value of h over b units if h over b is negative. Again, minus a negative would be plus a positive. So if this was plus some positive h over b, now you're going to the left by, I guess if we converted it to positive, you say h over b units. Again, if you keep it as negative to match this form, you'd say the absolute value of h over b units. Okay, let's look at an example. So we have f of x equals the absolute value of x, and then g of x equals the absolute value of 2x minus 4. So if you want, again, not necessary, you could write this as g of x is equal to f of, again, this gets plugged in there, and I'm going to factor. So 2 times the quantity x minus 2. Let's close all that down. So this right here is done first, and this is done second. Let me write that as this is 1, and this is 2. Because we're undoing things, so we're going in the reverse of the order of operations. If you can't remember this, again, just remember factor and then go in the reverse of the order of operations. You know what the order of operations, you work inside the parentheses first, followed by doing this multiplication. Well, now you're going in reverse, so you need to undo this first and then undo this second. Everything must be undone. So how do we undo multiplication by 2? We divide by 2 or we multiply by half. So the first thing is we have a horizontal compression by a factor of 2. Again, a lot of people like to say that as a horizontal shrink by a factor of a half. Different terminology, same meaning. You're taking the x coordinate and dividing it by 2 or multiplying it by a half. The second thing is you have this minus 2. I need to undo that. So I want to add 2. That's going to shift me to the right by 2 units. So you could say shift right by 2 units. So that's all we're really going to do here. So for a given y value, let's say you have x comma y on the graph of that f of x equals the absolute value of x. When you get to g of x equals the absolute value of 2x minus 4, well, now we're going to take the x and we're going to divide by 2, or again, you could multiply by half, and then we're going to shift right by 2 units. So we're going to add 2. Again, the y value would not be changed. Let me go ahead and grab this. And again, I have a link for you if you want to check this out on your own. So you have something like negative 6 comma 6. That's on the graph of f of x equals the absolute value of x. Again, the y value of 6 is going to be the same. The x value is now going to be found by saying, well, you take that x value of negative 6, you divide by 2, and then you add 2. Well, this becomes negative 6 over 2. That's negative 3. So negative 3, and then plus 2, that gives me negative 1. So that's how you get this x value of negative 1 paired up with this y value of 6. Let's do the other ones. So this one is 0, 0. This is going to go to 2, 0. That's pretty easy. If you plug in a 0 right here, you end up with 2. So it would just be 2, 0. And then this one is going to be 6, 6 going to 5, 6. So let's go 6 over 2 and then plus 2. Well, this would be 6 over 2 is 3 plus 2 is 5. So that's how you go from 6, 6 to 5, 6. Again, the y value is not changing here because we didn't do anything to it. I'm going to have that link for you if you want to play around with some more points. All right, what I want to do now is give you one example where we put everything together. So I want to just say that when you deal with horizontal transformations and vertical transformations, they do not impact each other. So you can play around with the order. You just need to make sure that you do things specifically in the order for the horizontal and for the vertical correctly. The way that you put them all together does not matter. So you might see different procedures out there that would still be correct. So combining graphing transformations, once again, I'm going to state that the order given below is for the factored form only. If your book tells you to do the horizontal shift first, that is because they did not factor. Okay, I can't stress that enough because a lot of people get confused in this section because there's different procedures out there and it's based on whether you factored or you didn't factor. So I'm going to put here first to factor out the coefficient of x. Then I'm going to say perform the vertical stretch or compression along with any reflection across the x-axis. Perform the horizontal stretch or compression along with any reflection across the y-axis. Perform the horizontal shift and then perform the vertical shift. So basically the way I like to do it is I like to just work left to right. This is very easy to remember and it will give you the correct ordering. Again, provided you have factored out the coefficient of x, you're good to go. And that way you can just say that I'm doing all the stretches or compressions with the reflections before any shifts. All right, let's take a look at f of x equals x squared. And then g of x equals negative 3 times the quantity 1/4 x minus 1 squared and then plus 9. Again, you might want to write this as g of x is equal to, this part right here is going to replace x right there. Okay, so this gets plugged in there. The negative 3 is on the outside. You could just write that. So negative 3 times f of, again, what am I plugging in for x here that would be squared? This right here. So this 1/4, might as well factor it now. So you'd have inside the parentheses x, and then how do I undo multiplication by a fourth? I would want to multiply by 4. So negative 1 times 4 is negative 4. We'll close all that down. And again, this gets plugged in for this. That's all we're doing. So you want f of 1/4 times the quantity x minus 4. Then you have this plus 9. So plus 9. Okay, once we have it in this form, you can scroll down. You don't need that anymore. And again, all I'm going to do is work left to right. You don't have to. There's different ways you could do it, but this is the way I'm going to do it. So I'll just say that this would be first, this would be second, this would be third, this would be fourth, and this would be fifth. That's all I'm going to do. So this on the outside, this negative right here, again, if I had negative 3 times f of x, that gives me a reflection across the x-axis, and I'm vertically stretching by a factor of 3. So I'm just going to say that we're going to reflect across the x-axis. Second thing is you have a vertical stretch, so that S is for stretch, by a factor of 3. Again, these can be done in any order. You can also put them together. Then when I get on the inside, you have to remember that you're undoing things. Okay, so you're undoing multiplication by a fourth. How do I undo multiplication by a fourth? I would multiply by 4. So that's giving me a horizontal stretch by a factor of 4. Horizontal stretch, again, this S is for stretch, by a factor of 4. Let me fix this A here. All right, then for the fourth thing, again, you're going to go on the inside of the parentheses here. You have this minus 4. How do I undo that? I want to add 4. That's going to shift me to the right by 4 units. So we want to shift right 4 units. The last thing here, you have this plus 9. Again, this is on the outside. This is very straightforward. That's just going to shift me up by 9 units. So let's say we're going to shift up 9 units. So if you take something on the graph of f of x equals x squared, so sum x comma y, when you get to this g of x, which we've written as -3 times f of 1/4 times the quantity x minus 4, and then plus 9, this is going to end up being what? Well, for x, you have a horizontal stretch by a factor of 4, so I'm going to multiply whatever the x is by 4, and then I'm going to shift right by 4 units, so plus 4. Then for the y, these two would be done together, so I'm going to multiply by -3, so -3y, and then I'm going to shift up by 9, so plus 9. So that's all it is. So you can use this to check, and I have a little graph for you. Let's just do all the points here, and again, if you want to click on the link and do more, that's up to you. So you have something like -2 comma 4, that's on the graph of f of x equals x squared. Well, that's going to go to -4 comma -3. Again, just following this, you have 4 times -2 plus 4. Well, this becomes 4 times -2 is -8, plus 4, that's -4. That's how you get the x value of -4. For the y value, you have -3 times the y value of 4. Let me make this better here. And then plus 9. Well, -3 times 4, that's -12. And then plus 9, that's -3. That's how you get the -3 there. If you look at something like 0 comma 0, well, that's going to go to 4 comma 9. So basically for that, this is going to go away, and this is going to go away. You'd have 4 comma 9. That's very straightforward. Then this one right here, which is 1 comma 1, that's going to go to 8 comma 6. So let's go 4 times 1 plus 4. This is 4 plus 4, which equals 8. That's how you get the 8. Then for the 6, again, you'd have -3 times your 1 plus 9. Well, this becomes -3, right? -3 times 1 is -3, plus 9, that's positive 6. So that's how you're going to get that positive 6 right there. Again, if you want to play around with this on Desmos, I gave you the link. You can check all the points that you want. All right, let's take a look at the practice test. For the instructions, we're asked to describe the transformation from f of x to g of x. For the first two problems, we're going to deal with just vertical transformations. Then for the next two, we'll deal with just horizontal transformations. And then after that, we'll mix them. So just to think about what we learned in the lesson once again, if you have vertical transformations, remember that they follow the order of operations. So something like g of x is equal to a times f of x plus k. This a right here is going to multiply your y value first before you add on this k. So multiplication, then addition. In other words, the way you would think about it is you're going to do this a right here first, which would be any vertical stretch or compression along with any reflection. Those could be done in any order, it would not matter, followed by your vertical shift, so going up or down. So with that being said, let's go to the first problem. All right, let's take a look at the first problem. So we're told that f of x is equal to the absolute value of x, and then g of x is equal to 1/2 times the absolute value of x, and then minus 1. Again, with vertical transformations, it's very straightforward. You're going to do the vertical stretch or compression first, followed by your vertical shift. In other words, you could write this as g of x is equal to, you go 1/2 times f of x. Again, f of x is the absolute value of x, so that's this right here. And then you have your minus 1. So again, just following the order of operations, you do multiplication first, followed by your subtraction. Okay, let me slide down here and I'll just write the order, and then we'll go to the coordinate plane, and I have a graph for each one so we can see this in action. So the first thing you would do again is any vertical stretch or compression. Here you're going to say that you have a vertical compression by a factor of 2, and that just means that you're taking your y value and you're dividing it by 2. Now, some books will say this as a vertical shrink by a factor of 1/2, so I don't want you to get confused by that. Just realize that you're dividing the y value by 2, or you could say you're multiplying it by 1/2. Either way, just use whatever terminology you're comfortable with. I'm going to say there's a vertical compression by a factor of 2. Then the second thing is you have this minus 1 here. Again, we're going to do that second, and that's just going to shift me down by 1 unit. So we're going to say shift down 1 unit. And those are your two transformations done in order. So in other words, if you have something on the graph of f of x, so x comma y, well then when you get to the graph of g of x, it's going to be, we're going to go from x comma y. So this is for your f of x. And when we get to g of x, this is going to basically say that we're going to take the same x value. The y value would first be cut in half. So again, you're going to divide that by 2 or multiply by 1/2. So let me say that is y over 2 done first. And then after that, you're going to shift down by 1. So you're just going to subtract away 1. Let's go to the graphs here. Now for everything today, I gave you a link on Desmos. so you can follow along more closely. Just click that and you can play around with these points if you want on your own. But let's just say we take this, and I color coded everything. Let's say we take something like -6, 6. So that's on the graph of f of x equals the absolute value of x. The absolute value of -6 would be 6. That's how you get this point there. So that same point, again, we have -6, 6. If you go through this process, the x value of -6 is the same. So you see that right there. How do we get this y value of 2? Well, you're going to take this +6 and you're going to divide by 2 first, then you're going to subtract away 1. Well, 6 divided by 2 is 3, and then 3 minus 1 is going to give me 2. So that's how this -6, 6 is going to go to this -6, 2. Let me put that one in there. I'll let you do the other points on your own, but we have something like this 0, 0. Again, when you get to your g of x function, it's now going to be 0, -1. You have something like 4, 4. When you get to your g of x function, now it's going to be 4, 1. Again, just following these steps here, keeping the x value the same, and then for the y value, you first divide it by 2 and then subtract away 1. All right, let's take a look at problem 2. So here we're given f of x equals x squared, and then g of x equals -2x squared plus 3. Again, when you have a negative involved here, now you have a reflection. In this case, it's a vertical reflection, meaning you're going to reflect across the x-axis. When you think about this, let me rewrite this. I'm going to say that g of x is equal to, I'm just going to write -1 times 2 times, again, for x squared, that's your f of x, right? F of x is x squared. So I'm going to put f of x like that, and then plus 3. So this 2 that's multiplying your f of x, that's a vertical stretch by a factor of 2. This -1 here, that's again reflecting me across the x-axis. These two can be done in any order. You just have to make sure you do it before the shift here. So you could write, if you want to go left to right, that the first thing is you're going to reflect across the x-axis. Remember, the vertical reflection is across the x-axis. Then the next thing you could do is you're going to deal with this vertical stretch by a factor of 2. So vertical stretch. I don't want you to get confused with shrink there. So this is for stretch. And then by a factor of 2. Then the last thing is you have this plus 3 here. That's just going to shift me up by 3 units. So 3, we're just going to say shift up by 3 units. And that's basically it. Now 1 and 2 could be swapped and it would not change the result. In other words, you could say that the first thing you do is vertically stretch by a factor of 2. Then the second thing you do is reflect across the x-axis. Then the third thing you do is shift up by 3 units. Again, the main thing is to do the shift last because we're just following the order of operations. So what I would do again is just think about a point that's on your f of x. So f of x, let's say this is x comma y. Again, when you go to g of x, what is that point going to be? Well, again, the x is just going to stay the same. We're not messing with that right now. The y value has been multiplied by -2. Again, you can just put these together. So first it's -2 times y. Then after that, you're just adding 3. So that's all it is. So let me go ahead and grab this. And let's come down here and paste this in. And again, we can test this with a few points. Again, a lot of stuff is on these graphs here. So I color coded everything to show you which points are together. In other words, this point right here, -2, 4, that's on the graph of f of x equals x squared. If you plugged in a -2 and you square that, you would get 4. So that's how you get -2, 4. Well, that point's going to become -2, -5 in your g of x. In other words, the x value would stay the same. Let's write first that we have -2, 4, and this is going to go to same x value of -2. But the y value is now, you're going to take this, which is 4, you're going to plug it in there. So -2 times 4, and then plus 3. So -2 times 4, that's -8. So this is -8 plus 3, which is -5. So that's how you get this -2, -5 right here. Again, you can do a similar process to go from this guy right here, which is 0, 0, to get this point right here, which is 0, 3. I'll let you do that on your own. You also have this one that's given, so 2, 4. You're going to see that's going to go to 2, -5. All right, for the next few problems, we're going to look at some examples with just horizontal transformations. These are the ones that most students struggle with. For one, it's counterintuitive. You have to undo what's being done to x. The second thing is you have to go in the reverse of the order of operations. We saw with graphing transformations with y, we follow the order of operations, it's nice and simple, but with graphing transformations with x, we're going in the reverse of the order of operations because we're trying to undo things. When you undo something, you go in reverse. So if I look at this form right here, so g of x equals f of, you have this b that's been factored out, So this would be times the quantity x minus h over b. This right here is going to follow the order where we do the horizontal stretch or compression first, along with any horizontal reflection, so reflecting across the y-axis now, before we do any shift. Okay, so any horizontal shift would be last. Now, if you're working in a book and they write it like this, so g of x is equal to, let's say f of bx minus h, they're going to tell you that you want to do the horizontal shift first. And that's because it's written differently, so it has a different order of operations, and therefore when you reverse that, you get a different order. I'm going to use this form right here. Again, we talked about why that's important in the lesson. You can go back and watch that if you want to review. So I'm going to factor the b out first. That's going to be the coefficient of x. And then I'm going to do any horizontal stretch or compression along with any reflection first. Again, those can be done in any order, followed by any horizontal shift. So that's going to be done last. All right, for problem 3, we're given f of x equals x cubed, and then g of x equals the quantity 2x minus 6 cubed. So the first thing I'm going to do, just like I've done previously, is just rewrite this. So I'm just going to say g of x is equal to this f of this guy right here, so 2x minus 6. Again, all you're really doing is you're taking this right here and you're plugging it in right there. So that's why you can write the g of x as being equal to f of, again, your argument would be that 2x minus 6. Once you look at this, again, you want to factor, so we can use that order that we talked about. If you don't factor, again, you're going to get a different order. But we are going to factor, so I'm going to say g of x is equal to f of, you're going to factor out that 2, again, the coefficient of x. So inside you get x minus 3. Close all that down. Let me get rid of this, and actually we can just slide down. We don't need that anymore. We're just going to go based on this. Now, when you work with horizontal transformations, again, you're trying to undo what's being done to x. Well, first, think about if I plug in something for x there, what do I do first? Well, I subtract away 3. What do I do second? Well, I multiply by 2. Again, that's because the order of operations says you work inside of parentheses first, then you would do this multiplication second. Well, when I'm undoing something, I'm going to undo this first and then this second. In other words, how do I undo multiplication by 2? Well, I would divide by 2 or multiply by half. So that is going to give me a horizontal compression by a factor of 2. And again, I know a lot of books say this differently. They might say there's a horizontal shrink by a factor of a half. It really means the same thing. It's just different ways to express it. So all you're doing is you're taking the x value and you're either dividing by 2 or multiplying by a half. So don't get too caught up on the different terminology. Just understand what's going on. The second thing is you would need to undo this subtraction of 3. So how do I undo minus 3? You want to add 3. So that's going to give me a shift to the right by 3 units. So I'm just going to say shift right. And we could say by 3 units. If you wanted to look at this graphically, again, you have some x comma y that's on the graph of this f of x function. Well, when you go to the g of x function, what is this going to become? So your x is now going to change because you have a horizontal compression by a factor of 2. So again, x is just divided by 2. And then you're shifting to the right by 3 units. So you're going to add 3. And then the y value is going to be the same. So let me go ahead and grab this and I'll show you real quick. Again, I have a link for you on Desmos if you want to click on that. But I have all these points done for you. They're all color coordinated. So let's just do this one and you can do these on your own. Basically, to get the same y value of 8, here the x value is 2, but here the x value needs to be 4. Again, when you plug in a 4 and you go through this, you're going to end up with 2 cubed, which gives you 8. Let me just show you that real quick. So if you did g of 4, this would be equal to, and you can do it in non-factor form, it doesn't matter, or maybe we'll factor it just for completeness. Let me go 2 times the quantity x minus 3 like this, just so you can see it, and this would be cubed. So this would be equal to, again, you're going to plug in a 4 there. So let me just erase that and put a 4. This would be 2 times 4 minus 3 is 1. Close that down. This would be cubed. And this equals 2 times 1 is obviously 2. So this is 2 cubed. So at this point, again, after we've done these operations, we're going to have this 2. Again, that's the same x value as here. And when we cube it, we're going to get the same y value. So we have 2 comma 8. And now we have 4 comma 8. Okay, so this would be equal to 8. Let me put that in there. And you can just erase it. And now let me just write that if you had this point, which was 2 comma 8, again, another way to think about it is just using this. Well, the x value now, you would go 2 over 2, which is 1, then plus 3, that's 4, and then comma, the y value would be the same. So it's 4 comma 8, that's what it's going to become. All right, for problem 4, we have f of x is equal to the square root of x, and then g of x is equal to the square root of negative 1/2 x plus 1. All right, so once again, I'm going to work on the inside of this guy and factor first. So let's say that g of x is equal to, let's go f of, pull out this negative 1/2 here. So negative 1/2, and then times the quantity inside, this would be x. And this is the one that causes a lot of confusion. So what should go right here? Well, think about the fact that to get back to this, I'd have to multiply by negative 1/2, or you could really say you're dividing by negative 2 if you want to think about it that way. So how do I undo division by negative 2? Well, I would want to multiply by negative 2. So you could really say that 1 times negative 2 would be negative 2. So you're going to put that as negative 2 like that and close that down. You can check it. So negative 1/2 times x, that's negative 1/2 x. And then negative 1/2 times negative 2, that's going to be positive 1. Okay, close that down. So again, once it's in factored form, we can go through and list the horizontal stretch or compression along with any horizontal reflection, so reflecting across the y-axis first before we do any horizontal shift. Again, whether you put the horizontal reflection first or the horizontal stretch or compression first, that doesn't matter. So I'll just put the reflection first since it's out in front. So let's say first we're going to reflect across for a horizontal reflection, it's going to be reflecting across the y-axis. So y-axis. And then the second thing here, we're going to think about, how do I undo multiplication by 1/2? Well, I want to multiply by 2. That's going to give me a horizontal stretch by a factor of 2. So let me put horizontal stretch. So that S there stands for stretch. It's not going to stand for shrink. So horizontal stretch by, let me make this y better, a factor of 2. Then the last thing you would do is undo this. Again, you have minus 2 there. To undo that, I need to add 2. So that's going to shift me to the right by 2 units. So let's say shift right 2 units. Again, if you want to think about this with the graph, you can say that if you have f of x here, some point on that, so x comma y, when you go to g of x, again, to get that same y value, well, what's the x value got to be now? Well, you're going to have to go through and take this x value here, and you're going to basically put these two together, 1 and 2. You're going to multiply by negative 2, right? You're stretching horizontally by a factor of 2, and you're making it negative. So let's say this would be, let me do this in a different color, negative 2 times x. And then when you shift to the right 2 units, you're going to add 2 to that, and then comma y. So the y value would be the same here. Let me grab this and come down here and paste this in. And again, you can use any of the points here that I've listed. You can do other points. You have a link for this on Desmos, but I have color-coded everything. Let's just work with this point right here. So you have 1 comma 1. That's on the graph of this. If you do f of 1 here, this equals the square root of 1, which would be 1. So that's going to end up going to this 0 comma 1. How do we get that? Again, if you plugged in, you would go g of 0. This is equal to the square root of negative 1/2 times 0 and then plus 1. Well, negative 1/2 times 0 is 0. So you really end up with the square root of 1. So the square root of 1, we know that gives us 1. So you have that same y value. Okay, let me get rid of this. We saw it that way. Let me do it this way. So you have 1 comma 1. That's going to go to, again, you're going to take this x value of 1. And you're going to say negative 2 times 1 and then plus 2. Well, negative 2 times 1 is negative 2. So plus 2, that's going to give me 0. So this is a 0 right here. And again, you get the same y value of 1. And you can verify that with the graph. Again, you can play around with more points, as many as you need. I give you that link on Desmos. All right, let's put everything together. The rest of the problems we're going to look at, we're going to have horizontal transformations and vertical transformations. Remember that these do not impact each other. So for the horizontal transformations, this is going to have an impact on the input values. And for the vertical transformations, these are going to have an impact on the output values. So it does not matter if you do all your horizontal transformations first, followed by all your vertical transformations, or vice versa. So as long as you do things horizontally in the correct order and then vertically in the correct order, you'll be okay. Now, again, I want to look at this form right here with you because some books do use this. If you have this form right here that is not factored, you are going to get a different order versus this form right here. So we are going to factor, and so that's going to change the order. So again, if you get a book that says something about doing the horizontal shift first, that's because they did not factor. Okay, so keep that in mind. With this one, again, we know that horizontally, this is 1 and this is 2, and then vertically, this is 1 and this is 2. So because the horizontal and the vertical can be done in any order, really what I like to do is just list these from left to right. So you can just go, this is 1, this is 2, this is 3, and this is 4. If you have a different order, again, as long as you're doing the horizontal in the correct order and the vertical in the correct order, it does not matter. So you have different ways of writing this out. You'll see as you search through the internet for different things that you have different procedures. So that might be a little bit confusing in terms of which is the right one. Again, as long as you're going in the correct order for horizontal and vertical, you're okay when you put this together. So I'm just going to work left to right. So I'm going to go 1, 2, 3, and then 4. So anything in terms of a vertical stretch or compression, along with any vertical reflection, that's what I'm going to do first. Then I'm going to do any horizontal stretch or compression along with any horizontal reflection. And I'm going to do that second. Then third, I'm going to do any horizontal shift. And then fourth, I'm going to do any vertical shift. All right, let's take a look at problem 5. So here we have f of x equals 1 over x, and we have g of x is equal to 3 over, we have 1/3 x minus 1, and then we have plus 1. The first thing I'm going to do is rewrite this. So g of x is equal to, so I'm going to write 3, let me put this like this. So 3 as multiplying f of, let's say I'm going to plug this right here, so this right here, in for x right there. So I'm just going to put the quantity 1/3 x minus 1. I will factor that in a moment. Then you have this plus 1 on the outside, so just like that. Let me come down here a little bit, and now let me factor this. So g of x is equal to, let me make this better here, 3 times f of, pull out the coefficient of x, so you're going to pull out the 1/3, and then inside you're going to have x minus. How do I undo multiplication by a third, or you could say division by 3? You would multiply by 3. So 1 times 3 would be 3. Close that down, close this down, then plus 1. The first few times you factor like this, it might be a little bit confusing. You can always check with multiplication. 1/3 times x is 1/3 x, and then minus 1/3 times 3 is going to be 1. Let me get rid of this form right here. Remember, if you don't factor, you're going to get a different order. We're going to factor, so we can use that order that I discussed. So we're going to go from left to right. Again, if you want to do it a different way, as long as you get the horizontal correct and the vertical correct, you'll be okay. But I'm just going to say that this is first, this is second, this is third, and this is fourth. I'm just going to go in that order. So the first thing is we're going to deal with our vertical stretch. So this is a 3 that's multiplying this guy. That just gives me a vertical stretch by a factor of 3. So vertical stretch by a factor of 3. Let me slide down here a little bit. It's going to be kind of hard to fit these on here. Let me use a different color. So let me change over to this one. So for number 2 here, we're dealing with this on the inside. Remember, on the inside, you have to undo what's being done to x. How do I undo multiplication by a third? I want to multiply by 3. So I'm going to say that that's going to give me a horizontal stretch by a factor of 3. Then let me come down here. The third thing we're going to do is deal with this. So again, we're still on the inside, so we have to undo things. How do I undo subtraction of 3? I want to add 3. That's going to shift me to the right by 3 units. I'm going to say shift right. Let me make this better here. 3 units. Then the fourth thing is I'm going to deal with this vertical shift. That's the easiest thing to deal with out of all of these. And basically the plus 1 is just shifting me up by 1 unit. So I'm going to say shift up 1 unit. So this is one order that you could use. Again, there's other orders that you could go with that would still be correct. As long as you get the horizontal correct and the vertical correct, the end order is not going to matter. Just make sure you get the individual parts correct. What do I do horizontally? What do I do vertically? And then you can put it together in some form of order. So I'm going to say that first we're going to vertically stretch by a factor of 3, followed by the second thing is horizontally stretch by a factor of 3, followed by shifting right by 3 units, and then followed by shifting up 1 unit. So basically, if you have f of x, which is x comma y, what's going to happen is when you go to g of x, you're now going to have, well, horizontally, we're multiplying by 3, so 3 times x, and then we're going to add 3, so 3x plus 3, and then vertically, we are multiplying by 3, so 3y, and then we're shifting up by 1, so plus 1. Let me grab this real quick and I'll show this to you. And let me paste this in. So let's just say we take a point that's on f of x equals 1 over x. So something like, this is easy, so 1 comma 1. What's going to happen is this is going to go to 6 comma 4. So let's say we have 1 comma 1. This is going to go to 6 comma 4. Again, you just plug in. So let me do this out here. So 3 times 1 plus 3. 3 times 1 is 3 plus 3 is 6. So the x value would be 6 there. And then for the y value, you have 3 times 1 and then plus 1. And so this is going to be 3 plus 1, which is 4. So that goes to 6 comma 4. Again, if you want to play around with more of these, you can. And again, this is on Desmos for you if you want to click the link. All right, for problem 6. we have f of x equals the cube root of x, and then g of x is equal to negative 2 times the cube root of 2x minus 2, and then minus 1. So let's first rewrite this. So g of x is equal to, let me make this better here. We would have negative 2 times f of, you're going to take this right here and plug it in for x. So 2x minus 2, close that down, and then you have minus 1. Now again, to follow our order, we want to factor on the inside. So you're going to pull out the coefficient of x. So g of x is equal to negative 2 times f of, if I pull out a 2, inside you'd have x minus 1. Close that down, close this down, and then minus 1. Okay, let me get rid of this, and let me move this up here like that. And so basically, once it's in this form, you could just work left to right. You could do it other ways, but again, left to right works for me. So because you have that negative there, I'm just going to add something in and say, I'm going to go ahead and do that first. So that's just dealing with the vertical reflection. I'm going to do this second. I'm going to do this third. I'm going to do this fourth, and I'm going to do this fifth. Okay, let me slide down here a little bit, and let's just write this out. So the first thing is, again, if I'm dealing with that negative, again, producing a vertical reflection or reflecting across the x-axis. So let's say we're going to reflect across the x-axis. Second thing, we're going to deal with this 2 here. So that's going to give me a vertical stretch by a factor of 2. So vertical stretch by a factor of 2. Third thing, we're coming on the inside. So once we get on the inside, remember we have to undo things. So this 2 here, again, with multiplication by 2, I need to undo that with division by 2, or I could say multiplication by a half. So that's going to be a horizontal compression by a factor of 2. Or again, some books would say a horizontal shrink by a factor of a half. Just realize that the x-coordinate is either divided by 2 or multiplied by half. Use whatever terminology you want. Then this right here, I need to undo this. How do I undo? Subtracting away 1, I need to add 1. So that is going to shift me to the right by 1 unit. So shift right 1 unit. Then the last thing we're going to do, we have this minus 1 on the outside here. That's just going to shift me down by 1 unit. So it's going to shift down 1 unit. So this is one order that would work. Again, as long as you have your horizontal stuff straight and your vertical stuff straight, there's other orders that would work. So feel free to play around with that. I'm just going to show you again with the graphs. If you have, again, f of x and you have some x comma y, when you go to g of x, again, what is it going to be? Let me get rid of this. For the x value, we see that we're going to end up dividing by 2. Again, that's what horizontal compression by a factor of 2 means. So let's go x over 2. And then after that, we're going to shift to the right 1. So that's going to be me adding 1. Then for the y, we have this reflect across the x-axis and also stretch by a factor of 2. So basically, we're just multiplying the y-coordinate by negative 2. So negative 2y. And then we're going to shift down by 1. So minus 1. So this is how you could check this. Let me grab this real quick. And let me put that right there. So you could do this with different points. Again, I'll use something. Let's maybe use this one right here. So 1, 1, and that's going to go to 1.5, negative 3. And again, I've got these all color-coded if you want to play around with the link for Desmos. So let's say that we start with, let's say 1, 1. So let's say you go 1 over 2, which is 1/2, plus 1. Let's write 1/2 plus 1. So 1, you could write 2 over 2. So that would be 3/2 or 1.5. So let's go 1.5 there, comma. For the y value of 1, again, you're going to multiply by negative 2. So negative 2 times 1, and then minus 1. Negative 2 times 1 is negative 2. Negative 2 minus 1 is negative 3. So this is negative 3. So again, you can see that that point, which was originally 1, 1, is going to go to 1.5, negative 3. Again, you've got that link on Desmos if you want to play around with the other ones on your own. All right, let's take a look at problem 7. So here we have f of x equals x squared, and then g of x equals negative 5. And then you have times this quantity, so 1/3 x plus 1, and then this is squared, and then minus 2. So it's pretty easy to rewrite this. Again, just saying that g of x here would be equal to, you have this negative 5, so negative 5, and then times your f of, again, this right here is just getting plugged in for x right there. So we're going to say 1/3, and then x plus 1. Close that down, and then you have the minus 2. All right, so now let's go ahead and factor so we can use our procedure. So we're going to say g of x is equal to -5 times f of, pull out the 1/3. So inside the parentheses, let me fix that 3 real quick. Inside the parentheses, you're going to have x plus, again, how do I undo multiplication by a third? You'd want to multiply by 3. So just take that 1 and multiply by 3. You're going to get 3. Close that down and close this down. Again, you can always check 1/3 times x is 1/3 x, and then plus 1/3 times 3 would be 1. So that is a match. Then we have this -2. So once you have that factor, just get rid of this one right here. We're going to work with this form. And I'm just going to, again, go left to right. Other ways to do it, but this is the way I'm going to. So I'm going to do this one as 1, this one as 2, this one as 3, this will be 4, and then this will be 5. So the first part here would be to deal with this vertical reflection. So that is a reflection across the x-axis, again, produced by that negative right there. So we're going to say that we're going to reflect across the x-axis. Second thing, this 5 here that's multiplying this guy is giving me a vertical stretch by a factor of 5. So vertical stretch by a factor of 5. Third thing, inside now, we want to undo things. How do I undo multiplication by a third? You want to multiply by 3. So that's going to give me a horizontal stretch by a factor of 3. Okay, fourth thing. Again, we're still inside. You need to undo what's being done to x here. I'm adding 3. To undo that, I want to subtract away 3. So that means I'm going to get a shift to the left by 3 units. So let's say shift left will go by 3 units. Then this last guy on the outside, again, that's straightforward. This -2 here is just shifting me down by 2 units. So for the fifth thing, we're just going to shift down by 2 units. So that is one order that would work. Again, there's different orders that you can use. Just make sure you got the horizontal straight and the vertical straight, and then you can put them together in any order that you like. So what I'm going to do now, again, is just go to the coordinate plane. We have some graphs set up, and I'll just show you how you can take one point from your f of x. So you have f of x. Let me fix that. So you're going to have some x comma y. And we're going to go to g of x and think about what the point's going to become. So here, if you think about what's being done to x, you have a horizontal stretch by a factor of 3. So that means I'm multiplying x by 3, and then you're shifting left by 3 units, so then -3, so 3x minus 3, and then comma. In terms of y, you can put these two together, so reflected across the x-axis, and then vertical stretch by a factor of 5. Again, that's just me multiplying the y-coordinate by -5. So this would be -5y, and then we're shifting down by 2 units, so -2. And we'll close that down. So let me arrow up to this so that's clear. And let me just go ahead and grab this real quick. And let's come down here. Again, I have this on Desmos for you so you can play around with the points. They're all color coordinated, so it makes it easy. I'm just going to pick one of these. It doesn't matter which one. I'm just going to pick this one, which is 1, 1. So 1, 1. Again, what is that going to become? You can see from the color coding that it's going to be 0, -7. But again, just following this, you take this 1 and you plug it in for x. So you'd have 3 times 1 minus 3. Let me make this 3 better here. So 3 times 1 is 3, then -3, that would be 0. So you can see that's going to match right there. And then the other one is also a 1, so you just plug that in for y there. So -5 times 1, and then -2. -5 times 1 is -5, and then -5 minus 2 would be -7. So you get -7 there. Again, that's going to be a match for that one. So you can just click that link if you want to do some more practice. All right, for problem 8, we have f of x is equal to x cubed, and then g of x is equal to -1/4 times the quantity 2x plus 6 cubed plus 2. All right, let me slide down here. We're just going to rewrite this. So let's say that g of x would be equal to, you've got -1/4 times your f of x, again, is x cubed. So this guy right here is getting plugged in right there. So let's say f of 2x plus 6, and then you have your plus 2. Now what I'm going to do at this point is I'm just going to factor out the coefficient of x. So I'm going to say that g of x is equal to -1/4 times f of, pull out the 2. This is very straightforward. We'll have x plus 3 on the inside. Close that down, close this down, and then plus 2. Okay, let's get rid of this. Again, we want it in factored form. So let me pull this up here like this. Because we have this negative out in front, again, you could really write this as 5 steps. I'm going to write this as first, this is second, this is third, this is fourth, and this is fifth. So the first thing we would do here is deal with that negative out in front. Again, that's giving me a vertical reflection or a reflection across the x-axis. So I'm going to reflect across the x-axis. Then for number 2, I'm going to deal with this multiplication by a fourth. Again, you could really think about this as a vertical compression by a factor of 4. A lot of books will like to say that as a vertical shrink by a factor of a fourth. Again, I don't really care about your terminology. Just realize that the y-coordinate is either being divided by 4 or multiplied by a fourth. Then the third thing we're going to do, we're coming on the inside. Remember, we need to undo things. So in this particular case, you have multiplication by 2. How do I undo that? Well, I need to divide by 2 or multiply by half. So you could say there's a horizontal compression by a factor of, let me make this better here, 2. Again, some books will say a horizontal shrink by a factor of a half means the same thing. I'm taking the x-coordinate, I'm dividing by 2, or you could say I'm multiplying by half. You would have the same impact. Then the fourth thing is we need to come inside the parentheses, and we need to think about how do I undo adding 3? Well, I want to subtract away 3. So that means I'm going to shift left by 3 units. Let me make this better here. Then the last thing we're going to do, we're going to deal with this plus 2. That's a vertical shift. We're going up 2 units. So I'm just going to go shift up 2 units. Again, there's different orders that you could give where they would still be correct. Just make sure you're doing the horizontal transformations in the correct order and the vertical transformations in the correct order, and you'll be okay. Let me just show you this with a graph in case you want to see it. So again, you have some x comma y. That's on the graph of f of x. When we go to g of x, we're now going to see, let me fix this real quick, that this is going to be, again, for the x-coordinate, well, what are we doing? We have a horizontal compression by a factor of 2, so that means I'm dividing the x-coordinate by 2, and we're shifting left by 3 units, so then minus 3. For the y, again, we have this reflection across the x-axis and a vertical compression by a factor of 4, so let's go ahead and say that's negative y over 4. And then we have this shift up by 2 units, so plus 2. So this is going to go to this. Okay, let me grab this and I'll just show you this with the graphs. Let me come down here and I'll just pick an easy point. So something like 2 comma 8. We know that's on the graph of f of x equals x cubed. Again, I've color coded this, so it's going to go to negative 2 comma 0. So we'll just write this out. So 2 comma 8. This is going to go to, again, start with 2. 2 divided by 2 is 1. 1 minus 3 is negative 2. And then you have 8. So let me write this one out. So negative 8 over 4 plus 2. Well, negative 8 over 4 is negative 2. And then you'd have negative 2 plus 2. And of course, that's 0. So you can play around with the other ones if you want. Again, I have them color-coded. You just click the link on Desmos where everything's ready for you. All right, for problem 9, we have f of x is equal to the square root of x. And g of x equals 1/2 times the square root of 2/3 x minus 1. Then we have plus 1. So let me rewrite. G of x is being equal to 1/2 times f of, again, this gets plugged in there. So this is 2/3 x minus 1. Close that down, you have plus 1. Again, I'm going to factor out the coefficient of x, so we can use our little procedure. So let's say that we have g of x is equal to 1/2 times f of, the 2/3 gets factored out. So inside you have x minus. How do I undo multiplication by 2/3? I'd want to multiply by the reciprocal, which is 3/2. 3/2 times 1 is just 3/2. Close this down, then plus 1. Okay, get rid of this. We're going to work in factored form only. And let me slide down here. So we'll say that this is first, this is second, this is third, and this is fourth. So the first thing is we have this vertical compression by a factor of 2. So vertical compression by a factor of 2. Again, you can also say there's a vertical shrink by a factor of a half. You're taking the y value and you're dividing it by 2, or again, you could say multiplying by half. The second thing we're going to do is we're going to undo multiplication by 2/3. To do that, you need to multiply by 3/2, right? You need to multiply by the reciprocal. And because that's greater than 1, that's giving you a horizontal stretch. So we're going to say this is a horizontal stretch by a factor of, you could say 1.5. I'm just going to say 3/2. Let me put this like that. Okay, the third thing is we're going to undo the subtraction of 3 halves. So that's going to mean we want to add 3 halves. So that's going to shift right 3 halves units. You can put 1.5 again if you want. Then for 4, we have this shift up here by 1 unit. Very straightforward. So we're going to shift up by 1 unit. Again, checking this with the graph, if you have f of x and a point on that is x comma y, when you go to g of x, again, now the point is going to go to, for x, we want to multiply by 3 halves. So we have 3 halves x. And then we want to add 3 halves. So add 3 halves. And then for y, we want to vertically compress by a factor of 2. So y over 2. Again, you're dividing by 2 or multiplying by half. And we want to shift up by 1 unit, so plus 1. So let's go ahead and look at this real quick. So let's just pick a point. Let's just take 4 comma 2. That's easy to work with. Again, on f of x equals the square root of x, square root of 4 would be 2. So you're going to take 4 comma 2, and that's going to go to, you would have 3 halves times 4 plus 3 halves. You could cancel here, but I wouldn't because you want a common denominator. So just do 3 times 4, that's going to be 12. So say that you have 12 over 2 plus 3 over 2, that's going to be 15 over 2. So 15 over 2. Now here it's written as 7.5. Again, if you did that with a calculator, 15 divided by 2, that would be 7.5. Maybe I could just write it like that. I think it would be more clear since we're matching it up there. Then for y, you have 2. So you're plugging that in, so you'd have 2 over 2, which is 1, plus 1, which would be 2. So that's how we get this point right here, which is 7.5 comma 2. Again, you have that link if you want to click it, play around with the other points. Everything is color-coded for you. All right, for problem 10, we have f of x is equal to x cubed minus x, and then g of x is equal to 1/3, and then times our quantity 2x minus 6 cubed minus 1/3 times the quantity 2x minus 6, and then minus 1. So this one, I think the hardest part is actually just rewriting it. So if you look, you can do g of x is equal to, you're going to go 1/3 times your f of, this would be plugged in for x. So we're going to go 2x minus 6, close that down, and then you have minus 1. So you can pause the video and go through this notation here and see that if you do this, you're going to end up with this. So once I have it set up this way, again, I just want a factor on the inside. So I'll do g of x is equal to 1/3 times f of, go ahead and pull the 2 out. Inside you'd have x minus 3. Close all that down, then minus 1. Again, just get rid of this form right here. We're going to work like this. And all we're going to do is just say that this is first, this is second, third, and then fourth. So first I'm going to deal with this 1/3. So I'm going to say that's going to give me a vertical compression by a factor of 3. So the y coordinates are divided by 3. Again, a lot of people will say that it's got a vertical shrink by a factor of 1/3, meaning that you take the y coordinate and multiply by 1/3. Use whatever terminology you're comfortable with. The second thing is, so for this right here, I want to undo multiplication by 2, and that means I want to divide by 2 or multiply by half. So I'm going to say there's a horizontal compression by a factor of 2. Or once again, if you wanted to, you could say that there is a horizontal shrink by a factor of a half. Different terminology, same meaning. The third thing, we want to come on the inside of the parentheses here and undo subtracting away 3. So how do I undo minus 3? I want to add 3, and that's going to shift right 3 units. I make this n better here. And then the fourth thing is we have this minus 1 here on the outside. That's just going to shift me down by 1 unit. So we'll say shift down 1 unit. Okay, so when we think about something like a point on f of x, which is x comma y, well, when we go to g of x, what is this going to become? Well, we're going to say that for the horizontal, well, we're going to divide by 2, or again, multiply by half. You have a horizontal compression by a factor of 2. So we're going to say x over 2, and then we're shifting right by 3 units, so just add 3. For the y, you have this vertical compression by a factor of 3, so you can go y over 3, and then we're going to shift down by 1, so minus 1. Okay, let's grab this real quick so we can check things. And we'll come down here. This writing over here is extremely small, just so I could fit it. Again, you can always click the link I gave you for Desmos if something is not clear from the video, and you can play around with some extra points if you need to. So I'm just going to take an easy one. So let's just say 2, 6. Again, just plugging that in for clarity. So f of 2 is equal to 2 cubed minus 2. So this is 8 minus 2, which is 6. So 2, 6 would be on that graph. And what that is going to go to is 4, 1. So that's going to be there on the other graph. Again, you have 2, 6. And what you're going to do is you're going to take that x value of 2 and plug it in there. So 2 over 2 would be 1, and then 1 plus 3 is 4. And then here you take the 6 and plug it in. 6 over 3 is 2. 2 minus 1 is 1. So that 2, 6 is going to go to 4, 1. You have this 0, 0 that's going to go to 3, negative 1. And you have this negative 2, negative 6, which is going to go to 2, negative 3. I'll let you do those other ones on your own.